Hello everyone, welcome to the Cloud Computing Full Course by Intellipaat. In this video, I am going to help you make sense of one of the trending technology that is cloud computing. I'm certain that you must have stored your photos in the Google Photos and files in the Drive. You must have ordered food on the Swiggy and seen things moving in the real time, or even binge watched an entire series on Netflix. All that at once without a single glitch. Maybe this sounds normal to you, but it wasn't back in the day when internet came into existence. This is the modern magic, and the musician behind all of this is cloud computing. Now, here's the real twist. Every app you use, every payment you make, and every file you store run on someone else's computer, like connected through the cloud. And this is how companies like Amazon, Google, Flipkart, and even your local bank scale in seconds for enormous users and never crash. And guess what? In 2025, there is already a huge demand for this technology. Almost 90% companies in the world consider themselves cloud first. And thus, there are lakhs of open cloud computing jobs available. But the supply for skilled cloud engineers is really limited. And this course is designed to get you the skills and frameworks to crack those cloud computing jobs and achieve your career objectives. Here, we will take you from basics of cloud computing to work on real AWS hands-on projects. So if you are a student, a job seeker, or even an IT professional interested in cloud, don't skip. Watch this course till the end and take your first step into the future of tech right here on Intellipaat's YouTube channel for absolutely free. Now let's begin with understanding cloud computing in a simplest manner.
Meet Ravi. He's the founder of a small software company based in Bangalore. His team builds web app for clients. They have just landed a big project, an e-commerce site for a global client. This sounds very exciting, right? But also scary because Ravi's local infrastructure is very limited. He doesn't have big servers, high-end GPUs or a fancy data center. And building one would take lakhs of rupees, months of setup and constant maintenance. And still there would be risk against cyber attacks, natural disaster which can whip around losses for Ravi's company. So what can Ravi do? At this moment, he came to know about cloud computing. So what is this cloud computing? Is it like data center sitting up in the clouds? No. In simple words, cloud computing means you don't need to own the physical hardware. You rent things like storage, server and networking over the internet. And you only pay for what you use. And since all these resources sit virtually in the internet and can be accessed with the use of internet, this way of accessing resources is termed as cloud computing. So simply put, computing that happens over the internet. Let's break down how cloud computing can help Ravi with his e-commerce project. We will compare what he would need to do for an on-premise setup versus what can he do on the cloud. In any software development project, even before Ravi's team write a single line of code for the mobile app, they need to set up a few essentials. For example, a server to run the backend, storage for user data, images and transaction, a secure way to connect components, a place to test features safely, tools for automatic deployment and daily backups for recovery, and the ability to handle sudden spikes in the user. So let's take these attributes one by one and see how cloud computing makes Ravi's job 10 times easier than going with physical on-premise infrastructure. So first up is storage. This is where all app data lives. Ravi's app lets user upload profile picture, store order history, save payment records, maintain session data. So if all this has to be stored on-premise, he would need to buy and configure physical servers, attach hard drives, set up cooling system and run backup routines, all while praying the business doesn't have a power outage. With cloud computing, Ravi just configures cloud storage units such as AWS S3 and that's it. It's encrypted, backed up and instantly available. Next up is compute power, the brain behind the app. So whenever a user logs in, updates their card or stream a product video, Ravi's backend has to process those actions fast. If it has to be on-premise, Ravi would have to buy a physical server, install operating system, keep them on 24/7 and upgrade them whenever traffic increases, meaning he will have to buy more hardware. On the contrary, with cloud computing, Ravi spins up virtual servers on demand using AWS EC2. He pays only what he uses and when the traffic dips, he shuts them with zero waste. Third on the list is networking. Ravi's apps front-end need to securely talk to the backend using APIs. So if Ravi were to implement network security on on-premise setup, he would have to manually set up routers, install firewalls, open only required ports and hire someone to monitor the threats. On the cloud, he just have to configure a VPC, a secure isolated network where only specific services can communicate with each other. The traffic is encrypted, everything is logged, so Ravi don't have to worry about the threats. Next up is testing. Let's consider that Ravi has built an app and it's live, but his client wants him to add new refer a friend feature. To do this on premise, Ravi would need to replicate the entire production environment. That means more servers, cloning the database, increasing the cost, plus the risk of accidental breakoffs. But when done on the cloud, Ravi could just create staging servers with a click. This new feature is tested without touching the live app. Once it is approved, it goes live instantly with new update. No drama at all. Fifth point is DevOps and automation. So let's consider that Ravi's development team commit code every single day. For the on-premise setup, every change would mean someone like specialized DevOps engineer sitting there and doing manually builds, test, bash scripting and deploying the app, which is very slow and then again error prone. But when relying on the cloud, Ravi simply integrates GitHub plus AWS code pipeline. Now every code push is auto-tested, auto-deployed, monitored in real time. His team focuses on coding, not babysitting the servers. Sixth point is scalability. One day this e-commerce app goes viral. Suddenly 5,000 users becomes 1 lakh. If this happens in on-prem, there is possibility that Ravi's fixed server might choke, leading to app breakdown and client's disappointment. But when things are worked on the cloud, Ravi could just enable auto-scaling. So when the traffic rises, more servers spin in automatically. When it falls, they shut down to save the cost. Smooth experience for customer, no panic for Ravi and the happy client. So you see, cloud computing in every step proved to be better than that of on-premises. That's why almost 96% companies today call themselves cloud first and are using cloud services one way or the other. Building an app like e-commerce without cloud computing today is like trying to run a race barefoot on broken glass. Cloud computing is cost effective since it uses pay-as-you-go model and provides services with just clicks whenever you need. It's fast, it's flexible and is the backbone of modern software development. Moving on, let me walk you through different deployment models cloud computing providers like AWS, Azure or GCP offer. First up is public cloud. You can consider it like taking a bus. You don't own it, but you share it with others. Public cloud like AWS, Azure, GCP provide infrastructure over the internet for anyone to use. Most startups and dev prefer this. It's affordable and easy to get started. Then we have a private cloud. Now think of a private car built and used by one company only. Private clouds are used by big enterprise needing full control, customer compliance or specific security setup. More expensive but fully owned and operated by one company. Finally, we have the hybrid cloud, a mix of both public and private cloud. You use public cloud for general stuff, private for sensitive workloads. This is flexible, cost-effective and popular among growing companies. So there you have it. You just understood different type of deployment models, how cloud computing is better than on-premise setup. You discovered how it's cost-effective and easy to access and manage. You won't wonder now about why Ravi chose cloud computing. By the way, if you're interested in pursuing cloud computing or DevOps as a career option, we can help you learn more with our strong curriculum-driven course. You can check out the link in the description to know more.
Alright. So let's begin with a question. When was the last time you actually bought a DVD to watch a movie or carried a USB drive just to store your files? Come on, think about it. Alright, let me answer this for you. Probably a while ago, right? And why is that? Well, nowadays we simply stream movies on platforms like Netflix or Amazon Prime, where there is no need to download files or worry about running out of space. Just one click and boom. Instant entertainment whenever you want, wherever you want. And it's the same with storing files as well. We just save the files over the Google Drive or Dropbox, where there is no need to panic over losing that USB or carrying extra devices around. Everything is just there whenever you need it. Now here's the fun part. This is what cloud computing looks in the action. And you have already been using the cloud in your day-to-day life without even realizing it. Like through the movies you stream, the files you save online, all of it is powered by cloud technology working silently into the background. Okay, let's make it even simpler with another example. So, think about how you listen to your favorite music nowadays. Do you still keep a giant collection of CDs or download every song onto your phone? Nope. Right. Chances are you just open your favorite music streaming app such as Spotify, Apple Music or YouTube, tap on the song you want and voila! Just instant music anywhere, anytime without worrying about storage or device space. Now, why am I talking about music and movies? Because that's exactly what cloud computing does for businesses and individuals as well. But instead of streaming songs or movies, You are getting instant access to the computing power, storage, software, and much more, all on your demand. Now imagine if a business had to buy and maintain massive servers and hardware for every little task. It is expensive, right? Not to mention the time and effort to manage it all. But with cloud computing, they don't have to do such a hassle. They can just rent what they need, like how you stream a song without buying the whole album. There is no maintenance worries or bulky equipments, right? No bulky equipments, right? Just instant access to the powerful resources whenever you need them. Now that is pretty cool. Cloud computing is like having a magical toolbox that's always stocked up with exactly what you need, without you ever having to carry it around. Now that we have seen how familiar these cloud-powered services already are into the day-to-day lives, let's dive into what cloud computing really is and why it is becoming such a game changer for businesses, startups, and individuals alike. So let's move forward with understanding what exactly is cloud computing. By the formal definition of the cloud computing, it is the delivery of on-demand computing services and resources like storage, computing power, networking, security, and more via the internet. And it operates on a pay-as-you-go basis. But what does that mean in simpler terms? For that, think of it this way. Normally, when you store your photos, documents, or apps, you save them on your computer or a local device, right? Or maybe you use external hard drives or USB sticks to keep them safe. Well, cloud computing flips that. Instead of storing all your stuff on a physical device that you own, you can save it on the internet. It acts like a virtual storage space that's available anywhere and anytime on demand. Now here's the cool part. Just like you don't need to own the movies or music you stream on Netflix or Spotify, you don't need to own all the equipment or servers to store or process data with cloud computing. Here, you can just rent these resources whenever you need them and actually only pay for what you use. Think of it like a subscription to power up your business or personal projects without the need for huge upfront costs. Now let's take a look at the diagram of cloud architecture. This will show you how cloud computing services are structured. You will see how different elements work together to provide computing resources in a seamless and a scalable way. In the cloud, there are several key components. First is clients. As you can see, this end line over here, it is even written end users. These are the users or devices accessing the cloud services like from your laptop, mobile phones, or from the desktops as well. Then comes this internet highway. This is the highway that connects everything, allowing you to access the cloud anytime and anywhere with a stable internet connection. Then comes the cloud service layer. This is where all the computing resources are live, such as storage, servers, networks, and security tools, and many more things, which is provided by the cloud service providers, by the companies like AWS, GCP, Microsoft Azure that manage the cloud infrastructure and provides the resources. So this was it for the cloud computing architecture diagram. So yeah, with cloud computing, the internet becomes like your personal virtual space where you can store, process and access anything you need without ever worrying about managing the hardware yourself. It's like renting a super powerful computer that's always ready to serve you. But wait, how does this all actually work? Why is everyone from fresh startups to the biggest tech giants moving to the cloud? And what makes it such a game changer for businesses? Well, that's exactly what we are going to break down in the coming topics. Let's start by looking at how things used to be done before cloud became a thing. In the past, businesses had to do it really hard way. Let's say you start a company. The first thing you would need to buy is tons of expensive servers and hardwares. And not just that, you will need to constantly maintain and upgrade these servers to make sure everything is running smoothly, which could really be an headache. And then you can launch your product successfully into the market. Now imagine your product gains the traction and more people are starting using it. Great, isn't it? But here's the problem. As the product grows, so does the databases. And more data means more servers. So what's next? The company has to spend even more money buying extra servers to keep up with the demand of the traffic. But here's the catch. As you add more servers, the risk of server crashing also increases. especially if the traffic spikes suddenly. So now you got a big problem. Your servers are overloaded, and when they break down, you can't just wait around and sit there, right? To get things back on the track, you need a maintenance team to fix everything, to patch the servers and make sure nothing crashes again and everything works just fine. But this sounds expensive, doesn't it? Not to mention it's incredibly time consuming. You need to have experts available around the clock to keep those servers running, and this process could take days or even weeks to fix every time. Imagine how much time and money gets wasted in this process. Now, there comes another scenario. Let's say the traffic slows down over the time. The extra servers you bought earlier, well, what about them? Now they are just sitting there wasting resources. But here's the kicker. You still have to maintain them regularly, which means extra charges for something you're not even using fully. This is the classic problem businesses used to face. Spending money on servers they didn't need or use all the time, but still they had to maintain them. So, to sum up the traditional setup, businesses and companies had to buy, maintain and upgrade expensive physical servers, which comes along with huge costs for expensive hardware and software, maintenance and IT teams, offering limited flexibility as upgrading as per the traffic spike means buying new hardware every time, which is a time-consuming approach as setting up and updating servers might take weeks or even months sometimes. The result? A lot of wasted time and money for businesses just to keep things running. And that's exactly where cloud computing steps in. Imagine starting a business today. Would you rather spend thousands of dollars buying servers and hiring teams to manage and maintain them? Or would you prefer to just rent the services and resources as you need on demand and only pay for what you actually use? Sounds pretty simple yet super efficient, isn't it? Well, that's the power of the cloud. With cloud computing, you don't need to worry about cost and hassle of owning and managing hardwares like servers. You just rent exactly what you need from a cloud provider whenever you need it and on a pay-as-you-go basis. So what makes the cloud such a game changer for businesses? Here's why. It makes them more agile, cost-efficient and scalable by providing a pay-as-you-go model where they don't need to invest huge upfront investments. They can only pay for what they actually use. It provides scalability and flexibility as well, where there is no need for more resources. The cloud scales up or down instantly based on the demand. It is also fast and efficient, as forget waiting weeks to set up your hardware. With the cloud, resources are deployed within the minutes, not even months. It also provides remote access and security. You can access your data from anywhere and have top-tier security without any kind of hassle. Where you also no need to worry about server crashes. The cloud ensures your data is backed up and properly secure. In a nutshell, the cloud gives businesses the ability to be more agile, cost-efficient and scalable without getting bogged down in expensive or time-consuming IT infrastructure management. Now, instead of worrying about servers, businesses can focus on building better products and serving their customers right. So that was it. The cloud is changing the game by giving businesses exactly what they need when they need and at a fraction of the cost of maintaining the physical servers. Alright, now that we have understood what cloud is, the next big question comes is, how do companies actually use the cloud? What are their options based on their needs and why does IT infrastructure even matters? In today's world, every business relies on technology to run efficiently, and having the right IT infrastructure is crucial, as it ensures things like scalability, security, and performance are spot on. But every organization needs are different. They choose the infrastructure based on the cost, flexibility, and the level of control they need. So let's break down the three main types of cloud infrastructure. First is on-premises infrastructure, second is cloud infrastructure, and third is hybrid cloud infrastructure. Let's start with on-premises infrastructure. Here, imagine you're owning a house where you're responsible for everything, the roof, the plumbing, and even deciding when to redecorate or renovate it. In the world of IT, that's what on-premises infrastructure looks like. Here, the company owns and manages all of its servers and IT resources in-house, meaning they have total control but also the full responsibility to maintain and make sure everything is running smoothly and efficiently. So now, What are the key features of on-premise infrastructure? The first one is it provides the full control over the infrastructure, where you can make all the decisions about how your system runs. Second is it provides high security and compliance, which is perfect for industries dealing with the sensitive data like banks or hospitals, where privacy is non-negotiable. But it also has some downsides, as it comes with huge upfront expenses. Buying hardware is expensive, and it doesn't stop there. Maintenance and upgrades are other ongoing expenses as well. It also comes with limited flexibility and scalability. If you need more capacity, that means you have to buy and set up more hardware, which can take time and can come with huge expenses as well. So when to use on-premises infrastructure? When your business requires complete control, a strict security, and you are prepared to handle the expenses involved in managing everything yourself. Now the next thing is cloud infrastructure. For this, picture using a ride-sharing app like Uber. You don't own the car, but you still get to decide where to go, in which car to go. That's essentially what cloud computing is. You can rent computing resources such as storage, processing power, databases, etc. over the internet and only pay for what you actually use, which is already provided and managed by the cloud service provider itself. So what are the key features of the cloud infrastructure? The first is there is no hardware ownership or maintenance hassle. Forget about buying, maintaining or fixing servers. Here, everything is managed by the cloud service provider itself. Second is, it is scalable and cost efficient. You can easily scale up or down without any large initial investments. It is also fast and accessible, as you can deploy services and resources quickly and access them from anywhere, anytime. But the trade-off, it gives you very less control over the infrastructure. As the cloud service provider manages the infrastructure, you don't have much control in how things are actually running. So when you should go with the cloud? When you need quick scalability, lower costs, and want to avoid the headache of hardware and maintenance, cloud is the best option to go with. And finally, we have hybrid cloud infrastructure. In simple terms, let's take an example. Imagine you take a subway for most of your daily travel. But for places the train doesn't go, you drive your own car. That's what hybrid cloud is about. It combines on-premise systems with cloud resources as well. So you get best of both the worlds. Now what are the key features of hybrid cloud? Well, the first is, it gives you control as well as flexibility, which is considered as best of both the worlds, where you can keep the sensitive data secure in the in-house while enjoying the scalability of the cloud. Second is, it provides cost optimization, where you can use the cloud for the things where it is cheaper but keep the critical systems on premises. It also allows you for gradual cloud adoption, where you can move to the cloud gradually without a full commitment initially. But the challenge here is complexity, as managing both on-premises and cloud systems can get tricky and may require extra resources and a hardcore experts handling it. So when to use hybrid cloud? When you need a balance of security and flexibility without fully committing to the cloud, this is the best option in this case. So as we have seen, each of these infrastructure types has its own pros and cons. Now let's take a look at the quick comparison of the types of IT infrastructures we just seen through a comparison table. So the first feature, that is ownership. On the on-premises, you own and control everything, which provides full control but with high responsibility. For the cloud computing infrastructure, it is managed by the cloud service provider itself. While in the hybrid, which provides mix of both, here you can control critical data on premises while leveraging the cloud benefits as well. Coming to the second point, that is cost model. On the on-premises, you have to pay high upfront investments for the hardwares and infrastructure. But with the cloud infrastructure, it provides you with pay-as-you-go model, where you can only pay for what you actually use, making it very cost-effective. Coming to the third, that is hybrid cloud infrastructure, it provides you optimized costs because it balances between capital and operational expenses as of both on-premises and cloud. Coming to the third point, that is scalability. On-premises provides you with limited scalability as it requires buying more hardware if required. Coming to the cloud infrastructure, here it is highly scalable as it gives you option where you want to expand or shrink resources as per the need. Coming to the hybrid cloud infrastructure, the scalability here is balanced as you can scale up with the cloud while keeping the core system stable on the on-premises. Coming to the fourth point, that is security. On-premises provides you with high security as there is full control over the security measures as everything is handled in-house. But coming to the cloud providers or cloud computing infrastructure, here everything depends on the provider as security is shared but it is robust. Now coming to the hybrid cloud infrastructure, the security here is flexible as you can secure sensitive data on premises and use cloud resources for less critical workloads. Now coming to the fifth point, that is maintenance. On the on-premises, it requires an in-house IT team for upkeep and updates, while in the cloud infrastructure, there is no maintenance on your end. The provider handles all of it very well. Now coming to the hybrid cloud infrastructure, the maintenance is partial because you can manage on-premises components while the cloud stays managed by the service provider itself. And coming to the last point, that is deployment speed. On-premises are pretty slow while cloud infrastructure is comparatively fast, while in hybrid cloud infrastructure, everything is moderate. So that's the comparison. Pick what suits your control, cost and scalability needs the best. Now that we have seen, while there are different cloud models that we have just studied, the cloud offers huge benefits for businesses, making operations smoother and faster and more cost-effective. So let's break down the top benefits of cloud computing, as this is what makes it a powerful tool for modern businesses. With the key benefits like, first is cost efficiency. Cloud computing saves businesses money in several ways. Here you can rent resources. No need to buy expensive hardwares. And you can just rent what you need and when you need. Second is, it has very low operational costs, where cloud providers take care of hardware updates and maintenance, so you don't need to worry about any kind of costly IT teams or downtime. Third is, it provides you with pay-as-you-go model, where you can only pay for what you use, avoiding unnecessary expenses. This helps businesses control costs and scale up or down easily as needed. Now the second advantage is security and compliance. Cloud providers invest heavily in cybersecurity to keep your data safe and secure, as the encryption and compliance certificates ensure that your businesses meets all the necessary regulatory requirements, such as GDPR or HIPAA, etc. Second is, it provides you with MFA, that is multi-factor authentication, and regular security updates, helping you protect your data from breaches, keeping everything safe and secure. Now the third point is scalability. One of cloud's biggest advantages is scalability. It provides you with auto-scaling. The auto-scaling mechanism allows businesses to instantly increase or decrease computing resources, keeping the cost aligned with actual needs, where there is no need to predict any kind of traffic spikes in demand. Whether you are running an e-commerce site during a sale or streaming a platform during a new release, the cloud adjusts everything in real time. Now, the fourth advantage is performance speed. Cloud providers use globally distributed data centers, which means reduced latency. Data is processed closer to the user, speeding up the access. The second point is, the load balancing ensures smooth performance as the traffic is spread out efficiently, preventing slowdowns during high demand too. It also comes with edge computing advantage, which takes a further step by processing data near the user, improving users' response times even more. Coming to the fifth one, cloud computing is all about accessibility, where you can access work from anywhere on any device and as long as you have a stable internet connection. It also comes with collaboration tools like Google Docs and Microsoft 365, which enables the real-time teamwork, allowing users to work together regardless of the location. And the sixth one is disaster recovery. No one likes thinking about disasters, but the cloud helps mitigate risks of this kind too. It is powered by automatic backups, which ensures that your critical data is protected even if the system fails. It also provides replicating the data across multiple locations, keeping your data safe just in case of a failure at one site, so businesses can quickly recover without losing any kind of valuable information or data. It also helps businesses restore lost data within the minutes, minimizing the downtime and keeping the operations real smooth. While the cloud makes life much more easier, but it's not without challenges. Companies need to be mindful of certain risks and concerns before fully making the move. Let's look at some of the main challenges businesses face when it comes to the cloud, as it is very important to address these challenges to maximize efficiency and enhance the security. The first one is the constant internet connection requirement. Cloud services rely totally on a stable internet connection. If your internet goes down, you lose all your access to the critical systems as well as your data. This means your entire business operation could be at risk if the connection is interrupted, especially if you're working remotely. Now the second challenge is the downtime and reliability issues. Cloud providers, just like any other servers, can experience downtime. If the cloud provider faces downtime, your business might also face interruptions impacting productivity and customer experiences, which can lead to major damages and huge loss. For example, in 2021, AWS went down, disrupting their services and resources for major platforms like Netflix and Reddit. Coming to the third one, that is data security and privacy issues. Moving data to the cloud means trusting a third-party service provider to manage your security and authentication. If a data breach occurs, sensitive customer information could be exposed. As businesses must assess the provider's security measures to ensure that the data is handled properly and is secure on the platforms. The fourth one is complex pricing models. The cost of cloud services can fluctuate unpredictably if the usage isn't monitored closely and properly, where the companies might need to overpay for resources and services they don't need, especially if they don't track the usage regularly and properly. It's important to choose the right plan to avoid unexpected charges as well. Now coming to the last challenge that we have and is majorly talked about is vendor lock-in. So what is vendor lock-in? Let's first see that. So vendor lock-in is when you're totally relied and dependent on a single cloud service provider that when it comes to migrating your systems or resources, it makes it difficult to switch to another cloud service provider. So that is basically called as vendor lock-in. Here, moving data and services to the cloud often involves proprietary technologies that make it hard to switch providers later, as we discussed just now. It comes with high migration cost and compatibility issues that can prevent businesses from easily moving to a different cloud service provider if needed. This is a critical consideration when deciding on a cloud service vendor. So as we have seen, while the cloud comes and offers with huge and immense benefits, businesses must carefully consider these challenges as well before migrating. There are ways to mitigate risks, but understanding the trade-offs is must and crucial. Now that we know the advantages and challenges of cloud computing, the next step is diving into how businesses deploy their resources in the cloud. In the next module, we will explore cloud deployment models, what they are, how they work, and why they matter for your business. So, your business can run efficiently, securely, and cost-effectively. Alright, let's dive in by understanding what cloud computing services are. In simple terms, cloud computing services are on-demand computing resources delivered over the internet. This includes servers, storage, databases, networking, software, and much more. These services allow users to access and manage computing power without the need to own or manage and maintain physical infrastructure. Think of it like renting tools from a hardware store instead of buying them. That's exactly how cloud services work. These services allow users to access and manage computing power without the need to own or maintain or manage any kind of physical infrastructure. Think of it like renting tools from a hardware store instead of buying them. That's exactly how cloud services work. But wait, even these services are categorized into two main models. These cloud models are basically different business models adopted by a cloud service provider. They operate on two main models. That is, first deployment models and second is server models. First, we will explore the deployment models as well. So what are the deployment models in the cloud? A deployment model basically defines the cloud services you are consuming, who is responsible for managing them, your cloud architecture, the scalability of your computing resources, and the level of control and customization you can have over your infrastructure, and the services provided to you versus how much you own of the infrastructure. In other words, it's like choosing the type of housing you want. Do you want to rent it, own it, or share your space with someone? That's how exactly cloud deployment models work, defining how you can access and manage your resources. Based on this, there are four major types of cloud deployment models. First is public cloud, second is private cloud, third is hybrid cloud, and fourth is multi-cloud. So, to make it easier, let's compare choosing a cloud deployment model to choosing a ride. When you pick a ride, you think about cost, control, and convenience, just like selecting a cloud model. Public cloud is like taking a bus, which is accessible for everyone, is cost effective, but offers shared resources. While the private cloud is like owning a private car. It's exclusive only for you. It gives you full control and high security, but it comes with higher expenses as well. While the hybrid cloud is like using a taxi, which offers privacy and flexibility without the burden of full ownership. See how relatable that is. Now let's explore these models one by one, starting with the public cloud first. So what is public cloud? A public cloud is a cloud computing model where the third-party providers offer computing resources and services over the internet, which is shared among multiple organizations at once. For that, imagine using a gym. You get to access all the equipments there, but you share it with others as well, right? That's how public cloud works. Shared resources at an affordable price. So what are the key features of public cloud? First is scalability. Here you can dynamically scale resources based on the demand. Second is it is cost effective. There is no upfront hardware costs. You can only pay for what you actually use. Third is accessibility. You can access services from anywhere with a stable internet connection. Fourth is managed services. The provider handles the complete infrastructure, updates and maintenance. So you don't have to worry about any of the technical side. But yeah, there are certain challenges that you need to address. First is security and compliance risks. Shared resources and environments may introduce certain vulnerabilities as well as risks. Second is limited customization, which means it gives you very less control compared to the private clouds. The third is potential downtime. Here you have to rely on the provider's reliability, which may occasionally lead to the service interruptions leading to the downtime. Now what are the common use cases of public cloud? Well, it is best for hosting websites. Think of platforms like WordPress or Shopify, just like them. The second is, it works great for big data analytics, where you need to process large data sets quickly. Third is cloud storage and backups, which works like Google Drive or Dropbox, but in an efficient and scalable way. Now the fourth is running AI and machine learning models efficiently. Here it provides you with lot of options and features where you can run and manage your machine learning models very efficiently, and they are also secure. So the public cloud is great for the businesses that prioritize cost efficiency and scalability, but are okay with sharing resources. Now that we have explored the public cloud, let's see and talk about the private cloud, the more exclusive option in the cloud world. Imagine having your own private car. You control where it goes, how fast it drives, and who gets in. Sure, but it's more expensive than public transport, right? But you get the privacy, comfort, and full control over your car. That's exactly what a private cloud offers for the businesses. So, a private cloud is a cloud computing model where the computing resources and services are dedicated to a single organization. Unlike the public cloud, these resources aren't shared with anyone else. These private environments can be hosted on premises, like within the organization's own data center, or can be managed by a third-party provider, but still dedicated exclusively for a single organization. This model is ideal for the businesses that need strict security, compliance, and control over their infrastructure. So what are the key features of private cloud now? Well, the exclusive use. Resources here are reserved solely for one single organization, ensuring maximum privacy. The second is enhanced security. Organizations have greater control over the data and privacy compliances, making it ideal for the sensitive industries like healthcare, banking, and finances. Third one is customization. Here you can tailor the infrastructure to meet specific business goals and needs, something that's limited in the public cloud environments. But in the private cloud, you get the full customization option. Now the fourth is consistent performance. Since there's no resource sharing, you avoid the slowdowns or downtimes and get predictable, reliable performance. But again, it comes with huge upfront costs. So let's address the challenges of private cloud. While the private cloud offers huge and significant benefits, it comes with few challenges as well. The first is higher expenses. Building and maintaining a private cloud requires a significant upfront investment as well, from buying hardware to hiring a skilled IT staff. Thus, it comes with huge expenses. Second is complex management. Here, you will need in-house expertise or third-party management to handle the infrastructure. It's not like just set it and forget it. You have to manage and implement each and everything efficiently and seamlessly. The third is scalability limitations. Unlike the public cloud, scaling a private cloud often means physically adding more hardwares, which again comes to on-premises, taking your money and time. So when does it make sense to use a private cloud? Well, for the organizations with strict security and compliance requirements, such as healthcare, finance, government sectors, where data privacy is non-negotiable, or businesses needing customized infrastructure solutions, where they want tailored environments for unique business needs. And the third one is enterprises, where the requirement is for high performance computing without any kind of shared resources. This is ideal for workloads like scientific simulations, financial modeling, or big data analytics without the risks of any kind of shared resources. So, this was for the private cloud. It gives you privacy and control, but it again comes with higher expenses and management responsibilities. But what if you could get best of both the worlds? That is, cost effectiveness of the public cloud and the security of a private one. Exactly. That's where hybrid cloud steps in. So let's see what hybrid cloud is. We have looked at the public cloud like taking a bus, affordable but shared resources. Then the private cloud like owning a car, private but costly. But what if you could combine both? Imagine using a public transport for daily travel but driving your own car for special occasions or private trips. You get the cost savings of the bus and the privacy of your car. Adds best of both worlds again, right? That's exactly what the hybrid cloud offers. But what is hybrid cloud? Hybrid cloud combines both public and private cloud environments, allowing data and applications to move between them seamlessly, which provides better flexibility, scalability, and security. Why is that useful? Well, sometimes you need extra resources for certain workload spikes. That's when you can tap into the public cloud. But for the other times, when you need a strict security and control, that's when you can use the private cloud. It's all about flexibility and smart resource management. So let's see the key features of hybrid cloud. First is, it provides flexibility. Here you can run sensitive workloads in the private cloud and less critical ones in the public cloud, where you can choose what works best for each situation individually. The second one is scalability. The need for extra power during peak seasons, right? Now expand resources instantly using the public cloud without any investment in more hardwares. The third one is security and compliance needs, where you can keep the sensitive data secure in the private cloud while enjoying the public cloud scalability for non-sensitive tasks, which is again cheaper than private cloud. The fourth one is cost optimization. Here you can avoid overspending by balancing the workloads, as you can use private infrastructure for the critical operations and public cloud for the variable demands. While the public and the private offers great benefits, and then comes the hybrid cloud, which is a perfect solution, but it does come with its own set of challenges. The first one is the complex management. Integrating two different environments means you will need to manage both and ensure they work together seamlessly and without any downtimes or any infrastructure complexity. Thus, it can be complex to manage both of it. The second is security risks. Moving data between the clouds. Well, that really requires a strong security measures to prevent data breaches or data leaks. And the third one is higher upfront costs. Managing both a private infrastructure and a public cloud can be expensive, especially if not optimized properly. As we have seen in one of the challenges, complex pricing. Remember? Yeah, exactly. This refers to that. Now, what are the common use cases of a hybrid cloud? So, when you should use a hybrid cloud? For the businesses needing data privacy and regulatory compliances, such as healthcare and finance sectors that also require cloud stability and scalability. Or for the companies with variable workloads, think of for e-commerce platforms where during holiday sales they need extra resources during peak times, but not around the year, like seasonal demand spikes. The third one is enterprises with on-premises infrastructure. The organizations that want cloud benefits without completely moving away from their existing on-premise setups. This is the best option to go with. Now, while the hybrid cloud offers best of the both worlds, that is flexibility, security, and cost optimization, but managing it can be tricky. But here's another interesting thought. What if you don't just stick to one cloud provider? What if you can use multiple cloud providers to avoid dependency and get the best features from each of it? While the hybrid cloud offers the best of the both worlds, providing you with flexibility, security, cost optimization, but managing it can be tricky and expensive. Here's another interesting thought. What if you didn't just stick to one cloud provider? What if you could use multiple cloud providers to avoid dependency and get the best features from each one of it? Yeah, that's exactly what the multi-cloud model is about. In the multi-cloud, you can just shop around and pick the best features from different cloud providers instead of sticking to one. It's like when you're shopping online, you might buy electronics from the Amazon, clothes from the Flipkart, and groceries from the Zepto. Why? Because you're looking for the best deal, quality, and convenience from different platforms. That's exactly what the multi-cloud approach is all about. The multi-cloud model involves using resources and services from multiple cloud providers like AWS, Azure, or Google Cloud Platform, that is GCP, simultaneously to optimize the performance, reduce dependency on a single cloud provider, and again enhance the resilience. Think of it like instead of putting all your eggs in one basket, you are spreading your workloads across different providers for better reliability and performance and easy access. So let's see the key features of multi-cloud. The first is, it comes with vendor independence. You remember I told you about the vendor lock-in and we have studied this concept into the challenges of cloud computing? Exactly. It gives you vendor independence, which means here you can avoid getting locked up into one provider's ecosystem. If one service becomes expensive or unreliable, you have got the alternatives as well. Here you no need for the high migration costs that comes with vendor lock-in as well. The second is best of breed services, which means here you can use different cloud service providers for the different multiple utilities. As you can use AWS for storage, GCP for AI tools, and Azure for enterprise solutions, getting the best each provider has to offer. The third one is resilience and redundancy. If one cloud goes down, others keep your services running, which means minimizing the downtime and reliability risks. The fourth one is optimized performance. It can help you deploy workloads on the cloud that best suits them. Need fast data processing? Choose the provider known for that. It's easy as that. So how does a multi-cloud environment actually works? Since this concept might seem new to you, let's break it down with a simple scenario. Imagine you run a global e-commerce platform. You use AWS to host your website for its scalability. Google Cloud manages your AI-driven product recommendations, and Azure handles financial transactions because of its strong compliance features. Yes, this is how it works. These services work together, ensuring your customer get the best experience without you being tied to a single cloud provider. So that is how it works. While multi-cloud has many perks, it's not all smooth sailing. It also has some challenges that need to be addressed. So, how does this actually work? Since this concept might seem new to you, let's break it down with a simple scenario. Imagine you're running a global e-commerce platform. You use AWS to host your website for its scalability, Google Cloud to manage your AI-driven product recommendations, and Azure to handle financial transactions because of its strong compliance features. This is exactly how it works. These services work together, ensuring your customers get the best experience without you being tied to a single cloud service provider. where organizations can distribute workloads across different cloud service providers, and the data and applications can interact across multiple cloud platforms as well. While the multi-cloud has so many perks, but it's not all smooth sailing. So the first challenge is complex management. Handling multiple cloud service providers means more dashboards, tools, and processes to manage and handle, which can be complex and tricky at times. The second is security risks. Different cloud service providers mean variety of security protocols, making it harder to maintain consistent protection as well. And the third one is integration issues. Ensuring a smooth communication between different cloud providers can be tricky and may need specialized tools and hardcore experts around you all the time. So, what are the common use cases and when you should use multi-cloud? For the enterprises needing high availability and disaster recovery, as if one cloud goes down, other clouds or other cloud service providers can keep things running smoothly and ensure everything is running just fine. The second is when you need cost optimization, where businesses pick best price services across clouds to save money. And the third one is businesses adopting to different cloud strength for different workloads. As we already discussed about this, you can use GCP for AI/ML projects, run databases on AWS, or handle enterprise applications on Azure. So now that we have explored how companies set up their cloud environments through different deployment models, let's quickly compare cloud deployment models with just enough context to make things crystal clear. Let's dive in. Alright, now that we have explored the different types of cloud deployment models, that is public, private, hybrid, and a multi-cloud strategy, let's bring these concepts to life with some real-world examples as well. Because, let's be honest, theory is great, but seeing actually how big companies use cloud deployment models in action, that's where the real learning happens, right? So, starting with the first, that is public cloud, let's take an example of Netflix here. Have you ever wondered how Netflix seamlessly streams your favorite shows to millions of the users across the world without any kind of buffering issues? Well, here's the secret. They use the public cloud, specifically speaking AWS, that is Amazon Web Services, to manage their massive streaming traffic, store terabytes of video data, and process big data analytics for the personalized recommendations. Since public cloud is fully managed by the provider and scales automatically, Netflix can focus on delivering an uninterrupted binge-watching experience while AWS handles the heavy weightlifting behind the scenes seamlessly. That was it for the public cloud. Now, what about industries where security is the number one priority? For example, take Bank of America. For an example, financial institutions handle sensitive customer data and they have to comply with the strict regulations as well. And that's why they use the private cloud, which gives them full control over their data, security, and infrastructure, while keeping it accessible only within their internal network. As this ensures that the customer data remains private and secure, meeting all the compliance requirements necessary for this. Now moving forward with the hybrid cloud model, have you heard about Lego? Yeah. Lego isn't just about colorful bricks anymore. It's also a tech-savvy company. To handle their operations efficiently, Lego uses a hybrid cloud approach as well. They store the sensitive data on premises for security and compliance reasons, while they use the public cloud, that is, Microsoft Azure, to scale their operations during high-demand seasons like Black Friday or holiday sales. This combination gives them the best of both the worlds, that is, security and flexibility on demand. Now, coming to the multi-cloud strategy, let's talk about Spotify here. Your go-to app for music streaming. Spotify uses the multi-cloud strategy relying on different cloud providers for different kind of tasks. For instance, they store the data on AWS while they also use Google Cloud for the AI-driven recommendations that suggest your next favorite song. Thus, by using multiple clouds, Spotify ensures high availability, cost optimization, and advanced analytics without being locked up into a single cloud provider. Efficient, isn't it? And there you have it. These real-world examples actually show how businesses use different kind of cloud deployment models to match their specific needs. Whether it's a global streaming service, a high-security financial institution, or a hybrid retail tech company, or even a data-driven music platform. Cloud computing plays a crucial role in making all of this happen. So next time when you watch Netflix or shop online or even stream your favorite song, you will know there's some serious cloud stuff happening behind the scenes. Now let's quickly compare the cloud deployment models once again to make things crystal clear with the comparison table here. So coming to the first point, that is the ownership. In the public cloud, everything is owned and managed by the third-party providers like AWS or Azure, which is great when you don't want to manage the infrastructure. Coming to the private cloud, which is dedicated to a single organization, it is ideal for the companies needing full control. Now moving to the hybrid cloud, which is a mix of public and private clouds, is perfect when you need flexibility as well as security. While the multi-cloud approach, here it uses services from multiple providers, which helps avoid the vendor lock-in and provide you with optimized performance. Coming to the second point, that is scalability. In the public cloud, it scales easily to handle varying workloads, which is good for unpredictable demands. But in the private cloud, the scalability is limited, but it is best for stable and consistent workloads. While in the hybrid cloud, it offers you with the flexible scaling, as you can use the private cloud for the critical data and public cloud for the extra capacity you need. While in the multi-cloud, it provides you with high scalability across the multiple cloud providers, which is ideal for the global operations. Now coming to the third point, that is security. In public cloud, the security is of moderate level, which is sufficient for the general applications. While in the private cloud, it provides you with the high security, which is best for sensitive data and compliance needs. While in the hybrid cloud model, it provides you with the balanced security, where you can control the sensitive data privately, while you can also leverage the public resources on the public cloud. Coming to the multi-cloud approach, the security here varies depending on each provider and how the security is managed in it. Now coming to the fourth point, that is cost. In the public cloud, it provides you with the low cost option, as it has the pay-as-you-go model, which suits the startups and small businesses the best. While in the private cloud, it comes with high cost, which is actually worth it for the organizations prioritizing security and control both. But in the hybrid cloud, the cost is kind of balanced, as it is more than public but less than a private cloud alone. While in the multi-cloud approach, the costs can vary according to the service provider you actually choose and the services to balance price and performance. Now coming to the fifth point, that is customization. In the public cloud, it provides you with a limited customization, while in the private cloud, it is highly customizable. Here you can also tailor it with your exact specification and requirements. While in the hybrid cloud, it provides you with a moderate level of customization, as here you can customize the private side while using the public for the general needs. But in the multi-cloud approach, the customization depends on the chosen providers that you have opted, like AWS, Azure or GCP. Now, which cloud is best for which? The public cloud is best for the startups or web apps needing quick and affordable solutions, while the private cloud is best in case of enterprises handling sensitive data with strict regulations, where security cannot be compromised at all. Coming to the hybrid cloud, which is best for businesses seeking both security as well as the cloud flexibility. Now, the multi-cloud approach is best for the large companies optimizing costs and avoiding the reliance on a single cloud provider, which also helps you to avoid the vendor lock-in. Thus, here it is. Now that we have explored how companies set up their cloud environments through different deployment models, it's time to dive into how they use cloud services like storage, servers, and softwares. In the coming module, we will explore the cloud service models, that is, infrastructure as a service, platform as a service, software as a service, and even function as a service, and how they help businesses build, deploy, and manage the applications more efficiently and seamlessly. So, now that we have explored how companies set up the cloud environments through different deployment models, it's time to dive into how they use cloud services like storage, servers, and softwares efficiently. In this module, we will explore the cloud service models, that is, infrastructure as a service, platform as a service, and software as a service, and how they help businesses build, deploy, and manage applications more efficiently and smoothly. So let's begin by understanding what exactly are cloud service models. So according to the definition, cloud computing service models define the different levels of computing resources that cloud providers offer to businesses and individuals. In simple terms, they define the levels of computing resources that cloud providers actually offer. They answer the one big question: who manages what? How much is handled by the provider itself, and how much do you actually manage? But why do we even need these service models? Think about it. Every business has different technical needs. Some companies want full control, managing their servers and softwares. Others just want ready-to-use applications without the headache of maintenance. And that's where cloud service models comes to rescue. They provide different levels of control, flexibility, and convenience, so companies can actually choose what works best as per their needs. The major 4 cloud service models are: first is infrastructure as a service, second is platform as a service, third is software as a service, and fourth is function as a service. Now to make things easier to understand, let's take a real world analogy here. Imagine you are setting up your dream house, or in this case your IT setup. Infrastructure as a service, think of it as renting an empty plot with the utilities. Here you can build the house your way, but the land and power supply are provided by a certain provider. While in the platform as a service, here think of it as renting a partially built house, where the walls and plumbing are already given to you. You just need to decorate and furnish it as per your needs. While in the software as a service model, think of it as booking a fully furnished Airbnb where you can just walk in and start living. Now coming to the function as a service model, think of it as ordering room service in that Airbnb. You don't even need to worry about the kitchen. They deliver what you need when you need as per your demands. Now this was the simplest example to understand each one of the services. Now let's break this down with a relatable scenario. Imagine you're launching a new business. Now to start your business, you will need a website, a database to store the customer information, a secure network connection, a software to manage your daily operations. Now, how do you will set it up? Traditionally, you would have to buy expensive hardware, set up physical servers, install all the necessary softwares, and constantly maintain everything by yourself. And damn, sounds like a lot of work and money, right? But thanks to the cloud service models, you get to choose how much responsibility you handle versus how much the cloud service provider manages. It's like deciding between cooking at home, which gives you all effort and full control, or using a meal kit where you require less effort but you don't have much control over it as well, or simply dining at a restaurant, minimal effort, sit back and just enjoy your food. You pick here based on how much effort and time you want to invest in it and how quickly you need things up and running. So here, instead of owning and managing everything, businesses can just rent IT resources from a cloud service provider based on their needs and specifications. So let's understand them in detail. Let's begin with the foundation model, that is infrastructure as a service. Infrastructure as a service is like renting the land and utilities to build your own house. Here you don't own the land. For example, that is the infrastructure here, but you actually build and manage the house, that is apps or data in your infrastructure, the way you want and exactly as per your specifications and requirements. In technical terms, the provider supplies and manages the infrastructure components needed to run applications such as servers like your house foundation, storage like closets of your data, networking, the roads connecting everything in between, and the virtual machines for running your applications. Here you can manage everything else like installing software, setting up firewalls, and maintaining the system. So what are the key features of infrastructure as a service? The first is, it provides you with the compute resources where you can quickly create virtual machines for various workloads. Second is, it gives you storage options where you can easily scale the storage up or down as per your needs and requirements. The third is, it provides you with also the networking part where you can manage networks, load balancers, and firewalls to secure your connections. The fourth is, it comes with pay-as-you-go model, as you can pay only for what you use. No need for massive upfront investments as well. Even with all the benefits, infrastructure as a service isn't without hurdles. there are some challenges as well. The first one is management complexity. Here you will need technical expertise to configure and manage the infrastructure. The second is security concerns. While the provider secures the physical data centers, but you are actually responsible for protecting your apps and data. The third point is data transfer costs, as moving large amounts of data from on-premises to the cloud can come up with huge upfront expenses as well. Now, what are the common use cases of infrastructure as a service? It is best in case for the companies handling variable workloads like e-commerce sites during holiday sales, or businesses needing data and privacy compliances but still wanting cloud scalability, or the enterprises expanding their infrastructure without buying any kind of new hardware. And it is also the best option for the startups wanting a cost-effective way to test the new applications without any kind of major investments. Now that we have seen how infrastructure as a service provides the building blocks of your IT setup, what if you don't want to handle the entire construction yourself? What if you just want a ready-made platform to build and deploy applications seamlessly without any kind of worry about underlying hardware? And that's exactly Platform as Service steps in. Platform as a Service is a cloud computing model that provides a ready-made platform for developers where they can build, deploy, and manage web applications without any kind of worrying about underlying infrastructure like servers, storage, or networks. Think of it as a one-stop shop for all the app development, perfect for teams that want to focus on coding and innovation rather than the boring IT management stuff. So what are the key features of Platform as a Service? Well, the first one is it provides you with the development tools. Here you have the access to frameworks, libraries, and tools to make the app development even more faster. Second is it provides you with a managed kind of hosting. Here you no need to manage servers or worry about the maintenance. The platform handles it all efficiently and effectively. The third one is it comes with integrated databases, where you can easily use built-in databases without any kind of complex setups or managements. The fourth one is it again comes with pay-as-you-go model, where you only pay for what you use, saving a lot on operational costs as well. Even with all of the convenience, there are favorite things that you need to watch out for. And the first one is vendor lock-in. As switching providers later can be tricky once you are tied to one particular cloud service provider or one platform. The next is customization limits, as it gives you less control over the underlying infrastructure, which is great for simplicity but not always for the flexibility and scalability you want to implement. And the third one is security concerns. While the provider secures the platform, but you are also responsible for the app level security. Thus, there can be risks of data breaches and data leaks if not properly configured. Now, what are the use cases of Platform as a Service? Well, it is best in case of web and mobile app development purposes, where you can quickly build and deploy applications seamlessly. It is also best for API development and integration, as here you can create and manage APIs with even bare minimal effort. It also comes with database integrations, which is best in case of database management, where you can effortlessly set up databases to power your applications. So, with Platform as a Service, you can focus on your app and the provider takes care of all the techy backend stuff by themselves. Now, what if you don't even want to develop anything by yourself? You just need ready-to-use softwares like email services or project management tools. And that's where Software as a Service comes into the play. Here, you don't need to deal with infrastructure or development at all. Here you can use the software without worrying about how it runs. Think about it like streaming movies on Netflix. You don't need to download anything or manage servers or even update softwares. You just log in and enjoy it. And that's exactly what Software as a Service is all about. It is a cloud computing model that delivers ready-to-use software applications over the internet, often on a subscription basis, where there is no need to install any kind of softwares, no hardware requirements. You can access it anytime through a web browser. Here, the provider handles everything, infrastructure, maintenance, and updates. So you can just focus on using the software and doing your work. Now, what are the key features of Software as a Service? The first one is There is no need of any kind of installations. You can access the softwares directly through your web browser. No downloads required. The second is, it gives you automatic updates. There is no need to manually update anything. The provider takes care of all of it. The third is, it comes with scalability. It can easily adjust to the usage based on users' numbers or needed features. And again, it comes with pay-as-you-go model, where you only have to pay for what you actually use, no hefty upfront costs required. And then again, while software as a service is super convenient, but there are certain challenges that you need to address. So the first one is the total dependence on internet connectivity, which means no internet equals to no access. A stable internet connection is a must requirement for you. A stable internet connection is a must requirement here. Now the second one is security concerns. Since the data is completely stored on the third-party servers, ensuring strong security measures is essential as well. And the third one is limited customization. Here you get a pre-packaged solution which might not fit every unique need or any kind of personal requirements or specification needed for your application or utility. Now what are the common use cases where software as a service can be ideal? The first one is email and collaboration tools like Gmail, Microsoft Outlook, or even Microsoft 365. Now again, for the customer relationship management, tools like Salesforce or HubSpot, which helps to manage customer relationships. Now the third one is for the project management purposes, for the platforms like Trello, Asana, or Slack streamlined teamwork management tools. And the fourth one is accounting and financial softwares like QuickBooks Online, Xero for financial management, etc. So this was it for the software as a service. So with software as a service, it's like enjoying a ready-made meal you ordered from a restaurant, right? But the question is, what if you need to run the code without worrying about servers or infrastructure at all? But now, what if you need to run the code without worrying about any kind of servers or infrastructures at all? And here comes function as a service, the ultimate set it and forget it model. To understand this, imagine a simple scenario. You walk into the coffee shop, place your order and get your coffee and leave. You don't care about how the coffee machine works or how the beans were roasted. You just want your coffee quickly. That's it. And that's function as a service in a nutshell. Here, you only focus on the code and the provider handles the rest of the things in the backend. So let's see, what is function as a service? It is a serverless cloud computing model where you can write small pieces of code called as functions that run in response to events like a website click, a file upload, or even an API request. Here, there's no need to manage any kind of servers. The code runs only when it is triggered. And you only pay for the actual execution time of the function and not for any kind of servers. And it automatically scales based on the demand. Think of it like a vending machine. For an event, you push a button. And then as a cloud provider, that is the machine, delivers your snack. That is running your function. Easy, right? Now this is how function as a service works. So what are the key features of function as a service? The first is, it's event-driven execution, where the function triggers when something happens like an HTTP request, a file upload, or even a database change. And it is completely serverless. Serverless, it doesn't mean that there are no servers here. They are there. You just don't need to manage them. The cloud provider handles all of it in the backend. It also provides automatic scaling, whether you got one request or a million requests. Function as a service scales automatically to handle the demands. It comes with pay per execution, which actually means here you only have to pay when your code actually runs and not a second more than that. The fifth key feature of this is, it provides faster time to market, where you can deploy your code quickly without worrying about any kind of infrastructure. But it comes with some challenges as well. The first is cold start latency. Now, if a function hasn't been used in a while, it might take a few extra seconds to start. This is what we call as cold start latency or a cold start. The second one is state management, which means the functions here are stateless, which means it makes it a little bit of tricky to manage the ongoing data across the executions. The third one is debugging and monitoring. Without traditional servers, troubleshooting can be a bit more challenging than it seems. So what are the common use cases for the function as a service? The first is, it comes with microservices architecture, which means it makes it easier to break down large applications into smaller and manageable services. The second one is real-time file processing. Here you can automatically resize images when users upload them. The third one is API backend. You can handle the API requests on demand without any kind of dedicated servers in the real time. The fourth one is IoT event processing. Here you can trigger the functions based on the sensors or sensor data from the devices. So with function as a service, you just write the code, set the trigger, and the cloud takes care of all the backend and manages your function efficiently. Now that we have explored all the cloud service models, that is infrastructure as a service, platform as a service, software as a service, and even function as a service, let's simplify them with some quick context and relatable examples with a comparison table as well. So the first point is definition. For the infrastructure as a service, it provides virtual server, storage, and networking, which is ideal when you need raw infrastructure but want to avoid physical hardware, as in short term, it is a virtualized infrastructure. While for the platform as a service, it offers a platform for developers to build and deploy apps without any worry about hardware or operating systems management. Thus, it provides a platform for web as well as app development purposes. While in the software as a service, it delivers fully functional software through the cloud. While in the function as a service, it lets you run the code triggered. While in the function as a service, it lets you execute the event-driven functions with the help of the triggers, which is perfect in the case of small or tiny tasks without any kind of server management. Now the second point is control. In the infrastructure as a service, it provides you with the high control over the servers and configurations, which is great for IT teams wanting flexibility as well. While for the platform as a service, it provides you with a medium level control where you can handle app. The provider manages the infrastructure. But in the software as a service, it provides you with a low control as you use what's provided, focusing purely on the usage. Lastly, in the function as a service, it again provides you with the low level control as here you just write the functions. Scaling and servers are handled for you by the service provider itself. Now coming to the third point, that is scalability. In the infrastructure as a service, it can scale manually or automatically depending on how you set it up, while in the platform as a service, the scalability is automated based on the app needs as developers don't have to worry about it. In the software as a service, the auto-scaling happens with the user demands. Lastly, in the function as a service, it instantly scales up with the number of function calls, which is perfect for fluctuating workloads. Coming to the fourth point, that is the pricing. In the infrastructure as a service, you only pay for the resources used, like storage or compute power. Thus, it goes with pay per use. While in the platform as a service, here you only pay for the platform services you consume. Coming to the software as a service, it is completely subscription based where you can pay monthly or yearly for software access or subscriptions. But in the function as a service, you only pay for the function execution, saving costs for event-driven tasks as well. Now for the examples, in the infrastructure as a service, take the example of AWS EC2, Google Compute Engine, like renting virtual machines. While in the platform as a service, you can take the example of Google App Engine, AWS Beanstalk, where you can focus on code and not on the infrastructure. While for the software as a service, Google Workspace and Salesforce are the softwares which are ready to use from day one. And lastly, for the function as a service, AWS Lambda and Google Functions are best examples of function as a service, where you can run the snippets of the code whenever needed. And that's it. Here, each model serves different needs, whether you want full control or just want things to work out of the box. Alright, so far we have explored the cloud deployment models and service models as well. But have you ever wondered who's actually behind the cloud services we use every day? Well, let me introduce you to the top players in the cloud market, the companies that power the internet's backbone and make the cloud possible for us. Alright, let's see who provides the cloud services. The cloud services are provided by cloud service providers, the companies that own and maintain large-scale data centers worldwide, offering the computing power, storage, networking, and more over the internet. These providers own massive data centers across the world, packed with thousands of server storage systems and networking equipments. Now imagine a warehouse the size of several football fields filled with blinking servers. That's the scale we are talking about here. Now, who actually runs the cloud and makes sure it's safe? Let's break it down in a simple terms. Cloud governance is a shared responsibility, meaning multiple parties work together to keep the cloud services secure, reliable, and running. So the first one is cloud providers. They own and maintain the cloud infrastructure, making sure the servers are running, the data centers are secure, and services comply with regulations and compliances. Then comes the government and regulatory bodies like GDPR and HIPAA. They create the laws and guidelines to protect the user data, ensure companies follow the security standards and compliances as well. Then comes businesses and users. That's exactly you. You are responsible for setting up security controls, managing your data, and ensuring the best practices are followed within your cloud environment. Think of it like renting an apartment, where the landlord, that is the cloud provider, takes care of the building and ensure the utilities work just fine. Then comes the city government regulations, which enforces safety codes and makes sure the building meet legal requirements and compliances. Then comes you, the tenant, who are staying there. You are responsible for locking your doors, managing your belongings, and keeping your space secure and clean. So, while the cloud providers give you the infrastructure, it's up to the businesses and users to ensure their data is safe and secure. Next, we'll see what is a cloud provider. The cloud provider is simply a company that rents out IT resources like servers, storage, databases, and software over the internet, where instead of buying expensive hardware and maintaining it, you pay for what you use. We have studied it already. So why do businesses use or choose or prefer cloud providers? Ever wondered why businesses don't just build their own massive data centers instead of using the cloud providers like AWS, Azure, or GCP? Simple. It's because cloud providers don't just offer storage. They offer powerful technology that helps businesses grow faster, smarter, and safer. The first one is security and compliances. Cloud providers offer built-in encryption, firewalls, and compliances with the industry regulations like GDPR and HIPAA. So businesses don't have to worry about setting up security from scratch and about the regulatory bodies. They can just focus on their own growth. The next is AI and big data capabilities. If you need to process huge data sets or even build AI-driven applications, AWS, Azure, and GCP provide powerful machine learning tools and analytics solutions as well. So, businesses can run and turn their data into insights effortlessly and without any kind of hustle. Then comes the seamless integrations. Each provider has its own strength. For example, Azure integrates seamlessly with Microsoft tools, while AWS offers the broadest range of cloud services. Then, Google Cloud leads in AI, machine learning, and analytics. The fourth factor is hybrid and multi-cloud flexibility. Companies don't have to stick to a single provider. Many use hybrid, that is mixing cloud plus on-premises infrastructure, or multi-cloud, that is using multiple providers, to maximize the flexibility and avoid the vendor lock-in. Thus, you see, at the end of the day, businesses don't just choose cloud providers for cost savings. They are about giving businesses the tool to innovate, scale, and stay secure while they focus on what truly matters, that is growth and innovation. And that's why businesses rely and prefer cloud providers. Okay, now that you know what cloud providers do, let's take a look at the top players dominating the cloud market. So this is the revenue graph. You can see it clearly that AWS, being the industry giant, holds the largest market share, that is 31%. It's known for its wide range of services, global reach, and scalability. Then comes the Microsoft Azure, holding the 20% of the market. Then comes our Google Cloud, which holds nearly 12% of the market share. And then comes other notable players like IBM Cloud, Oracle Cloud, and Alibaba Cloud, serving major industries and regional markets offering specialized solutions. As we already saw the top cloud providers in the market, The first one is AWS, the largest and most widely used. Then comes Microsoft Azure, which is popular for enterprises and Microsoft users. Then comes Google Cloud Platform, which is strong in AI and data analytics capabilities. Then comes other notable players like IBM Cloud, Oracle Cloud, Alibaba Cloud, etc. These providers are in fierce competition, but each has its own strengths, so choosing the right one depends on your own business needs and specifications. Now let's see the biggest player in the cloud space, that is AWS, which stands for Amazon Web Services, which was launched in 2006, as AWS was the first major cloud provider and has become the go-to choice for startups, large enterprises, and even governments worldwide. But why is AWS so popular? It provides vast range of services, that is over 200 services covering everything from computing to the AI. Second, it provides global infrastructure. The data centers called availability zones in regions are spread all across the globe. Third, that is reliability and scalability. It is trusted by companies like Netflix, Airbnb, and even NASA. Now let's see what are some AWS popular services. For the compute, EC2, which provides virtual machines to run your applications. Then comes Lambda, which is widely used for serverless computing. Remember the function as a service model? Yep, that's Lambda. Then comes the storage. For that, S3, which is a scalable object storage, which provides storage for files and backups. Then comes EBS, that is block storage for virtual machines. Then comes the databases. AWS provides RDS and DynamoDB. RDS is managed relational databases like MySQL and PostgreSQL, while the DynamoDB is a NoSQL database for high-speed applications. Then comes AI-enabled. AWS provides platforms like SageMaker, where you can build, train, and deploy machine learning models easily and smoothly. It also provides the recognition, where it provides the analysis tools for images and videos too. Yes, it can recognize faces and objects. So, that's AWS. Powerful, versatile, and the market leader. But what about the competitors? Yeah. How does Microsoft Azure stand out? And why do companies choose Google Cloud for AI projects? Now, next up, let's see and talk about Microsoft Azure, the second largest cloud provider launched by Microsoft in 2010. Azure is one of the top cloud providers. But why is it so popular? Well, imagine you're already using tools like Microsoft 365, Teams, or even Windows servers in your company. Wouldn't it be convenient for you if the cloud platform just clicked with everything that you're already using? Well, that's exactly where Azure shines. It provides seamless integration with all the Microsoft products. It is the second largest cloud provider with around 20% of market. Impressive, right? Now let's see what are some popular Azure services. For the compute, it provides virtual machines. Here you can run various operating systems and applications as well. And then it also provides Azure Functions for serverless computing, which is perfect for event-driven applications. Then for the storage, Azure provides blob storage, where you can store massive amounts of unstructured data as well, like images or videos. Then it also provides Azure Files, which is used for file sharing across multiple machines. For the databases, it provides you with SQL database, which is fully managed relational database. Then Cosmos DB, which is globally distributed NoSQL database with ultra-low latency. This is a major fact about Cosmos DB, that it is globally distributed NoSQL database with ultra-low latency. Then for the AI and analytics, Azure provides AI tools for speech recognition, computer vision, and more. It also provides Azure ML, where you can build and deploy ML models without starting from scratch. Now here's a quick thought. If AWS is like the popular all-rounded charmer in the class, Azure is a super organized one who always has the notes in sync with the teacher, like Microsoft tools in this case. Got it? Now, let's meet the third largest player in the cloud game, that is Google Cloud Platform or GCP, which was launched in 2008 by Google. GCP is like tech-savvy friend who's really good with data and AI. Companies focused on big data analytics, AI, and machine learning often turn to GCP. Why? It already holds a market share of around 12% and it's growing really fast. Now let's take a look at the popular GCP services. For the compute, it provides compute engines where the virtual machines are tailored to your needs. Actually, they are tailored to your own specific needs. Then for the serverless execution, it provides you with cloud functions. For the storage, it comes with cloud storage, which is reliable object storage for files, backups, and media. It also provides you with persistent disks, which are durable and high-performance storage for virtual machines as well. For the database, it provides you with BigQuery, which provides super-fast data analytics, handling massive data sets with ease. It also provides you with FileStore, which is a NoSQL database for building scalable and real-time apps as well. Then for the AI and ML, it provides TensorFlow, which is the open source machine learning framework, and yes, it's Google's. Then it also provides AutoML, which helps you to build custom ML models with minimal amount of coding. Then Vertex AI, which provides you with end-to-end platform for ML model deployment and management. Fun fact, have you ever used Google Maps or Google Photos? Yep, that also comes under GCP, AI working behind the scenes. So there you have it. AWS, the versatile leader, Microsoft Azure, the enterprise favorite with seamless Microsoft integrations, Google Cloud, the go-to choice for the data-driven and AI-powered solutions. Now let's see how to choose which provider is best for you. Let's break it down with the help of the comparison table here. For the business needs, when it comes to AWS, it is great for scalability and a wide range of services as well. And it is ideal for businesses of all sizes needing global reach. While for the Azure, it is best if you are heavily using Microsoft products, where you can seamlessly integrate it with the tools like Office 365 and Windows Server. While for the Google Cloud, it is perfect for AI-driven data-heavy workloads and startups looking for innovation and speed. Second point, that is pricing. AWS offers pay-as-you-go with options like reserved instances for cost savings on long-term use, while Azure provides volume-based discounts, which is ideal for large enterprises planning for long-term usages. Then Google Cloud features per-second billing with sustained use discounts, which is great for the cost-conscious projects as well. For the third point, that is performance and availability. AWS has the largest global infrastructure, which is also reliable for businesses needing worldwide availability, while Azure is strong in hybrid cloud solutions and is trusted by enterprises for consistent performances. Then, the Google Cloud excels in AI services and resources with high-speed data processing, which is perfect for analytics-driven applications. The fourth point, that is security and compliances. AWS offers strong compliances with standards like GDPR and HIPAA, which is suitable for sensitive industries, while the Azure matches AWS in compliances, making it a solid choice for regulated industries as well. Then comes the Google Cloud, which focuses on advanced security with robust measures for data protection and enhancements. So now, which cloud is best for what? When it comes to AWS, companies needing global services and a broad range of services and solutions, this is the best one to go with. While for the Azure, enterprises relying on Microsoft products and hybrid environments can be the choice. Then lastly, for the Google Cloud, the businesses which are more focused on AI, data analytics and cost efficiency, this is the best option for you. So that was it. A quick rundown. Now you can choose the provider that aligns with your business goals and tech needs. Not to forget, each provider has its unique strength and businesses should choose based on their needs, budget and existing tech stack. Now that you have got a solid foundation in cloud computing, it's time to dive into the core concepts and understand what truly powers the cloud. These are the essential building blocks that you will need to understand how the cloud operates behind the scenes. So let's begin by understanding what are the core concepts of cloud computing. Speaking of it, cloud computing is a powerful and transformative technology that enables the organizations to leverage computing resources without the need for any kind of heavy investments into the physical hardware. But how does this thing actually works? It's all because of these core concepts that keep everything running smoothly. So let's see what are those. The first one is virtualization, second are containers, the third is serverless computing, fourth is scalability, fifth is elasticity, And sixth is, the most importantly, cost optimizations. So first, let's see what is virtualization. Virtualization is the process of creating virtual versions of physical hardware resources such as server, storage systems, devices, or networks. To make things even more simpler to understand, let's take an example. Imagine you are having one giant pizza, but instead of giving the whole thing to just one person, you slice it up into many pieces so that multiple people can share it and enjoy it. Virtualization works the same way. It's the process of creating virtual versions of physical hardware resources like server, storage, or networks so that they can be shared among multiple users. Now let's see what are the benefits of virtualization. First one is efficiency. What does this mean is, you can maximize the hardware usage without wasting resources by creating a multiple virtual versions of it. The second is cost savings. Here you no need to buy tons of hardware. You can rent whatever you need virtually. The third one is flexibility. Here you can also run different types of operating systems and apps simultaneously on your system. The fourth one is isolation. Here, each virtual machine works independently so that one issue won't affect the others. So this was about virtualization. But now, how does virtualization actually works? Cloud providers use virtualization to host multiple virtual machines on a single physical server, as you can see in the picture. Here, each VM acts like its own mini computer. You seeing this? VM guest 1, VM guest 2, VM guest 3. That is how each VM acts like its own mini computer, with its own operating system, apps, but they all are sharing the same hardware underneath. Think of it like roommates sharing an apartment. Everyone has their own room, but they share the kitchen and living room. That is the hardware resources in this case. So that was it for the virtualization. Next we will see about what are containers. Alright, let's take an example so that will make things easier for you to understand. Imagine you are packing lunch. You put the sandwich, salad and dessert into 3 separate containers so that they don't mix with each other but can still be carried together. The containers in cloud computing works exactly the same way. Here you can package an application along with everything it needs, like the code, libraries and dependencies into a single unit. This means the app can run anywhere without any kind of issues. So by the formal definition, containers are lightweight portable units that package an application and all of its dependencies such as code, libraries and runtime together to run consistently across any computing environments. Now let's see what are the benefits of containers. The first one is portability. Here you can run the same container on any machine so that there will be no issues if we switch the machine. The second one is efficiency. Containers are lightweight and can start up really super fast. The third one is isolation. Each container runs separately so that the apps don't interfere with each other. The fourth one is scalability. The containers can easily scale up or down based on the demand. So, how does containers work? Unlike virtualization, which uses the full-blown virtual machines, containers share the operating system, but keep the app environments separate. Think of it like a hotel, that is OS in our case, with different rooms that are the containers, and the guests in each room have their own privacy, but they all use the same building structure and services. So that's how it works. The most popular containers are Docker and Kubernetes. You might have heard about them, don't you? So the next up, that is, we'll see serverless computing. And no, it doesn't mean that there are no servers. There are servers, but you don't have to manage them. The cloud provider takes care of that for you. So what is serverless computing? Serverless computing is a cloud service model where developers write and deploy code without managing or provisioning any kind of physical infrastructure. The cloud providers handle the underlying servers and scaling and all the maintenance of it as well. For that, let's take an example here also. You're at a restaurant, you order the food, it gets served and you enjoy without worrying about cooking, cleaning, handling anything. Just order, it gets served and you enjoy it. That's how serverless is like for the developers. They write code and the cloud provider runs it automatically whenever the trigger happens. We have seen this before, didn't we? So what are the benefits of serverless computing? The first one is there is no need of managing any kind of infrastructure. You only focus on your codes and not on the servers, and everything is handled in the backend by the cloud service providers. The second one is automatic scaling. The functions you write here can scale up or down depending on the usage and on your needs. The third one is it is cost effective because you only pay for when your code actually runs. No idle charges of the servers. And the fourth one is faster market time. Here you can deploy apps faster without any backend headaches or managing any kind of infrastructure or servers. But how does this actually work? In the serverless computing, the code that are your functions are triggered by the events like HTTP requests, a file upload, or a database changes. Imagine flipping the light switch. The light, that is the code here, turns on only when you need it. No power wasted otherwise. Just like that. And the popular tools for serverless computing are AWS Lambda, Azure Functions, and Google Cloud Functions. Now moving next, let's see what is scalability in the cloud computing and why it is so important. So basically, scalability means the cloud's ability to handle growth without breaking anything. The formal definition goes like scalability refers to the ability of a cloud system to handle a growing amount of work or its potential to accommodate to the growth that is necessary and demanding. To understand this in a simpler way, let's take an example of an ice cream truck. On a hot day, you need more staff to serve the crowd, but on a cold day, fewer people show up, right? And that's how scalability works. Scalability in the cloud works similarly. It allows resources to expand or shrink based on the demand without any wastage of the resources. That is the most important thing, without any wastage of resources. So basically there are two types of scaling. The first is vertical scaling. Here you have to add more resources like CPU, RAM to an existing machine, like upgrading your phone to a newer model. The second one is horizontal scaling, or another called as scaling out. Here you have to add more machines to handle the load, like opening more ice cream trucks to serve more people. So what are the benefits of scalability in the cloud computing? The first one is improved performance. Here you can handle more users without any kind of lagging. The second one is it is cost effective. Here you can scale down whenever the demand drops to save money that will be wasting on the idle or extra resources. The third one is business growth, as it supports increasing workload seamlessly and there is no any kind of wastage of the resources here. So that was it for the scalability. Next we'll see what is elasticity in the cloud computing. Yeah, it is closely related to the scalability, but there's a difference. Elasticity is about automatic scaling. The system detects the change in demand and adjusts the resources on the fly. The formal definition goes by elasticity is the ability to automatically adjust the amount of cloud resources, that is compute, power, storage, which can go up or down based on the real-time demand. It involves adding resources to handle increased demand without affecting the performance of the system. To understand this easily, let's take an example of a self-driving car that speeds up or slows down depending on the traffic rate without you touching the steering wheel, accelerator, or brake. And that's how elasticity works. So what are the benefits of elasticity? The benefits of elasticity are, first is on-demand resource adjustment, as you don't have to do any kind of manual intervention. It adjusts automatically. The second one is cost optimizations. Here you only pay for what you actually use, nothing more, nothing less. The third one is improved user experience, as it prevents slowdowns during high traffic times. As we already seen how it works, right? I will read it again for you. Cloud resources automatically scale resources in response to any kind of change in the demands. When the demand decreases, resources are reduced to save the costs. But when the demand increases, resources are again brought into the usage so that everything runs smoothly. That's it. Now the next thing is, what is cost optimization? Cost optimization in the cloud is all about reducing the expenses while keeping your services efficient, reliable, and high performing. It's like getting the best value for your money without compromising the quality. It also involves strategies and tools to reduce the cloud service expenses while maintaining the performance and reliability of your application or systems. So, there are several techniques that are used to optimize the cost. The first one is using reserved instances. Here you can commit to certain resources like reserved instances for 1 to 3 years and again enjoy the significant discounts, that is up to 75% compared to on-demand pricing, which is perfect for predictable and long-term workloads. The second one is auto-scaling, where you can automatically add or remove resources based on the real-time demand. It is best in case when you have to handle peak loads without overspending when demand even drops. The third one is right sizing, which means matching your resources to actual workload needs. Like, why pay for an 8-core server when you can handle everything on a 4-core one, right? That is how it works. Now, the fourth one is using cost management tools, which are already provided by every cloud service provider. For example, AWS Cost Explorer or AWS Budgets, Azure Cost Management, and Google Cloud Billing helps to track, analyze, and control your expenses. So, what are the benefits of cost optimization? The first one is it prevents resource wastage. Here, you don't pay for idle or unused resources, you only pay for what you actually use. The second one is here you get to control the scalability costs, as you can scale efficiently without overspending. The third one is you can manage the dynamic usage patterns and adjust the resources as the demand fluctuates. The fourth one is budget control. Once you enable the budget control, you can stay within the spending limits, and even when you exceed the spending limits, immediately the alert is issued on your Gmail account that you have used in it. The fifth one is cheaper cloud billing. When you learn to manage these resources and services smartly, you can save a huge amount of money on this. So, cost optimization isn't just about saving money, but it's also about spending smarter while keeping your system reliable, efficient, and smooth. Pro tip: please regularly review your cloud usage and adapt to your strategies as per your business or project evolves. These were the concepts which are seen as the backbone of modern cloud solutions, helping businesses innovate faster, smarter, and speedier. So that was it for the core cloud concepts. Let me know if you have any doubts in the comment section.
Just a quick info, guys. Intellipaat brings you executive postgraduate certification in cloud computing and DevOps in collaboration with IAM Divya Sampar, IIT Roorkee. Through this program, you will gain in-demand skills like AWS, DevOps, Kubernetes, Terraform, Azure, and even cutting-edge topics like generative AI for cloud computing. This 9-month online bootcamp features 100 plus live sessions from IIT faculty and top industry mentors, 50 plus real-world projects, and a 2-day campus immersion at IIT Roorkee. You also get guaranteed placement assistance with 3 Azure job interviews after entering the placement pool. And that's not all. This program offers Microsoft certification, a free exam voucher, and even a chance to pitch your startup idea for incubation support, up to rupees 50 lakhs from IAM Divya Sampark. If you are serious about building a future in cloud and DevOps, visit the course page linked in the description and take your first step toward an exciting career in cloud technology.
So, before we get started, guys, $1 billion question: what is cloud? So, what does it come to your mind when you hear the word cloud? So, the cloud is basically nothing but services, right? Now, these services can be utilizing resources. See, we don't directly use the word resources. So, we say services that can be utilized over what? Internet. Now, can I use a service that is local in my laptop and say it is in cloud? Okay, let me put it this way. If I right now, okay, let me do this, right? If I open a notepad here, guys, okay, I open a notepad here. Do you think this notepad, whatever I'm doing here, operation, or this notepad provides me a service? What is that service? It can basically take notes, correct? So my notepad provides a service that I can take notes, correct? Now, do you think this service, I can say it's in cloud? Very importantly, we only say cloud when there is access to internet or when you're accessing that service via internet. You're getting my point, right? So the key differentiator or the key word, right? Very small, important point that we always miss is cloud is whatever you say, resources, service, no matter, you can use your word. I'm not going to restrict that, right? Yes, you can use it, pay as you go, you can use these services, but make sure to put at the end via internet. because your cloud can only be accessed via internet. Yes, cool. Now comes the second question. Why internet? I could have done it via Bluetooth. I could have done it via wireless network. I could have done it via local LAN also. Why only internet? Why can I only access this service via internet? Why this racism to other wireless providers like Bluetooth, Wi-Fi, LAN? Why this discrimination? So the reason we are using internet is because what is the range of internet, guys? I can sit in India, right? And I can still access any of my services from any part of globe, be it US, be it I be in Denmark, right? I be it in Denmark, I can use whatever service I have in India, right? Because their range of internet is global, correct? Whereas if you think I try to access it via Bluetooth, it's limited, right? Bluetooth is like few meters, correct? If I even take wireless is also few meters, couple of meters. If I take even transmissions, right, transmissions of this networks, that will be up to few kilometers, right? So the max I can go is wirelessly kilometers. But if I want to access it globally, then I know that internet is my go-to-go, right? So that's the reason why we use internet itself in the cloud, right? And now I hope you guys are clear with what is cloud. In simple words, you can say services that are being utilized over the internet, right? Okay. Now, why do I need these services via internet? Why do I need this? Do I really need this? Is it really helping me? Do you think you guys have benefited from this? Or is it of any real benefit? If yes, what benefits do you see using over cloud? Cost effective, scalability, availability, pay as you go. Okay. So the reason we use this cloud, the first and the foremost thing is, okay, the reason we do it is because there is a lot of things to consider while you actually have these services on-prem, right? Now, let me give you a quick example first, and then I'll talk about this cloud, right? Imagine for your use case, that is, let's say, for example, your the distance between your office and your home is, let's say, 3 kilometers. Okay. And let's say the auto takes approximately $50, okay, for this 3 kilometers to and fro, let's say 100 rupees per day. Okay, 100 rupees per day. Now, should you purchase a car worth 20-25 lakh, maintain it, wash it, if anything happens, service it, keep filling in the fuel, just to go to office every day for 3 kilometers? Or should you just go and rent a cab or an auto? Let's take cab 100 rupees per day. Okay, what would you do, guys, given this scenario where also office, let's say office, you don't have to go every day. Let's say it's hybrid, so you have to go, let's say, 2 or 3 days in a week. What would you do? Cab. Why? For obvious reason, you will say, hey, I have done my due diligence, I have done my calculation. Cab is more suitable for me because first, I need not maintain it, I need not wash if it's dirty, right? The cab, whatever cabs comes, they'll be washed. I need not worry if any part is broken, or if any mice comes and cuts my wire, or if there's a leakage. I need not worry about anything because I don't have to do. Whatever cab I'm getting would be a neat, clean, and working condition, correct? It will fulfill my work, right? Whatever is my work, that I'll be able to do, correct? And I need to just spend amount that I need, right? Sometimes what happens, you might fall ill, you don't want to go office, right? Sometimes you don't feel like going office, so why would you simply spend so much, right, and commit in advance and then regret later, correct? So similar scenario, this you're thinking in terms of a small scale with just a car, but just imagine for corporate, guys, where there is a fluctuation of what the number of projects that's coming in and going out, right? Basically the revenue. So the revenue, there is a fluctuation, right? Sometimes they are in a very good profit, sometimes they are not, sometimes they get many projects from clients, sometimes clients are not giving them project, right? A lot of these scenarios happen. So because of this fluctuation, they cannot commit or foresee a set amount of resources, like hey, go ahead and purchase 5 servers. Hey, go ahead and hire 10 site engineers. Hey, go ahead and hire cyber security engineers, ethical hackers, network engineers, then security guards, then Wi-Fi, then ACs, then water coolers. You can't just commit, right? Because the commitment is too huge, just like you buying a car, right, for a simple small task. So it is this opportunity, right, which cloud providers like Google, AWS, and Azure saw that I can sell these things, like how you have Ola, Uber, right, where you don't have to purchase car. If you need car, you can book it, right? Same way, like how Ola and Uber is a company that provide cab as a service, there are companies like Google, AWS, and so on, right, who provides these services via internet, that is cloud, for us to use, right? So technically they're not doing anything important. That is also a business model for them. They are doing a business, but that business is helping save many industry. Now, why am I saying it is helping many industry, guys? Because consider a scenario where you are having a startup, or you're planning for a startup, or you're building a product, right? Do you think would you go ahead and straight away go and commit for purchasing a server so that you can deploy your application and you can cater your customers, right? You would be hesitant, right? Because you would say, hey, I don't know if my product's gonna work, right? I don't know if it'll work. In 6 months it can be a boom, or in 2 months it can basically be in a loss, right? So you would be scared or hesitant, right, when you initially want to invest such a huge amount, purchase servers, racks, and then deploy your application, right? Or imagine you're a company with just 100 or 200 employees, right? Why would you commit to something so large, right? So that's why these service providers are able to are able to create a monopoly in this industry, right? Be it we as an individual student going to learn this, right, or a 10, or you doing a personal freelance project, or having a company of 10 employees, 100 employees, 200 employees, or 10,000 employees, these service providers will cater that to you, right? So this is that monopoly what they have created, and they are trying to target every customer, from a single person to an organization of 10,000, 20,000, 30,000 employees, right? And it is because of that that everyone is trying to shift to cloud. Yes, no doubt. Moving to cloud has its own disadvantages, but the advantages what we see is more than the disadvantages, right? So that is the major reason why people are using cloud. Yeah, all these things can be put into fancy words like fault tolerance, where you need not worry about if your servers crash or if anything happens. These service providers is going to have the backup, they'll give you, right? High availability, right? And also scalability, right? So for consider an example here where we have an organization. Let's say, for example, we launched our website amazon.com, right? Assume amazon.com was built something by us, and then we are launching in 2016 for an example, and we foresee that there would be close to 1,000 users who would be using it, right? Now, if I would have taken it offline, that is, I have my own infra setup on premises, then I would go ahead and purchase 3 server racks. Then after an year, I see a sudden spike in users from 1,000 to 5,000. So that's where what I'm going to do, I'm going to say, okay, I foresee, and then I'm going to increase my again servers, right? Then again there'll be a massive hike in my customer base. Then what I'm going to do now, I'm going to foresee not next 1 year, I would say, okay, next 2 to 3 years it will be increasing like this. So I would go and do an extra commitment to this servers, right? But let's say for some fun foreseen reason my customer base goes down, right? My customer satisfaction rate is low, and then turns out the number of users using it actually drastically drops. Then I have actually overcommitted, right, purchasing this. Then either might have to think of some alternative like renting these out, or maybe selling it back at lower price, right? All these things might happen, right? So you see the law, you know, I wouldn't say it's a loss, but I would say there are a lot of things at stake when you're trying to do it at your own on-prem infra level, right? A lot of things that you're risking at your end, right? Whereas you do it in cloud, you will have that easy scalability. You need it at an hour, you can scale it. After that, after an hour, you need to scale down, you can scale it down, right? So the scalability, elasticity, all this are an advantage, right? Capex, Apex, what is this? Capex, basically OPEX, we call it as OPEX. OPEX is basically your operational cost. Capex is basically your capital cost, where you need to purchase, either hire or rent out floors, buildings to, and rent out lot of things like internet, human resources to run all of this, right? So all this comes under Capex and OPEX, right? So you can, whatever I've explained, you can put it in fancy 4 to 5 pointers, and you can explain them the advantage of using cloud over your native on premises. So basically your elasticity is similar to scalability, right? Where scalability means you getting these services based on your demand, you can increase them. But elasticity talks about ease of increasing and decreasing, right? So easily you can increase and easily you can decrease your resources count, right? That's your elasticity, like how you can just pull and then leave your rubber band, right? Easily it can actually increase, increase and shrink its size, right? Same way like that. So that stands for your elasticity. Scalability talks more about, catering a lot of users, right? These two would be somewhere, I would say siblings, the words. It's quite similar, right? Okay, right. Any disadvantage of using cloud? So yeah, there are a couple of disadvantages, right? So how about this, right? So the first and the foremost disadvantage is that you have to trust. Now, why do I say trust is a disadvantage? Because your entire data is given to an org based on a trust, where you trust that this org will keep my data safe. It won't be hijacked, hacked, or whatever you say, right? So the biggest or the number one disadvantage or the concern still is that my data should be secured, right? It shouldn't be exposed, leak, or no one should have access to my data. So that's the biggest. And second thing is, yeah, I mean, other pointers also revolve around this. Second thing is you don't have control over it. See, you have control over the services to utilize it, but you cannot go and change the networks, right? See, Google have its own set of protocols. It has its own set of ways of dealing things, right? You can't go and say that, hey, I don't like the way you transfer the packet over internet. Can you just quickly change them to this, right? To my needs. Basically, you want to tweak something, right? You want to make some changes according to your needs. You can't do that. You just have to use what they provide. They provide virtual machine. You want, you use it. You can't just go and say that, hey, can you just make a small changes to this service based on my need? No, they will create their need, they'll give for their need, we just use them, right? So customization, now I explained all this, and if you come down to one word, customization is what you won't get that, right? So that's also a disadvantage. Whereas if you have it on premises, you sure go ahead and do whatever customization you want, right? So your security is the biggest concern and disadvantages. Second thing is customization, right? And yeah, these two are the major, I would say, concern or disadvantages. Okay, so if we are good so far, guys, so let's get started with GCP. Now we'll dive deeper, not deeper, but now we'll get started with the GCP. Now, what is GCP? Your GCP stands for your Google Cloud Platform. Now, what is this Google Cloud Platform? Google Cloud Platform is basically a suite of cloud computing services offered by an organization called as Google, which we all are aware of, right? So Google is a very big tech giant, right? And they have one of their product called as GCP, that is Google Cloud Platform, which provides a group or a suite of cloud computing services. Why did we say cloud computing services? Because these utilizes at the end compute. No matter what service you use, it needs a compute to run or cater you, right? So that's why the name cloud computing services. So it's a platform or a service provided by Google, right? Cool. Now, why should I use GCP, right? No one is forcing me. No one is blackmailing to use GCP. Then why do I use this, right? So there are a couple of pointers. Now, there are a lot of pointers, guys, but we have picked 4, right, that we will be discussing. And very importantly, doesn't mean that only these 4 things Google provides, others also provides, right? But yeah, it's just that the commitment and trust that we have, right? So the first and the foremost thing is trust and security, right? So the most important reason why someone would pick an organization is a trust, right? Now, if you guys have good experience, or if you guys have got good feedback of using Ola over Uber, or vice versa, would you not use that service, right? Saying that, hey, I got to know that this service, they provide better cabs. I mean, the experience, the feedback, everything is good, so I would use Ola over Uber, right? So you get that basically, right? I mean, you're trying to understand what I'm trying to say here, right? So it's basically this customer experience and the trust is important, right? If a person can trust that, okay, if I book a cab in Ola, the driver is going to be polite, he's going to drive safely, he's going to make sure that I reach my destination safely, and he listens to me. If I ask him to turn on my AC, he does that. I ask him to turn it off, he does that, right? So you would be more happier, right? So, and you will trust that service more. So once they gain your trust, you ideally tend to go and use that service. No matter one or twice you might have bad experience, yet you would go to them, right? Because they've gained that trust basically, right? Same thing happens with these organizations. They try to get a trust, and for these people, trust is what, guys? Security, right? Now, if you are working in an organization with thousands of employees, what is the biggest thing this company would trust with? Breaches, right? So they have to make sure they trust with security so that there is no breach in your data, their data remains confidential, it doesn't leak, right? So for these big tech giants, the biggest thing is they work on is security. So they are able to create a trust in an industry, saying that we keep your data secure, right? In fact, Google does that, right? If you see, Google alone creates close to 300 petabytes of data per day. That massive amount of data every day Google stores, and yet it is somehow able to try to keep its data secure. I know somewhere here and there it gets leaked, but most of the time, if you see, they are able to keep it secured, right? So that itself is a massive trust that they can get, right? They themselves are creating that secured environment, and they are giving that security to other organization also via GCP, saying that we will keep your data also secure, right? So I would say one thing Google is very good at is security, right? The security system of Google, I feel personally from my experience, is by far the best compared to AWS and Azure. That doesn't mean that they too have bad. No, they also have brilliant security system, but somewhere our trust goes to GCP for this security reason, right? Second thing is open cloud platform. Let me give you a hint, right? It's open to anyone and everyone. So if you remember, I spoke about how advantage of cloud is that anyone can access it. We being an individual person who's going to use it for learning purpose, or an individual freelancer, or I said, right, a team doing a project of 10 members, or a small company of 100 employees, to large company of tens of thousands of employees, clouds can be accessed by anyone and everyone, right? So that is that this open cloud platform means, guys. Meaning you as an individual person can use it, as a freelancer with 10 members team, with 100 members employee, 1000 members, a million employees. It's same for everyone. Yeah, apart from the prices and discounts, yes, but it is generally the service is same for everyone. That's what your open cloud platform means here. Okay. What is the global network here? So global network here is not internet, okay, but it's basically similar kind of network provided by Google, right? So what I try to say is Google has its own network connected worldwide. Think it like a private internet. See, internet is public, meaning any websites, anyone can access and use internet, right? Whereas Google has created its own network like internet that can be accessed globally, but it is private to only GCP, right? Intranet, yeah. So that is basically your global network, right? Where Google provides a private network across globe for our GCP. Meaning if you want to do anything, you're storing your data, you're transferring your data, you're performing any action, that is done via Google's private global network. So in that case, your data is actually, or your request is not going to public internet. It is within your Google's private ecosystem, right? So henceforth it is safe. Okay. And then AI driven. So this AI driven is something Google is actually better at, right? And Google did it first. What? Not bringing AI, but using AI in the cloud, right? For what do they use AI? They use AI to actually handle DDoS attack. What is this DDoS attack? Denial of service attack. It's basically when someone is not happy and they want to load a website, right? Now if some hackers want to bring down a website, what they do is they send a lot of traffic to a website. They send like millions of traffic to a website, and because of the traffic your site crash. Why does it crash? Because the server cannot take that load, right? So they do that, and Google uses AI in their load balancers and network service to smartly eradicate and throw out such malicious and facetious request, right? That or whatever attacks that it get, right? First thing. Second thing, it uses AI at bottom level to help you recommend and reduce your cost, right? So Google has this AI service which is going to help you give recommendation of how you can save cost, right? So if you create a VM and leave it, so Google's AI system will analyze your usage of that VM, and based on that it will recommend what you could have done or what you can edit those configuration to make sure your price reduces, right? Like for example, you only use it on weekdays, Monday to Friday, Saturday Sunday you don't use it, right? So Google AI can give you an example recommendation that you can write a script or you can automate it where Monday to Friday your VM will be on, Friday night automatically your VM switches off, Saturday Sunday it will be off, and Monday morning it will automatically on. So henceforth you're saving the 2 days of price or cost, right? So I'm just giving an example like that, but such scenarios happens where Google AI will give you a recommendation of how you can save cost or cut cost on services, right? So these are, again, I'm not saying that these are the only 4 reasons why you should pick GCP, but yeah, these are some of the top reasons why we trust and pick GCP. Cool, great. So now proceeding further. Now, what are the GCP services that we will be doing in this batch hands-on, or we will be learning about and doing hands-on, right? Now, this slide is a slide old, guys, these slides. So few of the names you will see here, but we won't do it because either the name is changed or the service is combined with other service, right? So please don't go by the name, but I will give you at high level what we'll be doing, right? So we have groups in GCP, right? Like a networking is a group, right? A service. Then we have compute as a group. We have storage as a group, right? So we have groups like this. Within these groups, we will be learning a lot of services, right? So first we will get started with networking. Actually, before networking, first we will understand something called as IAM, right? IAM roles and services, right? What is this IAM? Basically, it's for your identity access management, right? So we will learn about how we can give user access to my GCP project. How can I onboard a person to my GCP project, right? So that we will be understanding how I can create roles. How can I create my custom roles, right? So that we will be looking into. And then we will get started with networking concepts. So in networking concepts, we'll learn something about VPC network. What is a VPC network, right? Then we will learn about VPC peering. Then we will learn about shared VPC and firewall rules. So these are a couple of topics that we will be learning, right? And then we will start with compute. And I think compute will by far be the most time consuming, I would say, right? Because yeah, at this part I'll be little slow and we need to do a lot of things here, right? So compute will actually take more time to do, and it's fine, we'll go slow, but we will do this compute. In compute, we will see how we can create virtual machines in GCP, how we can create something known as managed instance group in GCP, right? And also we will see how we can deploy application. We will take a sample application. We will not write from scratch because in this course we are not focused on coding or developing. So what we'll do is we'll take some existing code or existing application, we will deploy it, and we will see how we can deploy application, cater it via VM, and then how we can cater it via managed instance group, right? So what is the difference between them and why do we choose and when do we choose each of this? That is what we will be understanding. Then we will jump into serverless services, right? So I know a lot of these words would be new to you guys. Don't worry, each of this in detail we will have, guys. We'll have like every day, every batch for these separate things, right? So in detail, I'll explain what is serverless service, what is the benefit, right? So all of that we will be learning. Okay. So we will be doing GCP serverless service, where in this serverless service, we will be learning about, uh, yeah, app engine, right? GCP's app engine, cloud run, cloud functions, right? And then after that, very important, we'll learn about basics of Kubernetes, and we will create a Kubernetes engine or a cluster in GCP and deploy a sample application, right? Then we will get started with storage service. So in GCP storage service, we will be learning about GCP's cloud storage bucket, where we can store unstructured files and formats, folders, and then we will see database services under storage like Cloud SQL, Cloud Spanner, Data Store, which is basically like your NoSQL database, right? So we'll be looking into these, and we will be doing BigQuery. So BigQuery comes under your big data, right? So we will be doing BigQuery, not anything else, right? So these are the services that we will be doing under storage. And then we will finally do artificial services, artificial intelligence services. So what is this? This is basically where we will be using out of the box readily available AI services by Google, meaning these AI models and AI services are already created by Google and ready to use. We will just go and use it, right? Okay. So the next step would be to understand and analyze how we will be doing hands-on. Okay. In this series of courses or the series of batches that we're going to have, how should we proceed with the hands-on? So we will be creating a free trial account, right? And this free trial account, GCP will be generous enough to give us close to 24,000 INR or close to $300 for free, right? That doesn't mean you can encash it in your UPI or card, guys. So we will be able to use any GCP service until unless we exhaust that 24,000 credit or $300 credit, right? So yeah, Google is generous about that. So we will be creating that free trial account. And don't worry, guys. I know a lot of times people get scared. They're like, hey, Aman, will it detect money from my cards? Because you know that when you create this account, you need to give your credit or debit card, right? So a lot of time people say, please tell me money should not be detected. This, don't worry, guys. Trust me. I'm going to show you how to deactivate your billing account, how to deactivate your GCP project, and how to remove that from your card also. I'm just gonna show all those things at the end, right? Like once we complete all hands-on, then I will show you. Before we talk about certification and all, we will deactivate the account. If you want to keep it, you can keep it and do it later. You can note down the steps and you can do it later, no doubt, right? But I will tell you how to deactivate. So you need not worry about money detected, right? First and the foremost thing, it will not. It will try to detect money from the 24,000 of what Google gives us. Only when you exhaust it, they give you a reminder. They give you an email saying that they are going to detect. So they'll give you warning and all that, right? And then they detect. So they will not just go away and straight away and go and detect money, right? So don't worry about that. And trust me, hardly we are going to use 500 rupees in our entire training, right? Because we will learn, we will do hands-on, and after 1 hour we'll delete that. Whatever we have created services, we're going to clean that services, right? So hardly we will keep anything which will keep costing, right? So that's why we will be cost hardly for this entire training. It will charge 500 rupees, that too not from your account. It will charge from the 24,000 rupees that GCP provides, right? So I will make sure I leave you guys with at least 23,000 INR credits. If you want, in the remaining 60 days of your time, you can learn, do whatever you want. Okay. I hope those expectations also set straight so that there shouldn't be any confusions further going forward. Okay. Now, how do we create this free trial account? Okay. Let me go ahead and show you once the steps to create a free trial GCP account, guys, if you have not created any. Okay. Because even I want to create one, right? It's been a long time. I need to create a fresh account because the last account I used is completed. I have exhausted basically the 90 days, right? Right. And let me create a new one, right? So guys, please make sure you guys jot down the steps or note the steps, right? Because I'm not going to do it in front of you. I'm just going to give you guys the steps and I want you guys to do it offline, right? So the first and the foremost thing is happily go to console.cloud.google.com and let me do it in incognito, right? So it'll take you to this sign in page, and after signing page, guys, it is up to you. If you want to use your personal email, go ahead and do it. But my suggestion and recommendation is go ahead and create a new one, right? Create a new Google account. The reason being, guys, from personal experience, you use this only for 20 days, 30 days, or 90 days, and after that, you never use this account, right? So because of that, I would suggest not to involve your personal account here. Rather, create a one for a learning purpose that will use this 90 days, and after that, we'll forget that we ever created it also, right? It'll automatically be decommissioned by GCP, right? So I would suggest go ahead and create a new Google account. How would I do it? That's very simple. You have your create account, right? So just go and create a personal account. For personal, just give your name, email, location, address, all that things, just go and fill. And then your step one will be completed. Then once you have it created, your step one would be filling details like address. Okay. Basically your personal details. So once you have created account, then in GCP, you will have step one. Step one would be filling in personal details, like it'll ask your address, right? It'll ask those details, okay? Then step two will be very important. This step two is where when most of them goes, wrong and they have doubt. Step two, the first option, I'll write it like this. First option, right? By default, will be business, right? Change it to individual, right? So what is your first option? First option is it asks basically what type of account are you creating? Is it a business account or individual, meaning personal use? If you select business, you have to give your registered business registration detail, which we don't want to give and don't want to do it, right? Then you have to go and validate domains and all that, which we don't want to do. You can select individual, and in individual, if prompted for PAN card, PAN details, ignore, because it is not compulsorily, it is optional, right? It is optional. So you can ignore them, right? So if they ask you PAN details and all, just ignore them. All you have to do is select it as individual, and then in step two itself, basically give your card. So it's going to detect some 2 rupees INR, and then after that, it's going to authenticate, validate everything, and then bam, you will be welcome to GCP Cloud, right? So it's as simple as you just going and doing 3 to 4 steps. Now I know it's easier to say, it might take 10 minutes of your time, but yeah, it's very simple, right, compared to others, right? You just have to go and use your personal account, make sure you select it as individual, and then yeah, give your card details. And giving your card details also, guys, this I'll be saying, be precautious, because you have to first and the foremost thing have international transaction enabled, and you have to have something known as, what is it called, guys? Smart, or this one where your money gets automatically debited. What's that feature called in banking? Oh shoot, I forgot the name. E-mandate, yeah. Mandate enabled. So these two should be enabled, guys. If in your account, like HDFC, ICICI, or Kotak, or whichever bank account you have, if these two are not enabled, then it will give you error. That is, after doing your payment, it will give you an error. Don't worry, if you detect 2 rupees, they will send you back the 2 rupees, right? But yeah, it will give error if you don't have these two enabled. So make sure these two things are very important: international enabled and e-mandate. So what is international enabled? Obviously, it's international payment, right? Even though you're doing domestic payment, make sure you keep international payment enabled. Second thing is e-mandate. So e-mandate is a feature where GCP will have the rights to go ahead and detect money from your account. But don't worry, it will not go ahead and detect it, guys. It's just for auto debit. Automatically, it will detect that money, right? Which I'll tell you how to close this e-mandate also at the end. So you need not worry about that. Trust me on that, right? So yeah.
Just a quick info, guys. Intellipaat offers Google Cloud certification training designed to help you clear the Google Professional Cloud Architect certification exam. Through this course, you'll gain hands on experience in Google Cloud services like storage, computing, databases, and security. You'll also learn to design and deploy scalable cloud solutions for enterprises under the guidance of the top 1% of industry experts worldwide. With this course, Intellipaat has already helped thousands of professionals achieve successful career transitions. This training is your gateway to excelling in the high demand cloud computing domain. Visit the course page link provided in the description and take the first step towards becoming a certified Google Cloud architect and advancing your career to new heights.
Okay, cool. Yeah, a quick recap of what we've done so far, right? So far we got started with cloud. We understood what is the concept of cloud, the advantage, disadvantage. We understood what is GCP, right? And then we did a quick walkthrough of the advantages of GCP and what all the services that we'll be learning in GCP, right? So this is what we've covered, and we had the final touch up on how you can create your GCP account, right? So I'll be starting with the GCP account creation, and I will create the GCP account for myself, because after this, I'm not going to explain again how to create the account or do whatever, right? So please pay attention. If you guys have already created, you can sit back and just relax and watch. If you guys are yet to create, then please do it alongside with me, right? So if you guys recall the steps that we had, let me quickly pull up the notepad that we had, right? So these are the steps that I've actually mentioned, right, to create your GCP free trial account. So the first one is we have to go to this console.google.com, right? And I'm going to go to this link, right? Right. So now let's try to create a new account so that you only use this account for 90 days and after that you forget about this account, right? So yeah, I'm going to create my account by filling in basic details. Let me fill this basic details quick. Give me 1 second. Okay. Email address, I'm just gonna keep it GCP Intellipaat@gmail.com. Get on Gmail, and yeah. And password, let me keep it simple. Oh my God, phone number. Okay, give me 1 second. So please, side by side, alongside, I want you guys also to fill your basic details or create this basically account. Okay, so my OTP verification is also done. I don't need recovery email, and then next. I agree. Yeah. So now we need to activate our free trial account, right? So far we have completed step one. Not even step one. We've just completed this step where we have created a new Google account, right? Gmail account and fill person. So now we have to start with these two, step one and step two, for activation of free trial, right? So for activation of free trial, all you have to do is, guys, on the top, just click on this start free, right? And once you click on this start free, it's going to take you to this page where you remember step one and step two I was mentioning, right? So please do that from the top right hand side. Just click on that button that says start free or start trial, right? Yes. Okay. And then you can click on agree and continue. So that's going to take to step two. Oh, wait, first. Okay. Yeah. So in step two, oh, initially they used to ask address and all that thing. They're not asking now. Okay. That's a nice update. So in step two, this is where we create a payment profile, guys, where basically we need to add in our card details, right? So just click on new payment profile, and yeah, the first option is profile type. Make sure you select it as individual, right? This is the most important step I told, right? You have to select it as individual from organization, right? So I'll select it as individual, right? And here is where they'll ask me street and everything else. So I'm just gonna mention it as, yeah, Bangalore. There you go, right? And then I'm going to click on create. Okay, we still have that. It's just that it's split into profile and payment. Okay, go ahead and add your payment profile. So now we'll go and add our payment, this one. So in payment, as I said, you can just make sure you have e-mandate and international payment enabled, and just go and do this. So let me just quickly go and add my card details. Give me 1 second. You can also do this step side by side. Okay. And also guys, RuPay doesn't work. It should only be a Visa or MasterCard. Okay. And then after adding it, I'm gonna say start free. It's going to detect 2 rupees. So I'm going to validate that by giving my OTP. There you go. So it detected around 2 rupees, validated my payment from my bank, and it has completed this. And it's going to take me to this page where I have the pop-up, right? So yeah. So for now, once you guys complete your payment step, you're going to be having this welcome pop-up, and you can respectfully just close it. I don't have to fill all those details, right? And finally, here we go. We land to our GCP console or GCP page, right? Welcome page. So we call this as console, right? This is where we have UI for doing everything. And you see close to 25,000 rupees credit they'll be giving you, right? And hardly will be using 500 rupees across our entire, batch, right? Training. So we're not going to utilize that much. Okay. And please don't get intimidated by this Gemini 1.5 Pro. Don't go and don't experiment all this. Okay. Forget all this. It's just marketing scheme. Okay. Now we'll get started with actual GCP, and I'll give you walkthrough of the GCP portal. Okay. So I want everyone to sit back and just wait, and I'll give you a walkthrough of GCP portal where you'll find what options, what you have to do. And then we will actually, I'll give you some time, and then you can play around with the GCP portal. Okay. And also if required, you can just bookmark this so that it's easier for the next time I go and open this, right? Okay. Hybrid formula, top footing. I think top footing is my project, right? Yeah. Okay, great. Cool. Right. So once you log into your GCP console, guys, this is the page where you will be landing. Okay. And how GCP works is they have something called as a project, GCP project. And if you create any amount of services in GCP, it will be associated to a project. Think a project like a container. Okay. Think your So think your GCP as in a container, right? So your GCP is like this, a container. Okay. GCP project, right? Inside this, you create virtual machines, you create your SQL database, right? Or you create, let's say, for example, you want to create Kubernetes, right? Cluster, or you want to, let's say, for example, create or storage bucket, right? No matter what service you want to create or use, guys, you have to make sure it comes or it is placed within a GCP project. Basically, in simple words, you cannot create a service outside a project. Okay. So any service, any service or resources that you were to use in GCP would be actually sitting inside a project. So this is how your GCP will be able to identify that the VM resides or it is accessed in which project, right? So if you were to create multiple projects, deploy multiple application, you would be creating multiple projects, right? So if let's say, for example, you're creating project A and you're creating application A and application B, right? And both of this application is for two different clients. So why would you definitely create one project, right? You would definitely create two different projects for both the client, which is completely independent, right? And those services will actually be used inside those projects, respective projects, right? So at higher level, we have GCP project within which we do everything. So anything and everything that you do in GCP will be done inside a GCP project. So yeah, anything and everything you have to do, guys, will be done inside a GCP project. So I hope you understood what a GCP project is, right? It's like more like a container where anything, any resources you have is associated to a project. Okay. And you can create multiple GCP projects in an organization, right? So you can create thousands and hundreds of projects in GCP organization. Where do I see these projects? So to see these projects, on the top side, you will get this next to your, on the top left, next to your Google Cloud, you will get this basically a square box where you see my first project, right? So your project, your GCP project name is my first project. Now, quick question. You guys might think, right? Hey, it's my first project for everyone, right? Everyone will see the same name, my first project. So this is a default project created by Google. So Google creates a default project and give it to you. And the name is same for everyone. So then your next question would be, how can then this name be uniquely identified, right? So how can the name can be uniquely identified, right? If everyone has the same my first project name, right? So your answer is very simple. This name is just like an alias name. Okay. The most important thing is something called as project ID. So whenever I say go and fetch your project details, it's this only one thing that you have to get or copy, that is your project ID. So your project ID is unique. Okay, and this one is randomly created by Google, which is combination of some two words and alphanumeric values. Okay, but in real time, if you want, in organizations, you can create custom project ID also, right? And this custom project ID is used in organization for scrutinizing and organizing projects, right? So they have a different nomenclature itself. If you look at them, so in organization, they will have like say, for example, ABC is my organization. And then let's say, for example, it's for AI vertical. And inside AI vertical, let's say it's for XYZ team. And in that, I'm having this as a dev bucket, or sorry, dev project, right? So same thing they will replicate, and they will have a test project. And same way they will have a prod project, right? So you can create your own project ID like this, right? The nomenclature can be anyhow you guys want, right? So you can create basically your own project ID like this and use them, right? If you don't want to create your own, it's fine. You can go ahead and use Google's auto created this one, but it's completely random, right? Now the problem here, what becomes, guys, is if Google randomly gives like this, right? So it becomes hard to know which project is for what, right? I know you can say, hey, I will give different project name. From project name, I can get to know what project this is, right? But ideally, from project name also, most importantly, it is ID. Because anywhere in GCP, if you're dealing with, let's say, Terraform, or you're dealing with code, or you're dealing with anywhere, you use only project ID. So if you're writing a script and you're given 5 project ID with like this random text, you tend to get confused, right? So that's why not just the name, even the project ID should be having meaningful names like this, should have a better nomenclature, right? So that's why it's good to have both name and ID created custom, which we need not worry for now, but I'm just telling you that option exists and can be done at organization level. Okay. Then here we are seeing only one project that is being given to us, guys. Why? Because this is the default project that is created by Google. But in organizations, you will have hundreds, not just hundreds, you might have few hundreds to thousands of GCP projects, right? So those GCP projects, where do I see them? So you see those GCP project under this All tab. So here in all tab, at the highest level, you will have organization. And in organization, it's basically no organization. Why? Because it is an individual account. When we created a free trial account, we selected it as individual, right? Whereas if you select an organization, you will see your organization name or email here, right? abc.com, like that. You will see your organization name, email, and then inside that, all the projects that is created inside this organization will be listed here. All the hundreds and thousands projects, right? Now, how is this access to this project given and all that? I will do later part, right? For now, you can just know that all the projects will be listed here, right? How do we give the permission to this project? What is folder structure, hierarchy? All this I'm going to do at the later part. Fine. Okay. So a quick recap. If I were to get to know what is my project details, in which project I'm currently working, because you can have access to multiple projects, right? So which project that I'm currently working in, or what is that project, right? Details, you can get it from the top left option here. That's basically a rectangular box here. From this, upon clicking on this, you will get to know which project you are currently selected and working on, right? So this is where you will get your project details. Okay. Now, so what you guys can do is, folks who see more than one project ID, I would say just pick one ID or one name and just select that, and keep in mind that that is the project that you want to use. So every time, make sure you just select that. Okay. Star it and just use that. Okay. So folks who has more than one project, just make sure you star it, add it basically like a favorite, any one, and use that itself for this entire training. Because what happens is, you might, if you have multiple and if you use multiple, you might create a VM or you might create a service in one project, and the next day if you're using other project, you might forget to delete, right? So you might think that, okay, everything is cleaned up, but in the backend, it will be charging from this free trial amount, right? So such scenarios can happen, right? So that's why just make sure you stick to one project. Okay, cool, great. Now, coming back to our GCP console, right? How can we best leverage or utilize this GCP console, right? How can I use this the fullest potential? Okay. Now, every day when I'll be doing any services, I will say you guys that, hey, go to this ABC service, right? Like for example, I would say go to VM services, go to load balancer, go to Kubernetes clusters, go to your storage bucket. So I'll keep saying this name, right? Go to this XYZ service. How do you actually go or redirect to this XYZ service is what we will see now. Okay. So there are two ways to do it, guys. You can forget about this. Whatever the recommendation here is based on the most commonly used, based on GCP analysis, and they have all this. You can forget about this. Okay. But apart from this, there are two approach or two way how you can actually navigate to a particular GCP service, right? So the first way is from the top left hand side, you get this navigation menu, right? So just click on this navigation menu, and on the left hand side, you will see a lot of GCP products. Within that products, you will have multiple options and services, right? Think it more like these are groups. I have a group, and within that, I'll have these services, right? Now, your next question is, do I have only these many products and services in GCP? These are just the pin product. Pinned by whom? Pinned by GCP. So GCP, definitely they have a lot of data, right? So they've done the analysis and seen that which is the most widely used GCP service here, right? So that people, when they come, they will be using one of these, right? They might use other also, but there is a high chance that they will be coming back to GCP or using GCP extensively for one of this service. So that's why they have just populated here and pinned it here, right? But that doesn't mean that these are the only service. If you scroll down a little bit, you would see this option that says view all product. So just click on that view all product, and then you will be redirected to a page where you would see a lot of GCP services and the groups, right? And you will have option to customize your pin. You can unpin and pin whatever service you want, right? So you see a lot of services are there in GCP, correct? And on the left hand side also, you see you have categories. So based on that categories, you can go and select that service, right? So this is one way to redirect to your service, guys. Go there and click on that particular service. But this actually is more like a complex step, right? You must know which group it is, and then you have to just go scroll, search, and then click, right? So ideally we don't use this navigation menu option, right? But yeah, it's good to know that it is there, but we don't use this. Rather, we use this beautiful search bar that we have, that Google has provisioned us with, right? So in this search panel, you write for whatever you want. You want virtual machine VM, you will get those autocompletes and recommendation. You say Cloud SQL, you will get Cloud SQLs. You say basically Kubernetes, whatever you write, you will get the recommendations and you will get the similar products, and you can click on that product or service and then redirect to that service, right? So if I were to ever go and say, hey, redirect to this service or go to this service, just come to this top search panel and type whatever service I say, okay? And then you can click on that service. So make sure you know that you have to use this search panel to search for any GCP service, right? Okay, so two things are clear, guys. Where do you look at for your projects? Where do you get the projects detail? And basically, how do you search for services, right? Okay, so now next thing is very important, your cloud shell. Okay, what is your cloud shell or your cloud terminal? So basically, you know, in every laptop, there would either be a command prompt or terminal or PowerShell, whatever you call it, right? So it's basically a terminal, right? And in this terminal, you can write commands like ls, clear, dir. You can get a lot of commands to perform some set of options, right? So each of this commands has a meaning, correct? Similar way, GCP has made sure, just like other cloud providers, you can not just access these services via UI. In fact, you can perform those operations via terminal. Meaning, if you wanted to create a VM, there would be commands here. I'm not writing the commands, but I'm just writing commands here saying there are some commands here. If you write and hit enter, it is going to spin up a VM for you, right? You need not use a UI or a browser. Okay. So this is the reason why people use this. Basically, what is the reason? The reason being, if you wanted to do something repetitively, right, we generally use command lines, right? Now, to use this command line locally, guys, we have to install something known as your Gcloud. So what is Gcloud? Gcloud is basically the package or SDK provided by Google. So we need to download Gcloud and install Gcloud, and then we need to authenticate to our GCP project, right? So we have to do basically all of this, right? But instead of doing all this in local, what Google has done is they have provided a way where you can actually use the terminal via this cloud itself. That is, you have this local terminal similar to this on GCP cloud that runs on GCP cloud, for which you need not install Google SDK, you need not authenticate, right? Authentication also is very simple. It's like a pop-up, that's all, right? So these two things becomes easier. So you need not download it or you need not do anything locally. You can do everything on cloud, right? On your GCP console and portal. So to do that, here we have cloud, activate cloud shell. Okay, click on that activate cloud shell. On the top right hand side, you will see a square button, guys. Okay, click on that square button and activate it, and then you'll get this pop-up, and then it says cloud shell is free for all users, right? So just say that and click on continue. So that is going to create your cloud terminal. So please do it at your end, guys. I'll repeat the step again. On the top right hand side, you will see the square button with a right chevron icon, right? So just click on that, which will be next to your notification button. So just click on that and you would see something like this, which is like a terminal but running on your GCP cloud. Done? Yes. Okay. So here also you can write commands, you can do a lot of operations here, right? Like if you want to run any scripts or anything, right? So a lot of things you can be doing there. The only difference is whatever you do will not run locally. It will run on GCP cloud. And technically, guys, this cloud shell that we are using, right? Let me tell you. So this cloud shell that we are using, this Cloud Shell that we are using under this GCP's ecosystem, right, is basically in the back end, nothing but it is basically a very tiny VM. I need not mention tiny VM, but I'm telling tiny VM to say that it's a very small instance that is provisioned, right? So when you're using this Cloud Shell, it's running on this VM, and actually you're using this VM, right? And the configuration of this VM is that you have shared memory, you have 10 GB storage, and you have a shared memory. That is your RAM, cores, everything is shared, right? So it's a very tiny VM that is being given to you, because first and the foremost thing is they told it's free. They can't give you a good instance for free, right? So that's why this is how your Cloud Shell works. So technically whatever I'm doing here is actually a tiny VM. Now, in the later part, I will explain you how this Cloud Shell actually works internally, right? Not now, but in the later parts. Okay, right? Now, I won't tell you guys to write what commands or how do we write commands and all that we will do it gradually. So once we learn services, then we will learn about GCP, basically CLI, and then we will try to create GCP services using CLI, right? But not now. For now, you just have to understand that what is a cloud terminal and how do we use this cloud terminal. Cool. In the quick walkthrough, so I hope you guys got a small gist of how your portal looks like, how you can navigate to any GCP service, how you can actually use a cloud terminal, right? I did not close the console, but I closed the terminal. So to close the terminal, you will have on the left hand side this cross button for the terminal, right? So you see here, so that will close the terminal. So just try to close the terminal, guys. Okay. Okay, so you see this is currently mapped to the project that is selected on the top, right? But if I were to select for different projects, I would click on this plus icon you see here, right? So I would click on this plus icon that will have a drop down, and then here you will have list of all GCP projects that you have access. So yeah, you can click on that GCP access and that will open up a new terminal on the right hand side like this. And here you can select the different projects. So you can have multiple tabs running side by sides. Cool, right? Now, one more thing let's quickly look at is, don't you see this actually is taking up half of my screen, right? Ideally, you cannot even have this small terminal, right? It won't look nice because you want to see text, right? So you would have terminal taking up half of your screen, right? And that actually tries to make things difficult to us, right? Just imagine you seeing half screen here in console and half screen here, right? So your development or whatever you using this GCP becomes a little bit tough, isn't it, guys? Right? First of all, nowadays everyone's getting glasses because of the screen time, right? And after that, everything is so small here and 50%, right? So that's why it's not ideal to use it, right? So for such scenario, you can open this terminal in a new tab, in a separate tab with 100% screen, right? So I'm going to show you how we do that. So to open this 100% in a different screen, on the right hand side, guys, on the left side to your close button, look here carefully where my cursor is. On the left hand side to your close button, you would see a square with an arrow popping outside, right? Or pointing towards outside, right? So that says basically open in new window if you hover over it, correct? So click on this button that says open in new window. So you see it will actually open this entire terminal. The whatever session is there, that session will be transferred to a new screen, right? So please do it, guys. Transfer the session to a new screen, and let me actually increase the size of this so that you can see this. Okay. Now, one more thing that is very good about GCP, guys, is you can not just use terminal. Sometimes you might have to do changes in configurations file, right? Like let's say, for example, you're working on Kubernetes, then you'll majorly have this YAML files. Or if you guys are running small application, or if you're running some shell script, or you're running some types of scripts, right? So in such scenarios, you might want to actually use an editor, code editor or ID like VS Code, right? So even GCP provides that. Where do they provide it? Okay, very simple. Clicking on this open editor. So on the top right hand side, you have this editor button, and clicking on this editor button, that will open a IDE. It's like basically your online version of VS Code, right? Which is like a text editor. You can have files, folders. You can basically write Python scripts, Java scripts. You can write your Docker files, Kubernetes, managed file. Basically, you can do anything and everything, right? You can run your actually Node.js application. You can do everything here, right? So you get both editor as well as terminal. Both you can have. So you can quickly go edit configuration files, deploy your application, redeploy application, make changes. Everything can be done here. Just make sure whatever you're doing should suffice in this, right? You cannot exceed 10 GB storage, and it's a shared memory. So you cannot run your application here, guys, right? Because it's a very tiny VM, right? You won't get that memory, right? So just make sure any small task that has to be done with your configuration, deployment, running GCP commands, those things you can happily and easily do it here, right? So this is how you can leverage your terminal, right? Open up in a new tab and use them side by side. Because majorly when we are working in GCP compute, when we are deploying application or we are working with this, right? So we will be, or working with Kubernetes, we will be using terminal extensively, and we will have editor and terminal both side by side, right? And we are doing, when we are doing GCP's AI services, at that time we will be writing some Python scripts, right? So for that time also we will be using this terminal with code editor and also a terminal, right? Both side by side. So at that time this will be helpful. Apart from that, we will only use terminal. Terminal is important to us, right? Anywhere we are dealing with code or deployment or changes in a configuration file, then only we will use this code editor, right? So I hope you guys got a quick gist about your terminal, guys. Okay, now then you can simply close this tab. So if you close this Cloud Shell tab, it will just close the terminal, right? It will close your terminal, right? Now a couple of pointers related to your terminal, guys. Now this terminal is a tiny VM, correct? And if you see, when you launch the VM, when you launch this terminal for the first time, GCP gave a pop-up and it says that Cloud Shell is free. Do you guys recall this? It mentioned, there was a lot of lines, but if you see one liner, it was pretty clear that GCP's Cloud Shell is free, right? Now you tell me, guys, this VM, even if I assume this VM might cost me or it might cost me, let's say $5 per month per user, right? Imagine there are millions of GCP users using this across projects, across organizations, using these terminals, right? Don't you think $5 into million is like $5 million, right? So do you think GCP would provide $5 million, shell out so much money just to give you for free of access? And that too, these are cost for per month. If you're using it from years, then imagine how much of resource we are freely using, right? Do you think company would go in profit with such huge commitments? Do you think any organization would do that? No, right? They will always have this loophole, or they will always have some or the other if else pointer, right? So we have same if else pointer for GCP, guys. GCP Cloud Shell also. Okay. Now, what is that pointers? It's very, very, very simple. They use the word it's free. They use the word it's VM. So what happens is, technically, if you see the architecture of this VM, right? If I expand this VM, and how does the architecture of this VM looks like, right? Okay. But now if I quickly show you what would be the internal architecture of this, right? So it's very simple, guys. It has two components. One is the storage and another one is the compute, right? So one is your storage and the next important one is your compute, right? So you need compute so that things run on top of it, like you need RAM and you need cores, and you need storage to store it, right? Now it doesn't mean that I create some file and after that, then if I close my terminal and come back to the terminal and the data is lost, it makes no sense, right? It's not good and not feasible, right? So in such scenario, they should have storage so that if you're working and then close the terminal and come back after 1 week also, your files will be there, right? So there are two important components. Now, for storage, what GCP does is they use their GCP storage bucket, and they store your files and data. So if you have code files, deployment files, YAML files, anything you have, right, they will store that storage in your bucket. So it will always be there. And for compute, what they'll do, right, they will shut down the compute. So compute, what happens is, for compute, what these people will do is they will have a pool of VMs, right? They'll have like this, a pool of VMs. They'll have hundreds of VMs running like this, right? So here we have a pool of VM, right? So there'll be a pool of VM. So every time you click on this terminal button, what happens is, guys, it takes one VM from this pool, which is free, that is basically which is ideal or idle, right? It will take this one idle VM. Okay, it'll take this one idle VM, and then what it does is it actually attaches this storage bucket to this VM so that your data will reside, and that's how you are actually accessing this Cloud Shell. So your Cloud Shell, this is how it is accessed, right? So this is how it does. So every time I close my terminal, guys, that means that VM is gone back to this pool. Okay, and in this pool, it will increase and decrease the VM based on demand, right? So it will quickly see an ideal VM. It will attach an ideal VM with the storage bucket where my data files reside. And then that's how every time I click on this, it looks like it's a fresh VM. See, it is provision. It takes some time to connect. It looks like it's a fresh VM, but if I write ls or if I write pwd and see in which path I will have my files there already. Why? Because those files are not stored in the VM, but rather in storage bucket, which is getting attached to this VM, right? So this is how I'm able to access this terminal, and this is how they are able to, first point is save the cost. Okay, this is how they are able to save the cost. Now the next important thing and the catch here is, in caps, if you do not, let me say, do not use your Cloud Shell for 30 consecutive days, they simply delete your bucket as well as the VM. So they won't delete, it will basically free up there itself, but they will delete your bucket. The reason being, guys, this bucket also, Google cannot hold for this bucket for lifetime, because they will pay for this bucket storage also, right? If you are using 1 GB storage and there are millions of users, then there'll be millions of GBs, right? Which people might not be using, but still it's kept. So that's why they have a 30 days time period. If you don't use for continuous, guys, again, continuous 30 days, if you don't use your Cloud Shell, then they delete your bucket. That is, your data will be lost. So this is how they are able to save money, because a lot of time what happens, if people are frequently using it, Google is happy giving them these services. If someone like us, we, like, let's say for example, we'll have for 8 days this batch. After 8 days, I'm not going to use it, right? So after that, I won't even delete it, right? So for our case, what will happen, this scenario is best, where it will wait for 30 days. And if it says we don't use this for next 30 days, consecutive 30 days, it will straight away go and delete my data, right? Because they want to save the money also, right? That storage can be utilized by someone else who actually needs it, right? So using these two techniques, Google is able to optimize their price. Don't you think how much of planning, how much of strategy, how much of implementation, business logic they need to do all this, right? How complex it is. But for us, it's as simple as I click on this button and I'm using it, right? We generally don't care what is happening in the back end, what is happening in the back. In back, it's like, let's say for example, it's like a tsunami, right? That level of thinking, that level of strategy, that huge complex optimization, everything they will worry about, network security. And for us, it's as simple as I click on this button and I'm happily using it, right? I need to be happy. That's all, right? So this is how they provide these services, just to make sure they gain your trust. They know that you come back to GCP, use them frequently, right? So all of this happens in the backend, guys. Cool. I hope it was informative and I was not boring you guys with all this, right? So I know that's a lot of things to take at a time, but yeah. Okay. So a quick recap of what we have done so far, right? So guys, we got started with basics of GCP. We understood and learned, what is a cloud. We understood what is a cloud. We understood services provided by cloud. Why do we leverage cloud? We understood the advantages and disadvantages of cloud, and then we created GCP account. We also had a quick walkthrough of our GCP account, and we saw how we can create cloud terminals. How does your cloud terminals work internally? How do you redirect to a page or service in GCP portal, right? So these are the things that we had a look. Pretty much basics. We did not get started with GCP, right? So the first and the foremost topic that we will be doing in GCP, and very important topic, is IAM, right? So it's identity access management, right? Now, the next question is, what is identity access management? What is this identity access management? A question mark. Related to ID access, giving limited resources, managing access. Okay. So the word here, let me put it this way, right? The word here, access management, gives you a hint that it has to do something with access permission, right? So here it means it has something to do with access or permission. The word access management says, right? Now, what is identity then here? Who is identity? What is identity? Why identity? The importance of this identity word is important here. The importance, you'll understand why. Let me put it to you, right? Identity can be a human, can be a device. It is not compulsory that identity here means it's a human itself or it's basically an ID. No, identity means basically a person or a device or a resource who will be actually having access management. Whom do you manage this access? You manage either to a human, or you manage to a device, or you manage to an account, right? So your device is nothing but even your IDs that you create, right? Accounts, that will also come under this device, right? So it is for this human account, human email or device email, meaning you're trying to create it for non-human users. For them also, you're trying to have this access management. It is for them, you control this access management, right? So the word identity here is not a unique ID or something. The word identity means it's basically a human. It's an entity. It's an entity. It's a thing, right? Like human device for which we'll be performing access management. The very basic of what is actually your identity access management, right? The word identity, what it means, right? Because generally when they ask this question, what is identity management, everyone says it's related to access. But it would be great if you further go and explain what is that identity, meaning for whom are you controlling this access. It's for human and device, right? And also you should know what that identity is. Cool. Now, so far we are good and we understood what our IAM is, and yes, what does it serve purpose, right? So in GCP, there are two ways we will be performing IAM. One is at principal. Okay. Another one is service account. Okay. Now, who is a principal? Who is a service account? Now, principal is not a principal of a school or university. Here, a principal is basically, I would say, a human. I'm very bad at drawing, guys. Sorry. Okay. And a service account is you creating account for a device. device or your application or your code, be it rather, right? So in GCP, you can perform IAM, that is Identity Access Management, at two levels. One is at human level, and human level you perform it for a principal. So in GCP, we use the word principal for human level access, and service account if you are using for non-human, meaning, let's say for example, you're writing a script or you have an application where, let's say, you are inserting data or you're trying to leverage some GCP service. To leverage that GCP service, you have to authenticate to GCP, right? So in that case, to authenticate and to give you permission, you will be creating a non-human user. Now, why is a non-human user important, guys? I mean, I can simply use my email address in my application, right? Or I can create a new user called as ABC application, and I can have password and I can use that itself, right? Why should I have a separate system, separate ecosystem for a non-human? Why is it compulsory to have a non-human device application level IAM? Why can't I use a human level itself, right? Things could have been more easier, because device is also connected at organization network. Yeah, be it. Yeah, so what? I mean, I could have simply made a whole thing for a group or a team group. Even if it is a group, I can create a new user called as human user called as ABC group and give that to everyone in the group, right? What's the most important aspect of getting a device? Because see, device working is exactly similar to human. There's only one change: automation, right? Automation, yes, it's secondary, but I would say more related to security concern, right? Now, guys, when you're trying to authenticate via human, don't you think when you're logging in, you will be asked for email and you'll be asked for password, both, correct? Now, do you think it is wise enough to just go and in your code or in your environment files or somewhere, you just go and blindly write in same plain English text saying this is my username, this is my password? Is it good? It's not wise, and it's not uh, suggested also to do that, right? And also it's a security concern, right? Your code might, let's say for example, for some unforeseen reason, let's say your code got public, or your website got I mean your company something got breached, right? At that case, if they get access to these things, it become vulnerable, right? So in such scenario, a device or application level IAM will not have a password. It'll have a user, and instead of password, it has other authentication mechanism, right? So there you don't expose password, right? Your keys and everything will be protected, let's say in a file, right? You will have a key file, and using that key file, it will authenticate instead of you going and manually writing in plain English text the password. So this is the major reason to split a human and non-human user, guys, because for non-human user, that means we have to go and hard code it. Hard coding is a bad security and is also not a wiser option. So because this is the main reason, after this everything comes automation, group comes secondary. So if you are asked anytime else, then you would be able to answer this. Cool. Okay. Now, the next thing is, a principal is basically you giving access to a human, and service account is basically creating an account and giving permission to a non-human, that is a device and application. So we will be looking at these two things, right? Now, the next two things we will see that is associated with this is, okay. Now, the next thing that we will see which is associated is, how do a principal or a service account I manage access? How do I manage access? So for principal or service account, we manage access by creating something called as role, guys. Role or roles. Yeah, up to you. If you can have multiple roles, right? So you can use this word. So we provide access via creating role. So this role is like your security guard, or you can say police thing, right? Police cops who would basically allow or not allow, right? So we create roles and we assign these roles to either a principal and service account based on which their access or permission is managed. Yes. Okay, cool. So now once you are landed to this IAM service and page, guys, on the top search panel, I want you guys to go and search for IAM. You can write it in caps or you can write it in small. It's up to you. Okay. So just go and write IAM on the top search panel, and there you will get this option under the product, you will see the first product here, IAM, right? So just click on IAM and admin. So just click on IAM, the first option that you get, and you will be redirected to a page like this. As you can see in my screen, you'll be redirected to a page like this. I hope everyone is in the same page as I am, right? Now, just sit back for a couple of seconds. Let me give you a walkthrough of IAM portal, right? And then we'll do it. So here under IAM portal, guys, on the left hand side, you can see this heading that says IAM and admin, right? So we are in this particular product or service, GCP service called IAM and admin. And on the left hand side, yes, you will see pretty good options. We won't be doing all of them. We'll just be picking and doing cherry picking and doing some a couple of them, right? And at the topmost, we have IAM. Now, this IAM is basically your identity access management, where upon clicking on this IAM, which is on the current page we are, you will be able to see view by principals. These principals are nothing but you will be able to see all the account of human account. These are human accounts. Okay. So in this human accounts, you can see only one email that you will see yourself email, right? You'll see yourself email, you'll see your name, you'll see owner as a role that is being given to you, right? So currently this GCP project that I'm working on, or what you guys will be working on, only there is one person who have access to this, correct? Now your next question would be, how do I give a new person access to my GCP project and a limited permission, that is a limited rules, correct? To do that, you would see a grant access button here, right? So you can just click on this grant access button and you'll have a pop-up window here, right? So just click on grant access button there, guys. Just click on grant access button and you will be redirected, or you will have this pop-up on the right hand side, right? Okay. Now here you would see the first option that says add principals, right? Now here you can add one or more email, and understand carefully, guys. You can't just go and randomly add emails. You can only add email of a user who has a GCP account. It need not be your GCP or your organization or this. It should be basically whoever you are inviting here, he or she should have a GCP account. How will he or she have GCP account? Basically, GCP account is nothing but using your email to log into this console, right? Because you guys might have account which you are using other Google product, but you have not ever signed up to console.cloud.com with that account, right? So those emails you cannot use, right? So that's why make sure you add here emails, okay, of a user who already have a GCP account, right? So let's say, for example, I would say randomly aman.ula@gmail.com. I know this is not my email, but I'm going to, okay, no, whoever it is, he or she has it already a GCP account. Okay, let me try with Aman GCP training@gmail.com. I hopefully this does not exist. Yeah. So this email does not exist. Yeah. So see, I have written here an email called as amangcptraining@gmail.com, and you will get this error saying email address and domain must be associated with an active Google account, meaning this email has never been logged into your console.cloud.google.com. That means GCP portal, right? Whereas if there is an email like, I think aman.ullah had, right? So imagine if I have an email, and if that person has actually logged into this GCP console, not my project, but his own project, he or she might have created and logged in to his or her also project, you would be able to see them and you can click them and you can add that user by sending invite, right? Okay. So here I have Ajay and then I have Ritikas, right? So now you see here, these two emails I'm able to add. Okay. And after adding this email, right? So you see, I don't see any red color error, meaning what? These three emails have access to GCP or have logged into GCP console, right? So they will be able to access my project. Now, before accessing project, you will see something here called as assigned roles, right? So I'll explain first about roles and then I'll come back here and select a role. Okay. So now we'll talk about a very, very, very important topic in GCP, that is role or roles. Okay. So there are three types of roles in GCP that we have, guys. The first one is primitive or basics, primitive itself, or we can say basic roles, okay, which is at high level. And then we have derived roles. The names might be a little different here and there, guys, but if you understand the meaning, it's fine that we have three types. And what are these three types? And for obvious, custom rules. Okay. Now in your primitive or in basic roles, you will have at high level owner, you will have reader, viewer, and I think owner, give me 1 second, browser, editor, owner, viewer, browser, editor, viewer, browser, right? So at high level, you have only 4 roles, guys. And this role works for every GCP service. If you are given owner permission, meaning any and every GCP service, any operation you can perform. If you're given editor role, it means you can edit. That means you can create, you can delete, you can update any GCP service. Okay. Now, this is at high level, can work at entire GCP project. Okay. Then in derived level, what happens is it is further scrutinized at service level. So here it is at service level. So what it means by service level, let's assume virtual machine is a service. So in virtual machine, you will have permission like VM owner or VM admin. Okay. Then you will have VM editor role. Then you will have VM, you will have viewer role, right? I'm just writing at high level. Exactly the words might not match, but I'm just trying to explain here, right? Viewer, reader permission or browser permission, right? Then you'll have VM connection permission or VM SSH permission. So that would be basically connection, right? Connection permission, right? And then there'll be VM delete permission, right? So I'm just trying to say that it will further be at service level. So if I want to give a user admin permission only for VM and other services, I don't want to give anything, then he or she, what I'll do, I'll come to derived roles. In that, I will select VM admin role, right? And in custom roles, what happens? You can combine 2 or more services role to create a custom role, right? So this we generally do more in organization, guys. Custom role. How do we use this custom role? So we create a custom role called as dev for developer role, tester role, manager role. So manager generally will give them owner and admin roles, right? So that they can access. Developers will only give editor roles. Tester we will give them, right? And if there is some guest user, right, who is coming for some time in this project, we'll give them browser roles, right? So we create custom roles here. Now you will say, why do we have to create custom role when I already have owner, editor, viewer here? Now the thing is, guys, if I give owner or editor, it means owner for all GCP services, editor for all GCP services. But in real life scenario, you will not use all the 200 GCP services, right? So in custom role, what happens? I will say basically developer as admin role in VM, editor role in Cloud SQL, because I don't want them to delete Cloud SQL, right? I don't want to give developer permission to delete anything in database. So I will give for VM admin permission. For SQL, I might select a read permission, right? And then maybe for storage bucket, I might give admin permission, right? So I can combine like this multiple services roles and create a custom role based on my need, right? So if you see the hierarchy in custom role, I can have 2 or more services roles combining. In derived role, I have it at service level. So for every service, I will further have whether for that service admin, reader, writer, and particularly extra roles are there for that service. So if it is database, then you'll have a separate permission for only connecting to database. You'll have a separate permission only to create a backup. So if there is an employee whose only work is to take backup, there is a separate role that is there for SQLs for creating only backup, right? So you will be selecting that. And if you don't want to do that, you want to give at very high level, that is not at granular level of GCP service, then you will go and blindly select your primitive role, which means it will be implied to all the GCP services. Okay. So now that it is clear, and now if I come back to my IAM roles and service, guys. So if now you expand this roles, or you actually select on this drop down of roles, see under basic, you will see 4 roles. That is very high level. Then you would see by product or service. So you see there is a GCP service called AI notebooks. In that you see notebook admin, notebook viewer, notebook runner, notebook viewer, right? Let's say for example, there is a service called as app engine. So in app engine further you will have roles like app engine admin, code viewer. So there is a separate permission where only a user can come and see the code. That's all, right? Creator role, deployer role, manage. You see all these roles are only specific to this service, right? So for every service level, you will have further these roles, correct? So this is what you can have at service level, or at the top, you will see in basic, you will have at high level, right? So if I select browser role here, and now if I click on save, what will happen is these 3 emails, these 3 users will get an email invite. And if they accept that email invite, these 3 users will be able to access my GCP project, the one which I am currently accessing. And they will have only browser role. So they can never create anything. They can just see. They can see I have VM. They can see I have anything, right? Any services, they can see that. They cannot create, they cannot delete, they cannot do any configuration, right? So if I click on save, so it will give them this access, and each of them will be actually shared an email invite, right? Which they accept, they will get access to my GCP project, right? So this GCP project that I am having, this top footing 45, this number, right? This GCP project they will get access to, right? So is it clear, guys? What is principles in your IAM? What is roles in GCP, and how do we invite or add a user to our GCP project, and how do we assign a role to a GCP user or a principal? Cool. So now let's go ahead and see how we can create a custom role. Okay, guys. So what we'll do is let's come up with a use case. Okay. I want to create a custom role for developer, right? So how do I do it? Let's say, for example, let's define what a developer will be doing, right? So the roles that I think, or the services the developers will be using would be, let's say, VM, then let's say SQL database, and then let's say, for example, storage bucket. Okay. And for each of this service, let's say VM, I don't want a user to give permission to create VM, because if I give a permission, a developer can create even 10 VMs and then just log off, right? Log off means he will just shut down his laptop and he'll go away. But those VMs, 10 VMs will be running in the background, even though it's not doing any work, but it will be running, right? So that will actually incur some cost, right? So I want to make sure that this developer doesn't do this, don't do this mischievous job of, creating unwanted, unnecessary, VMs and leaving it, right? So I would give more of a reader or viewer permission where they can read or view. We will see whichever is the closest to our use case, we will give that. For SQL also, I'll only give a permission to connect. I don't want user to delete or create a store bucket. Database, right? Because database are very sensitive, right? If a user goes and deletes a data, then organization will get a heart attack, right? So that's why I'll just give connection permission. So we will see whichever permission is closest to just connecting database, we will give that. For storage bucket, let's say, for example, I will give admin permission. A user can create a temporary storage bucket and they can, store their files, application code, everything, right? And anyways, it's very cheap, right? So I don't mind, if a user goes and creates extra, buckets, I can shell a couple of bucks there, right? So it's fine. So with this, let's say this is the requirement that we get, and this is the role every time we give to a developer who onboards it to our GCP project so that they can do the development. Cool. So shall we go ahead and do this, guys? Create a custom role with these permissions. Okay. So going back to your GCP console, right? If you scroll down a little bit on the left hand side, if you scroll down a little bit, guys, you would see this roles here, right? If you scroll down towards your end, right, somewhere in the center towards your end, you will see this roles option on the left hand side. So just click on this roles here. And then you'll be redirected to a screen like this. Redirect yourself to this roles tab. Okay, so I assume now most of you are in the same page as I am, right? Okay, now here you would see, guys, there are already a lot of roles created, right? So you will see already there are a lot of roles created here. Now what are these roles? So these are the roles created by Google. Google was generous enough to go ahead and take this headache and create roles for each and every service, right? So for each and every service, you see Google has created this role, right? Now we don't want to use this because these are specific to one service. What I want to do is I want to create a role where which is basically 2 or more services I can combine, right? So to create a custom role, guys, on the top, do you guys see this create role button here, right? So you guys will be seeing a create role button on the top of the page, just below your project screen. So just go ahead and click on create role, and then you will be redirected to a page where you just have to fill form. And trust me, guys, it's very simple. Hardly you have to fill 2 to 3 options to create roles in GCP. That easy it is compared to any other cloud providers, right? Okay, so once you're in this page, the first thing you see is title here, right? So title, I'm just gonna give developer role or something like this. A developer role. Okay, I'm just gonna give the name as developer role. In real time, you will not give so vaguely or not at high level. You will in fact give at granular level, right? Whether it's basically, for your application developer or ML developer or Salesforce developer role, right? So based on that, because for ML role, there would be different permissions. For application development developers, they need some other services, right? So the services will be different. So in real time, you will have this developer role also further scrutinize at granular level of roles, right? So yeah, but anyways, for us, we will keep it vaguely developer role, right? And then there is description, guys. Description, if you want, you can add description. I'll just leave it blank. I'm just lazy enough to write a description. Okay, in real time, you'll be writing description explaining what this developer role is and what it will do. Okay, ID is nothing but you will have a unique text. By unique text, you will identify this particular role, right? So for now, let my unique ID or unique text be as custom role itself. Then comes your launch phase. Okay, so I hope this first 3 options is clear. Then comes your launch phase. So is anyone aware of what is alpha testing, beta testing, and general availability? Alpha is initial testing, beta is also initial testing. But what is the difference? See, alpha is also testing, beta is also testing. But what is the difference between these two testing? Subset of users. Both of them have users. Even alpha testing would have a subset of users. Even beta would have a subset of users. I'll explain you guys, right? And I'll take a simple example here. Okay. So let's assume I have a beautiful iPhone here with a dynamic island feature. Okay. So this is my iPhone with a dynamic island feature. Okay. Now, let's say iPhone or Apple takes 6 months to build this new iPhone with the new dynamic island feature. Okay, with a proper notch, with a good animation and all these beautiful things and so on, right? Now, while Apple is building this, who does the first round of testing while it is building itself? What I'm talking about is in build phase. Who does the first round of testing? Developer, right? So developer will become very granular level. At high level, you will say internal testing. That internal testing can be managers, developers, testers, Apple employees. So we can say internal itself, right? Organization, within an organization, correct? Right? So instead of saying specifically developer, we will say they'll basically an internal testing, right? At organization level, right? So yeah, that's all, guys. This is your alpha testing. So alpha testing is nothing but which happens at initial phase while people internally it happens. Developers are testing, employees, basically employees itself, organization, within organization, you're testing. Okay. Then what happens? Then you release it to a wide range of subset of users, as you said, right? Then you release it for public testers, then you will have, correct? So this public tester is nothing but the subset of user that Vijay Lakshmi was mentioning, right? So these public testers are basically nothing but a lot of public who is volunteered to test this, right? So this is what your beta testing is. So if you ever hear something as beta testing, that means it is tested by public, correct? So that is your beta phase or beta testing. So is it clear, guys, the difference between alpha testing and beta testing? Alpha is that internal, the first level where the developer or the internal testing happens. Beta is where they release it for public, right? There will be public who will be testing it. And once public is tested and everything is done, then you make it public. You make it public, or you make it public, or you make it general available, right? Something like that. Something like that, right? So that is your public or general availability once both of this test is done, right? So coming back here, now I'm creating this role, right? Do you think, guys, we as a human, you know that for obvious reason, we tend to make mistakes, right? We can't be 100% accurate, right? So here in simple, guys, we are only working with 3 services, right? But in real time in organization, a developer can have access to like 15-20 services, right? So there can be places where a human can make some errors, right? Maybe might have added instead of viewer admin role, or missed entire VM role, right? I mean, I'm trying to say there might be some mistakes, right? So do you think I make a role and directly make it as general availability? It'll be bad, right? It'll basically be like a bug that will be accessible to entire public, right? So that is why they also created these phases where you can have alpha phases where first you test within your team, then you make it beta test, and then you roll it out to your teammates in a sense, nothing but who actually needs this. Then once, let's say for example, for 3 months there is tested, right? 3 months, let's say the developers did not come back and say that, hey, this permission is missing or that permission is missing, meaning if everything is perfect, there's no permission missing, there's no bug in your permissions, then you can, after a couple of months, I'm just giving 3 months, but you can keep it 3 weeks, 1 week, it's up to your business use case. It's you who would take the decision, right? But let's assume for me, I would, let's say for 3 months, I'll keep it in beta phase, and I'll see if developer raise any bug or raise any ticket saying that some permission is missing. If 3 months I don't see anything like that, then I will select it as general availability, right? And this option, I can always come back and edit this role, guys, right? So I can come back, edit a role, and always change this option. So for now, I'll keep it in beta phase so that I can create this and be it in beta phase so that we will test it properly. Does it make sense, guys? Now, what are these launch phases, right? And the fourth option is disabled. What is disabled? Yes, for obvious reason, let's say for example, if you are retiring a role, you further don't need this custom role. So you can't just go and delete it off, right? Because there might be some users which you might have forgot who is actually using this, right? Some users who might not be, some users who is actually still actively using it, or some users whom you have forgot to remove this roles, right? So in such cases, you can't just go and abruptly delete this role. So what you do is, instead of deleting it, you select it as disabled, right? So that it will be there for some amount of time, and later you can delete it after the audit. Like if no one is using, all good, all clear, you get a green signal, then you go and delete it, right? You just don't go and delete it at the first itself, right? So those are the roles and stages. What are these 4 options explaining here in role launch? So for now, select a beta phase. Select it as beta and just make sure these first 4 options are filled. Done. Okay. So now you can scroll a little bit down and you will see a a blue button that says add permission, correct? Do you guys see this, a blue button that says add permission, right? So just click on add permission, right? So once you click on this add permission, you will see this page, guys, right, which has close to 9,800 permission, right? So yeah, there are 9,800 permission. What is a permission? Permission is further inside a role. A role is list of permission, right? So a permission is like, for this particular service, you have approved permission, dismiss permission, get permission, invalid permission, right? So you will have further inside a role, you will have permissions, right? So if, for example, if I go here and select SQL, I think we were going to give Cloud SQL, right? So if I go and search here SQL, guys, on the filter, right? So here you see, if I select SQL admin role, so in admin role, you will see there are so many further permissions, right? So your role is created, or it is a group of permission. What are the permission? So a admin role will have permission to create a Cloud SQL instance, to delete, to get, to list. List means, in a sense, in your GCP, you can list that, right? Sometimes you don't want even a user to see what are the database, right? Then you will not give this permission. So you will select in admin permission, I will give create, delete and list permission, right? But I won't give anything else permission, right? And that to these three, what we have given is for backup. There are further permission for databases. Then there are further permission for instances, further permission for, let's say, creating SSL certificates. So if you want a user, only admins, if you want that only admins can create SSL certificates for security reasons, then you will only select this, right? So all I'm trying to say is that further within a role, there are permissions and you will be able to select that here, right? So now what we'll do is we will search for these roles that we have mentioned here, right? VM reader role, Cloud SQL connection role, and storage bucket admin role. So first let's go and select cloud bucket, storage bucket admin role, because that's simpler, right? So I'm just going to search. So there are two search options, guys. Okay, let me explain. Please pay attention here. There are actually two search here you will get. There are two filter, guys. Let me explain what each of this filter does, or else you will get confused. And please pay attention, guys. I'm not going to explain this again and again, these two filters. Okay. The first filter is at service level, right? So if you select on first filter, you can select an entire service role. So you can select a role at service level. Second filter is to filter on permission, only permissions, right? So these are the two levels of filters. So we don't use second filter often. Why? Because this is at permission level. I will first select or filter by roles, right? So first I'll go and select cloud bucket role. So I'm just going to say on that first, this one as storage bucket. Is there no storage bucket? Okay, let me say cloud storage. Yeah. Let me just write storage. Yeah. Storage, let's find for storage. Here it is, storage admin user, right? So if you guys write storage on the top, if you scroll down, now again, it should not be compulsorily like you have to select the right roles only, guys, because anyways we will delete this role after today's class, right? So even if you select a wrong one, it's fine. You just have to understand how to do it. Don't worry if it's right or wrong, right? So I'm just going to randomly select this storage admin role here. And in admin, these are the roles of storage. So I'm just going to blindly select all. I'm not going to spend time and properly select only the one which is required for now. I'm not going to do that, right? So I'm just going to blindly select all under storage admin and click on add button. Okay. I will repeat again the step, guys. Please pay attention, right? So let's assume I want to add a role here. So what I will do in add permission, first I will filter by the service role. So for example, now I'm doing to Cloud SQL, right? So I'll search for SQL. So in SQL, let's say for example, I want to give editor role. So I will select this editor filter. So now what happens? Out of 9,800 permission, it will drop down to 80 permission. Why? Because now it is only listing all the permission related to Cloud SQL editor role. And within this further, what all you want based on your requirement, you can check that box and say add. And that roles or that permissions and roles will be added, right? So this way, an actual cloud admin team will sit and create and assign properly all the permission that is being required. So I know in real time it is a tedious job because you have to validate whether this is required or not required. But for now you can randomly select. We are just doing for learning purpose, right? So please go ahead and randomly select some 10 to 12 permissions. Okay. Now, once you have added, guys, this permissions, just scroll down and click on create. Guys, don't you think this is way simpler than any other cloud service that you might have learned, right? You just gave a title, selected a launch stage and just selected the permission and clicked on create bucket, create option or button, right? Don't you think this is very easy, guys, in GCP? So this is why GCP has made it easier, right? AWS is also same for now, but by the end of this course, you would say, yes, GCP is far more simpler, right? Because every service you'll see, it is as simple as how you're seeing right now, right? That simple GCP has made it. But in AWS, I feel it's more complicated because you have to configure a lot of things. There are a lot of customizations that they allow, right? Which is good, but it's not quick and easy compared to GCP. I mean, again, it's my thought, my opinion. It might differ from others also, but yeah. Okay, so please go ahead and click on create button, and that will create our first custom role. And you would see here, guys, in use also, you will see here it as custom, right? Because this is a custom created, correct? Okay, so now we have created this custom role. Now that we have this custom role created, we will try to assign this custom role to a user. Let's see how we can attach this role to a principal, meaning a human account, right? So to go to human account, I will scroll up and I'll go back to this IAM option, guys, on the left hand side, right? So I'll go back to this IAM options that I have here. So I want you guys to click on this IAM option here that we have, guys. Okay. Now, once you are in this IAM page, guys, you might have added some users, right? Just click on edit if you have added a user. If you have not added a user, just click edit on your email itself, against your email itself. Just click on edit button and we will assign a new role. Let the role be there as it is, the whatever base role we had. We will assign another role. Okay. And we will click on add assign another role. And here now you will see a quick access called as custom. And in custom, you will see this custom role that we created, right? Or you can even search here. If I write developer role, wait, what is the name of my role, guys? Is it custom role itself? I did not change the name of my role as developer role. So I think I did the mistake, guys. I forgot to rename it. Yeah, you see, I kept it as this itself. Let me go ahead and quickly edit it as developer role. But I wrote it as developer role. I don't know, it might got have refreshed. Oh, I just refreshed my page, right? Yes. In between, I refreshed my page because my browser was not working. That's where it actually. Yeah. Now I get it where that mistake happened. Anyways, so now I'll go back to this and I will say add another role. And here under custom, we will see developer role, right? So if you select developer role and you can click on save. So what happens? That role is added to that user. So now that user will be able to, let's say, create, delete, or whatever role you give, that he or she would be able to perform. Does it make sense, guys? So you see how simple it is, right? To even attach the new role, right? Okay. So now I would request you guys to go ahead. And again, guys, please pay attention to what I'm saying. If you guys have added additional user, except your email, if you have any other user, go ahead and delete those user. Okay. Just select them and click on this button that says remove access. Again, I'm saying, please don't do it for your original email, your account. Please don't do it. Apart from that, if you have added any other user email, for those users, just go ahead and click on remove access. So that is going to remove access to all the users. So they will no longer have access to my GCP project. So it's as simple as now they don't have access to it, right? Because we are done with principles now, but don't delete your role. Let your role be there, because now this role I have to attach and we have to learn about service account, right? Where is my service account? So we still have to learn about service account right here. So we still have service account, right? So let your role be there, custom role, right? So we will delete it later after doing service account. Okay. So now we will, guys, learn about service account. Now I mentioned, right? Principles are basically for humans, living beings like us who breathe. Service accounts are used for basically a non-human or non-living beings, right? Like device and application. What is an example use case? So let's say, for example, in your mobile, you want to authenticate to, let's say, Google's database, right? Or let's say, for example, you have written an application or you have built an application which uses Google AI service to convert text to speech or convert from one language to another language, like how in Twitter, like how in X, you have, like, if you see tweets, below tweets, you'll have a small button that or option that says translate to English, right? So let's assume you are building some application where you're translating from one language to other language, and Google has that model or AI service. So if you want to use those, you want to authenticate your application, right, to use their API. So in that authentication, you cannot pass human email and human password. That would basically, as I said, it will not be wiser, and it's a security concern, right? So in such scenarios, when you're using application or you're using a device where you're trying to access a GCP service, you will be using a service account, right? And this service account will only be at your code level, guys, meaning where you're doing developing code, there you have to provide this. You don't have to provide in actual mobile, or you don't have to provide it to billions of users. No, only at your code level once you have to provide, right, in your server. That's all. Okay, so technically it acts same as a human user account, but the only difference is a human will have an email and password through which you redirect use browser to log in. Here it will create a temporary email, and the password will basically be a key. It will create a key in a file and it will download those information. That key is very important. That file is as important as your password. You can't just go and share that password across WhatsApp or across Teams chat or Zoom chats to your employees or colleagues. You can't do that. That key file is as important, as sensitive as password. So you should make sure you encrypt it and then share it across, or just right sources, right person have access to those keys when they're developing, right? So we will be looking into that service account right now. Now, to go and create a service account, on the left hand side, again, if you scroll down a little bit towards your end, I think not towards end, here itself. So no need to scroll down, guys. At the top itself, somewhere in the middle of the screen, somewhere in the center, you will have this option that says service account, right? So just click on this option that says service account, and you'll be redirected to this page here. Okay. So now that you guys are in this page, you can see an option or a button that says here, create service account. Okay. And click on that button that says create service account. Okay. And then you will see this service account name. What is this service account name? It's just name to your service account, right? So you just give any name. Let me give a dummy -account, or you can write anything as you guys want. In real life, again, you will not write like this. You in real life, you'll write properly with project name, what use case and all, right? So like that. So yeah, just make sure you give any name. Okay. Then once you give a service account name, guys, then you will see that an email ID will be created. That is service account ID. That if you see email here, you see dummy-account @ your project id.iam.gservice.com, right? So this is that email that it will create, right? That you will use for authentication at your device or code level, right? Description, again, I'm lazy to write. You guys can write a description if you want, right? So I hope this first two options verified, right? I mean, first option is verified, right? Whatever you write in first option, that actually gets copied to second one, right? So here we have created service account email. So your next option would be create and continue, which will jump to second option. So click on create and continue. Then that will take me to second option, where I will grant a role here, right? So this is where I select a role here, guys. So I can select a custom role and this. The only difference is, guys, if I do it to a principal, then a user, human, will have the restriction. If I do it to service account, that means via code, I will be able to create VM. Via code, I'll be able to delete VM, right? So same things can be done, but at code level, right? So that's why in service account, actually, we give few permission, guys. We don't give admin permission no matter what, right? Because admins, this service account will be used at code level. So for human, we might create a custom role with actually more permissions, but in service account, we will create a separate custom role with even more fewer options or fewer roles. And if we are giving also, we will give the least privileges, right? Because it's via code. Imagine if you give a developer role same as a human, that means via code you can go and delete VM, via code you can create VM, right? Which can be devious, which can cause harm, right? So that's why in real scenarios, you create a role with further more fine-grained minor permissions, right? But for now, for our case, just imagine that this developer role is actually what we need, okay? And then you can simply click on continue. Okay, then you can click on continue. Then it will take to this third option. So in third option here, you will write basically which user can use this service account, meaning which principal, which human can see and use this service account. So there can be scenario, guys, where you basically have 50 members who is having access to your GCP project, right? There can be 50 developers having it, but you don't want every developer to see or use this service account, right? You might want to give it to that 1 or 2 leads, right? So you can just write their emails here. You can copy paste their emails here. So those users will only be able to see or use this service account, right? But if I don't give anything, if I keep it optional, that means if I don't give anything, that means everyone in the GCP project will be able to see this, right? Which I am fine with. For now, my use case, let it be as it is, right? So I'll simply click on done. So go ahead and click on done and create your final service account, guys. So you see my service account is successfully created here, right? Okay, great. So here you see we have only created email, guys, here, but we did not create like a password, right? And I said in service account, there's no password. I said there will be keys. So we did not create any keys, right? You see there is no keys, right? So now we will see how we can actually create keys, right? And I said that key is as sensitive and as equivalent and important as a password, right? So to create a key, guys, you can just click on this service account. Okay, just click on this service account. It will take to a page where you can see the details of the service account, like whatever option you fill, right? You'll just see those details, correct? So just click on that service account first. Okay, and then do you see this third tab or third option here on the top that says key, right? You see details, permissions, and keys, right? So just click on this third option that says key. Okay, then below you can see a button that says add keys, and below that you will see a table where you can see all the keys that you have created. Now a good thing about a service account is, guys, you can create multiple keys which equivalent to multiple passwords, right? So let's say, for example, there are 2 teams who wants this service account. You can create 2 keys and give independent keys to them, right? Both can do the same task and you can keep well defined, right? Rather than using 1 key for everything, you can create multiple keys and you can give them, right? So we do have options to create multiple keys also. So you can see all those keys in this table here. Now it's empty because we did not create any keys here, right? So you can just click on add key here, right? And then click on create new key. So if you click on this button that says create new key, you will be redirected to a pop-up which will say you which format do you want to create your key file, whether a JSON or whether a P12, which is basically it was for your legacy. This one for now it is JSON, right? Which is recommended and default. So we will keep it JSON itself. So select it as JSON, guys, and then click on create. So that will actually download in your browser, whichever is your browser. You see, it will download a JSON file. This JSON file is very important. As I said, it's as equivalent to as a key. It's a key basically, right? So now you will see this key, right? Now, if I open up this key, guys, this JSON, and show you what this contains. So I told you, right, this is as equivalent to as your password. So this JSON file, if you give it to your code, I mean, wherever you're writing code and you're using GCP service, if you pass this JSON file, see here, your project ID, your private key ID, your private key value encrypted. You see, it is encrypted, guys. The password kind of thing, right? Your private key is encrypted here, client email, client ID, the authentication URLs, the URLs where it will go and validate these keys, right? Everything detail is present in this key files, right? So this is very important. And I said as equivalent to as your password, right? So these values, these files should be not just shared across email or Teams or given to your colleagues. No, you should actually keep it secured, right? So using this, you can authenticate and use GCP service via your devices or your code or application. So we will be actually creating a service account and using it when we are learning or doing GCP AI/ML service. So in GCP AI/ML service, we will be using GCP APIs. So in that APIs, we will use this service account to authenticate and use GCP AI models, right? So in that, there you will see how to use it at code. but use case is clear, right? When do we use this? At code, while you in device and code or application level, that is understood, right? Okay. Yeah, so let me go ahead and do that also from my end. So I'm gonna simply delete this key by clicking on delete, and then once this key is deleted, then I'm going to delete this service account also. And then once I've deleted this service account, I will go ahead and delete the roles also. Right? So the role will not be deleted on the spot, guys. It will just be grayed out, right? But it won't be deleted. The reason being because in the backend, it will first test, right? This role is not being used, or it should not break something else, right? So first it will do the test and later it will delete. So currently it's a soft delete. Automatically it will be disappeared once the Google runs and Google's run is complete, right? Those checks are complete. So we have cleaned up all the resources that we have done, right? So a quick recap of what we have done so far before we proceed to the next topic, right? So that is all with respect to your GCP's IAM roles and services, right? So in IAM, we first understood what is your access management and who do we do access management, right? We do it for an identity, and an identity is basically a human or a device. It's like a thing, right? And then there are two levels of IAM that we handle in GCP. One is at principal level, another one is at service account level, right? So principal level is nothing but a user or a human level. So each user or group of user you can add or you can remove access, right? And then service account is where via code level you give them access to device and application, right? And how do I control this? I control this via roles here. Roles is something that we create. Via this role, we give access, we handle access for a user, right? So I hope it is clear, right? Then in roles, we have further three types. We have primitive roles, which is 4 roles at high level. Then we have derived roles, which is basically we actually have role at service level. Further at service level, we have a role. Then we have custom roles here, where what we'll do is we will combine 2 or more custom, or we will combine 2 or more roles and permission service level and create a custom role, which we did like creating a developer role, right? Right. So that is all with respect to your GCP IAM roles and services, guys. Now, the next topic that we will be going and doing is GCP networks. Okay. Now, going back to your GCP network service, before we start with GCP networks, we'll get on with some basic theoretical concepts, right? The first and the foremost theoretical concept, guys. What is IP, or not Indian patent, but Internet Protocol? Yeah, it is set of rules, or it's a unique address. It's a unique identifier basically, right? But unique identifier for what? And from whom? What and whom? What you guys have answered for a website, right? It can be website, it can be a host, it can be a server, right? Yeah, whom part I answered. Whom part is basically the website, application and server. So for these things we will use internet protocol, but for what purpose we use this and where do we use this? So your internet protocol works and is majorly for your internet itself, right? You can't use this internet protocol on your house address, right? So these are defined only for your network configurations, for your network communication, that is internet communication, right? So your internet protocol, right? Your IP address is basically an address. It is a unique address. How it would look like? Again, I am only considering IPv4 and explaining. So assume your IP would be a unique identifier would be something like this: 178.168.78.9, something like this, right? So assume this is one of an IP address. What is this IP address? This will be a unique address of, let's say, my laptop. So if my laptop connects to internet, this is the address of my laptop. So if I say google.com, so the server will know that google.com response I have to send to this IP address that I have here. That is my laptop, it should come, because there are millions, in fact there are trillions of devices on internet. How will it know that this packet or this data should go to that device? By using this internet protocol. Yes, what is this internet protocol and how it helps is it's clear, right? To uniquely identify in your internet, this is required. Okay. Now let's talk about something known as your CIDR range, right? So the full form is classless inter-domain routing. Okay. Now, what do we use this CIDR for? It's a range. Okay. Now, so you know, guys, our IP address will be created like this, right? And in IP address, you can't just go and randomly set a name or set a number, sorry, right? Because in an IP address, okay, in an IP address, if you carefully look, guys, I will have point separated and I will have 4 values and each value is 8-bit. 8-bit in a sense, each of this, okay, values can be between 0 to max 255, right? Each of this, right? So in total, I have 32-bit of my IP address range, right? But for each of this, 8-bit is allocated, guys, right? Octets, blocks, yes. So for each of these blocks, you would have 8-bit allocated. So a number within this block would be between 0 to 255 for each of this, right? That means what? I have a minimum number and maximum number, right? So I can have at max trillions of possibilities, because see, there can be possibility of 0.0.0.1. I'm just giving an example. Then 0.0.0.2. Then it can go all the way up to 0.0.0.255. Then again, I can start 0.0.1.0. Then again, I can start 0.0.1.1. Then so on, I can go up to 0.0.1.255. Then again, I can go on, right? So you see, the permutation increases, right? So I can have trillions of IP address, right? Meaning trillions of devices I can connect, right? Now, I can't just go and write like this IP address, right? Now, imagine if for my organization, I need 50 IP address, right? So what would I do? Would I go and write 50 times 179.168.11.1? Then I'll say 179.168.11.2. So on, I'll go and say 179.168.11.50. Would I go and write like this 50 times IP address? No, right? So we will basically have basically a subnet range that we will give. We will give a range and we will create a range, right? That range is called as your CIDR. So this CIDR is basically a way where you can provide range and you can create a dynamic IP address here. How does it work, guys? I'll tell you. It's very simple how your CIDR works, right? So I told you, right? Each of this block is 8-bit, guys, right? Each of this block is 8-bit, correct? So in total, how many bits you have? In total, I have 32 bits. Okay. Now, let's assume I'm starting my IP address as 168.172.0.0. Okay. This is my base address. This is my starting address. IP address, that is, how do I get this address? This is allocated by your internet service provider, guys, right? So your internet service provider will be giving you this, right? And it will differ based on region, differ based on your internet service providers, right? So let's assume this is the IP address I got from my internet service provider. Now I need 50 IP addresses. So if I need 50 IP addresses, then what will I be doing? Instead of writing 50 times, right? Or let's say, for example, I need 1000 IP address, something like that, right? So what I'll do is, or let's say, for example, I need 256 IP addresses. Okay. If I need 256 IP addresses, don't you think only this last block suffices my work? Between 0 to 255, I'll get 256 IP address, correct? So which is the only dynamic block, meaning the block which value will change? Only this block, right? The first 3 blocks will be static, right? So if I write 168.172.0.0/24, what does this 24 mean? Meaning the first 24 bits will be static. It is fixed. It cannot be variable. It is fixed. Then how many bits are remaining? 32 minus 24, that is 8 bits. That is, this last 8 bits is variable. So I will be able to create 256 dynamic IP address, right? Now, assume I want to create more. I need to create 1000 IP address, right? Or I need only 5 IP addresses, right? Or I need only like 16 IP addresses, right? So in such scenario, what you will do, you can give like custom /30 also you can give. Then you might ask question, how is /30 possible? Because I said here each of this is 8 bits, right? Now, let me further tell you, visualize each bit as a block, guys. So 1, 2, 3, 4, 5, 6, 7, 8, then my block end. 1, 2, 3, 4, 5, 6, 7, 8, then my block end. 1, 2, 3, 4, 5, 6, 7, 8, then my blocks end. Then 1, 2, 3, 4, 5, 6, 7, 8. So imagine out of 32, 30 blocks. If I give /30, that means these 30 blocks will be fixed. Only these two will be different, guys. And just imagine the possibility would be 0, 0 in binary number, 0, 1, then 1, 0, 1, 1, right? So if I give /30, then I'll be able to only get these many IPs, right? I can have only these many possibilities, right? So I can have only these many IP address, right? So all you have to understand is, guys, this CIDR range is for providing you set of IP address. Rather than you go and writing 100 IP address, you create a CIDR range here, which will tell you how many IP address you have. Now in detail, there are more to this. At high level, I'm trying to make you understand. Now you would say, hey Aman, how can I just go and if I need, let's say, 16 IP address, or I need 1000 IP address, or I need 16,000 IP address, I can't just go and sit and do this maths, learn about these blocks, right? You don't have to do that. In real time also, we don't do that. What we will do is, we will just go to any website, online CIDR calculator, any website you pick, randomly any website you pick. I'll just pick the first one, but you can pick any website. And there you can give your, let's say, for example, 179.168.0.0. Then see, if I give /28, that says I will get one IP address. If I, oh no, what did I give? I gave /32/28. So see here, if I give /28, that means I'll get 16 IP addresses, right? If I give let's say 30, see here, I will only get 4 IP addresses, right? If I give /24, I will get 256 IP address, right? So based on this, based on your requirement, if you need how many IP addresses, you can go and create a subnet range with this CIDR range. If the number of IP change in later point things progress, then CIDR can dynamically increase. Yes. So if, let's say, for example, you have one machine assigned, right? So this IP address will be assigned. Then the next machine, this automatically does that. Let's say, for example, you delete this machine, then it will clear off and again do that. So those things internally GCP will handle. When you create your subnets and all that, GCP will handle that, right? But in real time, you understood, guys. So instead of you writing IP addresses range, right? Like how, if I explain you in simple words, guys, if I want to write number between 0 and 100, I'll not write 0, 1, 2, 3, 4. What I'll do, I'll write 0, then I'll put a long hyphen, and then I'll write 100, right? Something like that in IP worlds. We will give the base IP address, and based on how many IP address I need, I will give the CIDR range, like /24, /26, and then I will get to know how many IP address I will have. So this will basically give me from 179.168.00 to 0.64 also, right? That will give me 64 IP addresses, right? So this CIDR or this subnet is only important to get you a range of IP address. Is it clear, guys? The topic of what is IP address, what is your CIDR? It's just a range to give you a minimum and maximum. You get that X amount of N amount of IP addresses within that range. So for that, we will be using this. I hope you understood the basic. I'm doing all this before starting GCP network, because there I have to make sure you guys don't get confused when we are writing or we are creating subnets, right? Cool. Okay.
Just a quick info, guys. Intellipaat brings you executive postgraduate certification in cloud computing and DevOps in collaboration with IAM IIT Roorkee. Through this program, you will gain in-demand skills like AWS, DevOps, Kubernetes, Terraform, Azure, and even cutting-edge topics like generative AI for cloud computing. This 9-month online bootcamp features 100+ live sessions from IIT faculty and top industry mentors, 50+ real-world projects, and a 2-day campus immersion at IIT Roorkee. You also get guaranteed placement assistance with 3 assured job interviews after entering the placement pool. And that's not all. This program offers Microsoft certification, a free exam voucher, and even a chance to pitch your startup idea for incubation support, up to rupees 50 lakhs from IAM Divya Sampark. If you are serious about building a future in cloud and DevOps, visit the course page linked in the description and take your first step toward an exciting career in cloud technology.
Fine. Now, we will get started with GCP's network. Start with some basic networking concepts, and then we will get started with GCP's VPC network concepts. Okay. Now, before we actually start with that, let me quickly take an example here, right? So let's take an example of a building. Again, I'm sorry for my bad drawing. Or yeah, let's take this building. Okay. Now, what are the kind of networks that you guys are aware of? You might have heard about, right? You might have heard about LAN, WAN, and MAN. Do you guys recall this, guys? The types of network that we might have studied, right? So if you guys recall, somewhere in your, I know, I'm not sure if you are in this domain, but if you are not, then you might have studied this in your colleges or in your universities, right? Types of networks: LAN, WAN, and MAN. LAN stands for your local area network, WAN stands for your wide area network, MAN stands for metropolitan area network, right? Now, what are these? A quick one-liner. So your local area network is more like it's a network that's limited to a local capital, right? Like, let's say, for example, a floor, a house, or a building, or an organization, right? Now, let's assume this is my organization, right? Now, in my organization, if I need a private network, right? So what will I be doing? I will be creating a private network such a way that only within this building that network will be accessible. Outside this building, it won't be accessible. How do we do that? So let's say each floor, we will have cables connected, or hubs or Wi-Fi routers connected to a hub, right? And for each floor, let's say, for example, all these tables will be connected to this hub, correct? So this is an example of your LAN, or your local area network, where this network is private, right? And all these floors, all this entire building would be connected to your LAN. Henceforth, it's a local area network. Okay. Now, once the range is actually increased, okay, so once we increase the range from, let's say, a large range, right? Like, for example, this is somewhere in India, and let's say this is somewhere in Japan. Okay, my organization is somewhere in India and somewhere in Japan, right? Now, if I want to connect both of them, right, I would have one local area network here. I would have one local area network here, and I would peer, or I would connect both of them, right, via internet, or via maybe a private VPN or something, right? So this would have been an example of your wide area network, where you are covering a wider range, right? You will have access across a wider range. Okay. And in metropolitan area network, what happens? It's like across cities, across countries, you'll have connection, right? Now, this happens when you are physically having your own server, right? In your organizations, your entire building you will make private, right? Same way, since GCP has its own data centers, so what GCP does is, GCP, let me come to this part now. So where your GCP, okay, across globe, it will have multiple data centers across region, across globe, right? It might have multiple data centers. So what are these box? These are basically your DC data centers, right? Now these are the data centers. Now these data centers are also having a local area network. That means it has a private network, right? That means no one from outside can connect or use anything that is inside this GCP network, right? All of this are made private. The entire network is made private. Then how do these actually communicate? They communicate via GCP's network. GCP has its own private network. If you guys remember, right? GCP will have its own network here, right? Plus GCP uses internet. It uses both. It uses internet plus it uses its own private network, right? So this green is nothing but like a connection. GCP having its own private connection, like own private internet kind of thing, right? That kind of network GCP has, right? Now, with these kinds of network, what happens is if you create any resource here, right? So if you want to, let's say, for example, this is India, okay, data center. This is US, right? This is Japan, right? Let's say this is Australia region. Let's say this is Europe region, right? Let's say this is North America region, right? So for each region, your data centers, if you want to create or use any servers or any service in that region, it will be actually given from this data center. From this data center, that particular VM, that particular storage disk, that particular whatever service you'll be using, right, will be actually leveraged from that data center that exists there, right? And it will be private to that. So in short, all I'm trying to say is GCP has its own network, okay, and it's completely private. So once you create your GCP's project, in that GCP project, you can create your own network like this for your services, that is VMs, storage buckets, or you want to create data disk, or you want to create data drives, you're going to create SQL database instance, be it anything, everything can be inside your own network, right? So that network on cloud is called as your VPC. That stands for your virtual private cloud, right? Which basically is nothing but like a virtual cloud, right? Now, this virtual cloud, how does it look like, right? So it looks something like this. You have your GCP project, okay, GCP project, okay. Inside a GCP project, you can create any amount of private network. So a private network would look like this, okay. And this private network is global, meaning you can actually create a private network for all the data centers combined, right? Meaning if I create a virtual machine from India region, and if I create a virtual machine from, let's say, Japan region, and both of them will lie under same VPC, that means it will be private, right? So I can create n number of VPC in a GCP project. And within this VPC project, see here, guys, each region, right, is a different geographic location, right? Why I'm trying to say this, because let's assume each of us are from different, let's say, city, state, country, or continent, right? Do you think our internet service providers would be same? Do you think our IP addresses subnet would be same? No, right? Every internet service providers, every region wise, every country wise, the IP addresses would be different, right? So similar way, because of here region difference, right, and the internet service provider difference, each region will have its own IP address, right? So if you go ahead and create a virtual machine in India and make it private, maybe your IP address would be 168.192.1.1. I'm just giving example. And if you create a virtual machine from Europe region, maybe it might be 176 or 172.168.1.1, right? So because those are basically physical location, they have their own data centers, they have their own internet service providers. So because they have their own internet service providers, the networks would be different, right? So that is why, because of this geographic location, right, each IP address would be varying. So what GCP is done is that for every region, guys, every region, okay, every region is nothing but a data center. So if I say India region, meaning India data center, right? So for every region, GCP has its own subnet range. Why the subnet range will be different? Because of geographic location, because of internet service providers are different, right? So for each region, GCP will have its own subnet. What is this subnet? Subnet would be nothing but an IP address assigned, right? You will see a subnet which will basically be an IP address range that will be defined using CIDR, right? So for each region, I will have like this bunch of subnet, okay? And when I create a VM, I will be selecting a region, right? So if I select India region, then it will be using this India region subnet, and from here an IP address will be assigned to me, right? If I create from this Japan region, so an IP address will be assigned from this Japan subnet, right? So these subnets are regional. Why regional? Because for every region, that is every data centers, my IP address will be different. But my private network is global, right? My private network is global here, meaning it will be only once created, and inside it, I will have subnets for each region. So it's a private network. A subnet would basically be an IP address range, right? Like say, for example, if I create a subnet for India, Mumbai region, Mumbai data center in Mumbai, right? In Mumbai, India, if I create a data centers, okay, so it might have a subnet, right? Like 172.10.10.1/24, something like this, right? Or /32 or 30, right? So this is your subnet where you create an IP address range, right? So that is your subnet. So each region, now when I tell region, guys, it means every data center. So I have data center in Mumbai, so I'll call it as Mumbai region. That means nothing, but I'm calling it as region, but I'm indirectly pointing to Mumbai's data center, right? So each region will have its own subnet because it's a different geographic location. It has different physical devices. It has different internet service providers, right? So that's why subnet will be different, but your private network will be global. That is clear, right? So if I create a virtual network in my GCP, it's private to all the data centers. But if I create any resources, it will be with respect to a subnet, because that resource will be created in that region. And because it is in that region, it will use those regions' IP addresses. Okay. And within a region also, guys, let me tell you one thing. Okay. So this is a GCP's region. Okay. A region is nothing but a data center. But within region, it is further divided into 3 parts kind of thing. That is separated by few kilometers, right? A data center will not be like simply 1-2 kilometers, guys. It will be hundreds of kilometers, right? And it will be separated by kilometers. So I would have a very huge data centers separated by few kilometers, and I will further call it as zone. So I have zone A, zone B, zone C. So minimum we have 3 zones. Apart from that, if they want, they can create more zones, right? But every data centers, they will have 3 zones. So what is the zone for? For fault tolerance. Now, what is a fault tolerance? Let's say, for example, I have lot of data, I have lot of servers in zone A, right? So these will be backed up at zone B and zone C. It will be replicated, so that if for some unforeseen reason, if my entire data center at A, due to some, let's say, natural calamities, or due to some reason, or due to fire, or due to any calamity, if entire zone A is gone, it will have backup from B and C. It can quickly spin up. So that is why further region is further divided into zone, and it is separated by kilometers. Why it is separated by kilometers? So that if there's any calamity, so that only one zone is affected, others can stay safe, right? If all of them are very nearby, then all of them will be affected, right? So that's why we don't have to dig into zone level, but I'm just saying for information level that each region, that is a data center, is further divided into 3 zone, minimum 3 zone, for such reasons, right? Backup, fault tolerance, right? Because imagine if Google is serving thousands of clients from this region and entire region goes away, entire data, everything goes away. It'll be a huge business loss, right? So that's why they have multiple zones, so that they keep backing it up, so that if anything happens, they quickly have the backup, so that they can serve the client. Because on what basis are they actually getting the client? Saying that we have 99.99% SLA, our data centers, we have backup, we make sure all your data is secured. So if they are telling those things, they have to cater those things also, right? So that's why they have to do all of this. And GCP, not just GCP, but every cloud provider does it, right? Okay. So that being said, so shall we jump into hands-on and create our first VPC, guys, in our GCP? Okay. Before that, there's one more thing to understand, guys. Okay. So in GCP, there are two ways you can create a VPC subnet. Okay. So in your GCP VPC, when you're creating a VPC inside your GCP, there are two ways you can create a subnet, guys. Okay. Give me 1 second. Let me quickly do that. Okay. Now, this is your auto mode VPC. What is an auto mode VPC? Its name is auto mode VPC, but don't get confused. Subnet is auto, not the VPC. Okay, don't get confused by the name. It is auto mode VPC, but auto mode for subnet, because VPC is global, guys. VPC is not regional. VPC is global. Okay. What happens in auto mode is, in auto mode, it is the simplest mode to create a VPC. You just create a VPC, and for every data center, every region GCP has, it will go ahead and create a subnet, right? So it will create like this close to 32 subnets. For every data centers, it will automatically go and create this subnets, right? So if you want to go and create a VM in any of these 32 region or data center, you can go and create it, right? Whereas in auto mode, what happens? Sorry, this is auto mode. Whereas in custom mode, what happens, right? So in your custom mode, you will not have subnet created automatically. The word auto means automatic, right? So automatically it won't be created, guys. You will have to manually go and create subnet for every region you want. So if, for example, you are building an application where your customers will only be from US, then why would you simply create a subnet for a Japan region or India region, right? So such scenarios, you will create a custom mode VPC where it is not a custom VPC, it's a custom subnet. So in custom subnet, what happens? You have the freedom to create one or more subnet in whichever region you want. So I can create one subnet in US Central data center or region. Then I can create one in, let's say, US West region. And then I can create one in US East region, right? So based on my requirement, I will create subnet here, right? In auto mode, what happens? It creates like this subnet, but it creates for every data center, every region, it will create automatically. And the subnet is fixed, guys. When I say subnet is fixed, what do I mean by that? So here the subnet would be, for example, 10. I'm just giving an example, 10.10.0.0/20. So this CIDR is fixed, guys. And even the IP address is fixed. This IP address is private IP address. Okay. You cannot access this from internet. So the IP address and even the CIDR is fixed in auto mode. You cannot change it. Okay. For every region, it will give like this. So for, let's say, this region, it will be like this. For other region, it might be like 10. Let's say 15. Like this, right? So the CIDR and IP address will be fixed in auto mode. Whereas in custom mode, you can create your own CIDR range, own subnet. So I can say for US Central, I can give 110.110.0.0/ I can give 28 also. It's up to me. Why? Because it's custom. So in custom mode, very importantly, in custom mode, I can give my own private IP address. Again, I'm emphasizing on this word private. So whatever IP address you give here, you can't just go in Google and write that IP address and it will work. No. Why? Because it is not public. It is private IP address, right? So private IP address, you can customize, and you can customize your CIDR range also. Whereas in auto mode, IP address, private IP address is also fixed, and even the CIDR range is also fixed. /20 means, I think, how many online CIDR calculator? If I say /20, let me say 10.10.0.0/20. So by default, you will be able to create 4,000, approximately 4,000 IP addresses, private IP address in every region in /20. Whereas in custom mode, based on your requirement, you don't need 4,000 IP address. You need only 2 IP address, 4 IP address, 10 IP address. Based on your requirement, you can write custom IP address and custom subnet CIDR range for custom mode, right? So is these two modes clear, guys? Auto mode VPC and custom mode VPC. Name wise, it's auto mode VPC, but it is actually for subnet, auto subnet and custom subnet. We'll create even an auto mode VPC and we will also create a custom mode VPC. Okay, cool. So let's go back to our GCP console, and on the top GCP console, just search for VPC, guys. Just search for VPC. And once you search for VPC, just click on this option that says VPC networks. Just search for VPC networks. And then it will redirect and it will actually ask you to enable this API. Because we are doing it for the first time, guys, we have to enable these APIs. Only after enabling the APIs, you will be able to use those services, right? So just make sure, go and enable this API. This will take some time. Yeah. So see, my API is enabled and now I'm redirected to this page. So do you guys see here? So you guys, everyone will have a VPC here already created for you called as default, right? If you guys see, you will also see this default VPC name, right? The reason because this is a default VPC created by GCP. Because the way this sample project was created for you, right? That is basically the first project. Same way they have created a default VPC for you so that you can directly come and create VMs or you can use any services, right? You don't have to create a VPC. So this, if you click on this, you see what is the mode? Mode is an auto. Auto means what? It's an auto mode VPC, meaning for every region you will have a subnet, right? So to see that, you just click on this default, guys. Just click on this default here. And then you will be redirected to this page where you will see default or you will see all these options. Click on subnet. So if you click on subnet, then you will see for every region, this region is nothing but a data center. There is a data center in this region. So for every region, you will see a primary IPv4 range. What is a primary IPv4? This is your private IP address with /20 and the IP address is fixed, guys, right? So this is the subnet range, CIDR range subnet created for that region. So if I go and create a VM from US Central 1, it will create an IP address, give me an IP address from this range. If I go ahead and create a VM from US East, then what it will do? It will create a VM and give me IP address from this subnet. So now you understood why for every region it's need a subnet, because it's a physical, every data center is a different location and physically it's different devices and different internet service provider. So that's why it will have different subnets, right? You see, so there are close to how many? 39. Okay, they have close to 39 regions, 39 data centers, and you can create service in any of this 39 data centers. So this is your auto mode. So we will go and create this right now. Okay. Now going back, so I'll click on, so if you're back here in the same VPC page after going back, so on the top, you will get this button that says create VPC button. So just click on that create VPC network button and you will be redirected to a page like this. Okay. So now we will try to create a VPC. So here you see it's asking a name. So what we will give the name here? Let's give the name as auto VPC. Auto-VPC. I'm just giving a VPC name, guys. In real time, you will not give like this auto VPC. You will give your project name, hyphen, those, what all this, right? You will have your different naming convention, right? But yeah, here we will give for now auto VPC because we are creating an auto VPC. Then after that description, again, you guys want, you can give description. I'm just lazy enough to give description, so I'm not going to give description. Okay. And then comes your maximum transmission unit, or called as MTU. What is this MTU? Your MTU is nothing but, guys, baud rate. Now, what is a baud rate? So your MTU, or also called as baud rate, is nothing but it's bits per second, right? So how many bits of packets or data will be transferred can be transferred per second, right? So here if I have 1460, meaning what? 1460 bits of data will be transferred per second. Then I have 1500 and I have 88696, right? Now your question is, when do I choose what? So it depends on your use case. Obviously, if you have an application in production where you will have a lot of transfer of data. What is a transfer of data, guys? Sending a request to your server. When you deploy an application, a lot of user is using your application. All these are nothing but transfer of data or packets, right? Between your internet and your GCP's server, right? So if you are having lot of such transactions of data and packets, then you will obviously go at higher baud rate like 8896. But for our project case, we will keep it default 1460, which is the smallest, because we will be hardly doing any transmissions, right? So we will select the default. But you guys understood, right? What is this MTU? That is your maximum transmission unit, or even called as a baud rate, which is nothing but bits per second. How many bits of data will be transferred per second? Okay. Then comes your subnet creation mode. How do you want to create a subnet? Remember, I told there are two ways you can create a subnet: auto mode subnet or custom mode subnet. So for now, it is selected as custom. Select it as auto. We will create a auto mode VPC first. Then we will create a custom mode VPC, right? So first select on auto and click on automatic. So once you click on automatic, then you will see IP address popping up below, right? Okay. Now, if I scroll down a little bit, you would see that for every region, I have an IP address created here, right? And this is a private IP address. And remember, I told in auto mode, you will not have the control over creating the subnet, right? So the private subnet and the CIDR range, that is /20, will be fixed. You cannot change it. And see here, it has 39 data centers, all data centers or region, it has created a subnet. So you can go ahead and create a resource or service from any of this location because we have the subnet there. Then scroll down. So there is something called as firewall rules. For now, you forget what is firewall rules. I will explain you later. We'll have a separate topic of firewall rules. For now, you simply just check on this box and select all these firewall rules. I'm going to explain firewall rules separately later, guys. Okay. Then you can scroll down a little bit and keep everything else default. That is basically what will be your routing configuration. Routing configuration is how do you want to route your data? Do you want to have cloud routers will learn routes only in region, or will you dynamic keep it global? So this way what happens is, so let me draw it to explain, right? So let's say, for example, this is my globe, right? I'm very bad at drawing, guys. Okay, let's say this is a globe. Okay, and this is all my water region, right? Now, if you consider, for example, all these red color dots are GCP's region, the data center in a region, right? So in a continent, it can have multiple region. Okay, let's say these are the data centers. Now, when you are actually transferring data, or when you're trying to send request and response between these regions, right? So in your global mode, what happens here? It will dynamically learn. So it will learn that from here, if I have to transfer packet till here, so it will learn which is the shortest path and dynamically transfer the packet, right? Whereas in regional, what happens? It jumps region to region. From this region to this region, it will hop from every region and reach here. Whereas in global, it will learn the best path and it will remember that best path. And from next time, if you're transferring data between that regions, it will use that best path, right? So for production use case, you will keep it as global so that it will learn automatically from all region and it will interconnect and use the shortest path. But we will keep regional, whereas from every region to region, it will keep jumping from the source region it was created to every region, right? And then finally, I will click on create, guys. You see, we hardly did any configuration, right? We just gave name, we selected regions, and then we're able to create a VPC, right? So please go ahead and click on create button here, guys, the blue button at the bottom. Please click on the blue create button here. That will take some time and that will create your auto mode VPC, auto subnet mode VPC, right? Done, right? So do you guys see like this an auto VPC? You see there are 39 subnets created, meaning 39 data centers, 39 regions, all the 39 regions, it has created a subnet, and you see it's an auto mode, right? So you can just click on it to see the details, right? You see this IP address is same. Now you might say this IP address is similar to this subnet is similar to my default VPC subnet. Won't it clash? It won't clash, guys, because it's a private network. It's a private IP. It only means inside this VPC. Only inside this VPC that IP address has a meaning. Outside that, that IP address is unknown. So if you're trying to use an IP address outside this VPC, it won't even be, you won't be able to even use it. It won't have any meaning. It will give you error, right? So that's why there is no collision of IP address, because it is completely private to a network. So that's how we are able to secure our entire application or deployment in VPC, right? By creating it as private and securing it, right? Okay. Shall we jump ahead and actually get started with our custom mode VPC? Okay. So now to create a custom mode VPC, again, we will click on create VPC network itself. Okay. And after clicking on create VPC network, we will again give a name. So here I will give name as custom-VPC. Okay. So once you give the name, guys, description, again, I'm going to leave it empty. MTU, I'm going to keeping it default, the lowest. And here we will retain the custom subnet creation, right? So in automatic, what happens? See here, default for every region it will create, but in subnet, it won't create. In subnet, you should go and create manually, right? So once you click on subnet, or subnet will be clicked by default, right? If you scroll down a little bit, you can ignore this option, guys. It's for private IPv6. We don't need IPv6, okay? Out of our scope. So under this subnet section here, you would see a new subnet and you will get this expand button, right? So just expand this. You need to fill this details, right? To create a subnet. Expand the subnet. Okay. After expanding the subnet, we will give the subnet range. So before giving subnet range, first let us select region, so that based on region, I will give the name. So let's say I will select it as US Central. So what I'm going to say? I'm going to say US Central subnet 1, something like that, right? So I'll say US Central subnet 1. Now, why did I give like this US Central name? So that when I'm creating any services using this VPC, I know, right, which subnet this belongs to. I should know, right? If I'm selecting a subnet, that subnet belongs to US Central region, right? Or else if you select by mistake others, first of all, it won't be possible, but it will give a lot of issues, right? So that's why we have prefix with region. Okay. Then description, you can leave it blank or you can fill it. And then comes your important part, IPv4 range. That means you can enter your private subnet. Whatever you want to enter here, you can enter that as your private subnet here. So I'm just going to give it as 110.110.0.0 / I can give 24, 26, 28. It's up to me. Now I will confirm. Okay. So I will give my own subnet, own CIDR range, and I will click on this confirm button. So you just have to click on this confirm button, right? So you're just confirming, verifying that your IP address is not colliding, or it is not, actually it will verify, or you're just confirming that your IP address doesn't exist and it will not actually collide with any other existing IP address, right? If there is any existing IP address, then it might cause issue, right? It'll cause this issue of where, it won't be able to find which IP address you're actually dealing with, right? If two systems have same IP address, then your system will actually go crazy, right? Because it will not know in which IP address it should respond to, right? So that will be the problem, right? So that's why you just have to confirm, and you can give your own IP address and you can give your own subnet, guys. It's not that whatever I've written you have to complete. You can give 10.10.0.0, you can give 11.11.11.0, up to you. Give your own IP address and CIDR range. And again I'm emphasizing it, this is a private IP address. So this IP address, if you go and check on internet, it doesn't mean anything, because it's a private, and private only to your VPC, not even GCP. Within GCP to a VPC, it is private, right? Cool. Yes. Okay, great. Then what happens? Then there is a secondary IP range. What happens in secondary IP range? You can create two subnets, guys. So in same region, if you want to create two subnets, let's take a scenario where you need to create like thousands of VMs. Let's say, for example, you want to create 10,000 VMs. So if you create with /24, in /24 only, 256 IP addresses allowed. But you need, let's say, 500 IP address. So what you will do, you will create a secondary IP address and you will give the name, and here you will give again, here I will give 10.10.110.10, right? So meaning you can create multiple subnet, you can create multiple IP addresses, guys, right? So to create multiple IP addresses within the same region, you can use this button that says create secondary IP range. But for our learning case, we don't need. For us, one itself is enough. Anyway, /24 or /26 will give me enough IP address, right? So I will keep it as it is. I'm not going to play around with this secondary IP address, meaning I don't need secondary or another subnet in the same region. Then what is private Google access? This is basically a VM in the subnet can access Google services without applying or without giving external IP addresses. Meaning, if you want to create a VM private, you don't want to attach a public IP address to a VM, then you will keep this on. For our case, we will keep it off. What is flow logs? Flow logs is basically it will generate logs and it will store logs for every packets, every request that is coming into your VPC, right? But we don't want to enable this, guys, because if we enable this, this will incur a lot of cost. Why? Because a lot of logs will be stored, and to store this, they need a storage mechanism, right? So that storage will be costly. Not costly, but yeah, it incurs some cost. So that's why for our learning purpose, we'll keep it off. But if you want, in your use case, in your production, you want every request that is coming in my VPC to be logged so that I can go and audit, then you can definitely go and turn this on. So we have a separate logging service in GCP. There you can go and see the logs, right? Hybrid subnet. So hybrid subnet actually allows you to modify your subnet. Then comes your firewall rules. For now, again, as I said, firewall rules, forget for now. Just select it blank. By default, just select it all. Okay, I'll explain later what is firewall rules. And then simply go ahead and click on create button, guys. So that is going to create your custom subnet mode VPC. Okay, now it's very important, guys, when you're dealing with VPC, you must understand that these VPCs are private. Remember, I told VPCs are private, right? So inside a GCP project, how many inside this GCP project? So this is my project, right? Top footing. Inside this GCP project, how many VPC do I have, guys? I have 3, right? Auto VPC, custom VPC, and default VPC. 3, right? I have 3 VPCs, right? So it will look something like this. I have 3 VPCs, correct? And each of these VPCs, what is the name? So this is my default VPC given by GCP. Then I have my auto VPC, which I created, correct? Then I have my custom VPC that I have created, right? So I have all of this. Now inside this, I have subnets, right? So let's assume if I go and create a virtual machine. So if I create a virtual machine in this, if I have multiple virtual machines like this, okay, very importantly, guys, inside a VPC, you can easily connect and you can send request or you can transfer anything between services. Basically, you can have connectivity, you can send request, you will get response within a VPC. Okay, within a VPC, any service you have, you can easily connect. Okay, whereas from one VPC to other VPC, if you're trying to send request, it will not be possible. It will basically not be possible, right? Why? Because entire VPC is your private. So think this as an independent vessel, think this as an independent vessel, and think this as an independent vessel. So how can a independent vessels be connected, right? That's not possible. If it gets connected, then what's the point of having a private network, right? If it can connect to every network I have, right? So all I'm trying to say is within a VPC, any services you can easily have connectivity, but one VPC to other VPC services, you cannot have connectivity, right? By default, you cannot have it, but there is a provision where you can have this connectivity. How do I do a connectivity? You will create a bridge. There will be a bridge here. Okay. Now this bridge is called as a peering. Okay. Think it like this, guys. There is two independent buildings. Okay. Huge buildings. And if you want to connect these two buildings, you will create like this, like a twin tower. You will create like a bridge here, right? So people can walk both the ways. People can walk both the ways to and from, right? Similarly, it happens here, guys. I will have two independent VPC. I create a bridge or a tunnel here called as a peering. So once I create a peering between two VPC, so here I've created a peering between default and auto VPC. So now the packets or request can be sent from this VM to this VM and vice versa also. It's a two-way connection, right? So now it will be able to communicate and connect. How? After creating this bridge or tunnel that we call the word as peering. So this is known as your VPC peering, where you create a connectivity between, very important, between two VPC, guys. It can only happen between two VPC. You cannot connect default even with auto VPC. You cannot create with even custom VPC. At a time, you can only connect with two VPCs. So then what happens? You will create two peering. First, you will create one peering between default and custom. Then you will create another VPC peering between default and custom. So at a time, you can only create VPC peering for two independent VPCs. That is important. You cannot connect 3 or 4 VPC at a time. No, in pairs only you can do it, 2 at a time. So you will first connect default with auto, then you will connect default with custom. So you will create two VPC peering. You will create two bridge, and that is how you will be then able to connect to any VMs or any services across this network. Okay, great. So again, pointers to remember: VPC peering can only happen in pairs and can happen only between two VPCs, right? So we have to make sure we have at least two VPCs to create this VPC peering. Okay. So let's go ahead and create a VPC peering. To create a VPC peering, we will be in the same GCP's VPC page. Okay. On the left hand side, guys, if you scroll down a little bit, you will see VPC network peering, last but fourth option, right? So on your left hand side, you would see this option that will say VPC's network peering. So just click on this option, VPC's network peering, and it will take you to this page. Now it shows nothing because we did not create any VPC peering, right? Okay. So now you can click on create connection button here. We will create our first VPC peering. So click on create connection and trust me, guys, and then click on continue. It's very, very, very simple to create a peering in GCP. You see hardly 3 or 4 options you have to select, right? That simple GCP has made it. Yes. Okay. So here we will give VPC peering name. So let me give the peering name as default to auto peering. Default to auto VPC. My another VPC name is this, right? And again, guys, let me clear the confusion. I have given the name default to auto. Okay. But it doesn't mean that it is one-way connection. It is two-way connection. You can even give auto to default, meaning you can either select default as your first VPC, auto as your second VPC, or you can select auto as your first VPC, default as your second VPC. It doesn't mind. doesn't bother. The reason, because it's a two-way connection. So you select it either way, it's fine. It's like potato. It's the same, right? So don't get confused with that why did I write default first? Why did I select default first? It is up to you. If you want, you can select auto VPC also first. It's up to you, because it's a two-way connection. So order is not required. Okay. Now, so I will select this as default VPC. And if you want to connect to a VPC that is in your project or even in another GCP project, you see here, they will give a provision there where you can connect to a VPC of a different GCP project itself, right? So that provision also you have. Currently, we don't have any other GCP project. So that's why in our project itself, we will select auto VPC. So we are creating a peering between default and auto VPC, correct? Okay. Then after that, you will select this IP address. What is this IP address? That IP address says basically in that VPC, you have subnets, right? Are those subnets only IP address v4 or IP address v4 or IP address v6? So remember, we only selected IPv4. We did not select IPv6. So that's why it will be default IPv4 single stack. Then there is something known as exchange IPv4 custom routes. For now, you can forget this. Okay, this is something in depth and out of our scope. So don't need to select any of these options and leave it blank, or leave these options as default. You need not select any of this, right? Exchange, custom routes. You guys need not worry about this. Okay. And then you can simply click on create. So that is going to create a VPC peering. It will take some time and it will create this peering. So see, it created my VPC peering, guys. Don't worry, you might see status as inactive, but don't worry. The reason it shows inactive is because currently there is no connection, right? Currently there is, your VMs, or there is no connectivity between these two, right? You're not using it. So that's why it is showing status as inactive. It's not currently being used. It is created, but it is not being used. That's why it is showing inactive, but don't worry about that inactive. Okay. It's not like any error. Okay, great. So now we have learned about VPCs. We have learned about VPC peering, which will help actually connect to independent peering, right? Now, third thing we will learn about is shared VPC. Sadly, we won't be able to do a hands-on because we need organization for this. Without organization account, you can't do it, but I will explain you theoretically what is shared VPC, right? So pay attention. I will explain what is a shared VPC. Okay. Again, before explaining shared VPC, let me write what is VPC peering, because always folks get confused and ask, right? So VPC peering, okay, first and the foremost thing, it happens in pairs, meaning you need two VPCs, right? And it can happen within a GCP project, or it can also happen with other GCP project. Okay, this is very, very, very important. If I try to draw this, so here I have two VPCs, VPC1, VPC2, and between this we create a peering or a bridge for connectivity. Correct? This is your VPC peering. Now coming to shared VPC. Please don't get confused. Shared VPC, as the name suggests, guys, right? Shared VPC. To give you another example, think VPC peering. Think VPC peering as I have there are two, let's say I have two kids here. Okay. Now these kids individually, I will give them chocolate. Both of them, I will give them chocolate. Okay. This is your VPC peering, where I have two users or two kids having two independent chocolate they eat. And if they want to share, what they'll do, they'll break a small piece of a slice and they will share across to each other. Correct? Whereas in shared VPC, let me explain non-technically. In shared VPC, I will have one chocolate that will be shared to multiple GCP project, like multiple human. So it's just one chocolate that is being shared to multiple humans, right? Same way, now coming to technical, this one, I will have a GCP project. This is a GCP project. Okay. Inside GCP project, I will have this VPC. This VPC can be shared to other GCP project. And when I'm sharing this to other GCP project, I'm not giving a part. I'm not creating two VPCs. Same VPC shared. So in this GCP project, I'm actually using this VPC. You guys understood what your shared VPC is, as the name suggests. You are sharing that VPC to other GCP project. So that other GCP project, whichever that user, whatever operation they perform, actually it is performing on this VPC. Right? So it is just one VPC, but it is used across multiple project, right? So that is your this one. So you will have one VPC, right? One VPC that will be created in your host project. So the GCP project where this VPC is created is called as your host project, and then it is shared to multiple GCP projects, right? Now, when I say shared, it is not multiple independent. It is one VPC itself that is shared and used across multiple projects. Is it clear, guys? The difference between VPC peering and shared VPC. So in shared VPC, you don't need a peering. Why? Because you're using the actual VPC itself. You're using the host project's VPC itself, right? So you create a shared VPC. But one thing is important, shared VPC can happen only between projects. So you need to have two different GCP projects, whereas peering is two independent VPC within a GCP project or outside a GCP project. That means other GCP project. Whereas shared VPC will be across multiple GCP projects, but it will be same single VPC. It won't be like a pair or multiple VPC. Is it clear what is difference between your VPC peering and what is a shared VPC? I'll give you an example, okay? So ideally what happens is in VPC peering, you do VPC peering like this. Okay, let's say this is my GCP project. Okay, within this GCP project, I will create two VPCs. Okay, and I will call this as data VPC. I will call this as my application VPCs. So in this case, what happens? All my application related services will be in this VPC. All my data related services will be in this VPC, and through peering, I will connect them. So in this case, what happened, guys? My data will be secured. Even if I'm making my application public, only this VPC will be public, correct? It will not affect my data VPC. Data VPC will always be private. So this will be security, right? So this is one example of VPC peering. Okay, where within a GCP project or across, I can create multiple VPCs like this for security reasons. Okay, shared VPC, what happens? Shared VPCs, what will happen in shared VPCs is I will have a GCP project here. Okay, I'll have a GCP project here. Inside this GCP project, I will have a VPC created here. Okay, now let's assume this is for some application called as ABC. Okay, and now you're building, another team is building same application and they want to access your database in this VPC. So in this VPC, there are some service, some XYZ application they're building, which need to actually get some data from this ABC. So instead of creating a replica of the database, you can directly share this VPC to this project also. Right? You can directly share this VPC to this project also, and folks of this GCP project, this GCP project 2, folks of this GCP project 2 can access services of GCP project also. It's like cross team, cross application development will become easier. So you understood, right? This is one of the example I gave. Use case can be completely up to you, right? But yeah, I hope this is clear, guys. So in real scenarios, this is how we can deal. One of the example or one of the use cases. Okay. So now let's continue to the next concept called as firewall. Okay. So let me explain firewall first non-technically, guys. Okay. Let me explain you non-technically firewall rules. Okay. Let's consider an example. Okay, great. So we have a car here, right? Wonderful. Okay. So let's take a scenario here, guys. Okay. Where we have a barricade here. Okay. and we have a police officer here. Okay, police officer here. Okay, now let's say green colors are number plate for your electric vehicles and blue are for your non-electric vehicles, right, which runs on diesels and petrol. Now if this police officer is given a command, or let's say for example there is a rule. Okay, so there is a rule. The rule states that green allow, blue don't allow. Okay, so if a rule like this is given to police officer, what will this police officer do standing near the barricade? He or she will allow all the green vehicles to cross this barricade, and all the blue color vehicles, they will ask to return back, right? Oops, I think I'm not able to reverse it, but they will be asked to move back, right? Maybe like this. Okay, anyways, so they will be asked to move back and they will actually go farther away, right? They'll just take a U-turn and they will go back. Correct? So far, are you guys understanding the narration here? All I'm trying to say is there is a police officer here whose responsibility is to abide by these rules, and these rules will be created by some person that is at higher level, and he has to follow it and make sure that there is this entrance. From this entrance, it allows or it doesn't allow some particular type of vehicle based on the rule. So far, you guys understood, right? Now, same way, let's come to technical world. Okay. Now, in technical world, what will happen is you will have your GCP here. Correct. Now, when you are getting request from internet, let's say this is globe. Okay. This is internet. From this internet, you will be getting multiple thousands of requests to your applications. Correct. If you have deployed an application, there will be thousands of requests that will be sent to this particular VPC, correct? And these requests will be of various type. Now you might ask, why do we have different type of here request in internet, right? That is because there are a lot of other things also in internet that you can serve, right? Like say for example, if you're trying to access any website, that will be your simple HTTP or HTTPS protocol. If you want to download or upload any files, if you basically need to copy a bigger or larger data, then you will use FTP protocol, which is like a different kind of request. If you guys want to send email via internet, then we use a separate protocol called as SMTP protocol, right? Meaning there are each request having its own type. So HTTP is used for this fixed type, FTP is used for this use case, SMTP is used for email use case. So they have their fixed use case, right? Now, if I'm trying to actually, I built an application and I'm trying to deploy and make sure users can use my application. So don't you think if I'm actually catering application, there is no point of me accepting FTP and SMTP request, correct? Because I'm not serving that, right? So what you can do is similar way, you can add here a gate or a barricade. Okay, this gate and barricade is called as your firewall. And in this firewall, you will attach rules. In rules, you will attach that HTTP and HTTPS is allowed. Okay. Then FTP is not allowed. SMTP is not allowed. Right. Then what happens? Let's say there are thousands of requests being sent. A lot of this request would be unwanted request sent by a hacker or sent by a DDoS attack, right? So in such cases, a lot of this request will be denied and thrown back. Thrown back in a sense, it will be sent back without giving any response. And then it filters out and sends the only correct or the actual HTTP request or allows it, right? So this acts as a one layer of security where all unwanted, unauthorized request will be eliminated and only accepted or allowed request will be allowed to pass through. Pass through where? Pass through and go to the destination. That is wherever your, whether it is a cloud run, whether it is virtual machine, whether it is Kubernetes cluster, wherever your destination is, it will go there, right? So the whole purpose of this firewall is to make sure either you allow or you don't allow some particular type of request in your GCP. And when we create a rule like this and attach it to firewall, that is nothing but called as your firewall rule, because that rule gets attached to this firewall. Cool. Okay. So now we will go back to our GCP portal, and on the left hand side, okay, on the left hand side, guys, you will see this firewall rules, or you will just see this firewall on the left hand side, right? So just click on that firewall, guys, and you will be redirected to a similar page like this. Okay. So here you will already see bunch of firewalls rules created, guys. These are default firewall rules that are created by Google, right? And we just went ahead and selected these while creating our VPCs, right? But in real scenarios, you might create your custom firewall rule based on your requirement, right? Whether you want to allow SMTP, allow FTP, allow TCP, or allow any different types of request, right? So you will do that. So we will create a firewall policy. So there is two things, firewall rule and firewall policy. In firewall rule, you just create a rule. In firewall policy, what happens? You attach that rule to a VPC, it becomes a policy. Does it make sense? So a rule is simply a law, and when that law is actually in it's basically, what do you say, people start abiding by this law. If that law is enforced, then it becomes a policy, right? So that's why we will directly create a policy. So in policy, what happens? You will create a firewall rule, plus you will attach it to a VPC. So from then on, in that VPC, that firewall will be active, right? So I'll create a firewall policy here. So I'll give the firewall policy here as custom firewall policy. I'll give the name as custom firewall policy. Okay. Then I will click on continue. And then here we will see there are a bunch of rules which are already ready. You can just attach them. This is like already created by Google for you to use, but we won't use them. We will create our custom rule. So to create a rule, you would see here a button that says add rule, correct? So just click on this button that says add rule, and then we will add, or we will create our rule here. So I will give this rule name as allow HTTP. Okay, I'll give the name. Oh, sorry, this is priority. Priority will be a number. My bad. So priority, I'm going to give a random number for now. Okay. So what is this priority, guys? The priority is basically nothing but the level of check, right? So there can be lot of rules. So these rules you have to check in a order. So that order is nothing but this priority. So lower the number, higher the priority. Okay. So I'll give a random number like 2, 3, 3, 4. Okay. So once you have added priority number, guys, then you can scroll down and you will have direction of traffic. What does this direction of traffic means? The direction of traffic means how is the flow of request? Is the request coming from outside world? Outside world means internet. From internet, is it coming inside my VPC, or from inside my VPC, it is going to outside world? Now, by default, this from VPC to outside world is always trusted, guys. Why? Because you have written the application, right? You know what data you are sending. It cannot be like anonymous, or it cannot be like hacker is sending, right? So always from VPC to outside is allowed. No matter which protocol, no matter what request, it is allowed, because it is trusted source, right? Because you are managing this. So the source is trusted. Okay. And this type of request that goes from inside a VPC to outside is called as egress, right? So you might see here egress, right? This egress means outside, outgoing from VPC to outside world, that is internet. And what ingress means? Ingress means a request that is coming from internet or outside world to VPC inside. So inside request that is coming to VPC is called as ingress, and this is egress. So generally we create request for ingress. Okay. And then what is that rule you are creating? What is that? This one. Do you want to allow something? Do you want to deny something, or do you want to go to next? Meaning just ignore this and go to the next request, right? Next request from the same source, right? So let's say, for example, now I want to create a rule where I'm allowing HTTP, right? So I will allow. Let's say, for example, in your scenario, you want to deny FTP, meaning you want to not allow FTP. Then you would select deny and write here FTP's request, right? So accordingly, you can select allow or deny based on your whether are you allowing it or you're denying it. Then comes your target, guys. So target will be all instance in a network, meaning everything inside your VPC will be abiding by this rule, right? So every service inside GCP HTTP will be allowed. So in GCP, guys, firewall is at VPC level, not at service level. So please make sure you know that, right? So it's at VPC level. So if I create something, it should be at VPC level. Okay. Then once I have this, then I will have source IP address. What do you mean by source IP address? That is, from where can you get request to this VPC? You can get request from anywhere in internet, right? And to mention anywhere in internet, you will write 0.0.0.0/0, meaning anywhere from internet I can get request, be it from US, be it from India, be it from laptop, be it from mobile, be it from smart devices, anywhere I can get request, right? So that 0.0.0/0 means public. From anywhere in internet, I can get request to this VPC. And if I get, what should be the destination? So destination would be, in destination, guys, you can forget all this FQDN, geolocation, that is location wise. If you guys want to filter, all these are out of our scope, so you can ignore them. So coming to this protocol, which protocol and which port do you want to allow? By default, it will say allow all. Allow all means allow all the type of request, but I don't want that, right? I want to only allow HTTP. I don't want to allow FTP and SMTP, right? So I will say specific protocol and port. And after clicking specific protocol and port, HTTP comes under TCP. And for HTTP, port number is 80, guys. And for HTTPS, it is 443 port number. What is this port number? This is basically equivalent to, this port number says what request it is, right? So HTTP actually works on port number 80 and HTTPS works on port number 443, right? So I will mention these ports. So what it means, guys, these two ports, I am allowing it from where? From the internet, 0.0.0. So from internet, anyone, allow means can send a what? A HTTP or a HTTP request. Okay, cool. So once this is done, all you can do is, guys, you can click on create. So once you click on create, then you will see your rule is created here. At the bottom, you will see your rule created. Okay. So now what you can do, you can select this firewall rule, guys. That means this rule you want to allow or attach in your firewall policy, right? So just select this rule that we created. Okay. And then click on continue. And that will take to your third and last option. Okay. So once you're on this third option, guys, you can click on associate and you can attach this firewall rule to any VPC. So let's say I will attach it to allow VPC, auto VPC and custom VPC, both this VPC, and click on associate. So that means what? This firewall rule or the policy will be followed in these two VPCs, right? Okay. Once you have it done, then you can simply click on create. So that is going to create this firewall policy. And then you will be able to see here network firewall policy, right? Under that, you will see your firewall policy, which is getting created. So once this firewall policy is created, then in auto VPC and custom VPC, except HTTP and HTTPS, none other request is accepted or allowed. It will just kick it out, right? So this is a very important aspect of security, because from here itself, you can scrutinize and ignore, or you can rule out all the unwanted requests, right? Okay. So now what we'll do, here's a task. I want everyone to go back and clear all the resources we have created so far. So first you have to delete the firewall policy, then delete the VPC peering, then delete the auto and custom VPC. Delete both of these VPC. Clean up whatever we have done so far before we proceed to the next part, that is how do we use CLI in GCP. Need to remove association first and then delete. So guys, to remove the association, so the reason you cannot delete it is, guys, because currently this is being used by two VPCs, right? We have associated with two VPCs, right? So first we should remove those association. So to remove the association, please follow the steps that I'm saying, guys. Okay. Just click on this custom firewall policy that you created. Okay. Click on that custom firewall policy that you created. Click on it. Okay. Then after that, you will see the second tab here that says association, right? So just select this and say remove association. Just select both this VPC and click on this button on the top that says remove association. So first you remove that and then you will be able to delete it. Okay. So now you do this, guys. Let me do it from my end. So let me delete this policy. After deleting this policy, I'll go back to my VPC page. And then I will delete this peering. And then I'll go back to my VPC network. And I will delete this auto VPC. It's asking me for confirmation. I'm going to confirm it. And then I'm going to even delete the custom VPC. Custom VPC. Okay, great. So now proceeding further to the next topic, let us learn about Gcloud. That is your Google's or GCP CLI, right? So whatever we have seen, we have actually created these services using console, that is the UI, correct? Now we will see how we can create VPC using CLI, that is through command line. So Gcloud is nothing but the name of our GCP CLI, right? And using this CLI, we will be able to perform any operation that we do through CLI or through console, right? So let me explain you the syntax of Google CLI. The syntax of Google CLI goes this way, guys. Okay. This dollar is basically your command line, or let me put it like this, right? So it starts with Gcloud, which is fixed. Okay. Then you basically have the group. Group is nothing but that service in which group it lies. Like for example, network comes under compute group, right? If you are creating storage bucket will come under storage group, right? SQL will come under storage group, right? Like it's at high level, all this service will be grouped, right, in some group. So you will have the group name, then you will have the service name, then you will have the action, and then you will have the hyphen all the params. So here you will have all the params, that is parameters. What are the parameters? Whatever parameters you fill by UI, right? Like see here, you're giving VPC name, right? VPC name, MTU, subnet mode, all these parameters that you have filled through UI, same things you will pass through CLI, right? Now, what would be all the actions that are available? So there are actions that are available like create if you want to create a service, delete if you want to delete a service, right? And modify if you want to modify it, right? So these are the actions. Okay. Now, if I were to create a VPC, how would I write the command now? I will simply write Gcloud compute, then it will come under networks, action would be create, then param will be name hyphen name is nothing but name of VPC. So I'll give this as CLI VPC, right? Then I will say hyphen MTU is equals to 1460, right? So I will write something like this. Now you might say, how is it easier to remember like this? First and the foremost thing is obviously practice. Second thing is you don't even have to by heart, guys. You just have to remember the syntax. How simple it is. Gcloud is fixed, then followed by your group name, then followed by your service name, action and params, right? So if you remember this, that's enough. Let me write it as whole, right? Parameters, right? Now, Second way to do it is there is a Gcloud documentation. Google, obviously not just Google, any cloud providers or any this one, they will have the documentation, right? So this is your Gcloud documentation link, where on the left hand side, guys, let me zoom a little bit. So if you see on the left hand side, all the GCP service you will see here, right, with the group. So you're seeing Gcloud and you're seeing group. So my network will come under compute, guys. So I'm seeing for compute. So see here, Gcloud compute, I will expand. Within that compute, see here, I will have networks. Under networks, I will say create action. So that will give me the documentation of how to create a VPC. See here. So Gcloud compute is the group, networks is my service name, create is the action. See here, name is a compulsory parameter, guys. Anything that is outside this square bracket is compulsory. That means you have to give name. And after that, anything that is in this bracket, that means it is optional. So if you don't give it, it's fine, because all this has default value, right? Like your UI. See here, if you don't give empty value, it is fine because it has a default value. If you don't give subnet, it is fine. It has selected default value, right? So the lowest you have to do is just write Gcloud compute networks create and give your name of VPC, and it will create a auto subnet mode VPC for you, right? Okay. So come back to your GCP console, and on the top right hand side, if you guys remember, I told, right, where you go and select your cell, where do you activate your cell? So just go on the top right hand side to this square icon with the chevron and click on that. So that will actually activate or launch your Cloud Shell or terminal, right? It's taking some time to provision. Okay, so I have my terminal ready. Okay, so here, first, let us see how many VPCs I have, right? So I'll write Gcloud space compute space networks space, I will write list. List is also an action, right? So list will, what it will do, I will authorize. So that is going to log into my GCP. And what will list do, guys? List will return all the VPCs that we currently have, right? So list is an action that will list all the VPCs. Then I will next say create, then I'll say name as CLI-VPC and hit enter. It will take some time because in the backend it will call those APIs and it will run those, right? So it will take some time, but then you will see your response that VPC is created. See here, I got response as created, right? So it says created, right? So if you rerun the list command, you will be now able to see two VPCs and not just CLI, even refresh. You see this refresh button in your console, right? On next to the create button, just click on refresh, guys. And then you see, you will be able to see your CLI VPC also here, right? So you see, rather than using UI, you can use CLI in order to make it quick, right? Creating services. And how easy it is, right? To use Google's CLI to write commands. It's very easy, guys, because it's the first time we are doing it. Might be confusing or it might be tough for you guys, but trust me, it's the simplest. Okay, now I will give you guys a task where I want you guys to delete this CLI VPC, but using CLI itself. Cool. So my action will be delete, and I will give my name of the VPC, and it will go ahead and delete the VPC, right? So in between, lot of service that we'll be learning, right? We will do it through console also, and we'll do it through CLI also. So that way it'll become a practice for you guys, right? So we'll do a lot of service hands-on, right? So we will do it through console also, and some of them we will do through CLI also, right? So that it will become a practice for you guys to use both console as well as the CLI, right? So yeah, we'll do that. Yeah, so now it has deleted that VPC for me also. Okay, so now I'll give you guys a task. Okay, create a auto subnet mode VPC, create two auto mode subnet VPCs, and then I want you guys to create a VPC peering between the two VPC. And I want you guys to do both of this task via CLI. So, okay, let me create CLI VPC 1, and then I'm going to create CLI VPC 2. First, let me create two CLI VPCs, auto modes VPCs. By default, it's auto mode. It's taking some time though. Okay, we have my first VPC created. Now I will run the same command and I'll create CLI VPC 2. And by the time this creates, let me look at the syntax for peering. So for network peering, it will be Gcloud compute network peering. This will be name of my peering. Then hyphen network, I'll give my first network name. Hyphen peer network, I will give my second VPC name. That's all I have to do, right? So I'll just copy this. By the time it's getting created, let me put it here itself. So Gcloud compute network peering create. Let me say CLI peering. I'll give CLI peering as the name of my VPC. Then I have to give hyphen network will be my first network name. So I'll give space hyphen network will be my CLI VPC 1. Then the next parameter is hyphen peer network, right? So then the next parameter hyphen peer network will be CLI VPC 2, my second VPC, right? So this will be my command. And if I paste this command in my terminal and hit enter, there you go. It has created the peering. So now if I go back to my VPC peering, guys, here, VPC network peering, see, I have my peering here. As simple as that, right? So what are the commands I ran? So first, I ran this Gcloud command, right? I ran this Gcloud command, create CLI VPC 1. Then I ran the same command and created my second VPC. And then I ran the third command that actually created this peering, VPC peering. So you guys understood, right? How you can actually leverage this CLI in order to quickly create resources if you're doing it like repetitively. If you're repetitively creating this services and all, you can do it via CLI. It is easier compared to using UI. Okay, cool. So now we can actually go ahead and we can now clean up these resources, right? So now I can go ahead and delete this. You can delete it from CLI, guys. Okay. But I'm deleting it from UI itself. Okay. I mean, you can keep the default VPC. Apart from default, other VPCs you can delete. The one which we created right now for our learning purpose, right? You can delete them. Just keep default VPCs and after that, just delete all other VPCs, peerings, everything else you can clean up. Okay. Now, as mentioned, we will be starting with GCP Compute. And in GCP Compute, we will majorly be doing services and resources that are to dealt with either deploying application, running application, right? Now, there are a lot of scenarios when you guys are building application, you might want to run your application, test your application locally, right? Now, to run them locally, you definitely need a compute. Okay. You basically need a compute, right? That is, think it like you need, like how you have your physical laptop, which has memory, which has storage, which has basically, settings and configurations, right? Which has OS. So similar things you require, right, to run these things. your deployment of application, testing of applications, right? Now, a quick thing is that how do we do it in GCP? How do I deploy? What are the ways in which I can deploy application in GCP, right? So we will be doing that. So in GCP, yeah. So in GCP compute, right, we will be learning first how to create a VM, virtual machine, right? And then after that, we're going to learn how to create a managed instance group. Cool. Then we will learn how to actually use GCP's serverless services. And within serverless, we have app engine, we have cloud run, cloud function. So we'll be seeing all these three GCP service. Then finally, we will see Google Kubernetes engine. Right? So these are the services that we will be learning in GCP compute, right? So I think this would be by far the time consuming because we will be learning all of this hands-on. After that, it will be quick and pretty straightforward, right? Because GCP storage and other services are very simple. Now, to first get started with virtual machine, what is virtual machine? Or what does it come to your mind when you hear the word virtual machine? Okay. A virtual machine is basically, as the name itself suggests, right? It's a machine. Virtual machine. So you have basically virtual compute or resources, right? Now, what do we mean by virtual compute or virtual resources, right? Just think it as equivalent as you using a laptop, but instead of physically having it, the laptop is somewhere in globe and you're just using it wirelessly, right? So it is similar to that. They will give you some set of resources and computes, that is memory, storage, and you use them. So technically it has OS, technically it has kernel, you can install application, you can run application. The only difference is that physically you cannot feel it, physically you cannot have it. It is virtually present in data centers, which you cannot actually imagine, right? I mean, you know that it is in this region, but it is, let's say for example, in some part of globe, right? Now, why do we use this virtual machine? Now let's talk about the application. Why do you think we need this? You might say, to run application, I can run application in my laptop also. Why do I need a virtual machine then for that? Any specific reason? So what happens with laptop is, guys, because it's physical, you need to carry it. You need to maintain it. You need to make sure it's fully charged. You need to make sure, you have mouse and keyboard. Actually, nowadays it's in laptop. So yeah, but yeah, you need to make sure that basically you have to have all of this to make sure you use your laptop, right? But what if you want to quickly have multiple laptops for multiple projects or multiple applications, right? In such cases, you can't just go and physically keep purchasing laptops, right? Now imagine if you're working on two different projects and for both different client, right? So you can't just go and purchase two different laptop, do the project and just shell out the laptop, right? I mean, technically, if you're rich, you can do that, but no one would do that, right? Ideally, it's not a good case, right? So that's what you do. You actually use this provided by cloud service providers like GCPs and all. They provide these virtual machines, which you can use based on your demand. We call it on demand, right? You use it for 1 day, use it for 1 hour, you use it for 1 year, you use it for lifetime. They will provide and they will charge you for this service. Just like I spoke, right? How we basically took an example of Uber or Ola, right? Saying how, let's say, for example, instead of you maintaining an entire car, you maintaining the service, you maintaining the insurance, everything. If you don't want to travel that frequently, all you have to do is just go and book a cab and you can reach your destination, right? If it's not that frequent. So similarly here, right? So these virtual machines will be provided by cloud service provider and you can use them, deploy any application, run any application from anywhere. All you need to do is you need to have internet access, right? Okay. Now that being said, so shall we go ahead and see how we create a virtual machine in GCP, guys? Okay. So coming back to our GCP console or GCP homepage, come back to your GCP's homepage or welcome page, and on the top, just search or type for VM, and you would get this option that says add VM instances. I repeat again, go back to your homepage, and on the top search panel, just type for VM and click on the first option or product that says add virtual machine, virtual instances. Okay. Now, okay, let's do one thing, guys. Okay, you guys just sit back. Let me explain you all the option and then we will redo it again. Okay, because if I explain all the option and make sure you guys select it, it'll take a lot of time. So first, you just sit back, watch me explain, understand each and everything that I explain here, and then we will redo this again. Okay, so please do not do anything that I say, guys, because I will be clicking on all configuration to explain you, right? You don't have to do that. So please sit back, watch, I'll tell you how to do it again. Okay, so the first option that says is the name here, and this name is pretty straightforward. It's just the name of a virtual machine, right? So that you can identify this virtual machine. Then you have a region. What is this region? So if you remember, I said in GCP, a region is basically nothing but a data center in that particular region, right? So by default, it is US West. That means it's in Las Vegas, right? So you can select any region you want, and in that region, it is going to actually create a virtual machine. That means that server it will use, that data center server it will use to create virtual machine. Now you might say, okay, I see something green leaf kind of thing here, right? What is that green leaf thing kind of thing? That means that data center is optimized and it leaves a lower, carbon footprints. That means it's basically more environment friendly. It's not technically fully, but yeah, it's little environment friendly, right? Because it has low carbon emission, right? So these regions are good to select when you have green because it's quite environment friendly, right? Compared to others. I have it Las Vegas. Let me not select Las Vegas. Let me select US Central just because it has low CO2. Okay. And then if you remember, I said for a region, you will have multiple zone also, right? Because there'll be a lot of zones. Like in a region, you will have further the data centers divided into zones so that they can take a backup. Because if there's any fault tolerance, there's any disaster management, they can quickly have the backup up and running, right? And these backups are taken place in these zones. Then we have machine configuration, guys. And as the name suggests, the machine configuration is nothing but what configuration machine do you need? So the first and the foremost thing is you'll get the series here. Do you need high performance instances? Do you need low cost day-to-day computing instance, right? Balance price and performance. Think it like when you're trying to go and purchase a laptop, you would question them, right? Hey, is it i3 processor, i7 processor, or i5 processor, i5 with Gen, right? How many virtual core CPUs? So similarly, right? So if you need better computing, obviously you will choose a better, course, right? You'll be able to choose a better chip, right? So similarly here, guys. So if you're running task which is memory intensive and it requires very good memory, then you will go with consistency high performance, right? If you are basically doing some basic task day to day, you don't need very high configuration machines, you can simply select low cost day to day computing, right? Now you will say, how do I know that what machine should I choose? So you can see here the range, right? How many virtual core CPUs it has, the lowest and highest range. So you'll get the range. So if I select a low cost day to day computing, which is by default E2, so I might get as lowest as a shared core and 1 GB memory, and I can get in this as high as 128 GB instance, 128 GB memory and 32 cores virtual CPUs, right? So from here you can get to know. If you need more cores, obviously you will select these options, right? See, if you select C3D, that means you can get up to 360 virtual CPU cores. That's like very, 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 very high-end compute, right? So based on your use case, you can select here, right? Now, if you further need details on each of these instances, you can click on this, guys, right? This is general purpose. This is compute optimized. So in compute optimized, you can see here, we'll have options related to ultra high performance, ultra high, configurations, right? You see, you can have memory up to 896 GB, right? In fact, if you see, guys, you can get, up to 240 GB in standard here, right? Machine types. Then memory optimized. In memory optimized, you'll have more memories or RAMs. And you see, it goes as high as 11 TB, basically 11,700 GB of RAM. Just imagine we are using laptops with like 8 GB, 16 GB, 32 GB, 64 GB max. And just imagine you have a virtual machine of 11,000 GB or 11 TB, right? It's like a whole server rack, right? That's like Google level of instances they use, right? Google alone generates 300 petabytes of data. So if that level you are generating, then you will be using such heavy computes, or else you won't, right? And if you use such instances, imagine the price, guys. On the right hand side, you can see $61,000 per month if you run it 24/7. So hourly rate is $84. So if you shut it down or turn it off, it won't charge, right? But if you keep your VM on 24/7, it can charge you like $61,000, right? If you go to this high-end memory optimized, right? Then you have storage optimized. So in storage optimized, you'll have high storage. You'll have, so that you want to cache or you want to have a quick storage and retrieval, you can use such instances. Then we also have GPUs. So if you want to attach a GPU to your virtual machine to run some, large language models, or to run basically your deep learning, this one, or you're writing any scripts that needs GPU, you can attach a GPU also to your VM. How many GPUs you need, what type of GPU you need, right? So there are a lot of NVIDIA's version of your GPUs, right? So these are all the options that we have, which based on your use case, you would select, right? Now, then once you select the machine configuration type, then you get the option which instance you need. So here you see on the top, EC2 is selected, which means I need a general purpose, low cost, day-to-day computing. I need a normal computing VM. And then here I can select how much memory and how much cores I need, right? So that selection, I do it here, right? Then we have availability policies. Okay, this you can skip. Okay, nothing for us. Okay, then comes display devices. So if you guys would actually be doing screen capturing, then you can enable this, right? So that, it'll be easier. Well, let's say, for example, you're sharing your screen or your recording screen, right? In this recording softwares, then you enable them so that, your virtual machines, the entire SSH window can capture all the actions, right? So anyways, we generally never enable this, right? Then there is something known as confidential VM instances. So what this does is this adds a protection to your data. So what does this mean? It basically encrypts your data that is in your memory and your storage, right? So do we have to enable this? Actually, not really, guys, because by default in GCP, any data that is stored is encrypted. This is like another level of encryption. That means if you need one more level of security, then you do it. But technically, till date, we haven't used this, right? So it's fine. But yeah, if you were to example enable another level of security even at your memory level, that is your RAM, then just go and enable, click on this enable button. It's just gonna make sure it does a second level of encryption also. Then comes your container here. What is a container here? So your container is basically nothing but for now, think it like it's basically a mini OS, right? I'll explain you what is container, what is Docker later when we are doing GK. But for now, think it like a container is basically a small OS kind of thing, mini OS kind of thing, right? So if you have your own OS, if you want to deploy your own OS, then you're going to click on deploy container and you deploy your own OS here, right? Which we won't be doing. It is out of our scope. Okay. Then comes the option related to your boot disk. This is the option where you select, right? Like for example, you know that we have Windows, we have Mac OS, we have Ubuntu, right? Same way, if you want to select what type of boot disk you need, you'll be going and doing it from here, right? So you will see, basically you'll get the option. So whatever you see here is default value. So by default, they'll give you 10 GB size. Now, what is this 10 GB size, guys? This 10 GB is the storage of your boot disk. Now, what is a boot disk? This is the disk where your OS is installed, right? Think it like people who use Windows, you'll have C drive. Inside the C drive, all your Windows files will be installed, right? System files and all that program files. Similarly, so this is a 10 GB disk. In that disk, you will have OS installed. Okay. Now, you might say, hey, is 10 GB fixed? No, 10 GB is just a default value. You can go and update. And like here, image. So by default, they have given Debian OS, which is a Linux OS, right? But definitely you can click on change here and you can change public images here, right? So operating system, I can select CentOS, Debian, Ubuntu, Windows, SQL. Like there are a lot of open source operating systems, right? You can, let's say, select Ubuntu. Then in Ubuntu, what version you want, that version you can select. Then you can select what type of disk you want. Oops. Then you can select what type of disk you want. Do you need an SSD, which is a faster and more balanced disk, or you need a normal HDD? Balanced persistent disk is a normal HDD, right? So you can select here what type of disk you need. If you are using for production use case, or you're using for a use case where you want your system to be faster, then you will go and select SSD, right? And then here you can give the size. So you can say I need 10 GB, 100 GB, I need 500 GB boot disk. That is my OS disk size. You can give that here, right? So all these configurations will be done here. Then comes your custom image. What is this custom image? So custom image is nothing but once you have a VM, you take backup of that VM. Okay. How do you take backup of that VM? By creating a custom image. So you create your own image with OS and configuration file, right? So that image can be selected here in custom image. So in this custom image, you can come here and you can select your backup image that you have created. So we will be doing this. We will see how to create a custom image later. Okay. Then comes the snapshot. What is a snapshot? A snapshot is nothing but a custom image, but it is done repetitively. Meaning when I create a custom image, it's a one time. I need to physically go click on button and say create backup. Whereas in snapshot, what happens? I will set it like a time frame, like every once a week, once a month, once a 10 days, it will automatically keep taking backup. So custom image and snapshot both are same. It takes backup. The only difference is custom image is a one time and you have to physically go and click on that backup button. Whereas a snapshot is like you create a cron job, you create a time frame and it automatically does that. Like as I said, right, once a week, once a month, once a year, once a 15 days, it will automatically keep taking backup. So that is the difference in snapshot and custom image, right? Right. So once we have the boot disk selected, then we have an option here that says identity and API access. So what is this identity and API access trying to say here? So it says basically what GCP services you want to use inside this VM. So, oh, sorry. No, I'm sorry, guys. My bad. So this identity and API access management is basically nothing but a service account. So internally, it will use a service account to create this service, right? Because at the end, it's making a GCP API call, correct? So here, by default, Google will create its own service account, which it will use to create a virtual machine. Okay. So there's nothing much to go and configure here. Then comes your access scope. And this app access scope says what all GCP services you want to access. So if I click on, or if I select allow default accesses, that means there are default services in GCP which you can access, that is read and write. Now you might ask, what are the GCP services that I can access within this? I'll tell you in some time. Then there is allow full access to all cloud APIs. That means all GCP services you can use through this VM. So if you're trying to write an application to store data in database, then you have to make sure you select allow default access. Let's say, for example, you're writing code to create some other GCP services, then you will make sure you select on allow all access or full access to GCP, this one. That means you can use other GCP services in your VM. For example, if I have a storage bucket in which I will upload files, from there, if I want to download files or I want to upload files from this VM, I can do it only after selecting allow default accesses, right? Or selecting allow full access to cloud APIs, right? And then we have set access for each API. So if you click on set access to each API, then we will see these are the GCP services that I can access, right? Now, are these the only service I can access? No, these are the service that I can access in default. In full access, you can access all the GCP services. And in set access, you manually select what access. BigQuery enable. That means you will be able to load data or write data in BigQuery. Then Bigtable admin, then other services, Cloud Data Store, debugger, this one, Cloud Engine. So all the service one by one, you will go and change the configuration, whether you will have access or not. If you say none, that means you cannot access this service. If you say read only, that means you can only download. If you say write only, that means you can read and write, that is upload also, right? So you can manually go and configure this, or for most of the cases, we always select one or two, right? So either for basic, this one we select default, or if you want to use any other services, then we will select on allow full access. Okay. Then comes a basic firewall rule, guys. Now, what is this basic firewall rules? So always when you create VM, not always, but most of the time when you create a virtual machine, guys, we do it to either deploy an application or test an application or run an application, right? Or even develop an application, right? Since application runs on top of your HTTP protocol, right, which is on it runs on top of TCP protocol, right? So they have given you a quick option where you can enable these two. That means your virtual machine will be able to actually accept HTTP and HTTPS request, so that it can deploy or it can render your application. It can fulfill that request, right? Then after that, so these are the basic things, guys. Okay, whatever we have seen so far is the basic things. Okay, then comes the advanced option, guys. So in advanced option, what happens? You go a step further, a little further, and then we configure all of this, right? Like networking, disk, security, management, and sole tenancy, right? Now, under networking, okay, here what you do under networking, you will simply go ahead and select your VPC. You don't have to play around with anything else here. You don't have to mess with anything. You simply, if you want, you can go and select your own VPCs, right? So if you have a VPC, you can go ahead and select that VPC. Now, very important part, this VPC is directly proportional to this region. Why is my region and VPC both important and both should be in hand? Okay, so what happens is, my question was, why is that my network, that is VPC, important based on my region? That is because if you create a auto subnet VPC, then you can select any region. Why? Because you will have subnet for every region, correct? But if it is a custom, let's assume you have a custom VPC and you have only created in one region subnet, then you have to make sure only that region you select here, right? Because you cannot go and create a VM for which you did not create a subnet, right, for that region. So that's why it's important, correct? Right. So we will keep it default itself, right? And then comes here an IP stack. So what is this IP stack here? This IP stack basically says if you need a public IP address, right? So here you see external IP address. External IP address, you will select it as ephemeral. What do you mean by ephemeral? Ephemeral means currently whichever public IP address is available, it will attach to it. Okay. Now there is two ways to this, guys. Okay. Let's assume I have my virtual machine here. Okay. What happens in ephemeral is I will have here a pool of IP address. Okay. Let's say this is one IP address, or let me write a proper IP address or else folks will get confused. Let's say, for example, 168.172.1.1. Okay. Then let's say I have 172.3.5.6, something like this. I'm just writing randomly, guys. My IP address doesn't make any sense. 162.10.170 or something like that, right? Now, so what GCP will do is GCP will have like this pool of static IP address, and these are IP address that is not assigned to anything. Okay, that means currently it's just sitting idle. So once you create a virtual machine and you say assign me an ephemeral IP address, what it does is it quickly takes an IP address and it assigns that IP address to your VM. So now your VM's public IP address will be this. Okay. Then what is difference here? This is like a normal IP address, right? Yes. But the different in ephemeral is that it is volatile, temporary, meaning if I shut down this VM or switch off this VM, again, I'm not talking about delete. I'm just talking about shut down. So if I shut down this VM, then what happens? This IP address gets released and it goes back in my pool. And the next time I switch on this VM or turn on this VM, it will take other IP address from this VM. It doesn't guarantee that it will give you same IP address, right? So this is what your ephemeral means. That means temporarily, currently, whichever from the pool it will get you IP address, it will assign that. And once you shut down or switch off and then again turn it on, you will again get a new IP address. So your IP address will not be static or fixed. But if you want a fixed IP address, then you have to click on reserve static external IP address. So this way what happens, one IP address is fixed, but then there is a caveat here. The caveat is pricing. So if you reserve a static IP address, you will pay more. Why? Because assume that now this IP address is 24/7 reserved for me. Even if my VM is switched off, this IP address is still reserved. That means it cannot be used anywhere else. It is fixed for my VM. So because you are fixing it, you need to pay some X amount, right? That means you need to pay a little amount. I won't say it will be very costly, but a little amount more. So let's say, for example, if you're paying $30 for your VM, might be $2 to $3 monthly will get added, right? For this reserving. I'm just giving again an example number. It doesn't mean that it's just $3, right? I'm just giving an example. So all I'm trying to say is if you reserve an IP address, some X amount of price will be incurred because you're reserving it. You're right. So that's why if you want to keep it this way, but we will leave it at ephemeral, right? Then comes your disk option, guys. So in disk option, if you want to attach any additional data disk, imagine you have a laptop and if your storage is full, what would you do? You would say that, hey, I can purchase an external USB hard drive, right? I can purchase an external hard disk and I can use that. Something like that, this disk is. So you can always attach any amount of disk so that external disk gets attached to your VM and you can access it. It'll be at a set particular path. In that path, you can go and access this disk. Okay. Then there is security options. Security options, there is nothing much, guys. Okay. Nothing to worry about. It's default. Like I mean to say that there's nothing for us to configure. Okay. Then comes your management. So in management, what happens? If you want to run any script that should automatically run every time you switch on your VM or turn on your VM or anything as such, right? Then you will go and run your automated script here. Like assume every time you switch on your laptop, you want to run an update command. So you will write here, for example, sudo apt get update. Then you will write sudo apt get upgrade, right? And then let's say, for example, you want to run a script. So you will say like, I will say / path to your script, right? Path to your script, right? So if you want to run any script, every time you switch on a VM, right? You want to do some set of operation or you want to run a pre-configuration something. So you can add that automation script here, right? Separated by new line. So these scripts will be running whenever you start, that is switch on your VM, right? Anyways, for now, I don't want to add any, but if you were to always or anytime give any script like this that should run on startup, you can do that. Then there is this option. Remember I told by default, Google encrypts your data. So this is that option, guys. Under management, you'll see data encryption. By default, it is Google managed encryption, meaning any data that you're storing in GCP will by default be encrypted, right? Then sole tenancy, you can forget for now. It's nothing to do from us, right? So I hope you guys understood all of these are basic settings or advanced settings for creating a virtual machine. Now I know we won't go through all of these settings while we are doing it, but hopefully I was able to explain you each and every concept. Okay. So now are we good to go ahead and create a virtual machine? I hope you guys did not click on any button, guys, because I clicked on all the buttons to give you guys a walkthrough. So for me, it was showing some errors and all. Okay. So please don't do that. If that is happening, just refresh your page so that you get a fresh form. Okay. If you're getting any error. So now the first option, guys, is the name. So we have to give name of the VM. So let me call this as dev underscore instance or dev VM. Let me call it as dev VM. That means our development VM. So here we will develop application. Technically we won't develop, but we'll deploy some dummy application. Okay. So I will call this VM name as dev VM. Okay. Then keep the region default, guys. It's fine. Okay. Then come down to machine configuration and let it be default EC2, which is basically a day-to-day computing and cost efficient machine configuration, right? So I'll keep it as E2 default. And then machine type, actually I will reduce it because I don't need a 4 GB VM. I need 1 GB VM because I'll hardly run an application that requires like KBs, right? So I can select EC2 micro. If you want, you can keep 4 GB, guys. It's up to you. But yeah, I'll try to select 1 GB. And you see on the right hand side, the price will automatically update based on what services, what options you're configuring, right? So if I create this VM will technically charge me $8, close to $8 per month, meaning 24/7 if I run this. Or if you calculate hourly, I'm going to pay $0.01, right? So if you take this $0.01, it's like very, very, very cheap, right? Then don't click on any other options. Just keep scrolling down and come to this option in boot disk. Okay. In boot disk, I just want to change this OS, guys. Okay. Because I want Ubuntu OS, right? So I'm just going to click on change in the boot disk, and operating system I'm going to change to Ubuntu, and Ubuntu version, let it be the 20.04. I don't mind Ubuntu version. It's just that operating system should be Ubuntu. So I repeat again, please go to this boot disk option and go ahead and change the image to Ubuntu 20.04 LTS. Okay. Then we'll scroll down and make sure, very, very, very important, I will enable firewall, allow HTTP, HTTPS. If I don't enable this firewall rule, technically it won't let me test my application, because again, I said, right, any web application, it always runs on HTTP and HTTPS, right? So please make sure under firewall, just select allow HTTP and allow HTTPS. Very, very, very important. Okay. Then you can simply go ahead and click on create, guys, because see, I don't want to attach any additional disk. I don't want to change my VPC. So that's why I'm not going in advanced option, right? So you can simply click on create and that will create your virtual machine. Okay. Then click on create. Okay. Let me click on create. VM created. Okay. Let's wait for me, guys. Okay. So my virtual machine is also created, guys, right? Now that my virtual machine is created, now we'll see how we can SSH or how we can connect to this virtual machine, right? Now, if you guys have used virtual machine in other cloud providers, you know that generally you can use third-party software like Putty or Terminal or PowerShell, and you can SSH, right? And it downloads key file, right? The PPK or PEM key file, right? But in GCP, it's little different, guys. In GCP, because of security concern, they won't just let you use third-party software. You have to use GCP itself, which is actually good and more secured, right? So that means if anyone, let's say, for example, other cloud providers, they download this PPK file or PM file, right? So if anyone has the public IP address and they have this PPK file, they can easily SSH to your VM, right? Whereas in GCP, they cannot connect to this VM until unless, first and the foremost thing, they have access to GCP. Second, very important thing, they should have access to your project. Third thing is they should have the role to connect to this. So you see 3 level of security before you connect to this VM, right? It's not as simple as someone, by mistakenly leaked this IP address and anyone can connect to my VM. No, because it doesn't generate key which you can download and use in third-party software, right? The only way to SSH or connect to this VM is on the right-hand side. Do you see, guys, an SSH button here, right? Below connect, you'll see an SSH button on the right-hand side of this VM, right? So just click on this SSH here, and that will actually launch up a browser here and give it some time. It will take some time. It will give you to authorize. So just authorize it. Authorize is nothing but it's trying to log into your GCP. Okay. Mine is connected. Okay. So now if you look at this, guys, this browser is basically the SSH console that is being given by GCP. Okay. And the reason GCP has done it, as I said, it is for security concern, right? GCP will be like, I don't trust you guys. So that's why I use my SSH. I won't let you guys use a third party software like Putty and all, and I won't let you play around with the keys, right? So the only way to access this VM is by using this browser's SSH given by Google, right? So you can just run any commands and you can basically do anything, right? Now, to give a quick walkthrough of this SSH terminal, you will have basically upload file here option. Why do we have an upload file or download file option here? Generally, we do that through FTP server, right? You might have seen we use software like WinZip or something like that, right? To connect to a virtual machine to upload or download file via FTP, right? But as I said, since GCP doesn't allow you download a key file and then use that key file in third-party software, that's why they have given their own upload and download button here if you want to upload or download any file, right? So if you want to upload, you just select upload, it will upload in the current directory. If you want to download, just give the absolute path, that's the full path, and it will download that particular file in your local machine, right? Then we have basic settings options, guys, that are related to your theme, font, and other basically options, right, which is not of our concern, right? So yeah, this is a quick walkthrough. It's a very simple and pretty straightforward SSH terminal. So now, since we are not going to focus development in this training batch, so what we'll do is we have something called as Apache. What is Apache? Apache is an HTTP server, guys, which actually helps render or display our website. Okay, so I'm going to install Apache Ubuntu. Okay, so what we will do is we will go and install this Apache web server in our VM. Why? So that we can render or we can actually test our application, which is a web application, right? It's a website, static website. Okay, now what do we have to do from this one? You just have to run step 1 and step 3 first command. So you guys have to just execute step 1 and step 3, only the first command. And in step 1, how many commands do we have? In step 1, we actually have 2 commands. So in step 1, go ahead and run first and second command, and then step 3, run the first command. Only these 3 commands you have to run. Forget everything else from this documentation in your VM. So once you run step 3 first command, you should see like this, a successful running, or you should see like this active. You should see something like this active. It will be in green color active. So you should verify that you see a green color active there. Okay. Okay. So let me do it then from my end. So I'm going to copy and run the first command here. Then copy the second command. And then by the time I'll copy this third command, right? So you see, I see active running. correct? So if you see like this active running, by the time you have reached third step, first command, that means it is successfully installed. Everything is good. Okay. Now that you have done this, guys, what I want you guys to do is go back to your GCP, this one, copy this IP address or click on this IP address. That's all. Click on this IP address or don't click, guys. It's going to HTTPS. So click on, copy the IP address and then type this in your browser. http:// paste the IP address. Make sure it is HTTP. We have not added certificate yet, right? So type this in your browser and you would see a Apache Ubuntu default page. So this is the default page of Apache Ubuntu. Okay. So if you guys are getting like this Apache Ubuntu default page, then it is successfully installed and you see we are able to render. Now we have not technically written this, but assume that this is the application that we have built and deployed, right? So this application is now running on this virtual machine, right? So we have written the code and we have installed this and it is running on this virtual machine that we have, correct? Now, what are the advantages and disadvantages of running my application on this VM? So we technically selected 1 GB RAM and we have 0.25 virtual core CPUs, correct? Now assume you're deploying an application, guys, and that application you will select 64 GB RAM, or let's say, for example, you'll select some X amount of RAM, correct? Do you think, can you foresee how much RAM you need for now? Let's say if I have less number of users using this application, so it's fine. What if there are millions of users who is using this application, millions of requests that is being served? Do you think my single one VM can handle this? Do you think your one VM can handle hundreds of parallel tasks? No, right? Limit resource, yes. Auto scaling, no. Auto scaling is not possible in VM because this is a single VM. You cannot auto scale in a single VM, right? So you have limited resource. Don't you think this is the disadvantage? Yes. Now, how can we solve this disadvantage? Then comes your answer, using auto scaling. Okay. Using auto scaling, we can solve this problem. You might say, what is auto scaling? How does it solve the problem? So what happens in auto scaling is, guys, okay, let's say, for example, you have a VM here. Okay. You have a virtual machine here. And this virtual machine, let's assume it has 1 GB memory. Okay. And at a time, let's say this VM can only handle, let's say, 100 users. I'm just giving you some random numbers, guys. Okay. Now in auto scaling, just assume I have like this 10 VMs or 3 VMs. I have a replica like this backed up and running, and which is running live. So don't you think that have auto scaler increased to handle 100, 300 users concurrently? Correct, right? So this is the advantage of auto scaling, where in auto scaling, what happens? You replicate and increase the resources, right? So in our case of auto scaling, we replicate this entire VM. We create a new VM itself. Like we'll have 1 VM, 2 VM, 3 VMs. You will have VMs count. So using this, we auto scale, and then through that, we make sure that whatever is the traffic that we are getting, we actually fulfill that traffic. You understood how to solve the problem of limited resource. So your single VM problem is limited resource, and how to solve that problem is clear, right? So technically we have learned so far what is virtual machine. And the next topic we will learn is managed instance group, which basically does this job of auto scaling. So in GCP, if you want to create a virtual machine that can auto scale, then we will be creating this managed instance group. Okay. So now we'll see how we can actually create an auto scalable version of our VMs, right? We actually configure this auto scaling where my VM auto scales automatically my application, right? And each time a VM spins up, a new VM spins up, it should make sure it has a replica of my code, my packages and everything, right? Installation, dependency, everything, so that the new VM that quickly spins up to handle the new set of users will have everything there by default, right? Now, to work with managed instance group, your managed instance group is further divided into multiple steps. So if I were to go ahead, managed instance group. So if I were to create a managed instance group, what would be the step? First and the foremost thing is take backup of VM or your development VM in which your application resides, right? Then we will create a instance template out of this. Okay, we will create an instance template out of this backup VM what we have taken. I'll explain you later what is an instance template. Okay, and then after creating an instance template, we are going to create a managed instance group. Okay, where we configure this, and then finally we will attach a load balancer, right? So these are the 4 steps that we have to perform in order to make sure we have a scalable virtual machine which automatically scales based on my traffic, right? Based on my resources of a VM being utilized, it will automatically scale. Okay. So the first thing what you can do, guys, is very importantly, just shut down or stop this VM. Again, I repeat, guys, just stop this VM. It is like a shutting down, right? Why? Because it is better to shut down and take a backup of your VM. Because if your VM is running and your application is running, let's say, for example, some users uses it, right? There is some process that is running in the background in the VM, right? So that backup won't be taken up properly, right? So in order to take proper backup, we have to make sure we actually shut down or switch off the VM, right? So to shut down or switch off the VM, just click on VM instances. Click on this 3 dot icon is here and simply say on stop. So that will stop our VM. Stop on a sense is nothing but it will shut down our VM. It will not delete, but it will stop. Okay. Okay, great. So how do you verify or how do you know if your VM is switched off? So on the left hand side, initially you will have a green icon and then you will have a gray icon. Gray icon means it's stopped. Okay. Then what you can do is on the left hand side, just scroll down. Okay. And then click on this images. So under storage, you would see this images option. So I would request everyone to click on this images. So we are going to create a backup by creating an image. We will create a custom image. If you remember while creating VM, I explained, right? Custom image is where you do one-time backup where you manually go and click a button and do it, right? So we are going to do that. We are going to create a custom image. So click on images. Okay. So once you're in this images page, just click on create image, guys. Click on create image and that will take you to this page where we will create a backup image, right? Okay. So here it is asking the name of your image. What do we give? So I'm going to say dev-image-backup, something like this. I'll say dev image, our development image backup. I'm going to give some name like this. Okay. So make sure you guys give the name. After giving the name, the source will be disk itself because you're taking backup from a disk, and just select your VM, guys. Under source disk, select your VM and from that VM, it is going to take a backup. Okay. So please make sure these first 3 options, just configure it. It's the same as mine. Okay. Then after that, you can simply scroll down and click on create, guys. That will create this image. So it will start taking backup of that VM and it will create a image out of this VM. Okay. So once this is done, guys, so you see our step 1 is completed. Step 1, that is we taking backup. How do we take a backup of a VM, guys? By creating an image, correct? So we'll create an image, and from that image we took a backup. Okay. Then after that, next thing we have to do is create an instance template. What is this instance template, guys? So technically, when we have virtual machine, don't you think when my new virtual machine is getting created, it should be an exact replica of my machine, main machine, right? That is basically nothing but even my VPC, even how much resources I have to give, right? These resources, right? Cores, storage, this image, the custom image that we are creating, everything has to be configured, right? You can't just go in every VM, you create a new configuration. You can't do that, right? It should basically be like a blueprint. My every VM should replicate, right? So in that scenario, what we will do is, if you scroll again on the left hand side top, you would see an option here that says instance template, right? I repeat again, on the left hand side here top, you would see an option that says instance template, right? So click on this instance template. Okay. And then we will go ahead and create a new instance template. Click on instance template, then click on create instance template, and you'll be redirected to a page like this. Okay. So here, if you see, guys, technically it is same as you creating a VM, right? The configuration. The reason being, this is instance template, meaning VM template. So when you do this, it will not create VM, but rather it will create a template of a VM, right? So I'm going to give name of this as dev instance template. So I'm just going to give the name as the dev instance template for this. Okay. I hope you guys have given the name. After the name, then you can just scroll down and select the machine type that we have selected similar to dev, right? That is EC2 Micron. We will select the same instance as we have selected in dev. Now, is it compulsory to select same instance as we have selected in dev? No, it's not compulsory, but we are still selecting the lowest because my application is very lightweight, right? That's why. But here, whatever I select, in my auto scaling, all the VMs will have same configuration because it will just simply replicate it, right? Okay. Then after that, I'll just scroll down, and coming to this boot disk configuration, guys, very important. If I select boot disk as Debian or Ubuntu, what will happen, guys? Every time it auto scales a new VM, it will be a fresh OS, but I don't need fresh OS. Remember, I took backup. I need OS in which my application is there, my dependency is there, everything is installed, correct? So that's why in boot disk, very importantly, we will click on change. Okay. And then select our custom image. So please go ahead, click on boot disk, click on change, and under custom images, select on dev images, the image that we created, right? Backup. You will see dev image backup, select that. Okay. So once you guys have selected custom image, guys, then very important, just verify once. Verify once here in boot disk, your image should not be Ubuntu or Linux or Debian. It should basically be this dev image backup, the backup image that we have created. Okay. Then after verifying this, the very next important thing you have to verify is firewall. Again, I repeat, important, this firewall, you have to check on this HTTP and HTTPS options. Very important. You have to check on these two boxes, right? In firewall, click on this allow HTTP and allow HTTPS. Okay. Then after that, simply click on create. So this will create our instance template. This will create a template for us. So in this template, all my VM configuration is preserved like a blueprint. So if I want to quickly create a VM, I can go and create it from this template. But again, I don't want to create one VM. Now I'm going to create group of VMs using managed instance group, right? So we will see that how we will do. So just create this instance template. Okay. Then what we'll do now, our step 2 is also complete. Correct. So we created the backup of our VM by using custom image. Then we created a instance template, right? We created template out of our, we created like a blueprint template for our VM, right? Now we will go and create a managed instance group, right? So this managed instance group is where we will go and configure that, hey, I need so and so VMs, minimum, maximum. This will be my auto scaling criteria, right? All of those things we will configure in this managed instance group. So let's go ahead and create this managed instance group. Okay. To do that, let's go back to our screen. And on the left hand side, if you scroll a little bit, you would see instance group. In this instance group, you have to click on instance groups. Okay. Then click on create instance group, guys. Click on that create instance group button. Okay. And then the first thing you will fill is the name. So I'm going to say dev instance group. So I'll give the name of this instance group, that is the dev instance group. Description, I'll leave it blank. If you want, you can give any description, it's optional. Then I'll select instance template. So I'll select the template which it will use to auto scale. That is, if you want to auto scale, it will quickly get the VM configurations from this instance template, right? Okay. Then you can scroll down a little bit and location, this zones will be the same. Then we come down to this auto scaling option, guys. Okay. What is this auto scaling option? This auto scaling option is where we say how many minimum number of instance we need and how many maximum number of instance we need, right? So here minimum number of instances is 1, which means that one VM is always going to be there on 24/7. So minimum one VM will be there. That means minimum 100 of user can access my application given a time, the traffic, right? And even when you auto scale, guys, it doesn't mean that when you auto scale, you can auto scale up to like thousands of VMs, right? Because you will also have budget constraint, right? You can't just go and auto scale thousands of VMs. So in that cases, we go and add maximum number of instances, right? So that we have a upper limit. This 10 is basically a max. It's basically giving a higher cap value, right? Above this, it's not gonna create, right? So 10 will basically be a max number. Above 10, we won't create. So even if there is more traffic or more load, it will not go and create a VM, right? So you can do that. For now, I'm just going to simply keep it 3 for our learning purpose, right? Because 3 auto scaling is more than enough for us. Okay. So auto scaling mode is basically what do you want to do? If you say auto scaling mode on, then it is going to add or remove instances. If you say scale out, it's only going to add instance. It will never reduce it. And off is basically no auto scale, right? So you have only 3 mode: on, off, scale out. Scale out is where you only increase it, but never decrease it, which is not good, right? I mean, if at one particular time, if you have a lot of traffic, it will create 10 VMs. After that, it will never reduce the 10 VM, even if your traffic reduces. So that's not a good use case, right? So generally, we don't use scale out and we don't use off. We use default the on, where it will add and also after some time automatically remove instances if there is less traffic or no traffic, right? Okay. Then comes your auto scaling signal. So in auto scaling signal, here you configure, guys, that is, when should you auto scale? So see, above this, you have configured that I'll have minimum 1 instances and maximum 3 instances, correct? But now you might have to tell, right, when it should auto scale. From 1, when should it become 2? From 2, when should it become 3 instances? That is where you do this auto scaling signals. That is, which gives a signal when to auto scale. So the condition here is CPU utilization 60 is the target, meaning if 60% of my CPU is utilized, then it will go ahead and increase my VM by 1. If you, let's say, for example, give it 80, the CPU utilization, that means once 80% of my CPU is utilized, that means the load on my virtual machine is 80%, then it will go and quickly spin up a new VM, right? Now you might say, how do I come up with this number? So you come up with this number ideally based on the development you're doing, and you know that application, right? Your application, how long it is going to take, right? To application, how long it is going to take to run, correct? Once it is booted or started. So based on that, you write this number. So if your application is heavy and it takes a lot of time, then you will reduce this number. If your application is very small, tiny, and it quickly spins up, then you will give a little larger number like 75, 80, 85, 90% as CPU utilization, right? So I'm going to keep it 60 default. Then comes your initialization period. What is this initialization period? This is the period that your VM is going to wait for your application to be ready and then serve, right? So what this means is, if my load is full, so it will quickly spin up a VM, but this VM will not directly start catering users. It will wait for this initialization period time. Why? Because once your VM start, you might require some time, right? Like 10, 15 seconds, 20 seconds of gap for your application to run, right? Your application also will take some time to load and run, right? Here it's a small application, it will take like milliseconds, but let's say our application takes 10 seconds to load, right? So that time you put here in initialization period. So what happens in that case? Once your VM is created, it will wait for this much of time and then it will start serving, right? So that in that case, your application will be up and running, right? Since my application is basically Apache default web page, it's a very light application. So I'm simply going to give a initialization period of 20 seconds. 20 seconds is more than enough, right? So I hope even this initialization period concept is clear. Okay. Then you just have to scroll down and click on create, right? So that's all you have to configure. Then finally you can scroll down and click on create button. Okay, then let me do it from my side also. So right now my managed instance group is getting created. It will take some time created. It will take ideally 2 to 3 minutes it will take. So let it take that time because it's spinning up a new VM. It will take the backup. Then it is going to start your VM. So it will take some time. Give it some time. Yeah. So see, it's in progress. It's created. I mean, it's not created. Do you see here progress or do you see green color here? Okay. Now it shows green for me. It's because our application is very small, tiny, right? That's why it took so less time. Anyways, so you see this green color, correct? Now, what does this green color mean? That your instance group, managed instance group is running successfully. You see, minimum how many VM is running? Minimum 1 VM is running. Again, to verify this, on the left hand side, click on VM instances. Now, if you click on VM instances, you guys will see 2 VM, right? One VM, the one which we created, the dev VM. Another VM is this VM which is dev instance group, and it has a random some alphanumeric characters, right? So this is created by managed instance group. So if my load increases, then here you will see one more VM created for dev instance group. If again my load increases, then you will see 3, but it will never cross 3. Why? Because the maximum number of instance I've given is 3, right? So at max it can have 3 VM, and because I've given minimum 1, so always this 1 VM will always be there. Okay. So now how do we test this? So to test this, I will ask you guys to go back to instance group and I'll tell you how to test it. So go back to instance group, guys. Click on instance group. Okay. After clicking on instance group, just click on your instance group. So if you click on your instance group, then you'll go to this page where you will see a lot of details and settings, right, related to your instance group. Then you can copy the external IP address from here, guys. This is the external IP address. And then you can go to new URL, new tab, HTTP, paste this URL and hit enter. And you see, this is working from my managed instance group VM. So please test if your application is working or not from the managed instance group VM. Okay. So now quick question, guys. Okay. If we have one virtual machine, you will have one public IPv4, public IP address. If you have two virtual machine, two IP address. When you have three virtual machine, we have three IP address, right? So there will be for every VM, we will have IP address. Do you think multiple IP address will be given to my users? No, right? And do you think remembering these multiple IP address is possible for multiple instances? No, right? It's very difficult, right? So how do my front end, that is basically how do my user use my application without knowing or worrying that I have one or multiple VM, and if it is multiple VM, the IP address is changing or not? So in such cases, we bring something called as a load balancer. So what is the work of load balancer, right? A load balancer is nothing but the one which connects to your backend. All the instances, automatically it will connect to all the instances, and then it will only have one IP address called as front end IP. Why? Because this one single IP address will be accessed by all the thousands of users, and load balancer will automatically do the job of redirecting this request to this VM or this VM or this VM, right? Based on the round robin algorithm or based on the utilization, automatically it will redirect, right? And the next thing that we will be doing, right, that is creating and attaching a load balancer, so that I have to not worry about multiple IP address. I will be given one IP address from the load balancer called as front end IP, right? And load balancer very worry about the backend multiple IP address. Okay. So now let's proceed further and then create a load balancer. Okay. So I'll go back to my home screen, and on the top, I'm going to search for load balancer or load balancing. So you can search for load balancer, or you can search for load balancing and click on load balancing. Okay. So let's go ahead and create a load balancer, guys. Okay. Now, to create this load balancer, I will click on this button that says create load balancer. Okay. And here it will tell me whether you need an application load balancer or network. We definitely need an application load balancer. Why? Because I'm deploying an application or I'm exposing an application, right? So that's why I'll select an application load balancer and then click on next. Okay. So in the step 1, select application load balancer. It is already selected by default. Click on next. Okay. Then second option is whether is this load balancer public facing, meaning will this be used at internet, that is will the request that I'll be getting will be from internet, or is it internal meaning inside GCP itself. For us, obviously it's public facing, right? Why? Because my application will be used by thousands of users from internet, and from internet is nothing but public. So I will keep it default, that is public facing. Okay. And then click on next. Then step 3, global or single region deployment. Okay. Step 3 is global or single region deployment. That means the application you're deploying, is it in single region or it can be used in multiple region. That is how it is, right? So we will select multi-region global, so that globally it can cater clients. Okay. My workload can be handled in multiple region. So I'll select it as global, which is better for high availability, right? Then load balancer generation, I'll say external. Everything is basically default, guys. Just click on next, 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 and click on configure. So far, we were just selecting what type of load balancer we want. Now we will go and configure our load balancer. Okay. Now, once everyone is in the same page as I am, so here on the top, you will see load balancer name, right? So just give the load balancer name as dev-lb, that is load balancer. You can give any name, whatever you want, right? Whatever it suits. So give dev-lb, which will basically be your load balancer name. Okay. After giving that, see here, there is something called as front-end configuration. Here, front-end configuration doesn't mean that it's a website. Front-end is nothing but, if you remember, I told a load balancer will have one public IP address. This public IP address is called front end. Why? Because it is front facing, right? It is being visible, it is being utilized by public or internet, right? So that's why it's called as front end IP. And configurations related to front end is your front end configuration, right? So please don't get confused. This front end is not like your website front end. This front end is basically front facing configuration, that is public side facing. So what is public side facing, guys? The only one thing is facing public side, right? An IP address. So all you need is one IP address which is front facing or public, right? So for that, here I will give my front end IP configuration, or I'll give the name of that IP. I'll call this as IP. I'll just give the name as IP, and it will basically, this IP address will actually use HTTP protocol. Okay. And I will say port number 80, and it will create an ephemeral IP address, meaning it will create a temporary IP address. Once I release this or delete this load balancer, that IP address will go back to the pool. It will be released, right? So please go ahead and actually just give the name of that IP address. That's all we have to fill. Others are already filled for us by default, right? Okay. Now, what is backend configuration? Backend configuration is where you tell the load balancer where your backend is. My backend is currently where, guys? My backend is in a managed instance group, MIG. MIG is nothing but your managed instance group, right? So here in backend configuration, we go and configure that. We explain the load balancer where my application is deployed. So currently, guys, now we have to go and tell my load balancer that my backend is a managed instance group, and I want to attach that, right? So here I will go and create a new backend service. Go and click and create on a new backend service. Okay. So here you will give the name here, right? Let me give the name here as backend. Let me just write it as backend. It's fine. Or you can write dev backend. It's up to you, right? Just give some meaningful name. So I'm just giving name to my backend service, right? Description, I leave it blank. Then after that, I'm selecting instance group. What does it mean? That means where is my application deployed? Currently, my application is deployed in instance group. You can even select if it is deployed in any serverless service, or if it is deployed in your Google Kubernetes cluster, right? So you can select where your application is deployed. Since our application is deployed currently in an instance group, so I will keep it default, the first option that says instance group, and everything else I'll keep default. It is HTTP protocol, name is also HTTP, timeout also I'll give it as 30 seconds, right? Everything else I'll keep it here default. So please make sure this first 4 to 5 options, it is matching. Okay. So once this first 3 to 4 options are configured, guys, just scroll down a little bit and click on instance group, and then click on this dev instance group. So remember, this is our instance group. So we are attaching our load balancer back into an instance group. Port number, I will tell 80. So in port number 80, my application runs. Now you might say, how do I know port number 80? So for HTTP, guys, port number is 80 by default. This is the default number. So if you are anytime using HTTP, port number 80 is default. Okay. So give 80 and press space or press enter, and that will give like a tag port number. So please configure these two things, instance group and port number. Okay. Next comes balancing mode. So balancing mode is nothing but based on utilization. Your load balancer will balance it. And here this is 80% utilization, meaning it will not send a new request to a VM if it is 80% utilized, right? It will send the request to new VM, right? So that's what your balancing here is. So it will not send any request to a virtual machine if it is maxed out, or if it has 80% of utilization, right? Then we will scroll down. Okay. And then you will see this enable cloud CDN, right? So what is a CDN, cloud CDN? So a cloud CDN is nothing but a mini version of your server, guys. Okay, think it like this. I have a globe. In this globe, okay, let's say this is land, something like this. Okay, now let's say, for example, these blue dots are my data centers. Okay, let's say these blue dots are my data centers, okay, of GCP. And let's assume this orange dot is where I am, or my laptop is somewhere in Australia. Okay, now let's say if I say www.google.com, so it will go to my nearest server and it will bring the www.google.com response. Correct, it will go and it will come back. But the problem is, if there are thousands of users from Australia using it, and for all 1,000 requests it has to travel so far, there would be a latency, or they would basically be extra time, because it will take time to go and come back, right? I know it will be in seconds itself, but still, right? So in such cases, what they do is there would be an extra node, guys. This node is nothing but, think it like a mini server that are in large number in multiple region. It will be in large number, right? It will be in large number. This green are nothing but nodes. These nodes are basically your CDN, guys. So what happens in this node is, once you write www.google.com, first it goes to this node. It checks if google.com is cached. Cached in a sense is nothing but, think it like a quick replica is there or not. So if it is cached, then the response is sent very immediately. So it's like super fast, right? If it is not cached in my node, if there is no cache in my CDN, then what it does, it goes to my server. From server, it will get response, store it in my CDN, and then from CDN, it will come back to my laptop. So this way, what happens, now it will get cached. So next time, if I say google.com, it will be like super fast, right? It will be very quick. Why? Because now it is cached. So these caching nodes that are available in globes, those are your cloud CDN. So generally we use it for caching the content. It only does static content. Okay. So if you enable this, then yes, it will make sure that your application is faster and it preserves or it caches, and then you can provide, right? How long do you want to cache it, right? 1 day, 1 hour. So you can provide those settings. Okay. So I'll be scrolling down, and below this cloud CDN, you guys will see something called as health check, right? What is this health check? This health check is to make sure to check if my application is healthy, meaning it will check if my application is successfully running or not. Because imagine, guys, I have 4 VMs. In this, let's say if this VM is not working, or my application is not working in this VM, it is not running, then attaching this to my load balancer will become a problem. Why? Because let's say if load increases and my load balancer sends a request to this VM which is not working, so that VM will give error. That means it will not give response, right? Which is nothing but a bad customer experience, right? So in such scenarios, you want to actually rule out or not attach such VM in which your application is not running, right? So to do that, we enable this health check. So this health check will make sure that my application is working or not, right? So I will go ahead and click on create a health check, guys. So please click on create health check and it will land you to this particular page. Okay. Then I will give this name as dev health check, something like this. You guys can also give same name. Okay. Protocol, and then make sure, guys, after giving the name, I will select protocol as HTTP. So HTTP protocol, I'll be sending a health check, and port number will be 80, and request part will be slash. That is nothing but my IP address. It will end with a slash, right? That is nothing but your root route. So it will be the default slash, right? Then comes your health interval. That's nothing but every it will check every 5 seconds. It will check health. It will check health of your application, if your application is running successful or not, if it is working successfully or not, right? So every 5 seconds, it is going to send a request and see if my application is successfully working or not, right? Okay. After that, you can simply click on save. So technically we only give the name of the health and we gave a protocol, and I'll click on save. And then I'll click on create. So that will create my backend service. Okay. After that, you can simply click on create, guys. So that will create your load balancer. Okay. So once your load balancers is created, click on your load balancer, guys. Okay. Then copy only this IP address. Don't copy the port number, guys. Okay. Just copy this IP address and then again http :/ paste your IP address, hit enter. But it won't work, guys. It'll at least take 3 to 5 minutes. Why? Because in the backend it should basically map this load balancer, do the DNS and all that, right? It does that mapping. So it will take ideally 3 to 5 minutes. So we have to wait 3 to 5 minutes, right? You have to copy this IP address from here. This is the front end IP. So you just have to worry about this one IP address. You need not worry if there is one VM, hundreds of VMs in the backend managed instance group. So that's the advantage. So copy that IP address. Okay. And then just give it 3 to 5 minutes, guys. It will take 3 to 5 minutes and then your IP address will work, because the load balancer takes some time to update, right? So that's why. Yeah. So now it's working. Yep. So see, now it's working for me, right? The IP address. So this is how you can actually create a managed instance group and auto scale your application. Is it clear, guys? I know this looks very big thing. That's because I've done very, very, very slow. Technically, we can do all of this in less than 5 minutes. Because I explained each and everything, I did very slowly. That's why it took so long, right? Or else technically, if you see, guys, in 5 minutes, we can do all these 4 steps, right? But these are the steps that you will make sure you do in order to deploy your application on multiple VMs or auto scaling VMs in GCP, right? And that is called as your managed instance group. Okay. So shall we go ahead and clean up whatever we have done today? Okay. Now there's a quick catch here, guys. While creating, we went 1, 2, 3, 4. But while deleting, we will go reverse, guys. We will go 4, 3, 2, 1. Why? Because if you go and delete the backup, it will give error, because that backup is currently used in instance template. If you go and try to delete the instance template, you will get error. Why? Because that instance template is currently used in managed instance group. If you go and delete this managed instance group, it will give error because that is currently used in load balancer, right? So that's why in managed instance group, while deleting, you have to go bottom up. First delete the load balancer, then delete managed instance group, then delete instance template, then delete the VM, right? So let us first go ahead and delete this load balancer. While deleting the load balancer, again I repeat, while deleting this load balancer, delete the backend service, delete even the health check. If you don't delete backend service, you won't be able to delete managed instance group, right? So please make sure you go and delete this. Right. So my load balancer is successfully deleted, guys. So next I'll go back to my instance group and I will delete the instance group under VM. So after my load balancer is deleted, guys, I'm going to delete the instance group. So once your load balancer is deleted, then go ahead and delete the instance group. Now, once this is deleted, so my managed instance group is also deleted. Then I will delete the instance template. Okay. Then once my instance template is deleted, then I will delete my image, the backup image that I have created. And then once my backup image is deleted, I can go ahead and delete the dev VM that we have created. Remember at the very beginning. So I'll go ahead and delete that VM also. Right? You have to first delete load balancer, then delete managed instance group, then delete your template, then delete your custom image, then delete the dev VM that you have created, right? So you have to go in this bottom top approach and delete these things 5 in order. Then, so now successfully I have cleaned up all the resources, whatever we have done, right? Okay, cool. So a quick recap of what we have done so far, right? So we got started with GCP Compute, and under GCP Compute, we actually got started with virtual machine, right? Now in virtual machine, we learned how to create a virtual machine in which we can do the development, right? And in managed instance group, and we saw what is the drawback of virtual machine, right? So we all saw that the drawback of having a virtual machine is that it's a single instance, right? And because it's a single instance, there are limitations, right? The limitation is that you have a boundary or you have a limited resource, right? Now, if you create a virtual machine of 4 GB RAM or 4 GB memory, that's the max you can have, right? You can't have a 4 GB memory and you can expect that it will work as if it has 32 GB memory. No, right? So there is a cap, there is a limitation of this resources, right? And you can't go beyond that number, right? Or the cap. So deploying actually production application on virtual machine can be done, but technically it's a very big risk, right? Because let's say assume you foresee that, okay, I might have 1,000 users or 10,000 users. Based on that, you might have your virtual machine. But what if you get more and more user, or if your traffic suddenly increases, right? So your virtual machine won't be able to handle the load. And lot of users will start getting those, errors saying that, not able to connection error and all that. And you guys know, bad user experience means they're never going to come back to that application again, right? Or they're going to get pissed off, right? So that's why it's important to make sure that it can scale and cater to any amount of users or customer, right? And to actually convert this drawback into an advantage, that's where we have managed instance group, right? So what is a managed instance group? So in managed instance group, as the name suggests, instance group. Instance means single VM, group means group of VMs. So you'll have group of VMs that auto scales automatically based on the request or demand. So if your demand is you need more traffic, it'll go ahead and replicate and create more virtual machines. If your demand is like less traffic, then it will go ahead and reduce it as lesser instances, right? Now, there is one more disadvantage of managed instance group. What can be a potential disadvantage in a managed instance group? It has something to do with first pricing and second thing with consistency. Consistency in traffic and pricing. These two things are the hint. What I mean to say by consistency in traffic is, do you think 24/7 into 30 days into 365 days, would I have thousands of customers every second? No, right? There would be basically ups and downs, right? Sometimes I might have zero users, right? I mean, basically, if you logically think, at night time, your number of users will actually reduce very drastically, right? I mean, technically, no one is going and ordering things at 2 or 2 a.m. or 3 a.m. in the morning. I mean, there'll be very few, right? All I'm trying to say is it'll be less. Whereas the same you take evening time or morning time, it'll be high, right? So if I, for example, go and say that I will set minimum 5 instances. So if I set as minimum 5 instances, I need always, don't you think I'm paying for 5 times into cost of 1 VM? So I'm paying cost of 5 VMs every time, even if it is increased or decreased. And the problem is, I can't just have always a person sitting and at night time go and decrease this count, and then morning time, early morning, go and increase this count. I can't do that manually, right? I can't just keep an employee to do that, right? So this is in terms of consistency what I mean, right? So what we actually plan to configure, it need not be that always this requirement will suffice. First thing. Second thing is about pricing. I told, right? This pricing itself deals with this also, right? I have to always give price of 5 instance because I always have 5 instance. Even if I have 1 instance, guys, 1 instance, I have to pay amount of 24/7 into 30 days per month, right? I have to pay that cost because I've given minimum 1 instance. Even if my traffic is zero for 6 hours, like let's say, for example, overnight, at night time, my traffic is zero, but still I'm spending that money, right? So that is your pricing. It's like you're not best utilizing it, right? So in such cases, so now you see, actually you see here, right? The disadvantage of virtual machine is become an advantage in managed instance group. The disadvantage in managed instance group will become an advantage in something called as a serverless services. So all this story, left, right, all this explanation, just to tell you something, that if you don't want to pay for something that is not consistent, right, and it's constant money, meaning I have to pay minimum amount for that minimum VM, right? But my consistency in traffic is not good. That means it can rise and drop, right? So in such scenarios, we will go with GCP serverless, right? So now come to a new topic called as GCP serverless. I hope it was clear. Okay, so far. Now, in GCP serverless, okay, in GCP serverless, there are 3 services that we will be learning. First is App Engine, then we'll learn Cloud Run, then we will run Cloud Function. Okay, now first let us talk about what is serverless, right? So in the name itself, guys, serverless, meaning you need not worry about server. You have to totally forget about server. Now, when I say server, what does it mean? You need to forget about what would be the OS, what would be the version of OS, what would be the dependency file, how much memory do I need, how much cores do I need. All these things which are infra related, you can simply forget. As simple as that, right? You can forget that. Now, in serverless, a very easy example of serverless is on demand, pay as you use, right? Now again, a example that we took, right, of a cab, right? Now imagine you have your own vehicle, you purchased your own vehicle, which you will be actually paying EMIs, then you will have lot of maintenance that you will be undertaking, then there would be insurance that you have to pay, then there would be other mechanic and other maintenance things, right? All of these things you have to maintain, right? And if anything happens, then you have to take care of it, right? Like if anything happens, like god forbid, but if any accident, then all of things would be your responsibility, right? Whereas if you don't own a car, all you have to do is whenever you travel, just book a cab, which is cost effective. It reaches, you will reach from your source to destination Okay, when you're not using that frequently, right? So here what happens, you don't have to shell out a lot of money to maintain your own car, rather just book a cab and quickly go somewhere, right? So something like that is same in serverless also. In serverless, you need not keep a VM or an instance 24/7 on. Even if it is on, you need not pay for it 24/7. You will only pay for it based on number of requests or number of traffic. So if I have 5 requests being sent to my application, I will only pay for that 5 request amount. I won't pay for in behind the scene how many VMs it is, what VM it is. I don't have to worry or care about that, right? So that's the beauty and that's the advantage of serverless. Okay. Now, other thing is serverless gives us a benefit of auto scaling your application and going as lowest as 0 instance and as highest as X. You can have like 1000, 2000, number of instances, right? So that means if there is no traffic, then there is no deployment itself. So technically you're not paying anything, you're paying 0, right? So this is an advantage. Then you'll be like, okay, what if there is a new request that comes in? So if there is a new request that comes in, right, then what happens? It quickly goes and spin up one instance. And from this one instance, it will cater the user, whoever sent the request, right? So to make sure this architecture works perfectly fine, you can only deploy microservices architecture or microservices application in serverless, right? Because it will be microservice, right? Just imagine I want to deploy whole, let's say there is an university. The universities, it'll have an entire portal, right, for attendance, fees management, subject, exam. Imagine such a huge application, you deploy it, right, as a single application, how heavy it will be. Whereas I deployed into multiple smaller application called as microservices, right? So that is far more better, right? So it is easier to deploy microservices application, which is like smaller application, because it's quicker to launch, it's lightweighted, and it will also cater a lot of users faster, right? Now that being said, shall we go ahead and see the first serverless service called as App Engine and do hands-on of how we can deploy an application in GCP App Engine? Okay. So before we go into App Engine, here's a task for you guys. I want you guys to launch the terminal. Okay. I want you guys to launch the terminal and open it in new tab. Please go to your GCP console, click on Cloud Shell and open it in new tab. Okay, fine. Let me do it from my end also. So I'll go here to my GCP console. So coming back to your home page, on the top right, you guys will see this, the option that says activate Cloud Shell, right? So click on this activate Cloud Shell option. Okay. And then you can click on, you see this option that says open in new window, right? Last but one options here. So that is open in new window, right? So just click on this open in new window, and that's going to open it in here, complete new window, right? So then here I can close it because now it has opened in this session. Okay. Now, once you have this terminal in new tab, you can click on this pencil icon, which is going to open it side by side. You have a cloud editor on the top and you have a terminal below, both side by side. Okay. So now in App Engine, how do we deploy? You simply have to focus on code. That is your application. You need not worry about what OS. You need not worry how much RAM I need. You need not worry about how much cores I need. You need not worry about storage. You just have to write your code or your application. You just have to build your application. Focus on code. Don't focus on anything else. Everything else will be done by GCP. As simple as that, right? Just bring your code and everything else will be taken care by the GCP cloud providers, right? So again, as we are not focused on code development in this training, so what we'll do is we will take an existing code that is already provided by Google, maybe a sample UI application, and then deploy that in App Engine. And trust me, guys, you'll say it's super easy to deploy App Engine in GCP. or deploy application using App Engine in GCP, right? Okay. Before that, I think we have to go and enable this App Engine, or else it will give us API error. But it's fine. Let's do it later. Fine. So we'll go to Google Cloud Platform Python doc sample GitHub repo. So there is a GitHub repository provided by GCP in which it has its code in Python, right? And here under App Engine, standard Python 3, under standard Python 3, hello world, right? So this is the path where we will go and we will get a code here. So this is the sample code that is being given by GCP, which we will use. Okay. So now what you can do is you can clone this repository. So you can simply click on this code option here, guys. Okay. You would see a green color code button here, right? So just click on that green color code button here and then click on copy this URL. Okay. So once you click on this copy button, you will get this URL. So just copy this URL. Okay. Once you have copied that URL, come back to your terminal. Okay. And in terminal, write git space clone space, right click and paste that URL that you copied and hit enter. Okay. Let me do at my end also. Okay. Then not what you can do is you can say cd space Python doc samples. Okay. You can just hit tab, guys. Just write first 4 characters and hit tab. It will autocomplete. Then write app engine, hit tab, then standard underscore 3, I think, right? What was that? App engine standard underscore Python 3. Okay. Standard underscore Python 3 in that hello world. Let me just verify once again, guys. Hello world is the app.yaml files. Okay. In that hello world. So this is the directory you have to cd to and hit enter. So once you hit enter, you must see here green color long path here, right? Python doc sample, app engine, standard, hello world, right? So technically you should be inside this hello world folder in your terminal. Okay. Same folder. Now I want you guys to open from this editor also, right? Click on this 3 dot icon, file. Okay, let me do it again slowly. So this path, what you see here, right? Same path or folder I have to open even from editor on the top here. Okay. So to open it from this editor, on the top left hand side, do you guys see this menu icon or a burger icon, right? You'll see these 3 lines, right? Click on these 3 lines. Okay. After clicking on these 3 lines, then select the first option that says file. And inside the first option file, click on the option that says open folder. You'll get like basically 4th or 5th, this one, right? Click on open folder. Okay. Then it will actually give you something like this. Once you click on open folder, you will have like this a pop-up here. Okay. And here you can scroll down a little bit and you see Python doc sample folder. I'll click on this, single click. Then I will single click on app engine folder. Then I will single click on standard Python 3. Then I will single click on hello world. So now I am inside hello world folder. So once I'm inside hello world folder, I'm simply going to click on OK. Okay. So now again, we are not going to focus on the code, guys, again, because we are not doing code development. So I'm not going to go and explain line by line code, but let's assume there is a sample code that returns hello world, or that will actually display hello world in the screen, right? And then very important thing is, guys, this app.yaml file. here we have an app.yaml file here. Okay. And in this app.yaml file, we have runtime as Python 3.9. That's nothing but Python version, where we are telling that, hey, whatever code I've written, it should run in Python 3.9 version, right? Like how you'll have Java version 11, 12, 13. Nowadays, we have in 20s, right? 24, 25. So same way, we have Python version 3.9, right? So what is this app.yaml? This app.yaml is the one where my GCP understands what tech stack it is, where is my code file, everything it will understand from this app.yaml. So technically, if you want to deploy your application in App Engine, you have to only make sure you have like this app.yaml in your project folder or your code folder. Whatever it is your code, just go and write and just make sure you create a app.yaml, right? Now, how does this app.yaml look? This is the latest app.yaml, guys. So it's very simplified version. But let's say if I pick up an older version of app.yaml, how will it look like, right? So it would look something like this, right? So here I would say Python 2.7 or 2.7, which is old version. Then I would say set save thread as true, API versions, and then handlers. Handlers are basically nothing but what files I should expose, what files I should not expose, right? This we generally add handlers when we have UI application, or when we are trying to render a HTML CSS file, right? But since we are deploying a microservice, in microservice we don't have any UI for now, it's only APIs. So that's why we don't have any such configuration, right? So if you as a developer is developing an application, then all you have to do is come here, write your code, build your application as it is, and then get this YAML file. Create only this app.yaml file. So once you create this app.yaml file, you can simply and quickly deploy application in App Engine. So you guys understood how technically in App Engine it deploys? It deploys configuration using in this app.yaml file. Now, what is this app.yaml? Each line by line, that is something you guys can go ahead and learn from the documentations. I'm not going to explain each and everything in app.yaml file, right? What are each and every configurations in this, how it works, those things, it's up to you guys for to explore, right? Shall we now go ahead and try to deploy this? Okay. Now comes the most simplest part, guys. Okay. To deploy this application, right? All you have to do is in your terminal, just write Gcloud app deploy, right? And then simply hit enter. So that is going to deploy your application in cloud. Wait, my authentication failed. Give me 1 second. Reconnect. What happened? My connection was lost. So just run Gcloud space app space deploy. That's all you have to do it. Sadly, there's no way to do it from UI, guys. We have to do it only from terminal, right? So cd Python docs app engine standard Python hello world, and then Gcloud app deploy. It's asking for region, so just give any one region number, right? Authorize. Just give whichever region you want to deploy, right? Let's say, for example, I want to deploy in US Central. US Central region is 17 number. So I'll just hit 17 number. So it is going to deploy in US Central region. So you see, it says user specified service account does not have access to this bucket, right? So we need to actually go ahead and give this permission. Now the thing is, okay, let me copy this error, paste it in Google. Because this error, it is fixed by cloud build setting page for project I was applying and enable app engine admin. Okay, I need to enable app engine admin API. Okay, for everyone, I'll tell you what this error is, guys. If you remember, if you are using any service in GCP for the first time, it will actually redirect to a page where you have to go and enable an API, correct? Like for example, when we were creating VPC, it redirected to a page where we enabled compute API, correct? Same way for App Engine, we have to go and enable App Engine API. Once we enable App Engine API, we will be able to deploy, right? So to enable App Engine API, go back to your home screen or go back to your welcome page. Okay. And then on the top search for app in or just search for enable API. Just write enable and you will get this option that says enable API and services. Okay. Just search for enable and click on enable API and services. Okay. Then click on this enable API and services. On the top, you will see this button that says enable API and services, right? Click on that enable API and services blue button, right? And then after that, in the search, just search for app engine. So you will see app engine admin API. So just go to app engine admin API and then you will get this app engine admin API, right? Click on this app engine admin API and enable this. Just enable this API. Understood? You just have to enable this app engine admin API. What is the command to deploy? Gcloud space app space deploy. Okay. Now you can go back and run the command again, guys. Gcloud app deploy. See this command that says Gcloud space app space deployed. Okay. And then hit enter. Okay. You will see a URL here, guys. Just copy this URL from this one, paste it in basically new tab, and then you will see hello world as a response. Okay. So I will now ask a very simple question. We have our application deployed, correct? Did we focus or worry about which OS it is running on or which OS I've selected? Did I worry about this, guys? No. Did I worry about what will be the RAM, what will be the OS version, what will be my boot disk, whether it is HDD, SSD? Did I worry about that? No. Did I even worry about what would be your traffic, auto scaling, 0 instance, 100 instance, 10,000 instance? Did I worry about anything? No. This is a pure example and benefit of serverless. So now you will understand the word serverless, meaning less server, meaning you don't have to worry itself about server. No need to worry about server. You worry about your application, you worry about your development, you focus on that, right? Now, coming back to this. So app engine, you understood that we just have to focus or we have to worry about code or application, and then we will have the application, correct? Now, the second thing is, how does it actually deploy, right? Where do I see this deployment? To see this deployment, we will use UI. Sadly, you cannot deploy application through UI, guys. Okay. If you want to deploy application, you can only do it through terminal by running this command that says Gcloud app deploy. So now, if I want to see how many app engine instances I have deployed, right? I'll click on this home page and then I will go here on the top and search for app engine. I'll just write app space engine. So once you write app engine, you will get here application settings app engine, right? So here you see, you will never get app engine, you will get settings. Why? Because app engine you cannot use by UI. You can just view them, but deployment can only be done through terminal, right? So just write app engine in your search bar, and here you will get application settings. So click on this application settings and you will be redirected to this page as IAM. So here in the first option that says dashboard. Okay. So here you will see this graph that says how many requests is been sent, right? So I tried to at least send, like, refresh this page 3 to 4 times, right? So that many requests, right? And under this service option or service tab, guys, you will see this, right? You will see this service default version 1. That means I have deployed my application once. So that's why I see version once. And you will see the name of my application is default. Why? Because I still did not give my name of my application. Because I did not give name of my application, it is default, right? Then under version, guys, you will see there is only one version. Why there is only one version? Because only one time I have deployed this application, right? Now, what if I make update in my application? Currently, guys, it is returning hello world. Let's say I make a change in my application. You guys need not do it. Just watch how I'm doing. Okay. I'll just go and make a code change. I'm going to say hello world Aman. I will save it. That means what? Technically, this is nothing but I've mimicked that. I've made changes in my application, right? And then after that, I will hit Gcloud app deploy. And then I will simply say yes. And then that will take some time. Just give it some time. Okay. So now it is done. So now if I go back and refresh, so see, guys, I see two version here. And in two version, you see the latest version 100% traffic is served, right? Why? Because now I have updated version. So updated version, it will start slowly serving traffic, right? So it is easier for your rollback. Meaning, let's say, for example, my latest application that I have deployed, okay, hello world Aman, and let's say there is bug in this application. I want to quickly go back to my previous version. So if I want to quickly go back to previous version, I can simply go here, select the previous version, and I can even migrate traffic, right? So you're seeing the benefit. I can even roll back, right? Then in instances, I will get information of how much CPU it has, or how much memory and how much CPU it is utilized so far. So far, based on the traffic, max it has utilized 121 memory, 121 MB memory, right? So this app engine dashboard you can use to check on your application of how many versions you have, which version it is currently serving, how much resources it has allocated GCP from its end. And if you were to go and deploy, make code changes, you will do it from the terminal end. So now you are clear with this app engine, what this app engine does. So it's code application. You just have to worry about code or application. It is serverless, right? So these are the advantage of using app engine, right? Now, so far we have completed the app engine part, right? Now we will start with Cloud Run. So what is a Cloud Run service? So Cloud Run is also a serverless service. Okay. It is a serverless service which helps you deploy application serverless, where you don't have to worry much about infra, right? Yes, to some extent you can configure few part of infra, but you cannot have control over all the aspects, right? Only couple of them you can work on, right? Now, in App Engine, you deploy code or application, whereas in Cloud Run, you deploy container image, right? Now, what is a container image? This container image is similar to your custom image that you have built for a VM, correct? If you remember, we created a backup image, right? That backup image is a custom image. That custom image, like how we built, same way we will build a container image. We build a container image using tools like Docker, which we will see when we are doing Kubernetes, right? But for now, just think that we build a container image. So what you have to do, you have to package your code into a image, container image, and then you have to pass that container image. That's all. You don't have to pass your entire code. You don't have to pass anything. You just have to pass the container. Inside this container, your code and everything will be there, right? So please know the difference, guys. App Engine, directly code can be deployed, whereas Cloud Run, it has nothing to do with your code directly. It deploys using container image, and container image is built using tools like Dockers, right? So we will not build a Docker image or container image right now. We'll take a sample Hello World container image that is provided by Google, and we will try to deploy and serverless service using Cloud Run, right? So is it clear, guys, about the Cloud Run serverless service? It is used to deploy your application using your container images. Advantages is that here you're dealing with container image. Container image is far more stable and better version than code application, right? Because your code application can tend to break, tend to change, right? And again give error. Whereas container image, you can test them locally. And once you have a container image, you can deploy it anywhere, right? So container images are more stable and more better in terms of deployment compared to your code or application. Okay. So now to do the hands-on of Cloud Run, let's come back to this home page, right? And in this home page, on the top, just search for Cloud space Run. Okay. On the top, search for Cloud space Run and click on Cloud Run. Okay. So here you can click on this button that says Create Service. Click on, again, I'll repeat. So here you'll get a button on the top that says Create Service. On the top or bottom, wherever you see, just click on Create Service, and that will redirect you to this particular page. Okay. Now on this page, guys, the first thing it means, so like how every repository, like how this repository has a unique URL, right? Why does it has this unique URL? So that it can uniquely identify this code, correct? Same way, every container will have a URL when it is deployed, not deployed, but wherever it is stored. So we store it in artifact registry, so that artifact registry has a URL. Through that URL, you can pull this container image. That is, you can download this image, right? Or take this image. So that image we haven't built yet. So that's why what we'll do is we will click on test, this one. Okay. You will get a button below that says test. If you don't get test button, then here you see there is a sample URL. So this URL you have to type here, or just type something and you will get this button that says test with sample container. So just click on this test with sample container button and you will get this URL filled automatically. So this is a sample Hello World application which is being built and ready as a container provided by GCP for quickly testing purpose, right? Okay. Then if you scroll a little bit, then you will get a service name, right? So here in service name, I'll keep it as hello itself, or you want it as hello service, whatever name you want, you can give. It's just name to your service, right? So it technically doesn't mind. So you can just give whatever service name you feel, you can give the name. And then region, you can keep it whatever it is default, right? Okay. Then scrolling down, you'll get this option that says authentication, right? So here in authentication, there is two options, guys. One says allow unauthenticated invocation, and the other one says requires authentication, right? So in allow unauthenticated invocation, it means that your deployment will be public. So anyone who is trying to access your application, it need not authenticate to this GCP project. Okay. Whereas the second option says requires authentication, meaning that user should have access to your GCP project, then only he or she will be able to use that URL. But I don't want to do that, right? Because my application should be public, right? So that anyone can use. It's not like people who have only my GCP account or GCP project can access it, right? So click on allow unauthenticated invocations, right? Then you can select CPU allocation. You can select CPU is allocated only during request processing or always allocated. So what happens is, the option here says is, if a user sent a request, at that time should CPU be allocated, or always some amount of CPU should be reserved for your instance. And obviously both comes at a price. The cheaper one is the first option. Why? Because CPU will not be allocated, and it gets allocated when there is request sent. Whereas here, always CPU will be allocated. So some tiny amount will be incurred, right? And that will be very, very minute. It doesn't have that much of difference, okay, in the price. And price in a sense, not like 24/7 price. It's just the price of per API. Because remember, in serverless, you don't have concept of paying based on hours. You pay based on number of requests, right? So the request would be a little costly. That little also is like very, very negligible amount, right? Then comes your scaling, guys. So scaling, here you give minimum number of instances. So minimum, we can set it as 0 also. So what happens when I set minimum as 0? That means when there is no traffic, then technically there is no deployment itself. Then once the user hit request, then my deployment again starts, right? So that is this minimum number of instances. So I can keep it 0 for now, right? It's fine. Then comes your in-guess control. In-guess control here is to tell whether your application, which will be actually attached to a load balancer, which you will not do it. It will automatically be attached to a load balancer. Should it be private or public? So if it is public, then you will select as all. That means every request from internet is allowed. If you select as internal, then only through a VPC you can send request. That is, inside of VPC itself, you can access this application. You cannot access it outside of VPC, right? So for now, I'll keep it as all. Okay. Then I'll scroll down to container volume network settings. Okay. And then here you can give the port number. What is this port number? Port number where your application is up and running. So generally what happens when you're building custom application like Java application or a Python application or Node.js application, generally your application will run on port number like 3000, 5000, 8000, right? So you can come and give your custom port here where your application is actually running, right? And then after that, here you can specify the minimum resource you want. What will be the minimum resource that would be required? Again, it will auto scale your instance, right? So if I select 4 GB, then if I send more requests, then what will happen? Another 4 GB Cloud Run instance will be spinned up, right? But here you see, you're still not selecting any VM, you're not selecting OS, you're not selecting boot disk and all, right? You're just selecting the memory, how much you want, right? Because they have given this provision where you can set the, this is the, sorry, not minimum, but I will say maximum memory, right? This would be the maximum memory so that you can cap your memory also, right? So I will keep everything else default. I'm just explaining you that these options exist, right? Then under volume, you have an option to attach a volume, guys. What will be this volume? You can create, basically, you can attach a volume to a storage bucket or in-memory volume, or you can create as a secret, right? So you can even attach additional volumes to your Cloud Runs to store some persistent data, but I don't want to do it, right? Then under networking, if you want to make it internal, then you will say connect to VPC for outbound traffic, right? So these are to make it internal, which we need not worry, out of our scope, right? Security also, there's nothing much to manage. It will do default Google managed encryption, meaning default it will encrypt all our data, right? So all these are the basic configurations that we need to run Cloud Run, right? So once you guys have done everything that I have mentioned, you can simply go ahead and click on create. Okay, before that, there is some options here that I forgot to explain, right? So here you see there is a request timeout. What is this request timeout? This request timeout is basically once I send a request to my application, if my application doesn't respond back in 300 seconds, that means my application is taking a lot of time and it will send back connection or your server did not respond, right? Generally, you might have seen when you're using Chrome, sometimes you'll get an application timeout error, application is not responding, right? You get it because of this timeout, right? So if, let's say, for example, you're writing some logic where it's taking a lot of time, then you can definitely go ahead and increase this request timeout, right? And the maximum number you can increase this is 3600 seconds. That is, I think, technically how much? 60 minutes? Not sure. Let me quickly Google it. 3000 seconds to minutes. Yeah, technically it means 60 minutes. That means it cannot, your API should give response less than 60 minutes. It cannot take more than 60 minutes. And also you have to go and configure here it. By default, it is 300 seconds. That is 6 minutes or 5 minutes, right? So in 5 minutes, if your API or if your application doesn't respond back, that means it will give a server timeout error. Then maximum concurrent request per instance. That means one instance, how many parallel request can it accept, or how many parallel traffic it can accept. How do I get to know this number? You generally do POCs at development time where you do load testing, right? So while you do load testing, you will get an ballpoint number that this is an ideal good number, and this number I can actually keep it, right? In some scenarios, if your application is very lightweighted, you can even give 200. Some cases, if your application is little heavy, then you'll give like 10, 20, right? Because heavy in a sense, it needs more compute to run. It needs more time to run, right? So then you reduce this maximum concurrent request. Concurrent request means parallel request per second. That means 80 users parallelly using it. One instance can easily handle it. Can it handle it? No. You have to do the due diligence and go and put a valid number. Since we are using the default application, it's a very lightweight. I'm keeping it default, right? But these numbers will not make sense for your use case, because your use case, your application, you don't know, right? It might be in any programming language. It can be, a heavy, or it can be a lightweighted application, right? So based on your application, make sure you go and put a valid number, right? You should not be in a state like, oh, if I go and put 100, that means 100 requests, it will handle off. No, it cannot, right? So you have to do the due diligence and put the right number here, right? Then comes your execution environment. Okay, then comes execution environment, guys. What is execution environment? You have default, first generation, second generation. So there is a difference here, okay? In first generation, we had basically once the Cloud Run started, right? So at that time, it is first generation. In second generation, they have more OS, they have more languages support, right? Like in first generation, they had only till Java 14 support. And in the second generation, they have till Java latest 24 and all version, right? Same way with Python, Node.js, .NET. These versions upgrade, plus a little bit, Linux compatibility, faster CPU. So they give you some advantages in second generation because they have optimized their infra, right? So if you want to deploy anything and get quick, you can select second generation. Because it's learning purpose, I will keep it default. And then here is where I give the option of minimum number of instances and maximum number of instances. At the top, I only specify minimum number of instances for auto scaling this service. That is, service is nothing but like your load balancer. Here I give for minimum and maximum number of instances, like how we have given in managed instance group, right? Why do I need a maximum number of instance? I need maximum number of instance so that if someone does a DDoS attack or someone tries to attack my application by sending lot of traffic, it doesn't mean they should go and auto scale to hundreds of Cloud Run, right? Then actually it will shell out a lot of money, right? Because hundreds and hundreds of instances are used to serve my request, right? So that's why you do have to put a max cap here. So this max caps make sure that the number of instances doesn't cross this limit, right? So yeah, I'll quickly scroll slowly from top. You guys can just verify. So technically nothing, guys. You just have to give sample URL of your container image. Make sure you give a service name. Select under authentication as allow unauthenticated invocations. Select CPU allocation as CPU is allocated. You can select in either of this. It's fine. Okay, because anyways, we are doing for learning purpose. Then everything else will be default, guys, right? And then simply click on create. So that will create my Cloud Run service. It will go ahead and deploy my Cloud Run service. For me, it's deployed. Okay. So now what you can do is you can simply copy this URL, paste it in new chat and hit enter. And here you see, you will have an application, right? So this application is your sample application built by GCP. We just deployed it, right? See how simple it is, right? You need not worry about code and all that. You simply package your code into container and you can deploy it very quickly using Cloud Run, right? So now let this Cloud Run be there. Later we will delete it. Okay. Once we complete all the three, we will delete all the three once. For now, let it be there. Okay. So did you guys get a proper knowledge on how we deploy in App Engine, how we deploy in Cloud Run, right? Because both have its own use cases, right? In App Engine, you deploy code. In Cloud Run, you deploy container image, right? So is the difference clear, guys? The difference between App Engine and Cloud Run, right? Both are serverless, but yeah, both have its own pros and cons, right? So one takes entire App Engine, takes entire code and it deploys, whereas Cloud Run, it takes container images and it deploys, right? Now let's come to the third serverless service in GCP called as Cloud Function. What is a function? What do you think is a function? To perform a particular task, collection of entity. Function is a piece of code that can be executed repetitively. Okay. Now, to go to Cloud Function, on the top search panel, I'm going to search for function. I'm just going to write function and I will get Cloud Function. So click on Cloud Function. Okay. Now, as you guys have mentioned, function is basically a piece of code, correct? So when you say a piece of code, that means it has basically a single purpose task, correct? So your Cloud Functions works serverless. You can, yes, go ahead and write code, but you will not build an application in Cloud Function. You build function that runs on cloud. So I can write a small function that can run locally when I call it. Whereas here I call the function in cloud and it goes and executes, right? It only runs once you execute it or trigger it, right? And these functions are event-based triggers. What do I mean by event-based triggers? That means only once there is an event, like you calling it, right? Or you attaching it to some other service, like for example, storage bucket. So once anyone uploads a file to storage bucket, or if anyone deletes a file from storage bucket, at that time, it will trigger this function and it will execute this function, right? I'll give you one more examples, couple of examples. To give you some examples, okay, that we generally use here, right? So one of the example is, so one live example you can take, if I want to send an email to a user, right? So what I can do is I can write the code to send email in this Cloud Function, because see, writing code to send email is a small part. It's a small part of an application, right? It's like a function, right? So I will write that function here. And whenever I want to send email to a user from any application, let's say in my organization, there are hundreds of applications, right? Deployed on GCP. From any application, if I want to send a custom email to my customer or user, I can trigger my Cloud Function, pass few parameters, and according to that, it will send email. Okay. One example. Another example is I can attach storage bucket as a trigger, right? So I can create two buckets. I can create a source bucket. I can create a backup bucket. So if any user uploads file to your source bucket, I will create a Cloud Function which will copy that into my backup bucket, so that even if someone deletes or something happens to my source bucket, in backup bucket, I have the data, right? You're trying to understand, right? So these small modules, these small use cases, you write in cloud function, which would basically be event based. It will be happening based on a trigger. Does it make sense, guys? So now coming back to your cloud function, in cloud function you focus on code, you write code. Second thing is it is serverless. Third thing very important is it is a single purpose, right? Single purpose function or very small application, single purpose application or function. And here I would say this is an entire application. You can deploy an entire application here in Cloud Run. It can be a UI application, it can be a backend application, and same thing can be done even in App Engine, right? You can deploy an entire application, right? Whereas in cloud function you can only deploy like a function. It's a very small single purpose task. It does a small single purpose task. So yeah, that being said, shall we go ahead and create our first function? Okay, so then you can click on create cloud function button here, and that will ask you to enable APIs. Okay, go ahead and enable APIs. And then okay, so here you will see again environment, guys. First generation, second generation. First generation means it has basically your older language, not older language, sorry, older version of language, like your Java 8, Java 9, Java 10, Python 2, Python 3 and all, right? Whereas in second gen, you have more programming languages, more version support, and plus you have some Linux support also, and it is faster. Okay, so I'll keep it default second generation. Then I have here a function name. So I can give whatever name I want to the function. I'll keep it default. Function one itself, it's fine. Okay. Then here region, you will see that the region here selected is US Central. I'll keep it default. It's fine. Okay. Then comes your trigger. So here in trigger, we configure what will trigger this function, or what event if I perform this function will execute. So here it's an HTTP based trigger, meaning if you send a HTTP request, then this function executes, right? Correct. So now there are other types of triggers also, right? Like cloud pops up, cloud storage, cloud firestore, other triggers, right? So that means you can connect to these services, and if there is any operation performed in that service, this cloud function will trigger. So for our first use case, we'll keep HTTP based itself. That is, it'll give me this URL. If anyone sends request to this URL, it will execute my function, right? Then comes this option, that is authentication. Now I'm not going to explain authentication again, guys, because it is very similar to your Cloud Run, right? So I'm going to click on allow unauthenticated invocation, so that my URL is public and anyone can actually access that URL. Okay. Okay. And then here in runtime, you would actually see all the settings same as Cloud Run. So I'm not going to explain in detail everything, right? But yeah, in Cloud Run, when you expand this, so you'll get runtime. In runtime, you will be able to select maximum memory, maximum CPUs. I'll keep it default. Then you'll have timeout. This is your timeout for application, right? So if your cloud function doesn't return response in 60 seconds, you will get timeout error, right? Concurrency is nothing but how many maximum request it can handle. So here it is by default 1. That means 1 request per Cloud Run instance it will handle. So if I'm sending 10 requests, then it will auto scale to 10 instances. Where do that auto scaling metrics I set? Here. Auto scaling minimum 0, maximum 59, right? You can set it lower number also, but it's fine. I'll keep it default, right? So yeah, everything else is the same, guys, like connection, security. It is similar to your Cloud Run. So that is nothing much to explain there, right? So these are the basic settings for your cloud function. And then you can simply click on next. And this is where we go and write our function or code here, right? So this is the part where we write our code. Okay. So in this page, you can see on the left hand side, guys, runtime, there are a lot of programming languages and their versions, right? Okay. Then, so you see here, guys, you cannot write an entire application here. You will just write a tiny function here, right? So this function will execute. Okay, this function will actually execute here, right? Now, what is the implementation of this function code? So generally, it will just send back response hello world. Okay, so technically, if I send a request or if I hit that URL or send a request to that URL, then it is going to return hello world. But this code here, this line of code can be replaced with sending email, copying data, or doing whatever you want, right? Small task, not whatever you want, small task, whatever small task you want, that can be done. Okay, then since you're not making any code changes, you can simply click on deploy. So that will deploy this cloud function. Click on that deploy, it will deploy the cloud function. It will take some 1 to 2 minutes and then it will deploy. Okay, so once you have it deployed, then you see you will get this URL, right? So you can copy this URL, paste it in new tab and hit enter, and see in response it returns hello world. Why it is returning hello world? Because currently I've written to return hello world, right? But you can write any code. You can write code to send, to insert data in database, to copy data, to send email, to do anything that you want, right? Or if you want to run a very small application, right? Like say for example, an application that takes a word and it returns some values in that text, right? So something like that, very small single purpose task, you will deploy it in cloud function. Cool. So I'll show you one more quick demo, guys. Everyone, you guys can just sit back and wait, or just sit back. I'll show you one quick demo of how right now we saw HTTPS based trigger, right? I'll show you a quick demo of how we can create a cloud function with cloud storage as a this one. Okay, so I'm going to click on create or let me do it. Okay, I will do it. You guys just sit back and just watch me do it. Okay, I'm just going to do it as a demo. It's not like compulsorily everyone has to do hands-on, right? So just sit back and see how I'll create a cloud function which is attached to a cloud storage bucket, right? Okay, for now I'm just going to create it. Just assume storage bucket as basically a folder in cloud. For now, just assume that. Okay, so I'm going to create a bucket that I will say aman -cloud -function -test -bucket. Okay, I'm gonna keep everything default, guys. I'm not gonna click on anything. Okay, and here I have a cloud bucket created, guys. What does this cloud bucket do? This will actually, cloud bucket will actually have basically files and folders here, right? So now let's assume I have a file here, right, in my bucket. Now what I want to do is every time a user uploads any file here, let's say for example, I want to trigger my cloud function. In cloud function, I'll simply write the code to print this file name, but in real, you can write code to copy this. You want to read this file, store this file to database, you can do that. For now, for demo purpose, I'll simply print the file name in the console, right? So what I'll do is I will go here and I'll say functions, cloud functions, and I'll create a new cloud function here. And this time cloud function, I will say cloud storage as my event. And in cloud storage, what is the action? Archive, delete, finalize, metadata update. Metadata update means updating a file. Finalize means uploading a new file. Delete means deleting a file. Archive means From storing it, you are archiving it. Archiving is basically, okay, for now, forget what is archiving. Okay, it's difficult to explain right now. So just imagine I have operations like delete, finalize, and metadata update. So if you want to trigger this cloud function once a user deletes a file, right? Like you want to send an email with alert warning saying that someone deleted file, right? Or once a new file is uploaded, you want to read that file, then you will select finalize. Finalize is when a user uploads, right? Then I will select the bucket where this trigger should be attached to. So I will select my cloud function bucket. That means in this bucket, if anyone finalize, meaning if anyone uploads a file, anyone uploads any file in this bucket, it will trigger this function, right? So it will trigger this function. So I'm going to go next. Okay, it's asking to enable API. Let me enable API because I've selected cloud storage. Okay. And then here, I will actually see here, there is a default code that actually prints the file name, right? So I'll keep it as it is, but in real life, you can write your code to save it to database, copy it to different bucket, all that code you can write here, or send email, you can do that. For now, I'll keep it as it is. So once a user uploads any file, so here in the logs, you will be able to see this file details, right? So I'll simply deploy this application, or I will deploy this cloud function. Arey yaar, which region did I create my bucket? I created in US multiple region. Oh my God. It'll give error while creating. Let me do one thing. Create a bucket. Uh, Let me select US West 2. Please don't give error or else I have to create a new bucket. It's single region. Please deploy, please deploy. Please deploy. Ah, shoot. Okay, never mind. Let me create a new bucket with one single region. This is a pain. Aman Cloud Test Bucket 2. Continue. Single region. Let me select it as US Central. Okay. I'll keep it US Central. Soft delete policy. I don't want all this. Okay. So I'm actually going to redo, guys, because technically it's giving me error because of region. Both should be in same region, right? So now this is in US Central. Cloud storage finalize. I'm going to select my bucket. Not this bucket. Bucket 2 I have to select, right? So I'll select bucket 2. Then I'll grant all the permission that it has. Then I'm going to finally say deploy. So that is just going to currently print all of this in my terminal or console, right? So now it will start deploying this cloud function. So we'll give it some time. Wait, why did it view logs? Why did it fail? Wait, Aman Cloud function test bucket, but I selected test bucket 2, right? Oh my God. Why is this so tough? Why is it HTTPS based when I selected as test bucket 2? Guys, I think this is bugged. Grant all access. Oh my God. Okay, let me give a last attempt by creating a third this one. I think it's just bugged. Let me do one thing. Let me create a first generation one. Second generation, I don't trust second generation. Cloud storage on creating my test2 bucket, which I have selected US central location. This was not the case before. I think now there's some bug in this Gen 2. Okay, it ran successfully here finally. I think there was some bug with respect to Gen 2, right? But anyways, so if you see here, guys, if I go to my logs, right? So I'll see nothing in my logs currently, right? But just see slowly if I try to upload this file, okay? If I upload a file here called food.sql, and now if I go back and if I refresh, I should technically see details related to this food.sql. Why would I see that logs? Because technically, if you see my code, what have I written code? Code is to simply console.log, that is to print in the console. In real time, you can go and change the code to whatever you want, right? But for now, the code is just to print it. So you would technically see in my logs, it will print the file name. So if you're seeing this file name printed here, that means what? This function executed. When did this function execute? This function executed when you uploaded a file, right? So here you see, once I uploaded a file, see here, processing file food.sql. That means my function got executed, right? So you can create such event-based trigger in your cloud function. Is it clear, guys? How we guys did for HTTPS based and how I gave you an example here, how you can even do it for a cloud storage based trigger, right? Majorly you need an event. On that event, this cloud function executes, right? Okay, so please go ahead and start deleting these resources. Okay, cool. So I've deleted my cloud functions. Then I'll go ahead and delete the cloud run that we created, right? So please go ahead and delete all these three, guys: cloud run, cloud function, and app engine that we created. Please go and delete and clean up all the service that we have done. So I hope you guys understood, guys, the concept of serverless and how to use GCP's app engine, cloud run, and cloud function. All these three serverless service, right? Yep. Also, guys, for app engine, you cannot delete app engine application easily. For app engine, you have to go under settings, and under settings, you have to click on disable application. That's how it will disable your app engine application, right? So you have to do this configuration. Yeah. ID is basically a project ID. You can just copy paste. See, if it is asking ID, right? ID is written here itself in the below. Last you will see here, right? So just copy paste this ID here itself and disable it. Cool. Okay.
Just a quick info, guys. Intellipaat brings you executive postgraduate certification in cloud computing and DevOps in collaboration with IAM IIT Roorkee. Through this program, you will gain in-demand skills like AWS, DevOps, Kubernetes, Terraform, Azure, and even cutting-edge topics like generative AI for cloud computing. This 9-month online bootcamp features 100 plus live sessions from IIT faculty and top industry mentors, 50 plus real-world projects, and a 2-day campus immersion at IIT Roorkee. You also get guaranteed placement assistance with 3 Azure job interviews after entering the placement pool. And that's not all. This program offers Microsoft certification, a free exam voucher, and even a chance to pitch your startup idea for incubation support, up to Rs 50 lakhs from IAM Sampark. If you are serious about building a future in cloud and DevOps, visit the course page linked in the description and take your first step toward an exciting career in cloud technology.
We will be starting with Google Kubernetes engine, right? So we will understand what is Kubernetes, the importance of Kubernetes, and why do Kubernetes is used majorly in industry, right? And we deploy a small application, right? I'm not going to explain you all the features and concepts of Kubernetes, right? This is just to get you started. Now, before we start with Kubernetes, first we will see how we can create our own container images, right? Okay, right? So here we will understand, right? So first we will understand what is Docker and how do we use Docker and all these things. Okay. Has anyone used or aware of using or creating containers using Docker? Cool. No worries. I'll explain from detail. I'll explain from scratch. No worries. Okay. So what is a Docker? A Docker is basically a tool or a framework that will help in containerization. Now you might say, what is this containerization, right? Don't worry, I will explain you all. Now, what is a major problem that we face, guys, in development? Anyone knows? The most painful experience for any developer. Volume? No. The biggest pain is packaging compatibility, right? Where always you see you will have this situation, you say some or the other dependency, that is versioning issue, some or the other issue. Always, guys, I'm telling you, same app running on dev but not in production. Yes, I'm telling you, it's basically in fate of every developer that it never runs in first go, no matter how much careful you are, right? So to avoid these things, right? To avoid what? To avoid this problem where, I wrote a code in my laptop, it runs perfectly fine in my laptop, but when I actually package that code or migrate that code to some servers, like let's say, for example, a VM is my server where I will deploy my application. In that VM, it might cause issue, right? Because there are a lot of reasons, right, to consider. See, first reason is you'll be having some compatibility issue, right? Let's say I'm doing development in my Windows laptop, then suddenly I'm shifting it to Linux. So there will be packages, right? There might be some packages, there might be some dependency, some library that in Windows that version is different, in Linux that different version, right? So a lot of this happens. Because of that, you get this issues, right? Now, to handle such thing, they actually thought of bringing in a concept called as container. Now, as I said, to solve the problem of your code working only in your laptop, or it's working in one specific place and it's not working other places, they thought of launching, or they thought of actually creating something called as containers. Now, what is this containers? So let's take first one non-technical example of a container. So let's take this example of shipping good. Okay. Now imagine you are basically a company that takes all these goods from user and you actually ship it across, right? And you have lot of commute modes, right? You have trains, you have trucks, you have aeroplane, you have ship, you have a lot of communication modes. Okay, commuting mode, sorry, not communication, a commuting mode. Okay, just think for an example, what would be the best way to actually transport a lot of these products that differs in size, quantity, shape, fragility, right? What would you do? Now, obviously, since we've used the word container, you will know that, okay, we will use container. Why do we use container, right? Just very simple example, right? In a container, I can even store thousands of bags of coffees, or I can store even 2 pianos, or I can store hundreds of drinks, or I can store tens of electronics items, right? So it's basically everything is getting fitted in a box. You are packing it in a container, correct? And now you just have to focus or worry about shipping the container, not what is inside it, because what is inside it is packed, completely packed, meaning if you get the container, you're getting everything that is inside it. Are you guys getting, guys, what I'm trying to say? So the best way to solve this problem is bring a container where you put all the product irrespective of shape, size, material, fragility, right? You just dump it in a container, right? And this container, it's easier to pick it from crane, keep it in your trucks, or in your plane, or cargo ship, and transport it. So don't you think this actually saves a problem? Correct. Now, very important thing that you have to understand from this is, guys, the packaging, right? Now, a container, inside it, what will it contain? A container will contain basically all the items. It can contain bags of coffees, pianos, electronic items, no matter what, all those will be packed inside. So you don't technically see what is inside container, but you completely shift the container, and whatever is inside the container comes along with it, right? That part you understand. Okay, same thing happens in your computer world also. So what happens is, I might have lot of such dependency, right? I need a database, I need some tech stack, some programming language, I need some other tech stacks, or I need some other frameworks and tools, right? All of these are like a library, right? Which you install independently, correct? Now, instead of doing that, what if I bring a container, and inside that container, what if I bring something like this, a container? Okay. Now, inside this container, I will install whatever is important for me to ship my software, right? That is to deploy my software. So let's say I will install PostgreSQL. Then let's say I will install Java. Then let's say I will install HTML, or Apache server for this one, right? And then let's say I'll install Python, right? Like this, I will pick and I will install all these libraries in this container. Now you would say, hey Aman, in container, it's easier to keep item, but we are talking about software here, right? What is this container that can hold this software? So this container is nothing but like your OS, guys. You can have an OS, right? This is your container image, which is just like your virtual machine image. So I can say that this should be an Ubuntu OS. So this container will basically be an Ubuntu OS. Inside that, these things I will install. How do I install it? We write the command. So we write the command to install them, right? And then once we install them, then what do? We can easily ship them, right? Now, once we ship them easily, that shipping is nothing but this container image that we created, that can be installed and run easily in any laptop or any server. Does it make sense, guys? Is it clear? So this is how we are solving the problem, by bringing in container image. So you guys understood what is a container, guys? Yeah, that's all I think. All I had to explain you is what is a container, and Docker is a tool or library that will help you build this container. Where did that container go? Yeah, this container. How will it help build this tool? Remember, I told you will write commands to install Postgres, to install Java, to run your application. Those commands are written in Docker. Okay, using the Docker tool, we will write those commands and build this image. That's the container image. So Docker is a tool which helps us create or build container images. So when we say container, it is actually container image. Yes, because a container is nothing but it consists of an OS, that is image, and then these dependency files, right? Like Java, whatever, up to you. So it will have these things. A container will never be empty. So that's why we call it as container image. Does it make sense? So you build this and then you run this. Build this is nothing but where you package it, where you write commands that, hey, I need PostgreSQL. Hey, I need Ubuntu OS. Hey, I need Python to be installed in this. So that is where you do that build phase. And deploy or run is where you're running this container and it runs. Now, the beauty is that when you run it, it will run as it's a different OS itself. because that container has its own OS. We will give Ubuntu or we will give some OS, right? Whatever OS we need, because we have that, it will actually go ahead and treat it as a different OS itself. So technically, that's why when you're trying to run this container images, there are very less chances or minimal chances of getting issues or errors. Why? Because it's technically not running in your laptop. It's technically running in its own OS, right? So think like that entire virtual machine that we installed Apache is being shifted and you're running that virtual machine wherever you want, right? So that's the beauty of this container. Cool. I want you to create it in new tab. So click on this open in new tab and open it in new tab, because I want even editor side by side. I want editor also side by side like this. I want both side by side. So guys, let's create a new folder, mkdir, called as GKE, or should we call it as microservice? Call it as microservice, guys. Create a folder called as microservice. And how to go to editor? Can you refresh? Yeah, just click on this pencil icon on the top. Okay. And then open the same microservice folder from editor also. So you have to be inside microservices folder from terminal here. You should see like this blue color microservice, and even from here, editor, you should see microservice here. I'm unable to see pencil button. Can you please go back? Click on this button, right? That says open in new window. You have to open it in new tab. Only in new tab you can have both side by side. So you're saying me you don't have an editor, a pencil button here on the top. Got it? Okay, cool. Okay. Where did you create microservice folder? I did it through command line, right? I wrote in terminal this command mkdir microservices, and then I ran the next command that says cd microservices. Can you do a pwd? Yeah, sure. By the way, you can see that microservice here itself, blue color. That means I'm inside this from home directory. I'm inside this microservice folder. And here also you see I have microservice here written, right? That means I've opened microservice folder from editor also. I don't see an editor. So in editor, you have to click on this, right? File, open folder. You have to go ahead and open it, right? You did that. After doing that, you're saying me you're not seeing this microservices folder. Yes. Can you just pwd and verify then that your microservice folder is created, or did you create it inside some other folder? I'm not able to see the path in editor. Okay, don't worry. In your terminal, write a pwd, hit enter, copy this entire path and paste it here. It's not showing up. It will show up. I think it's empty. That's why you're telling it's not showing up, because you should see below Explorer. Do you see microservice name, or what name do you see below Explorer? Here, what do you see below Explorer? Because it's empty, I think you're thinking it's not opened. For others, what we'll do is here we'll write a script to create a very small API, guys. And again, since we are not focused on doing development, we will go ahead and we will just copy paste some code and we will try to build it. Okay, we will not understand from scratch what this line means, what that lines means in code. Okay, and to keep it very simple, I'm going to use Python, because in Python I can create a microservice in less than 5 lines of code, right? So that's why, to keep it quick and simpler, we will do that. So I will say fast API container. So fast API is a Python framework or library that is used to build microservices, fast microservices. Okay. Okay. Then I want you guys to create a folder structure like this inside your this one. I want you to create a requirement.txt file, a Docker file without any extension, guys, then an app folder, inside app folder to 2 of this file. Okay. So guys, do one thing, forget the documentation. I'll do it here and you guys do it side by side. Okay. I don't want to confuse you guys. So here, guys, on my editor, you would see that I have this empty gray space below this microservice, right? Because it's an empty folder. So just right click and create a new file called as requirements. And very important, guys, you cannot do spelling mistake. Rename it requirements, requirement.txt, requirement.txt file. So create this requirement.txt file. Guys, again, go back to the documentation and verify the spelling, guys. The reason I'm telling you to verify the spelling is because the same spellings we will use in other files, right? So if you do a spelling mistake here and their spelling is different. So that might cause issue, right? So now go back to your documentation. And if you scroll a little bit up, you will see this line that says, for example, your requirement.txt file should look like this, correct? So just copy the two lines that it says it should look like and paste it here as a content. So this requirement.txt file technically has the libraries that Python should install. So if I mention these two package or library name, it will go and install these two library with the version technically from internet, right? So I repeat again, in your documentation, if you scroll somewhere, you see my scroll bar here, right? Somewhere in the top 20%, you will see a line that says, for example, your requirement.txt should look like this, and below it will have like this gray color box with two lines. So just copy the two lines and paste it in requirement.txt file. Done? Okay. Then let's do one thing. Okay. Then I will create a new file, guys. How do we create a new file? Again, I will right click here. I'm going to say new file, and the file name I'll give as Docker file. And look here, guys, very important. In Docker file, D should be capital, no space, Docker file, and there is no extension. So D capital Docker file with no extension, just Docker file. Okay. Once you have this Docker file, then go back to the documentation, guys. And if you scroll little bit below, so here we copied requirement.txt file, right? If you scroll little bit below, you will see this Docker file content, right? So just you see, you will have a copy button here. Copy the content of Docker file and paste it here. I'll just remove these extra spaces, guys, so that it will fit in my screen, so that it's easier to explain you guys, okay? But you can keep it as it is. It's up to you, okay? Okay, so let me explain you what it does, right? So this is how you guys write the Docker file, okay? Now, what is this Docker file? This is basically the base containers content, what should be inside container. So my first line will always mention what should be my OS, right? So here it is from Python 3.9, right? Now you might be confused that, hey, Aman, Python 3.9 is not an OS name, right? Yes, you are correct. We have OS like Ubuntu, Debian, Fedora, right? We have CentOS. These are operating systems, OS. But what is Python 3.9? So generally what happens, we have a Docker Hub. Docker Hub is basically like a repository, online public repository, just like your GitHub, okay? So here, if you go and see, here you see, you will have Ubuntu OS, right? You will have like this, all this OS. Now, people can come and bring their own OS also, not OS, sorry, bring their own Docker image also here. So because companies and people can bring their Docker images here to make it public, and since Python is also public, right, it's more like a open source programming language. So Python organization actually manages this Docker image, meaning it builds its own Docker image with its base image. So what it will do is, it will take Ubuntu, and in that Ubuntu, it will install Python language, and it will create its own image called as Python. So if you write Python here, technically it is built on top of Ubuntu and it just has Python installed, right? So that is why we are writing here from Python 3.9. Let's assume if I were not to do this, then what I will do? I'll say from Ubuntu 20.04, then I'm going to say run, I'm going to say apt install Python 3, Python 3 dev, Python 3 pip, right? And all this, like how you sudo apt install, right? So technically I had to write these two lines so that I will get my base OS as Ubuntu. Then I will get this, right? Okay. Now, these two lines are already done by some company or some folks and readily available to us by the name of Python 3.9, which means on an OS, already Python 3.9 version is installed for us. So these two extra line, we need not do this, right? So if you want basically any dependency, any package that is already installed on an OS, you can go and search here, right? So you can have similarly Java. So if you want to install Java on Ubuntu OS, there are millions of people who might have already done it, right? So just go and copy their image and put that image here. So that will become your base image, right? So here Python 3.9 is basically a base image which has Ubuntu OS plus it has Python installed. Okay. Then you have work directory / code. So what is this work directory / code? Just like your Linux, if I say pwd, you see I have /home /GCP Intellipaat /microservices, right? So inside this Docker, since I told, remember guys, container will have its own image OS. So inside that OS at the root folder, it will create a folder called as /code. And what I will do, first thing I will do is I will copy this requirement.txt file to from here, from current directory. I'll copy from current directory to my container /code /requirement.txt file. We will have to make that file structure according to Docker file. Generally, we actually have application and then we custom write this Docker file. So we write Docker file based on our current code, but here I'm doing it reverse. Okay. Okay. Right. Then what we do pip install. So in pip install, you're technically just installing this packages. Okay. And yeah, then what we are doing, we are copying app folder. We are copying app folder from current directory to code /app. Now your next question is, where is this app folder? We did not create it. Yes, we did not create it. We are just going from backwards. We will go and create it, right? And then there is this command to run my fast API code that will serve as an API, right? So you see how simple it is to write Docker file, right? It's like easier to learn and write your own custom Docker file, right? Now that being said, let's complete this half puzzle that we left, right? That is app folder. So now everyone carefully understand, you have to right click here and new folder, not a new file, because sometimes people do mistake and click new file and app will be the file name, which is wrong. I want to create a new folder. So I repeat again, right click and click on new folder and give the folder name as app. Do that. Done. Okay. Inside this app folder, then you have to right click and then click on new file and then say __ init __ .py. I repeat again, inside this app folder, that means right click in your app folder, right click on your app folder and create a new file. And this is the new file, __ without any spaces, guys. There should be no spaces. __ init __ init.py without any spaces, guys. So create this new file inside app folder. To create it inside app folder, guys, right click on your app folder. So if you right click on your app folder, then whatever you do will create inside that app folder. Okay. Done. Okay. Again, right click on your app folder and create a new file called as main.py. Okay. Is it done, everyone? Just to verify, guys, just you will see this, you'll get this arrow next to app folder. Just shrink it and expand it just to verify that main and init.py, both of these should be inside app folder. That main.py and init.py both should be inside app folder, not outside. Or else again, when you are trying to deploy application, it will give error. Yes, it's inside app folder. Great. Okay. Now, one more thing is, go back to your documentation. And if you scroll a little bit up, that is above Docker file, you'll have the content of main.py, right? So just copy the content of main.py and paste it in main.py. And you can remove this function actually, or let it be there. I'll not confuse you guys. Let it be there. So just copy that entire content of main.py and keep it and paste it in your main.py. Okay. My init folder is grayed out. I minimize the window and check the name. The file is grayed out because init is not a folder. Init is a file. __ init __ .py is a file. I cannot change the name. You have to delete it and then create a new one or rename it. If it is a folder, then delete it and create a init file. And if it's already a file, then just right click and you can click on rename and just rename it properly. Right? It's __ init __ .py without any spaces. So now what we'll do, we have our code ready. Okay. We have our code ready, guys, in our main.py file. We have our requirement.txt file ready here. We have our Docker file. So in Docker file, I've mentioned use Ubuntu base OS, create a working directory or create a folder called as code, Inside that code, copy this requirement file, and then please repeat main.py file. No, I'm not going to explain main.py file. Sorry. We're just going to ignore. Just think that we have copy pasted something. Okay. And then we are going to copy requirement.txt file. We are going to install those requirements. Then we are going to copy the entire app folder, and then we are going to run the main.py inside app folder. Right. So it's very, very, very simple to learn and create like this Docker file. Okay. Now to quickly verify again, guys, in the terminal, just write ls and hit enter, and you should see app Docker file requirement.txt file as it is in your editor, just to verify that you are in the same folder as in editor and terminal, right? So just hit ls and in your terminal, just verify you see same content as you see above. Correct? Yes. Okay. So now we will run the command to create the Docker file. And to create the Docker file, we'll simply run the command Docker. So the CLI starts with Docker. Then I'm going to say build, then space -t is to give the tag name. And I'll give this microservice name as hello. And then let me give it a sample. So I'm going to give it a sample. And then I'm going to give tag as 1 and space dot, right? So first write this command, then I'll explain you this command. So now I'll explain you how it means. Okay. So Docker is basically the CLI here, right? Like how we have basically, Gcloud, other CLI tools, right? Same way, Docker is a CLI. Then build is basically the action. Okay. And build is an action here, which says that means you have to build this image. Okay. Build the image. Then what should be my image name? Like here you see image name is Python 3.9, right? So you have to give a name, right? So that it will understand what is the name. You're giving a name to this image. So I have given the name. So if I give -t, that means I'm giving a tag name. What is the name? Then I'm going to say sample. Sample is name of my container. Then after colon, I can give version. So that's like a tag. Okay, version. So sample is my name and 1 is my tag or version of this Docker image that it is building. Then space, then I have to give the path to this folder because I'm already in a microservice folder. Now what path I have to give? I have to give path to this Docker file, right? Since I'm already inside this folder, I'll just give a dot, which means I'm already in that current folder. In this current folder, go and look for Docker file. If suppose I was in different folder, then I would write the complete path here where my Docker file exists. Okay. Is it clear, guys? Okay. Then just go ahead and hit enter. So that will start building this Docker image. So see here, it's running step 1 of 5. So first it is downloading that Ubuntu OS, right? And after downloading Ubuntu OS, then it will create this folder, then it will copy this file, it will install that file. So all this step it is running. Steps to run your application, right? Is it done? Why is it showing error failed? That's because requirements requirement.txt file could not find version that satisfies fast API. Give me 1 second, guys. I think Python version with this, it's fine. Yeah, 3.9. Okay, do one thing, guys. Do one thing. Just go to this requirement.txt file. And in this requirement.txt file, just make sure you remove this versioning. So I think the problem where is in Docker file, we have mentioned Python 3.9, and in requirement.txt file, we are actually trying to mention a package version that's not supported in Python 3.9, right? So better to fix this issue, what you can do is remove the versioning from both of this line. So you can remove after this greater than symbol and just keep the package name and remove the version, right? So it'll be plain and simple here. So go ahead and remove the version from this requirement.txt file, which will actually resolve this issue that we are getting. After doing that, you can save it. And after saving, then you can just go and rerun this command, right? Docker build command to build it again. So I'm going to say Docker build -t, that's my tag. Then I'll keep sample as my Docker name and version 1. And then I'm going to pass the same folder, right? So that will actually start from where it left off. So you see in step 4, it actually failed. And now from step 4, it actually started running then, right? So it will actually cache all the layers. So in my Docker file, I have close to 6 layers, right? So because my first 4 or first 3 layers ran successfully, it is cached in my memory. So that's why it will not rerun these 3 steps, and it will rerun from the step where it actually failed, right? So that's also one advantage of using Docker. And because of that, it's faster when you're doing a quick development and you're making a quick, iteration of changes. Run successfully. Okay, that's great. So even I have my Docker image built here, right? As you can see in my screen, I have my Docker image built successfully, right? Now to quickly verify this, I'm just going to run Docker space images command. So that's going to list my Docker images. So run this command. Now this sample image is, guys, locally as in it's in just this Cloud shell, right? From this Cloud shell, how do I push it to Google Cloud? Because I want to use this in my project, correct? So to use this in a project, I can't just use it from local. Like how, for example, if I have code locally in my laptop, how can I share it with you guys? You would simply say, hey, use GitHub. GitHub is like an online public repositories, right? So similarly, we will use GCP's repository to push this Docker image. So any container image you want to save in GCP Cloud, there is a service called as artifact registry. So we're going to go and use that artifact registry. Okay. So I'll go back to my GCP console, and on the top, I'm going to search for artifact registry. So if you just write artifact, you will get artifact registry. So click on artifact registry. Open. Okay. So you might actually already see there are some artifacts created here. So these artifacts are created by Google itself when we were actually deploying in Cloud Run and App Engine, right? So you will see that, which you need not worry about it. So what we'll do is we will create our own repository. So to create our own repository, I'll click on this plus icon, and then I'm going to give repository name. So let me give repository name as hello-microservice. So this will be my repository name, and everything else will be default. Region, let me select it as US Central. Nothing showing my project is showing there. So don't worry, if nothing is also showing there, can you see create project here? Do you see a create repository button here? I'm not able to go to artifact registry. I mean, are you not even getting the suggestion in the search bar? I need to enable. Okay, if you're getting some enable API, yes, go ahead and click on enable, guys. You might have to enable that API. Nothing is within repository. Yeah, we have to go and create a repository. That's what I'm saying. So I'll click on create repository, and I'm going to say hello-microservice. I'll give this name as my repository. I'll keep format as default, mode as this one, and region as US Central 1. I repeat, give the name as hello microservice, select format as Docker, mode as standard. I mean, everything else is default, and just select region as US Central. We'll go and deploy in US Central. Okay. And then click on finally create. Everything else keep default, guys, except name and region, which you have to fill. Keep everything else default, and just go ahead and click on create button. Created. So do you guys see like this hello-microservices repository, correct? Yes. Okay. So click on that hello microservice. Click on that hello microservice repository so that you will be redirected to that microservice repository. Done. Okay. So here, do you guys see a setup instruction here at the top? Do you guys see a setup instruction here at the top? Click on that setup instruction. Okay. Click on that setup instruction, and you will basically get a command here. So you have to run this command in your terminal, because we have created this repository in US Central location, right? And in US Central location, this is the domain provided by Google to push. So our artifact registry is in this domain or URL, right? So to allow pushing that, you have to copy this command and run in terminal. Oops, you have to copy that entire command. I just copied the location. So I'll copy and paste it, and I will run it. Yeah, you'll get something like this. You'll get a big JSON, something like this. Correct? Okay. So now we have authenticated. So now if I try to push this location, it will identify because we have authenticated this location. Okay. Now, next question is, just imagine guys, Python docs sample GitHub. So on online public repositories, you have code repositories. How do you uniquely identify this repository? You identify by the URL or the domain. So if you look here carefully, https github.com/Google Cloud Platform, which is repository name slash, no, sorry, Google Cloud Platform is a username, and then /Python doc sample is a repository name .git, right? All I'm trying to say is there will be a URL. This URL will be unique globally for every repository. That is how it will identify this particular repository in entire internet, right? Same thing should happen for my GCP. In GCP, there will be millions of Docker images, millions of projects. How will it know that this is the Docker image that I am calling, or I'm going to, oops, Docker images? How will it know that this is the image I have to push? This is the image I have to deploy. So we will create a unique URL like this, which Google accepts and Google understands that URL. What is that URL? So I'm going to first open up a notepad. Okay. Open up a notepad so that we will create this URL. Okay. Then go back to your artifact registry, and below this repository options, you'll get a copy button here, right? I repeat again, below this edit repository setup instruction, you will get a copy button, right? So just click on this copy button and paste it here. So this will be your URL. See here, the Google location domain / your project ID / your repository name. You will get a URL like this. Yes. Okay. Now what you have to do is, guys, after that you have to write / then you have to write your image name. So I'm going to say sample:1. So in this repository also I have to give the image name. So this you have to add from your end. So just add /sample-1, because here we have given sample hyphen, our tag is 1, right? So that's why make sure you give sample-1 at the end, /sample-1. So this will complete our URL. Okay. Now, how will GCP knows that I have to push to this URL, right? Because see here, what is my here sample? How will this know that this sample should be pushed to this URL? The simplest way is I have to rename my image to this complete this one. So this complete URL should become my Docker image name. So here my image name is just sample, which it should not be. It should be this huge URL as the name, right? So that means I have to rename it. Now in your Docker, you can't just rename it. What you will do is you will create a soft link. That is, you will create a copy of this sample, and then you will rename that, or while copying that sample, you will give the name as this, right? So technically this sample will be my original image. I will just create a new image which is pointing to sample, but the name is this, more like creating a soft link. Okay. So how can I do that? I will run this command, guys. So I'll say docker tag what? Create this sample1, which is my original name, create a replica of it, soft link with the name this. So what it will do, it will say docker tag this by creating a replica and renaming it to this complete. So it will create this entire thing as my image name, and :1 will be my version. You guys understood this command? So just copy this command and paste and run this command. After running this command, if you run docker space images, now you will see 2 images, right? So just do this, verify. Done. So when you run docker space images, do you guys see these 2 images here? But if you see here, image ID is also same here. That means what? That means basically this new image is technically sample itself is just renamed it. It's like a soft link. Okay. Now, after doing that, we will now say next command is docker space push space, copy this URL, right? So this will now know that it should push to this particular domain or URL. If you do any changes in this new image created, will it affect in original one? No. When you're creating a new image, then you will say this entire URL and you will create a new tag called as to. Then it will create a new one, right? So yeah, shall we paste the docker push command? Yeah. You can just paste your docker command and you can push it. So that will start pushing it. So it will start showing like this uploading option. So once it's uploading, that means it's pushing. Everyone like this, you see some uploading use progress bar. Yeah, so my uploading is almost done. My uploading is done. My shell reconnected. So what was the last command that you ran? Is it docker push command, docker tag? Yeah, then just do one thing now, for better sake, just run the tag and run that push, run both this command. Your image technically never built. Do you see at least the folder microservices? If you see, then you have to run these three commands. Docker build -t sample one dot, then docker tag, and then copy that URL and docker push, these three commands. But yeah, you have to make changes according to your URL and run only these three commands, right? Okay. Now going forward, if you just go back to your artifact registry and refresh, do you guys see sample one in your artifact registry? If you see this in artifact registry, that means it is already pushed to cloud. So from here now you can deploy your application anywhere in GCP. Can you go back to that file? Which file? This notepad file? It's not running the first command. I don't know suddenly what happened after your reconnect. There you go, guys. Just open this to copy it from there. Okay. Terminal restarted. My terminal though did not start. So if you guys can go back to your artifact registry and refresh, guys, and you successfully see this sample image here, that means successfully push the image here in your repository. Cool. So you guys can push this. Now we'll see how we can deploy this application, that is microservice, using Google Kubernetes engine, right? So using our Kubernetes engine, how we can deploy them is what we will be looking at. Fine. So for that, we will have to go ahead and create a Kubernetes engine. Before that, we will understand what is a Kubernetes. Okay, let me quickly get the. So first we will understand what is Kubernetes, and then we will see how to create a Kubernetes engine in GCP and deploy a sample application, right? So the require of Kubernetes was important once we, as in technology, we migrated or shifted from monolith architecture to microservice architecture. Now, what is the difference between monolith and microservice architecture? In monolith architecture, your entire application, UI, backend, data layer, business layer, everything was into a single code base. Whereas in microservice, each of this is basically a different application itself, called as micro application, small application, right? Now, if I take a quick example, imagine we have an application like let's say for our example, an EMS portal or an CRM portal, right? Now this would generally have a login page, then it will have sign up page, then it will have basically product page, something like that, right? Now all of these are bundled in monolith in a single application, right? And you cannot reuse it. Whereas in microservice architecture, I can have a different and entire application for my login related APIs, right? So if I want, an application A can use this login service, whereas an application B, which is completely different application, can use the same login, microservice, right? Because it's common, right? Like Amazon's, right? Amazon Prime, you can log in Amazon Prime Video, Amazon's e-commerce, all of that you can log in using your phone number. How is that possible? Because they have a common login microservice which is used via multiple apps, right? So this is the benefit of microservice, where instead of putting your entire code into single code base, you are splitting into multiple applications, small application called as microservice, and each of this microservice can interact with each other or can interact with database and so on for performing or fulfilling its duty, right? Now, if you look here carefully, when we migrated from monolith to microservice architecture, in monolith, I had to only deploy one instance of my application because there is only one code base. My entire application is in one application. Whereas now, if I try to split this monolith into microservice, same application now, it needs one separate application deployment for UI, one separate application deployment for login, one separate application for my backend, and one separate for database, so on, right? So now here you're deploying only one application, but here you have to deploy 5 different applications just to make sure your this one application works successfully, right? So the number of application deploying is exponentially increased for one application, right? Now imagine if I deploy only one application in Cloud Run, my life is simple. But if I try to deploy like this hundreds of microservices in organization in Cloud Run, don't you think it will become difficult, guys? Hundreds of Cloud Runs I have to manage, all with hundreds of different URLs, correct? So here there is a problem of managing or orchestrating. Orchestrating is nothing but like a managing. Managing or orchestrating massive amount of microservice is a problem here, right? Which with current system like Cloud Run, App Engine, we cannot solve it. So that's where we need a container orchestration, meaning we need a manager kind of thing. We need a management tool that can manage multiple microservice deployment. And Kubernetes is one of those container orchestration framework or library or tool created by Google initially to help resolve Google issue, because Google was facing this issue a lot because they had they'll have thousands of applications, right? Now managing so many applications becomes tough. So Google initially created Kubernetes to solve its problem, but then later they made it open source, and now it is handled by CNCF, that is your Cloud Native Computing Foundation, which is an open source, it's an open source community, right? So now since it's open source, this open source community actually manages it, right? So it is open source. So what is Kubernetes? In a simple word, Kubernetes is basically an container orchestration framework, right? Which handles multiple deployment. How does it handle multiple deployment? All these microservice deployment are put in manifest files like YAML files. And using that YAML files, you will be able to deploy it quickly, right? So that's what we are going to learn about. So we will be creating a Kubernetes, right? Now, how does this Kubernetes deploy internally? Like, does it goes and deploys to Cloud Run, App Engine? What does it do? So your Kubernetes actually uses virtual machine internally. Okay. So what happens is, if you look here carefully, here I have something called as node. This node is nothing but, guys, VM. So node is basically a name given to VM. So a VM means node. So I will have multiple VMs here. Okay. And what is a Kubernetes master here? Kubernetes master is nothing but the Kubernetes application, right? Which basically does the orchestration. It's a very small application that will run on your VM, right? So you will use either Kubernetes UI or using Kubernetes CLI, like how you used Docker build via CLI command line, right? So same way you can manage Kubernetes via command line. So either from UI or from command line, when you perform an operation, that is if you want to deploy a new application, right? That's nothing but an operation, right? That's a transaction that you're performing. So internally an API call is hit, or internally that application calls Kubernetes masters and says that, hey, there is an application called as login, which I have to deploy. Then your Kubernetes master checks in the VMs that is have, which VM has space, right? How will it know which VM has space? Assuming in this orchestration, that is the configuration file that you create. In configuration file, you will say that, hey, I need 6 GB RAM memory and I need 2 virtual core CPUs. So it will go and check which VM has this much of space. Let's say my first VM has this space. So it will go and deploy in this first VM. So my container will run in this VM here, or deploy in this VM here, right? So don't get confused. Node is nothing but VM. And where do I get this container image from? like here we created an image, right? Docker image. In our case, we created a Docker image here, right? Where do we get this Docker image from? This Docker image will reside in our container registry, image registry or container registry, which is basically our GCP's artifact registry. So in an artifact registry, it will be there or present there, right? So this is how internally your Kubernetes architecture is. This is how it basically works. Does it make sense? Now you don't have to go internally and in depth, guys. At high level, you just have to get the knowledge of it. Okay. It will be basically a DevOps team work to, manage all of this in production. Okay. Now, how does your Kubernetes YAML file or manifest file looks like, the configuration file, right? So it'll look like this. It'll basically, it's a YAML file, and YAML file, it'll have like this key value pair, and it'll be indented by tab space, right? So here first you'll have API version. That is nothing but your Kubernetes API version. Then you will have kind. Kind is nothing but what kind of manifest this is, that is configuration. So kind is deployment, meaning that whatever configuration I have here is to deploy an application. You can same way as kind as service. Service is to expose it so that you can test it via API. You will get like a IP address and all that, right? So you will have different kind here. So here I'm saying deployment kind, meaning whatever configuration here, it is to deploy an container. Then in metadata, I give name, and this name is basically my Kubernetes deployment name. So the name of the deployment is Nginx deployment. And then in specs, I give other specifications, like I give the app name. I'll give my container app name. Then I'll tell how many replicas, that is like how in our managed instance group, minimum number of instance will be running, right? Same way here, minimum number of pods. What is pod? Pod is basically a smallest unit. Your container is running, right? Your container runs inside a pod, right? So a pod is, think it like a container. Inside that your container runs, right? So it will have 2 container replica running, right? So that minimum 2 pod you will have running, that is equivalent to 2 instance of your application that is running. And in other templates, basically other templates will give value like what is your app URL. So here you pass the app URL, right? Here you give the URL. Then if it is application is in some port number, you give this port number, right? Now these configurations also will be like similar. You can just copy paste and make minor changes like app name, app URL, port number, and you can deploy new application, right? So we generally create a proper generic deployment YAML file, and then later copy paste and make small changes in our configuration to deploy new application. So that's how also it is quicker, right? So first we will go and create a Google Kubernetes engine. Okay. And then we will create like this a YAML file, and we will deploy this YAML file in our Kubernetes. Does it make sense? Okay. So let's go back to our console, and on the top search for GKE. Just type GKE and you will get Kubernetes engine here. The first option that says Kubernetes engine, right? So please go ahead and click that. Done. Cool. Let me do it from my end. Enable, right? Yeah. Because we are doing it for first time, we have to enable it. Let me know once everyone you are in this page as I am. So right now you guys are in overview page, correct? Just click on cluster. Right below it, you will see clusters, right? So just click on clusters page, right? So just below this overview, you will have clusters. So just click on this clusters and then click on create. So we will create a new cluster. Why cluster? Because you will have group of VMs, right? Group of nodes. So that's why it's called as a cluster. Okay. Now, whatever you see here, guys, you will see some autopilot mode, right? What is this autopilot mode? Autopilot mode is more advanced GKE where Google manages everything. Google will manage your virtual machines, that nodes and all, right? Which we don't want to do. We will go and do the native or old way so that we do the manual configuration for everything, right? So that's why on the top right hand side, you guys will get a button that says switch to standard cluster. So click on switch to standard cluster. Done. So once you switch, so you'll see there'll be a lot of options that we have to fill, right? Again, I won't go in depth, guys. If all the options, I'll be skipping most of them because it's not required and it's out of our scope. I'll only be talking about some important configurations. Okay. So the first and the foremost thing is, guys, clusters basic, which is nothing but basically filling the basic details, like what is your cluster name, where do you want it, right? So cluster name, I'll give it as my GKE. I'll give my GKE name as my GKE. Okay. And I'll keep as US Central itself. Why? Because if you remember in artifact registry, I have kept my artifact registry in US Central region. So I'll keep it from US Central so that it's easier to get this image quickly because it's in same location, right? So I'll keep everything else default. And if I scroll below, I will see release version. This release version is nothing but GKE release version, the GKE version, right? Since it's open source, so it'll basically, people will be making updates, right? And upgrading it. So that's the GKE version. So yeah, here I think we did not do anything, guys. Just made the change in the name. That is the cluster name. Okay. Then fleet registration, you can forget for now. Then we'll go to node pools. Node pools are important. Why? Because node is nothing but a VM, right? VM pools, because you will have multiple VMs, correct? So we'll go to this node pools, and here we'll have a node pool, and it will say number of nodes as 3. That is nothing but minimum number of VMs. So it means always these 3 VMs will be created, which I don't want, right? Because it's for learning purpose. For learning purpose, I will keep it as 1. I don't want 3 VMs running always, right? So just reduce it to 1, guys, number of VM here as 1, right? So in under node pool, default pool, just reduce this number of size of to 1, right? Then I'll click on node, guys. And in nodes, on the left hand side, you'll get nodes. If I click on nodes, it'll basically give me the configuration of selecting a VM. Why? Because I told you, right? Node is nothing but a VM, right? So you'll get similar options selecting to VM. I'll keep it default itself. It's fine. Let it be 4 GB memory. It's fine. So I won't touch anything here. Networking, where basically I won't touch anything in networking. Security also, I won't touch anything. I will allow default access. These are the settings similar to your guys creating of your VM, right? So I'm going to keep all of this default, right? Automation, you need not worry anything. It's not related to us. Networking, here basically we will tell in which VPC it will go and create this GKE cluster. So it will create in default VPC, which let it be there. Then it will have public cluster. That means it will have public IP address and it will accept load from public. Security, you can just skip a lot of things, guys. It's out of our scope, right? So technically everything is default, guys. The only thing we have done is given the cluster name, and under nodes, we have given the size as 1, right? Instead of 3 number of pool. What is the difference between node, NW and networking? So in node, this is networking related to your virtual machine. Like if you want to add a node network, right? This networking is related to your VPC networking. That is GKE level. Does it make sense? Yeah, cool. So everything else will be default, guys. You can just go ahead and click on create, and that will create your Kubernetes cluster. So do that. This will actually take 1 to 2 minutes. Let it create our Kubernetes cluster. So it's just creating a cluster, right? It's taking cluster, that is, it's creating VM. In that VM, it will install Kubernetes, and then it will make sure everything connects and everything is working fine, right? So because of that, it will take so long. So we have no other option but to check. Health check is running. Yeah, so a lot of thing is running in the background, right? It will make sure Kubernetes is installed in that instance because it's managed by GCP, right? So it will do everything on the fly. So we have no other option but to wait. But I think it will take 1 or 2 minutes max, because already it took 5 minutes. So it's somewhere close. So let's give it some time, guys. Okay. Okay. Yeah. Mine is created. Yeah. Mine is successfully created, guys. So just make sure in next couple of seconds, yours will also be created. Created. Great. Done. Okay. So now we have to simply select or click on this my GKE and go inside this my GKE, right? So just click on that my GKE, go inside this my GKE, guys. Enter this. You'll get details here. Correct. Now with these details on the top, do you see, guys, a connect button? You guys will see a connect button, right? So click on this connect button, and then that will also give you a Gcloud. Basically, it will give you Google's command. So we have to run this command in a terminal to connect or log into our my GKE cluster, so that if I run any Kubernetes command, it should know that this cluster, it should go and execute, right? Or this cluster, it should go and do the changes. So for that, you have to copy this, right? I repeat again, where will you get this? Once you click on the GK that is created, click on the GK service. On the top, you'll get connect button. So just click on connect, copy this command, go back to your terminal and make sure your project is selected, guys. You should see an yellow text like this if your terminal is reconnected, and then paste and run it. So that will give you an successful this one. So it says cube config entry generated. So do it. One thing is, if you leave your terminal open for more than 25 minutes or 30 minutes, it will ask you to reconnect. Yeah, if you leave your terminal for 25-30 minutes open like this in a tab, not using it, it will actually ask you to reconnect. It will shut it down and ask you to reconnect. That one thing is there. But if it is asking you to reconnect where you're frequently working on it, then it is actually, I would say, issue from GCP side, right? Something might be issue. Anyways, so once you run this command, guys, let's do one thing. Now, just say cd space enter. Docker images are gone. Yeah, so yeah, it'll be gone. Whatever was there stored in the memory, that will be gone, because a new instance is provisioned to us, right? Once we reconnected, that means a new VM got attached, right? So that's why. Anyways, we don't need the Docker, right? It's fine, because our Docker is already in cloud, right? At this URL, remember, in a repository. So it's fine. Okay. Now, guys, just run cd space enter and make sure you guys are outside, or you guys are in your home / your user directory. So you guys should be in this directory. Please verify. You guys should be outside in this /home / your user ID directory, because we will create a new folder now. Verified? Yes. Okay. Now create a new folder called as mkdir gke and cd gke. So I'll create a new folder called as gke, where I will upload all the configuration file. But I don't see top footing. Top footing is my project, right? So you will see your project. If you're not seeing like this top footing, click on this plus icon and click on this plus icon drop down and select top footing then, or whatever is your project, right? Then only you will get. Okay. Please do that. Got it? Okay. So just run mkdir gke and cd gke and open the same gke folder from editor also. So I'll say file, open, and I'll say gke folder. So I'll open gke folder. Done. It's saying no such file or directory gke. Did you run the mkdir command first? Because mkdir first creates the folder and then you cd to gke. Yes, done now. Okay, fine. So once you're under this folder, let me do one thing. So you just upload it in this folder, guys. So right click in this gray space, then you will get upload button. Just go and upload both these files here. I've joined using smartphone. You can just type that URL, Sandeep. That URL is very small, so you can type it. It's fine. Just type that URL. It's gofile.io /d/A w 77 o B. Done. Okay. Okay, so let me give you a quick walkthrough of this YAML files that we have, guys. So deployment at YAML is basically nothing but a kind deployment YAML file, which we saw in the PPT, right? That we did a walkthrough. So API version, kind, then we will give metadata, we will give our deployment name, specs, then app name. App name, I'll give it as sample, guys, or let it be hello gateway, it's fine. Okay. Who doesn't have the image URL, keep it as it is. Okay. For others, what we will do, we will copy our URL. We will deploy our application, right? And I will paste it here. So this is that image URL from where it will download and run my container image, right? For others who are not able to push, just leave the URL as it is to what it was. You will get Google's Cloud Run Hello World page. For others who were able to push to artifact registry, paste that artifact registry URL here, and very important, port number should be 80, guys, because remember in our okay, I don't have it here, but in our Docker file we gave port number 80, right? So that's why make sure port number is 80 and this URL is your artifact URL. For others who have not done it, keep it everything default. Don't make any changes in the YAML files. Okay. So let me know once this changes is done. Only port number. So I hope changes is done, guys. Then let me give you a quick walkthrough, right? So see this once done, guys. Okay. It will deploy your application. But to test your application, you need a IP address or load balancer, right? So that, okay. So that application to test, you need to expose it and get a URL. Okay. And to deploy and test it, we need a load balancer. So in service.yaml, that is, we will create API version 1 kind of service. We will go and create a load balancer and say that port 80 and 80. Again, this changes will be only done if you have made changes in this port number, then only go and make change in this port number, or else please don't do anything. Okay. So folks who are using custom image URL and who has updated port 80, go and update in service.yaml that target port is 80. That is inside my container. My application is running in my port 80. So this will go ahead and create a load balancer, attach it to your application, that is service, so that you can test your application, right? So both of this we will be running. So I'm saving both of these YAML files which I have edited, right? Okay. So now let's try to deploy this. Okay. And to deploy this in the terminal, we are going to write kubectl. So kubectl is basically your Kubernetes command line. Kubectl -f. -f means it is a file. And what file? -f apply deployment.yaml file. That means what? Okay, it will be kubectl apply -f deployment.yaml file. It will be something like this. Sorry, my bad. So kubectl apply. Apply what? Apply changes and take it from -f. -f means file, and I'll give the file path, that is deployment.yaml, which is in current folder. So it will go ahead and deploy this, right? And then hit enter. Then you see, you will get basically that it is created. Then same thing you will run again, kubectl apply -f for service.yaml. So that will go ahead and create a load balancer and attach your load balancer to your service, right? So you should see two services like this created. Okay, cool. So now you can say kubectl get pods. So that will list all the pods that is running. Currently only one pod is running in which our application runs, right? What is a pod? Pod is the smallest unit inside which your application or container runs, right? So here you see one pod is running, correct? Then I'll say kubectl get svc. Svc stands for your service. Kubectl, sorry, I spelled it wrong. So here you see, if I say kubectl, it will give me the load balancer. See, hello gateway service load balancer. It will give me this external IP address. So I can copy this external IP address, give HTTP, paste that IP address and slash, and that will return hello world, right? That means our API is working, right? Make sure it is HTTP, guys, not HTTPS, right? It's HTTP. So just go ahead and run these commands to see if your pod is running, to see the service, get the external IP address, that's your public IP address, and test if your application is successfully running or not, right? It's running. Great. So you understood, right? How easy it is to manage like this, right? So all you have to do is, guys, in this YAML file itself, you can copy paste and you can have all the 15 applications. I'm just showing, you need not do it. You can have all the 15 applications like this, right? You can have all the 15 applications, microservices, informations in one YAML file itself, right? So it's easier to maintain, and then just using one command, all of this will be updated and redeployed if there is any changes made, right? So handling multiple deployments becomes very easy using Kubernetes. That is why we call it as orchestrator, right? Or we call it as orchestration framework or orchestrator. Why? Because it orchestrates, it manages what it manages multiple deployment. That is the only main reason, and this benefits, and that's why we use Kubernetes in industry, because it helps us manage multiple deployments. Is it clear, guys? Cool. Then we can go ahead and we can delete our Kubernetes cluster that we have created, right? My external IP is not running. It's http:// and the IP address. Cool. What we can do is we can go back and delete our Kubernetes cluster because we have completed our test, right? Anyways, for others, guys, we can go and delete our Kubernetes cluster. So I'll go back to my GCP console page and I'll click on delete button. And then yes, I can say delete my GKE. So it will go ahead and delete this Kubernetes cluster. So go ahead and delete this Kubernetes cluster, everyone. And you can even close this Cloud Shell. Let me know once you guys have deleted your Kubernetes cluster. Then we'll go ahead and delete the artifact registry repository that we created. So ideally what we do is once our Docker image is ready, right, we run it locally to test if there's any code error, right? But we did not run it locally to save time, right? So that's why we could not cross verify if your code is correct or not. So if your port is 80 and it's working, but if it's not working, that means code wise there is some error in code, maybe copy paste, something that might be missing in your code, Docker file or requirement or text file, some or the other thing might be missing. Okay. So probably you can just redo it later. Cool. So by the time this GK is deleting, guys, you guys can go and search for artifact registry. On the top, just go and search for artifact registry and go ahead and delete the registry that we created today, right? The repository, hello microservice. So just go and delete that. We don't need that also because we are winding up our GCP compute, right? Before we start the next one, that is GCP storage, but not the cluster. Cluster will take time. Like how it took time to create, it will take time to delete also. So if I go back to my GKE, it will take time because it has to decommission and lot of things, right? We will get started with GCP group, that is GCP storage. Now in GCP storage, we will be learning and we'll be doing, services that are related to your storage to store data, right? So the first service that we'll be doing in GCP storage is our cloud storage bucket, cloud storage, right? So we'll learn about cloud storage. We'll see how we can leverage cloud storage. Then the next thing that we're going to learn is how we can deploy or render static website in, okay, that will be part of cloud storage itself. Then we will see Cloud SQL. Then we'll see Cloud Spanner, and then we'll see data store also. Then we'll see the data store or Firestore, which is the new name, right? And then we will see BigQuery, right? BigQuery will come under big data, but yeah, we will be doing it in our cloud storage itself, right? So these are the services that we will be learning how to check all the services which is running. 150 rupees has been detected so far. There is sadly no way to see. The only way is you go and check each and every service, like go and check if there's any virtual machine or if there's any GKE or if there is any managed instance group, any of this that is there, right? Cool. Okay. So getting started with first cloud storage, what is the purpose or requirement of cloud storage is what we will understand first, right? Now, the very first thing that we have to understand is that cloud storage is used to basically store or actually have archive any file formats, any structured, unstructured, any data you have, you want to store, basically you will be using cloud storage, right? So in your cloud storage service, you will be actually uploading any amount of files and folders to create backup or to upload any data, right? So how does this work? This works just like your container. Think it like an folder, right? So in your desktop or in your laptop, you'll go and create a folder, and inside that folder, you can have any amount of files and folders, right? So that thing will be there in your cloud storage. Okay. So let's directly jump into hands-on of cloud storage, guys. Let's create a first cloud storage bucket in GCP. Okay, so here on the top search panel, we will search for cloud storage. Okay, and that will redirect to a page where we will see this storage buckets here, right? So quickly do that, guys. On the top search panel, search or click for cloud storage and then have these, because if you guys have pushed anything to artifact registry, right? So you will have buckets created for artifact registry. So this is your app engine bucket where all the files will be there, right? So some of you might have, some of you might not have, based on whatever services that we have used so far, right? I can see too. No worries. Don't worry about that seeing. Okay. Now we will go and create our first bucket here. Okay. So to create our first bucket, on the top, click on create. Fine. And search here the name. I'll give the name here as sample bucket Aman test, something like this. Now make sure you give a unique name, guys, because the bucket has to be unique globally. It's not just that my bucket should only be unique for my project. It should be unique globally, right? So make sure you give a name so that that does not exist globally. So this name should not have been taken entire GCP, not just your project, right? Whole GCP server, this name should be unique. So make sure you give the first name, guys, unique name. If it's not unique, it will give any error. Yes. Like say, for example, if I say sample bucket, so you will see like this red color line and it'll say this bucket name is already taken, try another, right? Sample bucket test Aman 2, something like this. I'll give some unique name. Okay. So once you have unique name, guys, just click on continue. That will take to step 2. Okay. That will take to step 2. And in step 2, you can select multi-region. So in multiple region, what happens? You select US. Remember, guys, in US also there are multiple zones like US East, US West, US Central, US West 2, US East 2, right? So if you select multi-region and select US, in all the region, you will have backup of your files. So you can access in any region via GCP network, right? So you can select multi-region if let's say you are building an application where you want to store some files, right? Or you can select dual region where you can select 2 regions, okay? Or you can select single region, right? And obviously price will also be depending on this, okay? So the price will also be dependent on this, right? Multi-region, dual region and region. So if you select single region, obviously it will be cheaper. If you select multi-region, it will be a little bit costly. You can see here, if I select multi-region, it will be $0.026, right? So if I convert this to INR, it will be like 2 rupees 17 paisa per GB per month. But if I select single region, see here, it's $0.020. So that's equivalent to like 16 bucks. No, I think I've missed something. How can 0.02 be so costly compared to, yeah, if I just convert this to 0.20, it should be 1 rupee 67 paisa, but it is saying 16 rupees here. It's a bug. I don't know. And it's not even 0.02, it's 0.020. Okay, my bad. So it will be 1 rupee 67 INR, right? So obviously based on, your backup, based on your region, it will actually be higher or lower. Okay. Then click on continue. And then you have to select a storage class. So what is a storage class here? So storage class will be what kind of data you are storing here, right? What kind of data it is. So if you select auto class, that means automatically based on your requirement, it will change the class. Okay. And if you select here default, in this default classes, you have 4 classes. I'll explain each of these 4 classes. Okay. So standard means, it means you are frequently accessing it. Okay. That means your data will be in the front line and you can access them quickly. Nearline means your data is accessed less than once a month. So if you're accessing your data less than once a month, it should not be readily available for you. It will be a little bit behind. It will be like a backup archive kind of thing. Then you can access once a quarter. That is cold line. So if you are creating this bucket and inside this bucket, you will be storing files which will be accessed once in a quarter, then you will select it as cold line. And then if you're accessing it once a year, then it will be archive, right? So archive means basically for your backup. Once a year, you're going to access this, right? So yeah, based on your use case, and again, your pricing will depend, guys. Standard means it will be little costly. Costly means it will be the standard price because you're frequently accessing it. Whereas if you select nearline, you see it will further reduce, because in nearline, what happens? Your files will not be in the front line. It will be somewhere in the back. It will be in the lower storage, right? Because you're not accessing daily or frequently, or not like every second or every minute or every hour. You're accessing it once a month. That's why. If you select code line, it's further more cheaper because you will be accessing once a quarter. So it will be further back, and you won't be having the best storage here. Like you won't have a faster SSD and all that, right? Because it's a once in a quarter. And archive means though it's far more cheaper, right? 0.0012 $, right? Which is like 10 paisa per GB storage, right? Why? Because you're accessing just once a year. That's why it's super cheap, right? For now, I'll keep it standard. Now, if you select auto class based on your object is nothing but a file or folder. Based on your usage of files and folders, automatically it will keep changing between these. So this was not there before. Google launched this like couple of months back, where in auto class, it will automatically transition like your object should it be standard nearline to save price. Is it clear, guys, so far? Okay. So we'll keep it default standard and we'll click on continue, right? And then comes your next option that says choose how to control access to objects. Okay. Here you will have option based on access control. That is, should your bucket be public or private, right? So if you see here, if you see enforce public access prevention on this bucket, which means what? It will enforce public access prevention. That means your bucket cannot be public. Don't get confused, guys. It's saying enforce public access prevention. That means prevent. It's not saying access publicly. It is reverse. It is saying public access prevention. So if this box is checked, that means your bucket cannot be public. It will be private, meaning you can only access it inside this GCP project. You cannot like access this in internet. Whereas if you make it public, then you can access it in public. Access it in public in a sense, if you have uploaded a file, you'll get a URL. If you have that URL anywhere in internet, you can go and download. You don't need to have access to GCP project or anything like that. It'll become public. Anyone and everyone can access, whoever has that URL, right? So yeah, I will make sure this is checked so that it'll be private. Then comes two types of access control, uniform and fine grain, right? So in uniform, what happens, guys? In uniform, it'll have uniform access to all the files and folders, that is objects. Meaning in uniform, what will happen? Let's assume I have like this file 1, file 2, file 3, file 4, file 5. Okay. And then if you select it as uniform, so in uniform, what happens? If I say public, all will be public. All of this will be public. Okay. If I say private, okay, all of this will become private, right? So as the name suggests, guys, here uniform means all the objects will have a uniform permission or uniform access, be it public or private, it will be uniform. Okay. Then you have fine grain. If you select fine grain, then what happens in fine grain is, in fine grain, each and every file you can say whether it is public or you can say if it is private, each and every file. Is it making sense, guys? What is different between uniform and fine grain? Uniform, as the name suggests, it will be uniform. Permission, whatever you select, it will be uniform everywhere, right? Whereas if you select it as fine grain, in fine grain, each and every object, we call this as object, guys. Any file or folder, we call it as object. Each and every object you can give independently whether it will be public or private. Does it make sense? Is it clear? Okay. So for now, I'll keep it uniform because anyways, this bucket is not important for me. I'm doing it for learning purpose. Okay. Uniform, please repeat. Yeah. Uniform, as the name suggests, uniform means whatever is the permission. If you put it as public, all the files folders will be public. If you set it as private, all the files and folders will be private. Whereas in fine grain, what happens? Each and every file manually you can go and select whether it's private or public. Clear? Okay, fine. So I'll keep it default. I'll click on continue. And then here I'll have the last option, that is choose how to protect object data. right? So here in choose how to protect your data is basically having a soft delete option here. What is a soft delete? It's just like how you delete something in your laptop, it doesn't delete, right? It will be there in recycle bin, correct? Then you go and delete from recycle bin. It is something like that, guys. So soft delete here, 7 days retention policy, meaning what happens if you delete some file, you have 7 days of time to get it back. And is 7 days fixed? No, guys, you can go and make it 19 days, 20 days, for 40 days, 100 days. It's up to you. Oh, sorry, 90 days is max. My bad, right? Or you can even select it is in months. You can say, 3 months, 1 month, 2 months, right? You can go give it in months. You can give it in years, seconds. You can give seconds, days. So you can basically go and configure it, right? Soft delete policy, meaning if you delete anything, that will not actually delete. It will be there it will not be seen in UI, but it will be there in the backup for 7 days. So you can go and get it back. If by mistake you have deleted, you can go and get it back. Okay. Then we have object versioning and retention. These two I'll explain later. Okay. So for now, keep everything default and just click on create, guys. That will create our first bucket. So that will go ahead and create this bucket. So first create this bucket and then I'll discuss further. Done. So the first and the foremost thing you'll see here is, guys, upload files. Again, I'm not going to explain this. It's very simple. Upload files is basically you upload a file, right? So you just select some files and click on upload and it will upload a file, or sorry, all the files, right? So that upload is basically to upload any files and folders in your storage bucket, right? Then you have upload folder where you can upload an entire folder, correct? Then you have create folder to create a folder in your cloud storage bucket. So here I can create folders like files. Then I can create folder here like called as images, right? I can give images name. Then I can create another folder and I can give the name as, let's say, for example, backups, right? So you can create folders here, and inside these folders, you can go and store files. I mean, however you want, you can go and, beautify it and clean it, right? But I'm trying to say that you can have files and folders here, right? Then you have transfer data in and out. Meaning, let's say, for example, I have lot of files which is in other storage providers. Then I want to bring it to GCP. So I have transfer in option, right? So I'll quickly show you this option. So it's very simple. You'll select your source. Where are you actually getting this from? Then you will select your destination. That is where you want to save this, right? So a source can be Amazon S3, Azure Blob. From URL, you can extract it, or from GCP itself. Because sometimes might happen, right? From GCP bucket to GCP bucket, you want to migrate, right? Or copy a data from one bucket to other bucket, right? So you can select that, right? Then you can say whether it's a batch job or event driven. What do you mean by event driven? That means if anytime there is new data, or if there is any changes in my data in my source bucket, it will upload or it will make the changes in my destination bucket. Batch wise, what happens? Batch time means it will do once, or it will do a recurring basis, meaning once a week or something like that, right? You can actually run this as a job, right? Then you can select your source bucket. If it is a bucket, if you select like Amazon S3, then you have to go and give the bucket name. Then you have to give the CloudFront domain if it is through CloudFront. Then you have to give AWS access key and all that things, right? So based on which cloud you're using, what you're doing, you will have to give those configuration files, right? After giving that configuration files, then you choose your destination bucket. Where do you want to copy this, right? And then you can run this as a job, and you can say runs once, runs every day, runs every week. So what happens every day, every week, it will take backup from that source to destination, right? So that is your simple option here. That is data transfer in. Same way we have data transfer out, meaning from your GCP bucket where you want to copy. You want to copy from, these sources to any other destination, right? So it is going to transfer out. Whatever is there here, it will be transferred out to your source bucket, right? So everything is same. Okay. Option wise, everything else is same. Cool. Then these are the basic options that we have related to, copying of files and folders and all that, right? So in objects tab, I'll be able to see all my files and folders. In configuration tab, I'll be able to see the settings that are related to my bucket. Then in permission tab, you will be able to see whether, your bucket is public or not, whether, it is uniform or not. Okay. Then protection we have here. In protection, there are 3 options here, guys. Okay. Soft delete, we have already seen. Soft delete is nothing but once you delete a file, it will not actually delete it. It will keep it, or it will retain it for 7 days. 7 days time you will have to get it back. If you don't get it back after 7 days, after 7 days it's gone. So there's no provision of getting it back. Then there is object versioning. So in object versioning, what happens in object versioning is you create a version. Why do you want to create a version? I'll give you an example. So guys, let's assume, okay, let's assume everyone, you have a file called as sample.txt in your local laptop. Okay, and the content of this is hi. There is a text called as hi in sample.txt. Okay, now assume guys, you copy paste, okay, or you override sample.txt with by as a text. So remember, when you're copying file guys, and if the file name already exists and you override, what will happen? Once you override a file that already exists, what happens? Content changes, right? So let's say, for example, I have a sample.txt with by, okay, and I copy paste that. If I copy paste it, I'll get a pop-up that says that, do you want to override? And I will say yes. So now my content will be what? My content will be by. Now, in Windows, is there any way I can go and get back my old content? Once, purposely or by mistake, if you override a content, can you get it back once you override a file? No, right? So this is one of a disadvantage, because sometimes what happens, you will be in a hurry and suddenly you'll be like, yes, override. But then you realize, oh shoot, I shouldn't have overridden it. I need both the data. But sadly, there is no way of going back. So in such scenario, what happens? We do object versioning. So what happens in object versioning is, technically, I will have old file. Okay. Now, if I bring a new file with a content and override, it will override, but it will keep the old version also. Let's say the old version is 1, the new version is 2. So it will map to new version, but old version will always be there, so that you can retain it back, you can get it back. So that is what this object versioning is for data recovery. Meaning, sometimes by mistake it happens, you overwrite the data and now you want the old data back. So what happens? That's where you do object versioning, where your old files will be versioned and you can get back that version. Now, very important, version will not be done based on number, it will be done based on a unique ID. Okay, so based on that unique ID and date, you will be able to go back and get back the old file also. Does it make sense, guys? What is this object versioning technically? Yes. Okay. Then we have retention policy. So what is retention policy? So there is two things, guys. Soft delete and retention policy. Please don't get confused. Soft delete is for retention, right? But it is for retention when you delete it. Whereas retention policy here is basically after they have uploaded, how long it should be there. So consider an example where if I upload a file, that file should be deleted automatically after 30 days. Right? So let's assume you have an application where you're only storing data last 30 days. You don't have data after 30 days, right? Because let's say, for example, you are building a cost optimized application where you don't want any data that is been there stored 30 days before, right? So in such scenario, what you do, you create a retention policy. Again, please don't get confused, guys. Soft delete happens in retention. Soft delete is in soft delete. Retention is when you click on delete button. Whereas in retention is it when you upload, from the time you uploaded, you can add a retention period where after that much of time it will delete. Say, for example, if I say 30 days. So what happens here in 30 days is once I upload a file, for 30 days, it will be there in my bucket. After 30 days, it will be gone. Right? So this is an automated retention where you want to clean or filter off, right? Whereas this soft delete is when you purposely go and click on delete, like you have to go and click on delete button. Whereas here it is based on time period. So that time period, it will automatically go and remove that object. So you're getting right. You're understanding, right? The difference between both is clear, right? Yes. Okay, great. Okay. So yeah, these are the options in protection, guys. And as the name says, protection meaning these are to protect your data. Okay. Life cycle. So coming to life cycle, guys, in life cycle, you can create a life cycle. You can create a life cycle rule. Now, what is this life cycle rule? There can be scenarios where imagine I'm building an application. Okay. In that application, all the files inside bucket will have retention applied. If you apply retention policy, yes. If you apply, it will apply for all. Okay. But your next question would be, what if I don't want for all? For that, we will use lifecycle. That's what I'm going to explain now. Okay. So let's assume, guys, a scenario where you upload a file or where a user uploads a file. So once a user uploads a file, it uploads in my bucket, correct? And once it uploads in my bucket, let's say in my application, let's say my application is related to, let's say it's a legal document application, something where you can upload your legal document. I'm not able to come up with a good example, right? Where you upload a legal document and it will scan your legal document and it will give some suggestion based on your legal document, right? Now let's assume that a user will be able to access their legal document only for last 30 days. After that, they will be able to access it, but I will store it as a backup, because it is obvious that, guys, when I create this bucket, I will keep it as standard. Why will I keep it as standard? Because if I keep it as standard, my objects will be in front line. It will have fastest storage. It will be in fastest SSD storage. So it will be quick, right? So obviously, and I want to give my user better experience, right? What is the purpose if I build a very good application and I ask user to wait 5 seconds to see the document? So it will not be a good thing, right? So I will keep it as standard. But if a user comes, upload the document and he doesn't come back, he comes back after 60 days, 90 days. I can't afford to keep that legal document in standard mode for 60, 90 days because I'm shelling out money, right? So there, what I can do, I can create a life cycle. Life cycle is a rule where based on some period, you can change. What can you change? You can change storage class. You can create, or you can change storage class. You can change delete option or retention option, right? And retention option. Retention is nothing but delete itself, right? When you're deleting, right? So you can create a rule, and not just one. You can create 5 rules also. You can create infinite rules. So I can create one rule where I will say, if a file is 30 days old, from standard, it should be gone to nearline storage. And then I will create second rule saying, if my file is 90 days old, okay, then from nearline, send it to archive. And I will create another third rule saying, if my file is, if my file is older than 1000 days, then I will simply say, go and delete. I don't need this file. Let's say, for example, a file is not been used for 1000 days. It's close to 3 years. Then I will finally go and delete it. That means that user won't use it itself, right? Just giving an example. So I'm trying to say that you can create like this n number of rules which will be followed, right? So that's what I will show here. So in life cycle, you can go and first add a rule. So what kind of rule are you adding? Are you adding a rule to set it from standard to nearline, or to from standard to cold line, or from archive, or you want to delete it? So let's say, for example, first I will create a rule where it should store from standard. It should convert the storage class to nearline, right? So I'll click on continue. Then here it will give me option like, do you want to do it for all the objects, or you want to do it for specific files? Then I will select that here. So I can select file name that matches with prefix or suffix. Prefix means starting with. So let's assume any file that starts with file underscore, it should go in. What it will do? It will convert it into nearline, right? So this is one option. Another option is suffix. So I can say any file that ends with .pdf, right? Because it is suffix. Suffix means at the end. So any file that ends with .pdf, .jpg, what it should do? It will convert from storage to nearline, standard to nearline, right? Another options are based on age, meaning any files that are 30 days older, any files that is been 30 days from day of upload, it should go and set it to nearline, right? Let's assume I want to delete it after 1000 days. So I will create a new rule where in that rule, I will select delete object and I will give age as 1000 days. Meaning after 1000 days, once it is 1000 days from day of uploading, what it will do? It will go and delete it. Or do you want to do any other operation? You can go and do it, right? And not just one, you can create multiple settings like this, right? And you can create multiple rules. You can create 5, 10, hundreds of rules, right? For this bucket. So is it clear, guys? What is this life cycle? Clear? Okay. Then Observability, observability is need not important. It's basically for, you basically getting a graph to see how many files do you have in your bucket, how much MB or KB of how many packets of data is read and write, buffer, all that thing, right? So these things are not required, right? So yeah, that is with respect to your storage buckets. It's very simple, right? I've uploaded one file and deleted. Where do I check my deleted file? Soft delete is enabled. Can you click on this show button here and this one? Can you see my screen? So here under show, you'll have live objects only, and then you'll have soft deleted, right? So just go and click on soft delete, and then you'll be able to see. Okay, cool. So were you able to find that soft deleted file? What is default event based hold option? Where is it? Default event based hold option protection. Yeah, actually, even I don't know this. This is new. When this option is enabled, event based holds are placed on objects when they are uploaded to the bucket. This supports an event-based retention strategy. Start the clock on an object's retention period by removing the hold when a user-defined trigger event occurs. For example, preserve records for 6 years after a contract ends. It's an event-based retention strategy. That is the least we can take. But start the clock of an object retention period and all these, I'm not sure. Yes. Okay, great. So let's proceed further. Now let's come back and create a new bucket. Okay. But this time we will create a bucket to deploy static websites. So in GCP, if you were to deploy static files like HTML, CSS, JavaScript, static files, we deploy it using storage bucket. We create it via storage bucket. Okay. Now, how do I do it via storage bucket? So I'm going to click on create button and I'm going to create a new bucket. The only difference is, guys, I have to make sure my bucket is public because websites can only be rendered on internet, right? Like see here, if I say go amazon.in, right? Only because amazon.in is public, that is why I'm able to render this website, correct? Same way, I have to make sure my website should be public. So for that, my bucket should be public so that that URL is public and it can be rendered publicly, right? So that's the only difference, guys. And one small minor configuration change, which I'll tell you, right? So we'll go ahead and create a bucket where I'll say Aman or sample website deployment Aman. Hopefully this is not taken. Yeah, this is not taken. So this will be my bucket name. Should we create a bucket or you will tell where the change in config? No, I will tell you, right? So click on continue. I was just waiting for the name. Okay. Then you can keep it multi-region or single region, guys. It's up to you. I'll keep it default. I don't mind. Standard class. Yes, it'll be standard class. Here is where I want you guys to do the changes. Where choose how to control access to objects. Here you have to uncheck this. Why? Because I want it to be public, whereas this says prevention. I don't want to prevent. I want it to be public. So that's why select on uncheck this option so that my bucket can be public. Okay. And everything else will be default, guys. That's all. So only one thing you have to make sure you change, that is selecting here enforce public access prevention. This you have to uncheck. That's all. Done creation. Shall we upload something? Yeah, I will tell you what to upload. So we will create a sample HTML file. Give me 1 second, guys. I will quickly create a sample HTML file and I'll store it in download. Call it as index.html. Index.html. Okay. And I'll give this as sample. Okay. And I'll give this as h1. Hello there. This is my website. Okay. So if I actually render this website, if I go to my downloads folder and render this index.html, so this is the website. So let's assume this is a static website that we are trying to render or upload, right? Or deploy. Now, one thing is we have to make this file public, guys. This file is not public. Okay. Now, this here you see, it says not public. But if it is not public, then how will it actually be rendered? Then you might say, hey, but we clicked on that button that says unchecked. We unchecked that prevention, right? So that option just make sure that you can make your bucket public. It did not make your bucket public, right? So that option is just to ensure that further in future you can make your bucket public. That option doesn't make sure that your bucket converts into public. You have to go and manually do it, right? So that's what we will go and do this. We will go and say that this index.html should be public. Okay. And how to do it public is click on these three dot icons and then click on edit access. I'll have my cursor here. Again, I repeat, go to this index.html, scroll towards your right hand side, right? And I'm saying there will be an option here, three dots icon, click on this and click on edit access. Please do this. Cannot get legacy ACL for object when uniform bucket is accessed. Read more. Acha, okay, we have to go and change it as fine grain, guys. Okay. I think we have done a small mess up. I think we have to make sure it is not uniform. It is fine grain. So to do that, I will go in permissions, and in permissions, I will go and click on switch to fine grain, guys. Yes. Sorry, guys. One mistake. We have to make sure two things. One is that prevent is unchecked and we have to have it as fine grain, right? We cannot have it as uniform. So just, I change it from configuration. Yeah. So just click on this switch to fine grain, guys. Done. Okay. Let me also do it. Okay. So once it is done, now you go back and click on here, click on edit access, and we will make sure we select it as, add entry, and I will say it as make it public. Okay. So we will select on add entry and we will make it as public. I repeat again, once you go to protection or permission, under permission, once you have switched to fine grain, come back to objects, then click on these three dot icons, click on edit access. For this index.html, click on edit access and add a public record, meaning it should be public. Anyone from internet can access it. Is it done, everyone? Showing as public? Okay. Now that it is showing public, just scroll a little bit right. You will get a copy URL also, right? You will get copy URL. Click on that copy URL, paste it, and then hit enter. So you see your website renders. Please test it. Able to see? Great. So you see how you will be able to access, right, or render basically static websites using storage buckets. It's very simple. Okay. Is it clear, everyone? So you understood we can use storage buckets two way. Okay. One way is to basically store files, folders, create backup, use it at your application level. Application level as in, let's say, for example, you have an application where a user is uploading the profile photo or uploading any post. All those things actually goes in this storage buckets, right? So those things, or if you want to render static websites, you can create a storage bucket, make it public, and render your static websites, right? So if now, let's say, for example, you'll say, hey, Aman, how can I get this to abc.com? That is to my domain. So what you do is, wherever you purchase your domain, in the DNS, you copy this URL and you paste it in the name server. So once you put it in the name server, it will render this websites, right? Is it come under serverless deployment? If we want error page, you can have an error page, 4 page. So you can basically configure that also. I'll tell you that error page. So you can actually click on that bucket, and in bucket, you can go and edit website configuration. So here you can give index page and you can give 404 page. So if that page does not exist, it will render this page. So again, yeah. So basically you just have to click on this three dots icon and then click on edit website. And here you'll get these two options. Got it? Great. So that if a page does not exist, it will go to this 404 page.html, right? Okay. So now you can go ahead and delete the break. Yeah. I'll give you guys. So now you can go ahead and delete the bucket, guys. I'll delete all the buckets. You can delete all the buckets, or you can delete the buckets that we created now. Okay. Deleted. Okay. And then we will continue with Cloud SQL. Okay. Now, what is a Cloud SQL? Cloud SQL is basically an cloud version of your SQL database. And there are three version or type of SQL database instance in a sense, nothing but a instance that GCP provides. One is MySQL flavor. Okay. Another one is PostgreSQL, or we call it as PSQL or PostgreSQL. Third one is SQL Server, right? So these are the three flavors of SQL database that we have ready-made out of the box that we can use in GCP's Cloud SQL. And this is a Cloud SQL instance, meaning it's an instance, it's a VM. In that VM, it will install MySQL, it will install PostgreSQL, it will install SQL Server and give you guys, right? But technically, you cannot go and access that VM, but you will be given the IP address and all to connect to this. You cannot access it, right? But in the backend, it's an instance, it's a VM, right? So shall we go ahead and try hands-on and create a Cloud SQL instance and see how we can connect, how we can secure our databases and all those things? Okay, fine. So let's go back to our GCP console, and on the top search panel, we will search for Cloud SQL. Okay, and click on SQL. So you'll be redirected to this page. Just click on Cloud SQL, SQL, and then you'll be redirected to this particular page. I hope everyone is in this page. Done? Everyone's on this page, guys. Please let me know. After clicking on Cloud SQL, everyone's on this particular page. Yes? Okay. So I'll click on Create Instance with free credits, and that's going to redirect to this particular page where it will give you option. Which flavor do you want? You want MySQL, you want PostgreSQL, or you need SQL Server, right? So given this option, you can simply say whatever version you want, right? Let's say, for example, I'll select MySQL. So it will click on MySQL. Okay. So once you're on this page, the first and the foremost option we'll fill is instance ID. That is nothing but instance name. So I'll say it as MySQL DB or MySQL instance. You can give any name, whatever you want, right? The name that you want, you can give here. Okay. Then you have to give here password. Now this password is basically your admin root user password, right? So I'm going to give password as admin, and make sure you remember what password you are giving, guys. And if you are not sure, then you also give it as admin. Everyone give it as admin. And again, I repeat, this password is for your root user. So every database will have a root user, and that root user password this is. Once you log into your database, you will log in as root user. So root user will have the password, that password you are generating here. So you can write anything, but for now I'll keep it simple admin. Okay, so you guys also can keep the same if you want. Okay, then you can come down and select database version. Let it be default, the latest version, right? It's fine. Let it be default, the latest version. Okay, then comes down, what kind of SQL edition do you need? Do you need an enterprise plus or do you need an enterprise, right? So I will select on enterprise because I don't need enterprise plus, because enterprise plus basically has more better SLA, it has more better speed and all that, which is good for production use case, actual use case. Because we are doing learning purpose, I'll select enterprise, the lowest version, so that it will be cost effective. It will be basically cheaper, right? Then after that, I will scroll down and click on this production. Okay. And here it will give what kind of instance you want. Do you want a production database instance? Do you want for development, or you want for sandbox? That is to run some quick POCs and run some quick tests. Okay. So yeah, I will select on sandbox because we are doing for learning purpose, right? If you select production, obviously you will have higher availability, you will have more virtual core CPUs, you will have higher RAM, but I'll select on sandbox for our learning purpose. Okay. So please go ahead and do that, guys. Select on enterprise and select on sandbox. So we'll get a smaller instance. Now you'll be like, hey, this is a database. Why will database have a RAM and storage? As I said, guys, very important. See this, it says MySQL instance, meaning at the backend, understand very carefully, guys. At the backend, it's a VM. Okay, when you create this service, it will go and install MySQL. MySQL is open source. It will install MySQL in this VM. And when you're trying to access MySQL, actually you're accessing MySQL in this VM, which has 10 GB storage, which has 8 GB RAM, which has 4 virtual core CPUs, right? So that's why this is called as a SQL instance, because it's in the end, it's a VM, right? But you cannot access this VM directly. You can just connect to this VM's MySQL, but you cannot access this VM like SSH and all that you can't do, right? So that's important. So that's why you will see these hard values like 8 GB RAM, 10 GB storage and so on, right? But yeah, you can go and change the storage, but RAM and this one will be fixed. Okay. Then region and availability, I'll keep it as it is. Okay. And then simply click on create instance. That's all we have to do. And then finally click on create instance, guys. So please go ahead and do it from your end. So it means if we talk about creating an instance, VM and SQLs are same. You should think that you're accessing MySQL, but internally GCP is giving you that MySQL by installing it in a VM and giving via VM. So from front end, you should not think like that. But how GCP is catering is via VM. But from front end, you think that it's a MySQL. You're accessing a database. Where is that database? It is in a VM, which is given by Google. It's Google headache. Yes, clear? Okay. Let's scroll down and then click on create instance. So that will create my instance. So give it some time, guys. Create it, or is it being shown in like this updated? Because it takes times to create. Wait, guys. So you guys are saying me that your SQL instance is created. Is it created or it is showing like this, guys, that instance is being updated? Like, are you getting tick or you're getting circle? It's been updated. Yeah, because ideally it takes 3 to 5 minutes, because it should create a VM. In that it should install MySQL, and then it will give you this success and you will be able to access that MySQL, right? So in the backend, it is doing a lot of process. Yeah, it is showing circle. Okay, that means it will take time. You have to wait. Ideally 3 to 5 minutes. Once it's done, then we will continue, right? How do you deploy this sandbox DB to prod? By selecting it as prod. So you'll get a different instance with different IP address. Use that for your prod instance. Put it in the prod environment variable. So you create another SQL instance and select it as prod version. The only difference is sandbox is a smaller version. Prod will be bigger version. That's all. Version in a sense, nothing but configuration. Instance will be same. Everything will be same. Only the configuration of VM will be better in prod. So create a new instance for prod and use that for your prod application by passing that in config map or environment variable. Okay. Yeah. There it is then successfully created. Yeah. Mine also created finally successfully. Right. Cool. Yes, done. Okay, cool. So now I'll tell you how you can connect to this database instance, right? To connect to this database instance, you can just scroll down a little bit and you see here, you will get here an option that says connect to this instance. Okay. Connect to this instance and then click on open Cloud Shell, and that will actually launch Cloud Shell where you can connect this DB. I'll explain you all these options that are there on the left hand side. Okay. So here on the top, you will see edit button. That is to edit some of the configuration of your database instance. Okay. Then you have import option. What does this import option do? You can import a .SQL file. What is a .SQL file? Which will have all the SQL commands, like right, creating a table, creating database, storing data in database table, right? All those commands will be in a .SQL file. Or you can do it in .csv also. So you can upload your entire data from .csv file format also, right? So that is your import option. Same way you have an export option. So if you want to dump your entire database into a SQL file, or you want to dump an entire table as a .csv file, that is your comma separated value. It will be like an Excel file. So you can either dump it as a .SQL or you can dump it as a CSV also, right? Then we have restart option. If you want to restart your database instance, we have stop and we have clone, right? So we have all these options. Then if you see in the home page or in overview page, so in overview page or tab, you will have all the configurations related to your instance, SQL instance, right? Like you'll have public IP address, you will have connection name, you'll have configurations like 10 GB, 8 GB memory, 2 virtual core CPUs, right? So these things, And then below that, you'll have service accounts, you'll have operation logs and all this, right? So these are the basic options. Okay. Then we have Cloud SQL Studio. So this is something new that they have launched where you can actually connect to your database from cloud itself. This is something new. Let's see what it is, guys. Even I have not used this, and it is new and bugged also. I cannot even select user. Root user is not supported. Oh, root user cannot access this. It's fine. Okay. Then we have System Insight, guys. So in System Insight, you will basically get observability, meaning basically how much CPU is utilized, how much of your CPU utilization percentage, how much of your disk is utilized, right? Out of 10 GB, then what is the pressure, what is utilization, how much bytes of data did you read or write, right? In and out, all those things, basically observability, all that monitoring dashboard, right? You will get basically monitoring features of a database. Then you have Query Insights. So Query Insights, as the name suggests, this is basically to get insight per query. So if you run a query, that query, how long it took to execute, how much bytes of data did it read, write, all that things you will get here. Okay. Then comes your connection. Okay. Under connection, you will get details related to what is your connection name, instance name, what is the public IP address. So using this public IP address, you can connect to this database through any programming languages, right? And then you'll have security related details. Then you have networking. So in networking, you have option whether you need a public IP address or you need a private IP address, whether you want to authorize it within a network. Meaning, if you want a specific organization, specific laptop to use this or specific computers to use this database, you can add that computer's IP address here, right? So if I add that computer or if I add the subnet of that network, let's say, for example, your office, let's say it's a Bangalore office or Mumbai office location. So Mumbai office, my office subnet, if I put here, internet subnet, so only via my office, once I'm in my office, connected to my office Wi-Fi, then only I can connect to this MySQL instance. So it's a very good level of security, right? So whatever is the IP address or subnet you give here, only that subnet or IP address will be able to access this instance, right? So generally what people do is a lot of company uses VPN, right? So VPN is also nothing but a public internet, but it's via routed. Okay. So they give the VPN IP address here or they give the VPN subnet here. So anyone in the company who connects to the VPN will be able to connect to this instance locally, right? So that is one level of security here where you can add an authorized network if you want. Okay. So these are three levels of network related security. One thing is making it private IP so that only through VPC you can access. Another way is adding a network, right? So that only that network can access this database. Then security. Okay. Then in security, we will scroll down and here we will see we have, okay, this option I'll do later, guys, security, because there is changes to be done. So this security option I'll do at the last. Okay. How to make your database super secured. Another level of security is by introducing certificates. Certificates will be like key files. It will download certificate files. Only through those certificate files you can connect to the database. No matter it's public, no matter it's private, no matter you are in the authorized network here, no matter what, but until unless you have this certificate file, you cannot connect to the database. Once you have access to the certificate files, only you will be able to access it, right? Then you have users here. What are these users? Are these GCP users? No, these are database users. So you will have something called as a DBA, right? Database access, where you will have users using your database, right? Now, not always you want to give root user. You don't want to access your database always at root, because in root, what happened, guys? You will have all permission, admin permission, right? So you can go and create a new account always. You can create a new account and you can change different permission by giving IAM roles, right? So you can change their permission, right? So you can create n number of user and you can give that username and password so that that user will be able to connect to the database using that username and password and not using root, because it's not a good case to generally give this root credentials, right? All right. After that, we have databases here. So under databases, we have these 4 databases schema. Now this database is not databases, these are database schemas here. Okay. So these are by default created by GCP. You can definitely go and create your database schemas like employees or your company, organization, whatever schemas you want, you can go ahead and do that, right? Then we have an option here to create a backup. You guys know technically what a backup is, right? That is to create a backup of your database. So you can go ahead and click on create backup and you can create a backup, right? Click on create button and it will create a backup, or you can schedule this backup also, right? So, and yeah, let's say for example, once you want to restore your backup, so you can just select the date, the backup that you want and click on restore. So that is going to restore. Okay. So that is going to restore your database to this particular version that it backed up, right? Then we have replicas. What is replicas? So let's assume there will be scenario where, okay, let's assume there will be scenario where you have your Cloud SQL instance, okay, and Cloud SQL instance, and this is your original instance, and there is your dev team which is doing the development concurrently. Okay. Now let's say for example, there is a HR team which wants to access this database to read some data. Now you don't want to give the access to this actual database. So what you will do is you will create a replica. Okay. You will create a replica. What is a replica? It will create an exact version of this SQL, what we have data, but it will only create a read only data. And this HR can access this. So technically whatever HR is doing that read operation, like reading the table, reading the data, it is doing from this SQL instance, not from the original one. It is doing from this replica, which is a read replica. So that is what this is, guys. You can create a read replica and that read replica can be used for other folks, or if you want to perform anything, right? You can use read replica so that you don't actually touch or play around with your actual SQL instances. Is it clear? Right? Operations, there's nothing to do with operations, right? So these are the options that we have in our Cloud SQL instance. So the backup option is only for backup, and restore provided by default by Google, right? Yeah, you can create a backup, and restore you can do it manually by clicking on this restore button. So you can create backup every day, and whichever version you want to go, just go and click on restore button here. So that will restore that particular version. But then once it restore, then your current version will be lost. So you better take backup of current version and then restore, so that if you want to again restore the latest version, then you do it. So if we have to use some other data solution backup software, then there must be configuration, right? You cannot actually take backup from different third-party software in your GCP. The only backup that is allowed by GCP itself. If you want to take the backup, then probably you will use their public IP address. You will give the password database, and then it will store in the third-party software. It will store, but it will not store in GCP. And I don't think so you can do restore from third party. Restore is only available from GCP's backup. So there is no point also if you go and do backup in third party backup solution, because there's no option here to take the restoration, right? Because on-prem our company uses just backup. Yeah, that's because on-prem, na, this is GCP. If GCP starts allowing third party this one, then there will be issue of security. Third party should be secured. They should come. They should abide by GCP's compliance and all that, right? And they said that we move to GCP, we will be able to use. I am not sure how, but still the work has not yet started on that. If they are able to do third party backup, that's great. Like create backup. I'm not sure how will be they able to do, or maybe the Chesty basically application might have tied up with Google to help do this backup. Not sure, yeah, because I've technically never done migration in this, so I'm not sure. But with the current system, what we are doing, there's only one way, that is what is being taken backup by here on GCP Cloud. Only that you can restore. I'm not sure about third party solution. My bad. AI powered data security. We secure and manage world's data, which is great. Product solution cloud. Backup and recovery. Okay, here we have backup and recovery. I'll go under products, solution, backup and recovery. Anyways, okay, fine, cool. And I can show you next how to secure this Cloud SQL database. So I told you, right, there is one way of securing your database, guys, that is going to connection, and in network you go and add a authorized network. So what you do is you add a CIDR range or you add a subnet. So only those IP address will be able to add this database or access this database. But if you want another level of security, that is with encryption, so there we use this security where we create a certificate files, and certificate files we will we will create client side certificate files. Client side means application or your third party software that you'll use, right? There how we can add this certificates, right? So for that we will be creating client certificate. So if you guys want to try this hands on, do it along with me. Click on connection, then after connection click on security, and then click on create client certificate, and I'll give the certificate name as test. So that will actually open up this pop-up. Okay, then look here carefully, guys. Once you have this pop-up, click on this download file, download this key, download this key, download this key. On the right hand side you'll have download button. Download all these 3 keys, guys, and below that you will have this command. Copy this command and put it in notepad. Copy this command and put it in notepad. Show the command again. Yes, I will show you. Give me 1 second. Yeah, so copy this command, this whole command, and paste it here in notepad. Okay, now how to come to this option, I'll tell again. Click on connection, then click on security, then scroll down and click on create client certificate. Once you click on create client certificate, then you will see this pop-up. In this pop-up, just click on this download button 3 times. There are 3 download. It will download 3 key files. Okay, and if you scroll down, you will get this command to connect to your database with this certificate files. So just copy that. Okay, you understood what you guys have to do, so please do that. Done? Okay. Okay, so now what you have to do, guys, so you will see you have these 3 key files downloaded: client key.pem, client certificate.pem, client ca.pem. So these 3 files will be deleted, downloaded, and you will have the MySQL connect command also. So this is the command to connect to your MySQL instance using certificate files, right? Okay, now once you do that, guys, scroll little bit up, and then here you will have manage SSL mode, correct? In the same tab security, you will have at the top managed SQL mode, SSL mode. So here it is saying allow unencrypted, but then you will say allow only or required trusted certificate, right? So you can select required trusted certificate, and that will restart your instance. That means from now on, you can only connect to this instance when you have client certificate, these 3 certificates that we downloaded. Without that, you cannot connect to this database itself. So it's like ultra level of security. But what is that security? These 3 files. These 3 files are important. You should not just go ahead and give anyone these 3 files. If anyone have access to these 3 files, all these 3 certificate files, he or she will be able to access it, right? So now it is your job to secure these 3 files, right? So yeah, please go ahead and select manage SSL mode and click on the third option that says require trusted client certificate, and it will ask you in pop-up and say restart. So yes, restart that instance. So it will restart. So it is restarting this instance, right? My instance is restarted, and see here, now it is selected this option that says require trusted client certificates. Yes, done. Okay, so now that this is done, what I want you guys to do is I want you guys to launch Cloud Shell, and we'll connect it via Cloud Shell. Okay, so now what we'll do, guys, let's actually we need to upload these 3 certificate files. Okay. So to upload the 3 certificate file, guys, do one thing. In your terminal, do you see this 3 dot icons or 3 more icons? You see this 3 dot icon that says more. So click on this 3 dot icon, then click on this option that says upload, and then select all these 3 files and select upload. So it will upload all these 3 files in your terminal. So you see, you will have client certificate.pem, client key.pem, you will have server ca.pem. All that you will have in your home directory. Please do it from your end. Also, let me know if you want me to repeat that steps or you're clear with that. Please do it. It will get uploaded within home directory, right? Yeah, it will be directed in your /home/user ID. In your user profile directory, it will be uploaded. Is it uploaded? Did you guys write ls, hit enter, and then verify? Yes. Okay. Now that you have these 3 files, guys, just write ls-la and hit enter, because I think it should have execute mode. Okay, let us verify once. Okay, I'm not sure if that execute mode is required right now or not. So just copy this command, guys, that you had to connect, and paste it here and try to see if you can connect to this database. I think no, it will not connect, because I think it requires execute permission. It's not connecting because it will not take usually this much of time. Hanging at enter password. Yeah, exactly. I think it's not working. That is because I think that is happening because chmod, I need to give execute, right? So it will be read and execute. So it will be 41467. No, 777 will give all permission. I don't want to give 777. 401, I think. Or so if I want to just give read and execute permission, the number will be, what would be the number? I forgot, yeah. It's been a long time. 400 or 401, because it's 4 to 1. So 4 will be there and 1 will be there. So it will be 401, I think, right? Or 400. Let me try with 401 star.pem. And then if I write ls-la, it is now only execute, read and execute. Yeah, I need it as read and execute. Oh, okay. No. I should say it as, my bad. 4 is read, 2 is write, 1 is execute. So it will be 5405. Yes. My bad. 405 and then hyphen ls-la, read, write, executes. Or I think let's give it 555, na? So if I give 555, it will have read and execute permission for everyone, even for user and guest user. Actually, we don't have to give for guest user. Yeah, I think 405 will work, guys. You can give 405. No need to give 555. 405. So this is the command you guys should hit to change the permission. chmod space 405 space star.pem, so that I'll change the permission of all the service certificate files. And then if I go ahead and try to connect and then give my password, hopefully, fingers crossed, it should work. It still hangs. Then I think we are missing something. Give me 1 second. Let me go back to network, add a network, add public network 0.0.0.0/0. Done. Save. Mine got connected without doing anything. Without doing editing, as in anything, as in you did not even add certificate files or anything, or you added certificate but without doing that chmod. No, the permission. Oh, without chmod it connected for you. Am I missing something? Required trusted client certificate. Yes, which I have given. Allow only connection using SSL, SSL. No. Network also I've gone and made it public. So anyone from public can connect. Whoever has trusted certificates, which is here. I'm not sure why. I think, have we missed some option? No, it's pretty straightforward. You're also facing? Okay, let me do one thing. For now, chmod 777 star.pem, just for safer side. No, I don't think so. It's 777. So read and execute permission is important. So that is clear. I have this permission. Yeah, how come you have option 3 selected? Okay, let me go back to chmod 400 star.pem ls minus la. So now I have only read permission. No, I think it will be 401. 401 will give me read this one. 411 I'll give then. 411. So 411 will basically give me read, execute, execute. I need read also. Let me say 555. I think I did 555, right? 555, which will give me read, execute, read, execute, read, execute permission. And then if I try to connect and give password admin, no, I think I'm missing something, guys. Something minute thing I'm missing, small thing I'm missing, which is authorized network is 0.0.0/0. Okay, this is for sure correct. In security, I have downloaded the key file and I'm using this key file, which is correct. It has 10 year of expiry. Yeah, everything is to connect. Okay, now it connects, guys. I think it is to do with networking then, I think. In networking, I have to go and add public in authorized network 0.0.0/0. Can you guys go and do that, guys? I think we have to even add authorized network where under networking tab. So on the top, we have security tab, correct? Click on networking tab, scroll down, add a new network tab, give the name as public and give 0.0.0/0. That means anyone from internet will connect to your database, plus they should have a certificate file. And then click on done. And then below you will get save button. So if you click on save button, it will restart your database. So please do that. Able to connect now? Great. So I think basically we had to add even a network to say that from anywhere internet they can add. So that was the thing missing. Okay, great. So now you understood, right? This is the most highest level of security you can have, guys. Why? Because to connect to your database, these 3 certificates are important. And if these 3 certificates are compromised, then gone. You cannot connect to this instance. Then what you should do? You should go back to security and download again a new certificate. Download new set of certificates. If old one is compromised, just go and delete old one and download a new one again by clicking on create, right? And this is the most or highest level of security you can have in your SQL instances. Is it clear, guys? So far, whatever we have done with respect to your Cloud SQL, is it clear? Very important. It's a Cloud SQL instance. So Google generate these SSL certificates for each data store. Yeah, it generates these certificates every time you click on it. Yes, for each of this. Now, can you guys think of any drawback? Like for Kafka also, it would be different. No, for Kafka, Google will not create and give you, right? You have to create your own certificate there. These certificates will be only created and managed by GCP for GCP services. Those certificates you have to manually create and configure it. Okay. Yeah. Now, I was talking about this. What do you think would be the disadvantages of using Cloud SQL instance? What do you think can be or will be disadvantage of using Cloud SQL instance? Public access? No. Only relational? No. How is only relational a disadvantage? Your SQL is relational. So if you're using SQL, that means you need is relational, right? Again, I'll stress, please understand the hint. What is disadvantage of Cloud SQL instance? I gave the hint in the words. Elasticity, somewhere close. Same for compute and storage. No. So I kept on stressing on the word instance. Instance related something. Yes. I kept on stressing the word instance. Instance means what, guys? In the back end, it is nothing but a VM. And if it is a VM, that means it has a fixed resources, right? So assume I am happy with the current resource. But if number of users, number of data increase, then what you do? Then you have to go manually edit it, manually increase the size of your database. But you can't keep doing that, right? Manually. It becomes a manual step. I'm talking about auto scaling. So auto scaling is not possible in your Cloud SQL instance. You have to manually go and upgrade it. There is no automatic auto scaling, right? Which is the biggest disadvantages. Why? Because again, as I said, it's an instance, single instance. So single instance means think it like one instance. So it can only cater up to some X amount of threshold, X amount of users, right? So that's why auto scaling is not possible in this Cloud SQL, right? Which in the next class we will do Cloud Spanner. So Cloud Spanner is basically auto scalable version of your Cloud SQL and serverless also. Does it make sense? Now, GCP storage service, we know very well that cloud storage is basically a bucket, more like a container, which will let you or allow you to upload or have any amount of files or folders, correct? And then we saw how we can use Google SQL for your relational databases, right? RDBMS. Cool. Now, what was one disadvantage that we spoke about Cloud SQL? Since we said, right, it's a Cloud SQL instance. So what is the disadvantage of having this? Auto scaling is not possible, right? Because it's an instance, it's a single instance. At the end, it's in the backend, it's a VM. You are using this as a database, but at the backend, it's a VM, right? So you cannot scale it globally. You cannot auto scale it, right? So that's where we use Cloud Spanner. Cloud Spanner is basically an RDBMS or a SQL database, but it is auto scalable version. Auto scalable, right? And also serverless. That means you don't have to pay for this instance 24/7 like how you pay in Cloud SQL, right? Here it is serverless plus it's auto scalable version. So it will scale at global level for your needs to fulfill your needs, right? So Cloud Spanner is nothing much. It's similar to your Cloud SQL, but at auto scalable version and serverless service also, correct? So if that's clear, then shall we go ahead and start with hands-on? Create a Cloud Spanner instance and see how we can use Cloud Spanner instance. Okay. So coming back to your GCP console, on the top, all you have to do is search for Spanner service, right? Just write Spanner and you will get the first service as Spanner, right? So just click on this Spanner and it will redirect you to this page where you will see welcome to Spanner. Cool. So there are two options, start free trial and create a provision instance. So we'll go ahead and create a provision instance so that we will know each and every options that are there manually also, right? So we'll say create a provision instance and then it's enabling the Spanner API and yeah, you'll be redirected to a page like this. Go ahead and click on create a provision instance. Okay. Then here you have to give the instance name. So I'm going to give the instance name as my-spanner, something like that, right? So that is my instance name. This will be my instance name. Okay. Once you give this, then click on continue. Then it will take you to the next page or the next step where you configure which location you want. Do you want it in single region or you want multi-region? So I'm going to keep it single regional, guys, because of pricing and learning purpose. But in real time, you will keep it as multi-regional. Okay. So I'll keep it single region and I'll select one with lowest carbon emission, US Central one, best location, right? So go ahead and select the configuration, guys, location of the instance. Once this is done, then you can simply click on continue. That will take to this third step, right? So what is this configure capacity here, right? What does a capacity here means? So capacity is nothing but how much of data throughput you need, right? So that is nothing but queries per second. How many SQL queries that you will be running per second, right? So you can either select by node. A one node can have thousands of query runnings per second, or you can have processing units. That's nothing but you will have your queries per second, right? So you can either give by nodes or processing unit. It's one at the same. One node is equivalent to 1000 processing units. That is thousands queries per second, right? So yeah. So you can give either node, like you can give up to like, let's say 10 nodes. That means you can have up to 10 into 1000. You can have up to 10,000 queries running per second. That is the level of auto scaling you can do, right? But for this one, we will keep it one itself for our learning purpose. Now there is another thing also called as auto scaling here option. So in auto scaling, what happens? This is manual allocation where manually it is fixed. But if you select auto scaling, In auto scaling, you will get this option where minimum how many nodes, maximum how many nodes, and what will be your target utilization. So if 65% of my CPU is utilized, it will quickly spin up another node. Or if 95% of my storage is utilized, then it will spin up another node, right? So you can specify this auto scaling parameter, right? So this is the advantage of your cloud spanner, where you will have this auto scaling options. So I'll keep it as minimum 1, maximum I'll keep it as 2, because anyways we are doing it for learning purpose, right? Or even if you keep it as manual allocation, it's fine, as long as you understood the options and setting. That's all we need, right? So I'm gonna just go and click on create. So that will create my cloud spanner instance. Okay, so once you're on this instance, guys, or once you have this instance created, if you scroll down below, you'll get this option that says create database, right? So what is this create database? This is basically your database schema. Right now we created a spanner instance, right? Within the spanner instance, we're going to go ahead and create a database schema. So if you scroll down a little bit, you'll get this button that says create database, right? So I'll click on that create database button, and I'm going to say, let's say the database name would be, for example, employee. So I'll give the database name as employee. That is a database schema name. And then it will give you an option here. Do you want SQL, SQL, or do you want PostgreSQL? These are the two databases that they allow, right? So let's say, for example, I'll select standard SQL itself. And from DDL templates, or let me go ahead and write create table command, right? So I'm going to say create table, create table users. Then I'm going to say ID int primary key, and then I'm going to say name string, right? So yeah, just go ahead and create table schema, this column type. Here the syntax is little different, guys, a little different. Okay, let me say if I put it as employee dot users, and let's say if I say ID, oh, it's integer, by the way, it's not int 64, and then primary key I'll say ID, and here I'm going to say name as string, right? Why is it giving me this error here? Unexpected. Cool. So the SQL syntax is little different, guys, here, because it's a Google standard SQL. It's managed by Google, the SQL, this one. So that's why it's little different, because in normal SQL or MySQL, what you'll do, you'll generally put it as varchar, you'll have int. Here we are using string, right? So it's a little different. So yeah. Now, why am I writing this table? Is it compulsory to write this table? No. If you don't write anything, if you basically keep this empty also, you will be able to create this schema. It's just that in this schema, I'm just creating a dummy table, right? So if you want, you can write queries here and click create. But if you don't want, you can just remove it. Later, you can go and write queries. Okay. You will have editor where you can go and write queries and create tables inside this database schema called employee, right? Just write that query and then click on create. So this is going to create a database schema. Unsupported statement. Did I miss anything? Do one thing. I'm just going to remove it. Why I'm taking so much tension for this? Later, I'll go and create a table, because the syntax is little different than we use in standard SQL, right? Cool. So here you see, I see employees database created here. That's nothing but database schema. Okay. Now that we have the database created here, inside this database, we will be creating a table. So I'll scroll down and it will give me here create table, right? So I'm going to click on create table, and yeah, let's go ahead and create a table now. Schema would be employee, and my table name would be users. Column name, I'm just gonna give it as name. Column type, I'm going to give it as string of 50 characters, and I don't need any primary key. That's all. Won't it allow me to create a table without a primary key? Oh my God. Okay, let me say name itself as primary key. Primary key. And I'm going to put name itself as my primary key. Cool. Then I'll say run selected. And that statement is getting executed. Unsupported statement. What is freaking wrong with this? Okay, I think let's not worry about creating tables and writing SQL queries, guys. Most important part is here how to create your spanner instance, right? Let's forget about tables and all. That's also anyways out of our scope. It's little tricky because it's little different than our normal MySQL what we write query, right? So it's a little tricky, but yeah, once you are used to writing the query in GCP Spanner, yeah, it will be easy for you guys. So let's not worry about the queries, guys. That's anyways out of our scope currently. But any doubt with respect to Spanner and creating of Spanner instance, you see how easy it is, right? Did we configure anything related to disk, anything related to computation? Nothing, right? Compared to Cloud SQL. In Cloud SQL, we did a lot of configuration, correct? So those configuration, those things, everything is actually reduced here, right? Okay, cool. So let's go ahead and delete this instance, guys. So I'll click on my instances. And when I click on my instances, I'll come back to Cloud Spanner page. Okay. And in this Cloud Spanner page, I'm just going to select my Cloud Spanner and I'm going to say, okay, it's not giving me delete permission. So probably I'll click on this spanner, go inside my spanner. Once I'm inside my spanner, then I'm going to say delete instance. So I'm going to delete my spanner instance. So we are done with Cloud Spanner also. Before we start with data store or Firestore, go ahead and clean up your Cloud Spanner instance. Cool. Just imagine what will be the use case where you might want millions of users using your websites. If you're building application where you are having millions of users, be it e-commerce, be it even a gaming website, anything. Yes, example use cases where you want millions of users using it, then you will use Spanner. Be it any application, be it anything, your use case is basically your auto scaling here, right? It's the load that we are talking about, because both Cloud SQL Spanner does the same job. It stores your data in RDBMS. The difference is for millions of users, the scale is what makes it difference. Okay, cool. So are we good to start with our data store or Firestore, guys? So data store was initially the name. Now also it's called as Firestore, right? Now, so far we have kept on talking about SQL database. So you know what is SQL database, right? It has a relational database. That means it has relationship, it has entities. It's basically a defined database, fixed database. There are also something called as NoSQL database, which is a no standard structured query language, right? So NoSQL database doesn't have any relationship, doesn't have any fixed structure. Like your relational database, you'll have a fixed table structure, right? Whereas in NoSQL database, there ain't any fixed structure. Then how do we store the data? We store it in a document type or entity type. That is, it will be like your JSON. How like your JSON? So I can have one record which has only name and value as Aman. Then I can have another record here which can have name, and also let's say for example it can have age, right? So this is an example of not having a fixed structure, where you see one record has some x key value pairs, other records will have other key value pairs, and there is no relationship here, right? Like how in SQL database we have relationship, we have primary key, we have foreign key, we have unique keys. Such things are not provided here, right? There's no relationship basically between one table to other table. In NoSQL there is no such relationship, right? And in GCP, one of your NoSQL database is your data store or Firestore. Data store was the older name, now it's called as Firestore. It's deprecated. Okay, So Firestore or data store is your NoSQL database in GCP. And it's serverless also, meaning you don't have to worry about the storage. You don't have to worry about the compute. Everything will be provided by GCP. All you have to do is very simply write the code to push data into your Firestore or data store or read it from there, right? So that simple it is. So shall we go ahead and see how we can load or store data from data store? We'll do it from UI because anyways, development is not part of our scope, right? So we'll do it from UI. We'll see how we can add and get data from UI, right? So coming back to your page, just search for Firestore. Just search for Firestore, and here you will get serverless NoSQL document DB, which is a NoSQL and serverless version of your document DB, right? So just click on Firestore. Firestore API is not enabled. Are you guys also getting this? Then just go at the top and refresh it. Okay. So let's go ahead and create a database. Okay. So just go ahead and click on create database, guys. Okay. And then let it be in native mode. Native mode is for your all use case, right? Whether it's service, mobile apps, or web application, right? So let it be native mode itself. Then click on continue. Okay. Then let's give the database ID as test Firestore DB. Yeah, I have the name. So give some name like this, test Firestore DB. Give some name like this. Is it done? Then select region, guys. So region, I'm going to keep it single region itself because of, yes, costing region. But yeah, make sure you guys select random region, guys. Don't need to select the region that I want, right? I have selected US Central 1. You can select whichever region you want, which is our closest to you. Okay. And then if you scroll down a little bit, there are two rules, production rules and test rules. So in production rule, that means you're creating this database for production. In production, you know that they should not give write permission, only read permission and all, right? So that your production data never gets deleted by mistakenly also, right? So that is that production rule where they have given saying that, only allow read, write it is if false, right? So your write permission will be set as false. Whereas I will select it as test rules. Test rules, I'll be able to do read, write, everything. Okay. So I'll select it as test rules and then scroll down and then click on create database. So that will create my test Firestore DB. Okay. Then click on start collection. So in start collection is where you can actually add your data. So each record is like a document. Document is nothing but your JSON structure, right? So collection ID, it will, let's say, for example, I'm adding users data inside this, right? So I'm going to add users. Document ID, it is going to auto generate. And then I'm going to say name and value. I'm going to say Aman. And I'll click on save. So in my users, that collection ID is nothing but think it like a table, guys. Technically, table is not a good name to tell, but a collection is which will have collection of documents here, right? So user is a collection. Inside user, I have a document. This document has a unique ID to identify this document, right? And for this document, see here, I have name as Aman as a value. Then I can add one more document to this, right? I can say name. Let's say, for example, I'm going to say allies. And then let's say, for example, I'm going to say country as, let's say, for example, India. So this is the advantage of NoSQL database, guys. See here, in the same user collection, one record, I have only name as Aman. Another record, I have name also, and I have a new property also, key value pair, country India, right? So this is the advantage of NoSQL database, where if you have basically like this need of changing and there's no relationship in your data, so you can use NoSQL database also, right? Just imagine, guys, how easy it is, right? And we are doing it from UI, guys. But let's say, for example, you would say, how would I do it from programming languages? So that is also there, right? You say Firestore, Google SDK documentation, right? So in all the programming languages you will have, so they support, let's say in Python, You will have source code, right? API references in Java, Node.js, Go language, in which they'll give you the library, they'll give you sample data library and sample code, right? Through this code, you will be able to see here, you will be able to add record, get record, you will be able to add, you will be able to do a lot of things, right? It's exactly similar to MongoDB because it's a NoSQL database, right? MongoDB is also a NoSQL database. Cassandra is also same like that. All NoSQL database will look same, right? Like how all the SQL database looks alike, same way NoSQL database will look alike, right? So here we are actually adding these documents via UI, guys. But technically in programming, in actual use case, what you'll do is in Java, Python, Node.js, Go language, they have their own library. Google has their own library. Using that library, you will be able to connect to this particular instance using your service account, and you will be able to add records. You'll be able to delete records, update records. That is, documents. You'll be able to perform those operation also. Field is nothing but a, think it like a record, right? A property, like name is a field here, value is alias, right? Same way, country is a field here, value is India. So that is basically a field. So if I want to add a new here field, let's say for example age, and I'll put value as number, and let's say if I put age as 10, so see here a new property is added, right? So that is a field. Data type is nothing but what type of data it will be stored in that field, right? Like, are you storing a string value, number value? Are you storing true, false? Are you storing any location, geo point? Are you storing a time, right? So that it will tell basically what type of data you are storing here, right? Okay. So let's go back one step. That is, I'll click on all databases, and then I'm going to click on this 3 dots of test firestore DB and delete this test firestore DB. Okay, cool. Okay, fine. So I hope we are clear with the cloud storage, cloud SQL, cloud planner, and even firestore DB, right? Now we'll do the last part of cloud storage, that is BigQuery. Okay. Now BigQuery is, it doesn't come under your database, it comes under big data, because as the name itself says, BigQuery, right? So if you have massive amount of data, it's like your data lake, right? Where you can dump massive amount of data and then query and read the data, right? So this BigQuery service, we'll see how this will be used as a data lake and how we can dump massive amount of raw data and then how we can query on top of it, right? So going back to the screen, I'm going to search for BigQuery. And then, yeah, it'll take me to this BigQuery page. Click on BigQuery and land to this particular page. Okay. So here, if you look carefully, guys, in BigQuery, you will have project ID here. This top footing, something will be written here, right? You'll see it will be written here. That is nothing but your project ID. Okay. And in that project ID, we will be creating something called as a data set. What is a data set? A data set, think it like a database schema, right? Like a container. Inside it, you will have multiple tables created, right? So click on this 3 dot icon in your project ID. Against your project ID, click on this 3 dot icon. Then click on create data set and give a data set name here. So let's say, for example, I'll say data set name as raw underscore data, something like this. And I'll select single region, which I'm going to randomly select US Central again. Give a dataset name, that is dataset ID, and select it as single region. Okay. Then if you scroll down a little bit, you will see this option that says enable table expiration, right? Now in table expiration, if you want to, let's say for example, you're creating this data set for temporary reason, like I just want it for 1 or 2 days where I want to store some temporary data, and after that I don't want the data, right? So you can enable temporary table expiration where you can mention in number of days here. Okay. That means if I put here, for example, 10 days. So if I create any table inside this database, or sorry, data set, if I create any, if I create any table inside this data set, it will be there till 10 days. After 10 days, it will expire and it will delete. So that is your expiration table option, but which we will disable it. Okay, we don't need that expiration. And then you can simply click on create data set. So that will create a data set here called as raw data. You would see here, we have raw data set created here. Now inside this data set, you can click on this 3-dot icon and click on create table. So now I'm going to create table inside this data set, right? And let's go ahead and upload a table. Okay, so how can I create a table, or from where can I get the table data? So I can create or get the table data basically from these sources. I can have data stored in a file that will be there in Google Cloud Storage, or I can upload it manually, or I can select it from Google Drive. I can even select Google Big Table, Amazon S3, or Azure Blob, right? So for now, I'll select upload so that I'll upload it from system, right? And then we have to select the file. So file, let me do one thing. Let me say customer.csv. Let's download it from GitHub, right? Customers.csv. Okay. Just pay attention, guys. After opening that link, you will get here a download raw file. You will get this download button, right? So just download this file, customer.csv. So let's say that, let's assume that my raw data of my company or my product or what application is this, and we'll see how we can load this massive amount of data. I mean, for us, it's a small data, but let's assume this is a massive amount of data. How I can upload this massive amount of data in BigQuery, right? Okay. So now I can go and select that file here. So I'll go and select that file. So it will automatically understand that, see here, it's a CSV file. And table name, I will give the table name as customers, right? Okay. So after that, if you scroll down, the next important thing is, guys, schema here. Why schema is important? In schema, you can manually go and you can say each column, right? Each column, what is the column name, like this? What type of data it is storing? Can it be null or not, right? But there is a caveat here. I have only 4 or 5 columns, which is good. What if in real scenarios, I have 500 columns, I have 600 columns in my database? Then, or if I have 700 columns, you can't just go and manually 700 columns, go and do this manually, right? So in such cases, what you will do, you will check on this box that says auto detect, right? So what will this auto detect do? It will analyze your data. It will get all the columns. It will analyze each, column wise data and see what type of data it stores, and it will set the data type, right? And then you can simply click on create table, guys, after selecting on auto detect. It has special character, guys. That's why annual income K dollar is a special character. That's why. So let's do one thing now, guys. Just open this customer.csv notepad. Open it in notepad and just remove this dollar symbol, guys, or remove all these brackets. Don't keep any special characters and save it. Do one thing, update the data. It's happening because of special character. So just open your customer.csv in a notepad and remove from the top heading, remove any brackets and all that, right? Once it's updated your customer.csv, then go ahead and select that customer.csv again, and then click on create table. Probably then it won't give that error. Okay. So what we have done here technically is, guys, we created a data set. In that we created a table, right? Now this table, you might say, hey Aman, this looks like a relational database, right? Because in SQL, what happened, guys? You have like this relation, you have tables, correct? But very importantly, guys, BigQuery is not an RDBMS. When do you call an RDBMS? When do you call it as a relational database? When there is relationship between two tables, right? You will have foreign keys, you will have primary keys, you will have foreign keys, you will have unique keys, you will have all this constraint, right? You will have relationship like one-to-one mapping, one-to-many mapping, right? So this relationship is what makes a database RDBMS. Whereas in BigQuery, think it just like it's a table dump, that's all. Here, there is no concept of primary key. There is no concept of your foreign key. There is no concept of unique key. It's just that you're dumping your data in table format. That's all. You cannot even update a single record, right? You cannot even go and delete a single record. You cannot do any alteration. You can just keep on dumping data in this. That's why it's called as a data lake. Because in data lake, what happens? You just keep on dumping data and then use your data to process it, clean it, right? And then use it in data warehouse, where in data warehouse, you'll have processed data, correct? So your BigQuery is like a data lake, where all you do is simply just dump in the data. Whatever massive amount of data you have, you keep dumping in. That's all, right? So once you dump it, then you can write SQL queries to process your data, right? For example, let's say, for example, I'll take gender here. Okay, gender will have two values, males and females. So let's say I want to filter my raw data. Let's say this is my raw data. In this raw data, I want to filter and create a table where I have gender as male and create another table where I have gender as female, right? So this customers is my raw table. Now, how can I extract clean data or only the data that I need, right? So that I can use that further in my application or for any purpose that I need, right? So that's what we are going to see now, how we can query and create another table out of a query in BigQuery, right? But I hope it is very clear, guys, right? That in BigQuery, BigQuery is not a relational database, because there's no concept of primary key, foreign key, no concept of one-to-one mapping, one-to-many mapping. There is nothing as such. So that's why it is not called a relational database. Though it looks like your data is in table structure, looks like a table, but it's just a table dump. It is not a relational database. I hope that is clear, right? Very importantly, it's a data lake. You just dump data here. Massive amount of data will be dumped here. That's the whole purpose of BigQuery. Okay. Now, let's say, for example, I want to create a customer's mail table where all the males I will have, and I'll have customer female table. I want to create two different tables. And let's say that is my derived table after pre-processing or after post-processing. So in such cases, I will click on here. On the top, you guys will see a plus icon here, right? So just click on this plus icon here, plus SQL query. That will actually open up a new query editor. And then I'll write here, select, or do one thing, guys, don't even do that. Actually, I want to show you something. I just close this editor. I will show you something. I want to actually show something else also. Okay. Now do one thing, come back to this customer tab. Okay. And in customer tab here itself, you will have query, right? So click on query and say new tab. So that will technically do the same thing, but it will autofill the query. I repeat again, go back to your customers tab where you'll have this customers data that you're seeing in. Then on the top, you will see query, right? Click on query and click on in new tab. So you will have it in new tab here. And now imagine Google being a $1 trillion company, multi-billion dollar company. They have millions and millions in profit. They have amazing, amount of developers skills. Yet why did they have and not fixing a bug in SQL query? Do you think this query is correct? Select from your project dot this one limit 1000. Do you think this is correct? In fact, you yourself will see it is giving syntax error, right? It's not correct. Why? Because there is a star missing. Now you tell me, guys, Google being Google, why would they let this bug be there for ages? Why aren't they fixing this? I mean, just a star they missed. Why couldn't they complete the query? Huge volume of data depends on respective client. So guys, this is BigQuery. I said, right, it's a data lake. Here you will have massive amount of data, hundreds of GBs, hundreds of TBs, hundreds of petabytes, right? So if you write query and if they give you 100% correct query like this, and by mistake a new person or someone just goes and run this, so in BigQuery you are paying GCP based on amount of data you have queried. So if I write select star from this one just for testing purpose and it actually loads, let's say 20 GB data, So I'm going to pay for the 20 GB data, right? So that's why they have done two things. Purposely, they have done a mistake here so that even if someone goes and run, it will never run. It will give an error. Second thing is they have purposely put this limit as 1000 so that even if you go and quickly hit on run, right? Even if you go and quickly hit on run, it will only limit to 1000 rows. So even if you have 100 GB data, it will only return 1000 rows, which is like 1 MB, 2 MB, right? So in that way, just if for testing purpose, you don't have to pay in dollars, right? So that's why they have done two things, guys. Purposely, they have done this mistake. And second thing is purposely they have added this limit 1000. Okay. So go ahead and now run this query and then you will see the result. Now let's remove limit 1000 and set select star from this where I'll say gender equals to male, where gender equals to male. So I'll only get records where gender is male. And you see, I get 88 records, right? So rephrase your query and run it again. Now, let's say, for example, this is my result. What can I do? So if you see on the top, I can save this. I can save this as a query also, because sometimes what happens, your query will not be as simple as select star. It will be like 15, 20 lines of queries also, right? Sometimes you write such big queries also, right? So in that those big queries, you can even save the query. So the query will be saved here on the left hand side. You see this query tab here, right? You see this query. So under this query, you will have that shared or you will have the saved queries. So you can save a query so that you can frequently come and run it. Okay. Second thing, what you can do is, guys, you can even save the result. So here you see, I got this result, right? This table result. So I can save this result here. How can I save this result? I can either download it or I can download it in Google Drive. I can download it locally as a CSV JSON, or I can even save it as a BigQuery table. That means it will create a new table out of it, right? So in BigQuery table, I will give which data set. And let's say, for example, I'll give the table name as customer_male. So here I have segregated all the males customer, and then, oh, it's giving failed. Why is it giving failed? Let's see. BigQuery table. I'm gonna say male_customers. Wait, why is it saying failed? Let me refresh this. Why am I not able to save the result? Why is it giving, oops, yeah, no, don't save it as sheet. Save it as BigQuery table. Select this, select it as table under table 2, or let me say it as male customers. I don't know why it's giving error. Is it because of data or is it because of something? I'm not sure. Let me say, okay, limit 10. Okay. I run this query. Then if I try to save this as sample, that is also failing. I think it is something to do with our data, guys. We just randomly selected some shady data. It's not even properly formatted. I think something issue with our data. Anyways, but I hope, I mean, it's clear, right? What we use this BigQuery for, right? So you generally load raw data, then you write here queries to clean your data, process your data, and then you save that data into either a BigQuery table or you save the query itself, right? So once you save it as a new table, BigQuery table, then here we will have a table called as customer_male, where I will have all the male customers, right? Then I can have another table, customer_female. So you understand, right, what I'm trying to say? From raw data, you can have processed data saved as another table so that you can simply load that table and directly read data out of that table, right? So not just loading data, raw data, you can in fact clean them by writing these SQL queries and then save the cleaned data as a table so that you can further utilize it. Okay, so let's go ahead and delete this, right? So on the left hand side, you'll have this 3 dot icons, right? So just click on this 3 dot icons and click on delete. So that will go and delete this table first. So delete the table first and then delete the raw data. So it's cleaned up. Oh, it was because of column name, guys. See this? I knew it, right? Something was wrong with respect to data. Because of annual income does not support table copy. It was because of column name annual income, guys. That's why it did not copy properly. Anyways, it's fine. No worries. Okay. So let's go back to our welcome screen. So that winds up our GCP storage service, right? So we have completed cloud storage, cloud SQL, cloud spanner, data store, firestore, and even BigQuery also, right? So that brings us to an end of storage services. Now we will start with GCP's logging and monitoring systems, right? So we will see how to read logs in GCP, how we generate logs, where do we get logs, how do we create monitoring dashboard in GCP, right? For our application, all of that we will be looking at. Okay. So first, let's start with GCP logging services, right? So in logging services, where do I go and check logs? Where can I create alerts, right? How can I know this in GCP? So in GCP, there is a separate service itself called as logging service, right? So on the top search panel, just search for logging or write logging and you will get logging and log explorer both, right? So just click on any one of this. Let's click on logging first. Okay. So just search or type logging on the top and click on logging. So that will redirect to this particular page. Okay. So here, if you see, guys, on the left hand side, you'll see resource type. Resource type is nothing but what service. And then you'll see severity, right? Whether it is a normal, logging or was there any error, right? So if you click on a particular, this one, let's say, for example, I'll click on BigQuery. So now my logs will be filtered and I will only get logs related to BigQuery. Because in GCP, there can be scenarios where you will be using multiple services, right? Maybe you have a Cloud SQL instance, maybe you have virtual machine, maybe you're using Kubernetes, right? So all of that logs will be flooded here. All these logs will be flooded here and you will be interested in one particular log, right? Like for example, now I'm trying to debug why my BigQuery is not working. So in such scenarios, you will have all this on the left hand side. You can click on that resource, which log you want to display so that it will be furthermore neater. And apart from that, again, I'm looking for the error, right? So I don't need information or notice. I will click on this below filter that says error. So that will then what it will do, it will only give me the errors, right? So it will further clean down, narrow down, filter down my logs. And then from here, I can see it is BigQuery logs, right? I can even see which user has performed these operations. Here it says GCP Intellipaat @gmail.com, right? So user will have their email address, right, in organization. So this will even add as an audit where you know who was performing this operation and it whether passed, failed, or whatever it is, right? So if you expand this, you will be able to understand expected keyword where at. So there was some query error. So we did some mistake in query. Then here it says, while we were actually copying a table, that copying did not work because of column name, right? So you will get the logs here in detail to understand what happened, right? So you can then understand and learn that, okay, why did it fail or what is the reason for its failing, right? So that's what you come and do here in logging service. So whatever filter you have selected here, you see at the top, it actually writes that query for us, right? And you can then later download even this, right? So here you have option where you'll be able to download. I think here, right? So see here, I'll be able to download this log even as a JSON file or as a CSV file with maximum log entry, right? So it's going to download this log file. So if you want to save it locally for, let's say, audit purpose, or you want to share someone these logs, so you can download these logs also and you can share, right? Plus you can even filter logs based on timeline like this. So you can change the timeline and you can say run query. That means give me only the logs that are ran between these two particular time frame, right? because you will keep getting this log and you want log of last 10 minutes. So you'll just come and update this, for last 10 minutes, right? Right now it's 10 o'clock. So I'll put this from 10 o'clock to 9:50 and then click on run query. So it will only give me the logs that is ran between 9:50 p.m. to right now 10 p.m., right? Between my time frame intervals, right? So yeah, this is also the advantage of using this, right? You can basically even have time, time frame interval. You can have resources here. You can have severity. So based on this, you can actually filter out and you can see the logs. Okay, fine. So on the left hand side, if you scroll a little bit, you will see some service like alert, error reporting, right? So what are these things? So let's look at these couple of them. Again, I won't be doing all of them, guys. Okay, I'll only do a couple of them which are like important and we use it. So here you will see alert, okay, or alerting. So in alerting, what happens? You can create like a trigger, right? You can create like a trigger, or you can create like a policy. And if that occurs, then it will send you a notification, right? Like for example, if there is any error related to my BigQuery or any error related to my Kubernetes, it should send me an alert. Because let's assume this is a production, and in production there shouldn't be any errors, or if there should anything, then there should be a high alert, right? So for example, I can go ahead and create a policy here, right? In policy, I can set up a metric. Like for example, BigQuery database. If I'm saying, let's say for example, if anyone has read or anyone has queried a lot of data, like for example, we have, terabytes of data, and if someone has loaded this massive amount of data, then it should send a alert. Or let's say for example, virtual machine itself you take, right? Or storage bucket or Kubernetes, right? So if someone actually, if my throughput of my Kubernetes, that is, if basically my load of the Kubernetes is increased, then it should send me a trigger, an email or notification, right? Or any other GCP service, you can do that, right? So for now, for example, if I'm going to set it as compute, I think compute I'll not get, because compute, I don't have any logs currently for compute. So let me keep it as dataset itself, right? So I'm going to say BigQuery, and BigQuery, what I'm going to give filter as add filter, and I'm going to say, okay, not filter, BigQuery here. In BigQuery, I have selected under BigQuery log byte or log entries. Let us select log entries. If someone tries to insert more than, let's say, 1,000 records, it should send an alert saying someone has, inserted more than 1,000 records, something like that, right? So I'm gonna select BigQuery's log entry, then scroll down a little bit. 5 minutes is a rolling window. That means every 5 minutes it will check for this one. Then I'll click on next. Then after clicking on next, I will select threshold value. Threshold value would be, let's say for example, 1,000. So if anyone inserts more than 1,000 records, so currently you see, currently we have, according to this line, currently we have very less amount of data. Okay, so from very less amount of data, I have created a threshold as 1,000. So if anyone tries to insert more than thousands of records, it's going to send me a trigger, right? So I'll click on next, then I will select notification channel. So I will create a notification channel, whether should I send that trigger or should I send that alert via Google Chat or using pager or to Slack or via email or via SMS. I have to go and add those, right? So all of this, I'm not going to explain, all these are out of the context, but know that you can use such channels for sending notifications, right? So let's say for example, if you want to create for GKE, currently because I don't have GKE, I won't be able to see all GKE related metrics, right? But let's say for example, here I'm seeing only throughput here, because I don't have any GCP currently live. If you have any GCP service, then you will be able to sell, you would be able to select metric like CPU utilization, GPU, storage utilization or course utilizations, right? Or number of nodes. So you will be able to select that. After selecting it, let's say for example, you want to add a filter that only one particular namespace you want, then you will add a filter there. So in filter, you will say the project ID, or you will specify your cluster name, or you will specify that node name, so that only for that cluster, only that node, it will create a alert, right? We use these filter options to further filter your alert to one specific resource. Even inside a resource, one specific resource can be done using these filters. So first and second is cleared. Third, I'll be doing next. Once I complete this alerting and all, I will show how we build a dashboard in GCP. Okay, fine. So we are not going to actually create alerts, guys, but yeah, I was just making sure you guys know how we do it and where do we do it, because there's a lot of configurations here, like you have to do your SMS configuration, email configuration and all that, right? Which is out of our scope. So yeah. Then we have something known as error reporting. So in error reporting, what happens if there is any error, right, that is being reported, where reported from GCP service, it will be here. Like say for example, it failed some HTTP, it gave some service error, then it gave some volume error, volume setup error, right? So these error are currently there in my GCP service, but you won't have it technically because we went and we deleted our Kubernetes, right, cluster. But let's assume if my Kubernetes cluster was there, then I will see here in error reporting that, okay, these two error was found in my Kubernetes. So I'll go fix it. After fixing it, I can change the state here, so that people will know that these issues or these bugs are resolved at your GCP level, which you have to do it as a cloud engineer, cloud admin, whoever, right? You will be doing this, where you will come here in error reporting, see what are the current errors in my GCP projects, and go ahead and fix that. After fixing it, change the resolution, right, to acknowledge, resolved, and so on. Is it clear, guys? Alerting, error reporting. Can we proceed to the next topic, that is dashboard, and see how we can create a custom dashboard in GCP, monitoring dashboard. So now on the left hand side, you guys will see this dashboard in the second option, right? On the top second option, you will see dashboard. So this is nothing but a monitoring dashboard, like how there are third party tools you use like Grafana, right? Or you use other Prometheus, Grafanas and all, right? For logging data, for creating dashboard. Same way, Google has its own dashboard service called as dashboard. So Google has its own dashboard service, right? Now in this dashboard, if you see, guys, if you click on these are inbuilt, or these are default created dashboard for each service. For example, there is this App Engine dashboard, which is created by Google to monitor App Engine. Okay. Then let's say, for example, they have log dashboard in GCP created to just monitor logs, right? So all I'm trying to say is Google has some default, dashboards created here. Okay. But you don't want this default dashboard, because these default dashboards are service specific, meaning it is for like App Engine, it is for Firewall, it will be for Kubernetes, it will be for storage bucket. But what if I want application level, meaning one Cloud SQL, one Kubernetes, and storage bucket? All of these three is used at my application to build one application. So that application level, I want to see all the metrics used in these services, not one by one service. I don't want one dashboard to only monitor my storage of my application. I don't want one monitoring dashboard to only monitor my Kubernetes, right? So I want all of these three mixed in single dashboard for my application, right? So that's where we will create our custom dashboard. How I can create my custom dashboard? So on the top, you will see this button that says create dashboard, right? So I'm going to click on that create dashboard button, and that is going to see here, take me to this page where I'll be creating a new dashboard. I'll be adding a widget, right? Click on that create dashboard button. Okay. So here I can click on this new dashboard. So on the top, you will see this new dashboard word here, right? So I can click on this dashboard and I can rename this dashboard to my custom dashboard or something like that. You can give any name you want. So you can give any name you want. Here I've given the name of this dashboard as custom dashboard. You can give your application name, Amazon -dashboard or Amazon Prime -dashboard, like that, right? Based on your application that you're building, you can create that dashboard, right? Then after naming the dashboard, on the right hand side to that name itself, you have this button at the top that says add widget. A widget here is nothing but it's an UI element here. You can add a metric, you can add a log, you can add basically alert graph, you can add line charts, you can add errors, you can add heat map, visualizations, you can add layouts, right? You can add like drop down option, you can add like headers, you can add like text, right? So all of these things you can add. So for example, I will click on text. So a text widget will be added where it will say it is in markdown what it should display. So I'm going to say it should display my ABC application dashboard, right? So I'll give this heading ABC application dashboard, and I will give the widget title as heading or header and click on apply. So see, this will create this header, and then I can always drag and drop to make sure it is in the format that I need, right? And I can drag and drop and put it anywhere in the screen, wherever I want in that screen, I can put it, right? Add a text widget here, somewhere in the center. Okay, now let's add one more widget, and this time let's add, probably let's do one thing, let's add a logger. Logs, let's add a logs, and in logs, let's say I will only select alert. There's no alert. Okay, let's select error. So I'll add only error logs so that in my dashboard I can see only errors. So, and I will expand the size little bit, and I will give this name as error logs. I'll give error logs as my widget name. So here I have error logs, right? So go ahead and add a new widget called as logs and filter it based on error. Filter it based on error so that only errors will be seen here. So this is like an error log, right? So let's add a new widget. Let's probably add a graph. In graph, let's say I'm going to select some utilization. Let's say BigQuery dataset itself, log entry utilization, right? We don't have any service, guys. That's why we don't have any options. But in real, if you have Kubernetes, if you have Cloud SQL database, right, all of that you will be able to add here. CPU utilization, memory utilization, cores utilization, disk utilizations, all of them you will be able to add here, right? So yeah, go ahead and add a couple of this one. Let's say I want to add a scorecard also. In scorecard, let's say I want to display how much bytes of data did my BigQuery read. So in BigQuery, so far, 7.44 bytes per second of data I have read or write, right? So you can keep on going on adding like this widgets, guys, text, KPIs, line, logs, headers. You can add lot of widgets. You see, all these are the widgets. You can even add a geo map, right? Pie chart, lot of things you can do, right? And then next I'll show you how we can share this dashboard, right? But share also, guys, very importantly, you can only share it to folks first who have access to GCP console, second who has access to this project. So there are two important aspects here. You can't just go and share a dashboard to anyone and everyone. You can only share a dashboard to person who has access to, first of all, GCP, okay, console, and second thing is access to your project, this project, right? And how do you share them? On the top right hand side, you have a share button. So you can just write an email, so they'll get that link, or you can just copy the link and give that link, and that person will then be able to access this dashboard. Any major limitation and advantage of GCP dashboard against Grafana and Prometheus or Loki? See, Prometheus, Loki, Grafana will help you at infra level and irrespective of any cloud, right? It's cloud agnostic. And it's at application and infra level, whereas GCP here, whatever you're seeing is at cloud service level. So both are good at its own place. Let's say if you are building an application where you want to see how many, in how many pods are up and running, what is the utilization of pods, you need logs of those pods from Loki. So all that things, Grafana is the best, right? But if you want a GCP service level logs, you will be using GCP monitoring dashboard. Okay. So yeah, coming back to the topic, guys, how can I share this dashboard? So on the top right hand side, you'll have this share button. write the email of that person. That email, the person will get an email invite saying that, hey, you have access to this dashboard. So he and she can look at this dashboard, or you can even copy the link by adding that email. Then you can click on copy, and then the user will be able to open and access this dashboard, right? So that's the only way where a user can basically go and access these dashboards. Topic, is it clear, the concept about GCP dashboard? How to create this monitoring dashboard to monitor GCP services? Very important. This is to monitor GCP service. So let's go back and delete our custom dashboard that we bring. So if we are using GKE, BigQuery and cloud storage only for all my application, I should no. If you are using for GKE services, then use GCP monitoring services. If you are specifically looking only for GKE, then go with Prometheus, Grafana and Loki. As of now, what I understand, we can't share dashboard as endpoint to developers. Correct. You can't share it as endpoint. It's just that you have to give them access to your GCP project and they can access it, but via redirecting to this this particular URL or page. So once you have the dashboard ready, you can just come back, guys, and we can delete our custom dashboard. So you can just select this custom dashboard, or you can just scroll towards right hand side of your custom dashboard, and you can simply click on this delete button, right? So that delete button will actually delete that custom dashboard. You can manage that from IAM when you're giving it in your, when you're creating a group, right? In that group, you will add a role, right? So make sure when you're creating a role in that policy, select only this monitoring dashboard read permission, right? So those users will only have read permission, right? Yeah. To show that, I have to create a VM. So let me give a quick demo. Because we don't have any VM created, that's why you're not able to see it. So let me do one thing. Just for, I'm going to randomly create a VM, guys, with everything set as default. And then I'll show you how you can, use this for alerts, right? Okay, my VM is created. Let me SSH and probably run some 1 or 2 commands also, so that some memory or CPU is utilized. Let's say I'll run some update. Then I'm going to run some upgrade. Okay, so let's assume by the time this is running, I'll go back, I'll refresh, I'll go back to my alerting. And this time, see here, guys, now you will see VM instances. Why? Because we have used VM instance service, right? So now in VM instance, let's say, for example, CPU usage or CPU utilization, right? So let's say I'll say CPU utilization, and then I will click on next, and I'll give threshold as 80%. So if more than 80% of CPU is utilized, see here, 80% red color line here is 80% threshold. So if my value crosses this threshold, then what I should do? I will set up a notification channel here. Notification channel is nothing but where do you want to send notification? At Slack, email, SMS, or to a cloud pub sub. So you can actually configure these, right? And that will create your trigger. And then anytime in your VM, if 80% and above is utilized, it will send that notification wherever you have configured, right? So I hope that helps clear your doubt. So I can go back and I can delete this VM now. Cool. So that brings us to an end of GCP logging and monitoring service. I know it was very quick because it's nothing hard skills. It's just like you can go to these services and go and read those, right? So it's nothing related to our compute or storage. But yeah, this was a quick intro about our GCP logging and monitoring service. Okay. So the next topic that we will be starting is GCP's Vertex AI. Okay. Now, what is Vertex AI used for, right? Now, all of this, what you are seeing API call that we are doing, right? All of this internally are basically an AI model. There is a model behind the scene, which is detecting face. There is a model behind the scene, which is helping me translate from one language to other language, right? There is a model behind the scene, which is actually identifying videos, or there is a model behind the scene, which actually detects labels from a image, right? All these models are already built by Google, or these are ready-made available by Google. Now, what if I want to build my own custom model with custom requirement? Because Google cannot have all requirement models, right? They'll have for generic requirements, they'll have these models. So in that case, we will use GCP's Vertex AI service. So GCP's Vertex AI is a service for end-to-end building model and deploying to production. So if you have a data science team or AI team, which basically wants to develop a model and you guys want to deploy that model to GCP, then you will be using this Vertex AI service. This Vertex AI service will do that for you, right? It will give you, or it will help you. It will provision you end-to-end, services for training your model, deploying your model, and running inference, right? Now you can just sit back and I'll give you a walkthrough of what this portal is. Anyways, we don't have this, it's out of our scope. So I'll just give you a walkthrough what this looks like, right? So in Vertex AI, first and the foremost thing, we have Google Colab Enterprise, right? Let me enable this API. So what is this Google Colab Enterprise? It's basically using Jupyter Notebook or online version of Jupyter Notebook. So we generally write Python's modeling code and all in Jupyter Notebook, and Google Colab is online version of Jupyter Notebook, right? It's like, think it like an online IDE where you can run your Python scripts or you can train your models, right? So you can create those notebooks here on cloud and you can run it on cloud. Your next question will be, where will it run? So you will select a compute, you will create a compute. In that compute, it will run your script. Okay. Then we have Vertex Studio. So in Vertex Studio, you have seen, right? We have done vision. So under vision, you will be able to upload an image and then you will be able to generate anything, right? You can generate a text, you can generate what is label, right? You can do all of those, right? So you have vision, you have language support, where in language support, what you can do, we have already seen translate text, right now itself we have seen translate text, right? So you can do a translate text. You can basically build like a chat bot which will start a conversation. So if you want to build like a chat bot kind of application, so you can start with this quick guide which will help you build a chat bot. Or if you want to basically generate some text, right, like given some data you want to generate text, you can do that also, right? Then you have speech related. So in speech related, if you want to convert text to speech, or you want to convert speech to text, you can do that also, right? So we have all of this available, right? Plus you can actually even leverage this via code. It's not just that from UI you can do this, you can do it even from code, right? Like how we have written here code, you can even use script to generate speech to text, text to speech. So all these are basically Vertex AI Studios ready-made SOTA models. That is on the go, it is already available. You just have to go ahead and use it. You just have to use them, right? Then we have data related services. That is, you want to store your data, right? Because when you're training a model, or once you are building your own model, you know that you have to require data. You need your historical data, right? Without historical data, you cannot train or build a model. So where will you store that historical data? You can upload it as a data set. That is, you can create a data set, right? And you can actually upload your data, which will be uploaded in a storage bucket. So your data will be available as a data set. So data sets feature will help you upload your data and have it ready in your Vertex AI service, right? Then if you have tabular data, once, for example, you read a raw data, like how we did in BigQuery, right? We read a raw data and then we process that data, right? So once we are processing that data, the final processed data will be stored in something called as feature store. What is a feature store? A feature store is like your database, which it is like a storage, centralized storage mechanism, which actually stores my final processed data, right? That is the data which has to go to my machine learning model. Before that, the final data I have, right? I can store the final data in feature store, which will be stored as a table, right? As a data. So data set is like your raw data that you can upload. Feature store is for tabular data, like Excel data, CSV data, right? In the table format, which you will use for building ML models, right? So those things will be uploaded here in feature store. So that is part of your data processing or data collection. Then comes your model development. So in model development, what you can do, you can create a training job. So you can create a training job where you can train a new model by selecting what data set, right? So currently we don't have any data set, but once you upload a data set, you can select the data set, then you can give the model details, right? Then you can give, whether you're training a new model or you want a new same model but different version. Then you can probably specify even, you can even specify, then you can specify the training, this one, right? What will you be using? Will you be using PyTorch framework, which is a PyTorch Python library, or you will be using scikit-learn, TensorFlow, XGBoost? So these are the frameworks. So what kind of model you are building, right? Which framework you will use? So let's say, for example, using TensorFlow, then which version? Then you will give path. You will give path where your model will, once all your application code, right, to train the model will be uploaded in this cloud storage path. And then you will give the Python module name like train.py or training_py, right? You will give the path of that Python module, which is going to trigger and run your job, right? So this is basically your train job. This is to start a training or run a training job. Then you can even have experiments. Experiments are basically to log your training values. Like for example, when you're training an ML data, or sorry, when you're training an ML model, so you should know the performance of your model, right? So there you have to log the performance, right? Like, hey, in the first run, my model was 90% accurate. In the second training, my model was 92% accurate. In the third run, it was 95% accurate. So this 90, 92, 95, you have to store all this experiment, right? So that you can store it here as an experiment. Okay. And then once you have built the model, once you have trained the model, you have to register the model in artifact registry or model registry. So in this model registry, what happens? You save your model, the best model, because see, not only once you will build the model, data science team or AI team will build more than 5 times, 10 times you will train the model. And then one best model you will pick, and that best model you will register in here model registry, right? So once you register your model in model registry, then you can either do batch prediction or you can do online prediction by creating it as an endpoint, that is API. So it will create as an API. You can keep sending requests to that API and that will do the model prediction, right? So these are all the services that you will use end to end to train your own model, deploy it and perform inference, like either using API or either using batch transformations, right? So these are the services that we have in Vertex AI. I know a lot of this would not be making sense to you guys or not important, but yeah, I had to give a quick walkthrough that if you were supposed to anywhere in future build your own ML model or AI model, you will be coming to GCP's Vertex AI service. Is that all clear, guys? Fine. Okay, cool. So let's create a mind map. Okay. And let's start with GCP. Cool. So at the very beginning, we got started with GCP's GCP IAM Roles and Services, right? And within this IAM, we learned about how to add user or principal. We learned about principals in GCP, how to add a user or principal, how to create a service account, and how to download a key file for that service account. And we also saw how to create a role and attach a role to a user, right? Then with that, we saw then GCP network service, right? So in GCP network service, or let me just write network. So under network service, we learned about VPC,